Chapter 7. Opinions examined with regard to petrifaction, or mineral concretion. The ideas of naturalists with regard to petrifaction are so vague and indistinct, that no proper answer can be given to them. They in general suppose water to be the solvent of bodies, and the vehicle of petrifying substances. But they neither say whether water be an universal menstruum, nor do they show in what manner a solid body has been formed in the bowels of the earth, from that solution. It may now be proper to examine this subject, not with a view to explain all those petrifactions of bodies which is performed in the mineral regions of the earth, those regions that are inaccessible to man, but to show that what has been wrote by naturalists, upon this subject, has only a tendency to corrupt science, by admitting the grossest supposition in place of just principle or truth, and to darken natural history by introducing an ill-conceived theory in place of matter of fact. Le Comte de Buffon has attempted to explain the crystallization of bodies, or production of mineral forms, by the accretion or juxtaposition of elementary bodies, which have only form in two dimensions, length and breadth. That is to say, that mineral concretions are composed of surfaces alone, and not of bodies. This however is only an attempt to explain, what we do not understand, by a proposition which is either evidently contradictory, or plainly inconceivable. It is true that this eloquent and ingenious author endeavors to correct the palpable absurdity of the proposition, by representing the constituent parts of the mineral bodies as Delame's infiniment minces. But who is it does not see, that these infinitely thin plates are no other than bodies of three dimensions, contrary to the supposition, for infinitely thin means a certain thickness. But the smallest possible or assignable thickness differs as much from a perfect superficies as the greatest. De Luc has given us his ideas of petrifaction with sufficient precision of term and clearness of expression. His opinion, therefore, deserves to be examined. And, as his theory of petrifaction is equally applicable to every species of substance, it is necessary again to examine this subject, notwithstanding of what has been already said, in the first part of this work, concerning consolidation and mineral concretion from the fluid state of fusion. This author has perhaps properly exposed Woodward's theory of petrification in saying 36, Son erreur à cet égard vient de ce qu'il n'a point réfléchi sur la manière dont est faite la pétrifaction. Il ramène d'abord les pierres pour y faire entrer les coquilles, sans bien connaître l'agent qu'il y emploie, et il les droit en soute, sans réfléchir au comment. To avoid this error or defect, M. De Luc, in his theory of petrifaction, sets out with the acknowledged principle of cohesion. And, in order to consolidate strata of a porous texture, he supposes water carrying minute bodies of all shapes and sizes, and depositing them in such close contact as to produce solidity and concretion. Now, if Dr. Woodward softened stones without a proper cause, De Luc, in employing the specious principle of cohesion, has consolidated them upon no better grounds. For, the application of this principle is as foreign to his purpose, as is that of magnetism. Bodies, it is true, cohere when their surfaces are closely applied to each other, but how apply this principle to consolidation? Only by supposing all the separate bodies, of which the solid is to be composed, to be in perfect contact in all their surfaces. But this, in other words, is supposing the body to be solid. And, to suppose the agent, water, capable of thus making hard bodies solid, is no other than having recourse to the fortuitous concourse of atoms to make a world, a thought which this author would surely hold in great contempt. He then illustrates this operation of nature by those of art, in building walls which certainly become hard, and which, as our author seems to think, become solid. But this is only an imperfect or erroneous representation of this subject. For, mortar does not become hard upon the principle of petrification adopted by our author. Mortar, made of clay, instead of lime, will not acquire a stony hardness, nor ever, by means of water, will it be more indurated than by simply drying. Neither will the most subtle powder of chalk, with water and sand, form any solid body, or a proper mortar. The induration of mortar arises from the solution of a stony substance, and the subsequent concretion of that dissolved matter, operations purely chemical. Now, if this philosopher, in his theory of petrifaction, means only to explain a chemical operation upon mechanical principles, why have recourse, for an example in this subject, to mineral bodies, the origin of which is questioned? Why does he not rather explain, upon this principle, the known concretion of some body, from a fluid state, or, conversely, the known solution of some concreted body? If again he means to explain petrifaction in the usual way, by a chemical operation, in that case, the application of his polished surfaces, so as to cohere, cannot take place until the dissolved body be separated from the fluid, by means of which it is transported from place to place in the mineral regions. But it is in this preliminary step that lies all the difficulty. For, could we see how every different substance might be dissolved, and every dissolved substance separated from its solvent at our pleasure, we should find no difficulty in admitting the cohesion of hard bodies. Whether by means of this doctrine of polished surfaces, or by the principle of general attraction, a principle which surely comprehends this particular, termed a cohesive power. It must not be alleged, that seeing we know not how water dissolves saline bodies, therefore, this fluid, for anything that we know, may also dissolve crystal. And, if water thus dissolves a mineral substance in a manner unknown to us, it may in like manner deposit it, although we may not be able to imagine how. This kind of reasoning is only calculated to keep us in ignorance. At the same time, the reasoning of philosophers, concerning petrifaction, does not in general appear to be founded on any principle that is more sound. That water dissolves salt is a fact. That water dissolves crystal is not a fact. Therefore, those two propositions, with regard to the power of water, are infinitely removed, and cannot be assimilated in sound physical reasoning. It is no more a truth that water is able to dissolve salt, than that we never have been able to detect the smallest disposition in water to dissolve crystal, flint, quartz, or metals. Therefore, to allege the possibility of water being capable of dissolving those bodies in the mineral regions, and of thus changing the substance of one body into another, as naturalists have supposed, contrary to their knowledge, or in order to explain appearances, is so far from tending to increase our science, that it is abandoning the human intellect to be bewildered in an error. It is the vain attempt of lulling to sleep the scientific conscience, and making the soul of man insensible to the natural distress of conscious ignorance. But besides that negative argument concerning the insolubility of crystal, by which the erroneous suppositions of naturalists are to be rejected, crystal in general is found regularly concreted in the cavities of the most solid rock, in the heart of the closest agate, and in the midst of granite mountains. But these masses of granite were formed by fusion. I hope that I shall give the most satisfactory proof of that truth. Consequently, here at least there is no occasion for the action of water in dissolving siliceous substances in one place, in order to concrete and crystallize it in another. In these cavities of the solid granite rock, where crystal is found regularly shooting from a basis which is the internal surface of the cavity, we find the other constituent substances of the granite also crystallized. I have those small cavities, in this rock, from the island of Arran, containing crystal, feldspar, and mica, all crystallized in the same cavity 37. But this is nothing to the drusen or crystalline concretions, which are found in a similar manner among metallic and mineral substances in the veins and mines. There, every species of mineral and metallic substance, with every variety of mixture and composition, are found both concreted and crystallized together in every imaginable shape and situation. Here is an infinite operation, but an operation which is easily performed by the natural arrangement of substances acting freely in a fluid state, and concreting together, each substance, whether more simple or more compound, directing itself by its internal principle of attraction, and affecting mechanically those that are concreting around it. We see the very same thing happen under our eye, and precisely in the same manner. When a fluid mass of any mineral or metallic substance is made to congeal by sudden cooling on the outside, while the mass within is fluid, a cavity is thus sometimes formed by the contraction of the contained fluid. And in this cavity are found artificial drusen, as they may be called, being crystallizations similar to those which the mineral cavities exhibit in such beauty and perfection. Petrification and consolidation, in some degree, may doubtless be performed, in certain circumstances, by means of the solution of calcareous earth, but the examples given by M. Deluc, of those bodies of limestone and agate petrified in the middle of strata of loose or sandy materials, are certainly inexplicable upon any other principle except the fusion of those substances with which the bodies are petrified. 38. This subject deserves the strictest attention. I propose it as a touchstone for every theory of petrification or perfect consolidation. First, there are found, among argillaceous strata, insulated bodies of ironstone, perfectly consolidated. Secondly, there are found, in strata of chalk and limestone, masses of insulated flints. Thirdly, there are found, in strata of sea sand, masses of that sand cemented by a siliceous substance. Fourthly, in the midst of blocks of sandstone, there are found masses of loose or pure sand enclosed in crystallized cavities. And in this sand are found insulated masses of crystallized spar, including within them the sand, but without having the sparry or calcareous crystallization disturbed by it. There are also other globular masses of the same kind, where the sparry crystallization is either not to be observed, or appears only partially. 39, and now, lastly, in strata of shell sand, there are found masses of consolidated limestone or marble. In all those cases, the consolidated bodies are perfectly insulated in the middle of strata, in which they must of necessity have been petrified or consolidated. The stratum around the bodies has not been affected by the petrifying substance, as there is not any vestige of it there, and here are examples of different substances, all conspiring to prove one uniform truth. Therefore, a general theory of petrification or consolidation of mineral bodies must explain this distinct fact, and not suffer it any longer to remain a lusus naturae. Let us now consider what it is that we have to explain, upon the supposition of those concretions being formed from a solution. We have, first, to understand what sort of a solution had been employed for the introducing of those various substances. Secondly, how those concretions had been formed from such solutions within those bodies of strata. And, lastly, how such concretions could have been formed, without any vestige appearing of the same substance, or of the same operation, in the surrounding part of the stratum. Whatever may be the difficulty of explaining those particular appearances by means of fusion and mechanical force, it is plainly impossible to conceive those bodies formed in those places by infiltration, or any manner of concretion from a state of solution. Naturalists, in explaining the formation of stones, often use a chemical language which either has no proper meaning, or which will not apply to the subject of mineral operations. We know the chemical process by which one or two stony concretions may be formed among bodies passing from one state to another. When, therefore, a change from a former state of things in mineral bodies is judged by naturalists to have happened, the present state is commonly explained, or the change is supposed to have been made by means of a similar process, without inquiring if this had truly been the case or not. Thus their knowledge of chemistry has led naturalists to reason erroneously, in explaining things upon false principles. It would be needless to give an example of any one particular author in this respect. For, so far as I have seen, it appears to be almost general, every one copying the language of another, and no one understanding that language which has been employed. These naturalists suppose everything done by means of solution in the mineral kingdom, and yet they are ignorant of those solvents. They conceive or they imagine concretions and crystallizations to be formed of every different substance, and in every place within the solid body of the earth, without considering how far the thing is possible which they suppose. They are constantly talking of operations which could only take place in the cavities of the earth above the level of the sea, and where the influence of the atmosphere were felt. And yet this is the very place which we have it in our power to examine, and where, besides the stalactite, and one or two more of the same kind, or formed on the same principle, they have never been able to discover one of the many which, according to their theory, ought always to be in action or effect. So far from knowing that general consolidating operation, which they suppose to be exerted in filling up the veins and cavities of the earth by means of the infiltrating water of the surface. They do not seem fully to understand the only operation of this kind which they see. The concretion of calcareous matter upon the surface of the earth is perhaps the only example upon which their theory is founded, and yet nothing can be more against it than the general history of this transaction. Calcareous matter, the great vinculum of many mineral bodies, is in a perpetual state of dissolution and decay, in every place where the influences of air and water may pervade. The general tendency of this is to dissolve calcareous matter out of the earth, and deliver that solution into the sea. Were it possible to deny that truth, the very formation of stalactite, that operation which has bewildered naturalists, would prove it. For it is upon the general solubility of calcareous matter exposed to water that those cavities are formed, in which may be found such collections of stalactical concretion. And the general tendency of those operations is to waste the calcareous bodies through which water percolates. But how is the general petrifaction or consolidation of strata, below the surface of the sea, to be explained by the general dissolution of that consolidating substance in the earth above that level? Instead of finding a general petrifying or consolidating operation in the part of the earth which we are able to examine, we find the contrary operation, so far at least as relates to calcareous spar, and many other mineral bodies which are decomposed and dissolved upon the surface of the earth. Thus in the surface of the earth, above the level of the sea, no petrifying operation of a durable nature is found, and, were such an operation there found, it could not be general, as affecting every kind of substance. But, even suppose that such a general operation were found to take place in the earth above the level of the sea, where there might be a circulation of air and percolation of water. How could the strata of the earth below the level of the sea be petrified? This is a question that does not seem to have entered into the heads of our naturalists who attempt to explain petrifaction or mineral concretion from aqueous solutions. But the consolidation of loose and incoherent things, gathered together at the bottom of the sea, and afterwards raised into rocks of various sorts, forms by far the greatest example of petrification or mineral operation of this globe. It is this that must be explained in a mineral theory. And it is this great process of petrifaction to which the doctrine of infiltration, whether for the mechanical purpose of applying cohesive surfaces, or the chemical one of forming crystallizations and concretions, will not by any means apply. Nothing shows more how little true science has been employed for the explanation of phenomena, than the language of modern naturalists, who attribute, to stalactical and stalagmical operations, every superficial or distant resemblance to those calcareous bodies, the origin of which we know so well. It is not a mere resemblance that should homologate different things, there should be a specific character in every thing that is to be generalized. It will be our business to show that, in the false stalactites, there is not the distinctive character of those water-formed bodies to be found. In the formation of stalactical concretions, besides the incrustation as well as crystallization of the stony substance from the aqueous vehicle by which it had been carried in the dissolved state, we have the other necessary accompaniments of the operation, or collateral circumstances of the case. Such, for example, is that tubular construction of the stalactite, first formed by the concretion of the calcareous substance upon the outside of the pendant gut of water exposed to the evaporation of the atmosphere. We then see the gradual filling up of that pervious tube through which the petrifying water had passed for a certain time. And, lastly, we see the continual accretion which this conducting body had received from the water running successively over every part of it. But among the infinite number of siliceous concretions and crystallizations, as well as those of an almost indefinite variety of other substances, all of which are attributed to solution, there is not the least vestige of any collateral operation, by which the nature of that concretion might be ascertained in the same manner. In all those cases, we see nothing but the concreted substances or their crystallizations, but no mark of any solvent or encrusting process is to be perceived. On the contrary, almost all, or the greatest part of them, are so situated, and attended with such circumstances, as demonstrate the physical impossibility of that being the manner in which they had been concreted. For, they are situated within close cavities, through which nothing can pervade but heat, electricity, magnetism, etc. And they fill those cavities more or less, from the thinnest incrustation of crystals to the full content of those cavities with various substances. All regularly concreted or crystallized according to an order which cannot apply to the concretion of any manner of solution. That there is, in the mineral system, an operation of water which may with great propriety be termed infiltration, I make no doubt. But this operation of water, that may be employed in consolidating the strata in the mineral regions, is essentially different from that which is inconsiderately employed or supposed by mineralists when they talk of infiltration. These two operations have nothing in common except employing the water of the surface of the earth to percolate a porous body. Now, the percolation of water may increase the porousness of that body which it pervades, but never can thus change it from a porous to a perfect solid body. But even the percolation of water through the strata deposited at the bottom of the sea, necessarily required, according to the supposition of naturalists, must be refused. For, the interstices of those strata are, from the supposition of the case, already filled with water, consequently, without first removing that stagnant water, it is in vain to propose the infiltration of any fluid from the surface. This is a difficulty which does not occur in our theory, where the strata, deposited at the bottom of the sea, are to be afterwards heated by the internal fires of the earth. The natural consequence of those heating operations may be considered as the converting of the water contained in the strata into steam, and the expulsion of steam or vapor, by raising it up against the power of gravity, to be delivered upon the surface of the earth and again condensed to the state of water. Let us now conceive the strata, which had been deposited at the bottom of the sea, as exhausted of their water, and as communicating with the surface of the earth impregnated with water. Here again we have the power of gravity to operate in carrying down water to that place which had been before exhausted by the power of heat. And in this manner, by alternately employing those two great physical agents, we cannot doubt that nature may convey soluble substances from above, and deposit them below for the purpose of consolidating porous bodies, or of filling with saline and earthy matter those interstices which had been originally filled with water, when the strata were deposited at the bottom of the sea. How far any marks of this operation may be perceived, by carefully examining our mines and minerals, I know not. I can only say that, on the contrary, whenever those examined objects were clear and distinct, with the concomitant circumstances, so as to be understood, I have always found the most certain marks of the solid bodies having concreted from the fluid state of fusion. This, however, does not exclude the case of infiltration having been previously employed, and I would entreat mineralists, who have the opportunity of examining the solid parts of the earth, to attend particularly to this distinction. But do not let them suppose that infiltration can be made to fill either the pores or veins of strata without the operation of mineral heat, or some such process by which the aqueous vehicle may be discharged. Not only are mineral philosophers so inconsiderate, in forming geological theories upon a mere supposition or false analogy, they have even proceeded, upon that erroneous theory, to form a geological supposition for explaining the appearances of strata and other stony masses in employing a particular physical operation, which is, that of crystallization 40. Now crystallization may be considered as a species of elective concretion, by which every particular substance, in passing from a fluid to a solid state, may assume a certain peculiar external shape and internal arrangement of its parts, by which it is often distinguished. But, to suppose the solid mineral structure of the earth explained, like an enigma, by the word crystallization, is to misunderstand the science by which we would explain the subject of research. And, to form a general mineral theory thus upon that term, is an attempt to generalize without a reason. For, when it were even admitted that every solid body is crystallized, we thus know no more of the geology of this earth, or understand as little of the general theory of mineral concretion, as we did before. We cannot, from that, say whether it be by the operation of solution or of fusion which had produced the perceived effect. M. de Carosi has wrote a treatise upon certain petrifactions 41. In the doctrine of this treatise there is something new or extraordinary. It will therefore be proper to make some observations on it. The object of this treatise is to describe the generation of silex and quartz, with their modifications or compositions, formed within mineral bodies of a different substance. The natural history contained in this little treatise is well described and sufficiently interesting. But it is chiefly in order to examine the means which, according to the theory of this treatise, are employed in petrifying bodies, that I consider it in this place. The first section of this treatise has for title, Generation du caillou et du quartz de la terre calcaire pure. It may be worthwhile to compare the natural history of this part of the earth with the flint and chert found in our chalk and limestone countries. I shall therefore transcribe what is worth observing upon that subject, page 5. Nous rencontrons chez nous dans les parties le plus montagneusses, et les moins couvertes de terreau, au tout au plus de sable, entre de pures rochers calcaires en quantité incroyable de cailloux, silex, tant en boules, que veins, couches. Et débris. Au premier coup d'œil l'on s'imagine que ces font de débris de montagnes éloignées, que y ferent amends par les eaux, mais, en examinant la chose de plus près, on est convaincu, que ces sont tout au contraire. De parties détachées de montagnes de la country. Car il y a sur presque tout l'étendue de nos montagnes calcaires en couche, au pour mieux dire, un banc composé de plusieurs couches de base calcaire, mais que au sont parsemés irrégulièrement de boules, de rognons, de veins. Et de petits filons de silex, au que contenant cette pierre en filon, veins, et couches parallèles, et irrégulièrement disposées. Les boules et rognons de silex y font de puits moins de la grandeur d'une petite noisette, jusqu'au diamètre de plus de 6 pouces de notre mesure. La plupart de ces boules tant qu'elles sont dans l'intérieur cache de la roche vive, et qu'elles en rien souffert de l'impression de l'air, ont, pour l'ordinaire, un croûte de spath calcaire. Au moyen de laquelle elles sont accrues à la roche mire. Au pour mieux dire la croûte spatius fait l'intermède entre le silex, et la roche calcaire, par aussi fait le passage de l'un à l'autre. Mais si n'y voit que de boules de silex entièrement formes. C'est donc on peut même s'y convaincre à la vue, par beaucoup de pierres dont le pave de la ville de Cracovie est composé. Mais là, où le silex n'est pas encore entièrement achieve, la croûte spatius manque, en revanche on y voit évidemment le passage par degrés successifs de la roche calcaire au silex que y est contenu. Et les nuances de ces passages sont souvent si peu marquises que même les acides minéraux n'y suffisent pas à les déterminer, si n'est que le briquet, que nous aide à les découvrir. On voit bien au la pierre calcaire s'enfonce en couleur, l'on s'apercoit, osa durit, ses cachers changent, mais, comme elle y souffre encore quelque impression de acides, l'on n'y saurait déterminer au juste le point. Elle a déjà plus de la nature du silex, que de celle de la chaux, tu en la frappant du briquet. Téléphones sont les cailloux en boules et rognons avant leur état de perfection Illinois y aura même au milieu en partie de pierre calcaire non changée. Au contraire, la nature a achieve son ouvrage, ont un croûte de chaux endurci, et sont purement du silex fini, mais de toutes coulas, d'un grain et d'une texture plus moins fine. Capacé à ses souvent par degrés dans les différentes variétés du noble silex. Ils pour l'ordinaire, dans leur intérieur en cavité, mais pas toujours au centre, et que vint apparemment de la consommation de cette partie calcaire que y reste la dernière, et en fait changer au dissolut et séparé. Que lorsque le reste du silex était déjà entièrement fini. Ces cavités sont toujours, au enduites de chalcédoine en couche concentriques recouvertes de petits cristaux fort brillants et d'ers de quartz, au bien seulement de ces derniers ci. Parfois il y a aussi du spath calcaire cristallisé, mais cela est extrêmement rare. Quelquefois enfin ces cavités sont remplies d'une noix de chalcédoine. Jnai réussi chuan seule fois en cassant un parel silex en boule dy travailler encore le reste de l'eau de crystallization. The only remark that I would here make is this, that, if the crystallization of those close cavities in the silex had at any time required water of solution, it must always have required it. But, if there had been water of solution contained in those close cavities, for the crystallization of the various things which are often found within them, how comes it that this water is almost never found? I have good reason to believe that water contained within a solid flint will not make its escape, as does that contained in the anhydrites of Mount Barico, which are composed of a porous chalcedony. But the siliceous crystallizations within close cavities is a curious subject, which we shall have occasion to examine more particularly in treating of agates. We now proceed to the next section, which is the generation of silex and quartz in marl, page 19. Ilya de contras, chez nous, que out de tendices considerables en long et en large, de montagnes de pierre de marne calcaire, dans lesquels on rencontre le même phénomène que dans celles de chaux pure, c. d. Nous y trouvons du silex de différentes variétés, et dans tous les degrés successifs de leur formation, et de leur perfection. Outre cela, nous y voyons encore quelque chose, que semble nous conduire à la découverte de moyens, dont est sort la nature pour effectuer cette opération. Et que nous étoit cache dans les montagnes de chaux pure, ces banks de pierre marne-silicious, consonant en partie considerable de parides sulfurieuses, que non seulement y forment en grande quantité de petits cylindres. Mais tout la masse de la montagne est remplie de parcelles souvent presque imperceptibles de ces mineral. Ces parides sont évidemment de productions du phlogistique et de l'élacide contenu dans la montagne. L'eau, que sy trouvé ordinairement en assez grande abondance, en détacha, extra d'un et l'autre, et les commina après tous les du ensemble. Cette même eau les dissout derechef, et en fait de nouvelles combinaisons. C'est ce qu'on voit évidemment là, ou la nature, ayant commence ces operations, Illinois ny est reste la pyrite, tu une portion de la partie inflammable li à un base terrestre. Dans ces endroits la marne n'est que fort plus sensible aux acids, et de blanche tu l'étoit, sa couleur est devenue presque noire. C'est là qu'on observe les différents degrés du changement de la marne en silex, contenant, même encore, parfois, de parties pyritiques non détruites dans son intérieur. Et comme la nature forme ici, de même, que dans la chaux pure les silex, la plupart en boules ou rognons. Comme les différents degrés de métamorphoses de la marne en silex, sont ici beaucoup plus nombreuses que là, de sorte qu'il de bandes entières, que mériteraient plutot d'être appelées bandes silicieuses, que marneuses. Comme enfin, en grande quantité de parides, leurs, ils très probable qu'ils servent la du même moyen ici pour opérer la métamorphose en question. Ne nous précipitons, cependant, pas à en tirer plus de conséquences. Poursuivons plutôt le fil de notre recette. Le silex, que s'y trouvé ici, est non seulement de différents degrés de perfection, Illinois est de plus d'une espèce. Ilya de la pierre à feu, 2 de la chalcédoine, 3 de agathes, et 4 différentes nuances et passages de species ordinaires aux fines du silex. La pierre à feu, est, ordinairement dans son état de perfection d'un grain assez fin, d'une couleur grise plus ou moins foncée, et même donnant, dans le moirateur, plus ou moins diaphane. Ses cachers sont concentriques ou coquilles, et sa masse est assez compacte. Outre sa conformation ordinaire en boules et rognons, elle fait presque toujours la noix de ursins marins, que y font en grand nombre, et dont la coquille est le plus souvent, et presque toujours de spath calcaire. Même au milieu d'une boule de silex parfait. Les chalcédoines et agathes de ces couches sont toujours, au moins, jni les ai pas encore vues autrement, de coro et autres cor marins petrifies. Donc Illinois faut que les couches de pierres roules, d'illuge tire ma collection city plus haute, soyant de débris de montagne détruites de cette espèce. Ilyn que sont très parfaits comme celles que composent ma collection, d'autres méritant plutot d'être ranges parmi les passages du silex ordinaire, et ses species plus fines. D'autres encore sont, en effet, de vrais agaths, mais que renferment dans leur intérieur plus ou moins de parties non parfaites presque calcaires, que s'énoncent d'abord par leur couleur blanche, par leurs gros grains relativement au reste. Par leur opacité, par leur mollesse respective, et souvent même par leur sensibilité pour les acides minéraux. Mais celles, que sont finis, quoiqu'elles ayant, pour la plupart, une couleur presque noire, enlacente, cependant, pas d'avoir aussi de teintes plus claires comme brunâtres, verdâtres, rougeâtres, jaunâtres, bleuâtres, taqueties, beignets, etc. Leur clarté n'est pas moins variable, que leur couleur Illinois y de presque opaques, comme aussi de presque transparence, sur tout la, ou la chalcédoine prédomine. Le quartz sy trouvé comme dans les pierres de la première section, C, A, D, cristallise, en groupes dans de petites cavités, quelquefois aussi en veins. La chalcédoine y est de même, ou bien en mamelons, ou bien en stalactites, lorsqu'elle a de la place pour sy déposer. Un phénomène encore plus curieux que cela est cette belle pyrite sulfureuse jaune, comme de l'or, que est quelquefois parsemée par toute la substance de petrifications agathocèses. Et que apparemment y fut déposée après la dite métamorphose à la faveur de petits pores, que y toyant restes ouverts. I would beg that mineralists, who use such language as this, would consider if it contains a distinct idea of the operation which they would thereby describe, or if it does not contain either a contradiction or an inconceivable proposition. It supposes a calcareous body to be metamorphosed, somehow by means of the mountain acid, into a siliceous body. But, finding many bodies of pyrites contained within that solid flint, it is said, that, when the calcareous body was flintified, there were left in it cavities which were afterwards filled with pyrites. Let us reflect a moment upon this doctrine. These cavities were first opened to the outside of the flinty body, but now the pyrites with which they had been filled is insulated in the solid flint. Here three things are required. First, the calcareous body is to be flintified, at the same time leaving the body full of small cavities open to the outside. Secondly, these cavities are to be filled with pyrites. Lastly, these mineral bodies are to be so enclosed within the flint, as to leave no vestige of the former processes. This marly mountain itself, which had been formed of loose materials gathered together at the bottom of the sea, was first to be filled with pyrites, in various shapes, by means of the phlogistic and the acid of the mountain. Here is proposed to us an operation which is totally unknown, or of which we have no kind of idea. But, let us suppose pyrites formed in this mountain, of whatever chemical substances, by means of water. Why should water again undo that pyrites, in order to form other concretions? And, why should the flint be formed first with cavities, and then made solid, after pyrites had been introduced into those cavities of the agate, and, as our author expresses it, parsemée pour toute la substance? Here are suppositions which are not only perfectly gratuitous, but are also inconsistent with anything that we understand. This is not explaining nature, it is only feigning causes. 42. The third section has for title, Génération du silex et quartz de la pierre pointée. Here we find an example worthy of being recorded, as contributing to throw great light upon those mineral operations. However, the opinion of our author and mine, upon this subject, differ widely. He proceeds thus. Cette pierre n'est, comme chacun le skate, une pierre calcaire contenant du bitume. Nos montagnes en contenant seulement pas de simples couches, mais il y en a mine de grandes banques for de paix. Le caillou, ou silex que sy génère, formé, tantot de gros blocs informes, que occupant de cavités dans l'intérieur de montagnes, tantot, enfin, en formé de filons. J remarque cette métamorphose sur trois endroits différents, dans chacun de quels la nature a autrement opère. Sur l'un, la pierre pointée fait un banc horizontal dans une montagne de pierre calcaire crystalline, ou d'une espèce de marbre, que contient de couches et filons de métal. So banque de pierre pointe y fait l'autoit d'une couche de galine de plomb et de pierre calaminaire, et don ses cavitas et defense ily et non seulement de blocs de grandeur different, mais aussi de veines et petites bandes courtes de silex. Tant ordinaire, que noble c, a, d, de la pierre à feu, de chalcédoine, d'agaths, et mime d'une espèce de cornaline jaune et rouge pale. Jni emeritari pas a en détail les variétés, parce qu'elles sont trop accidentelles. Jni les connais pas mime touts Illinois s'en faut de beaucoup, parce qu'elles se trouvent dans de anciennes mines négligées, peut être depuis plus d'un siècle, et par conséquent peu accessibles. Jni doute, cependant pas, que, si l'on pouvait mieux sonder le terrain, on y trouverait bien plus encore du peu que j cite. Parmi ces silex Illinois y a aussi de petits groupes et de petites veines de quartz solide et cristallisées. Au second endroit la pierre pointe fait un filon, ousi l'on voûte, un couche ou band verticale, que partage la montagne en deux parties presque égales de l'épaisseur de 3 à peu près. La montagne, ou cela se voit est aussi un ancien mine de cuivre et de plomb, consistent en plusieurs variétés de marbre, different en couleur et en grain, déposées par couches les uns sur les autres. Le filon de silex est forme de feuilles alternatives de pierre pointe et de silex, tous les deux de couleur brun de bois à peu près, mais le silex est plus foncé que sa compagne. Ces feuilles alternatives, consistent d'autres bien plus minces encore, que souvent n'ont pas l'épaisseur d'une ligne, mais ce chuily et de plus curieux, c'est que la mime feuille est d'un but de pierre porquée, que, vers le milieu. Passez successivement en silex, que, à son tour, vers l'autre but, que etoit exposé à l'air repasse par les mêmes gradations en une espèce de tuff calcaire. Ce que nous fait voir avidement la génération et la destruction du silex, même avec un parti de moyens par lesquels elles opèrent. Comme l'endroit de cette découverte n'est accessible qu'à la superficie, jni sur dire sily et d'autres variétés de silex outre la dite. Il est à supposer autant par analogie, que par quelques morceaux que ont de petites veines transversales d'une espèce de chalcédoine, et que sont, même, sur leur fence, garnis de petits cristaux de roche. Mais ce chuily et de sur ces que ce filon, parvenu à une certaine profondeur, essenable et contient du métal, c, d, de la galine de plomb, et de la pyrite cuivreuse, j'nai trouvé de morceaux, que en font de preuves incontestables. Le caillou dici est un grain fin d'une texture forte, peu transparente, dans beaucoup d'étincelles au briquet, mais ses cachers sont écaliaces. La montagne calcaire du troisième lieu en couche de pierre pointée épaisse de plusieurs ons, que, derechef contient de petites couches irrégulières et de bandes transversales de silex, que ont jusqu'à 6 pouces passes d'épaisseur. La pierre pointée est d'une couleur gris-brune, d'un grain assez fin, et d'un tissu assez dur, ses cachers sont irrégulières, mais plus la pierre s'approche du silex, plus elles donnent dans le coquel. Le silex ordinaire est d'un brun de bois, d'un grain assez fin, et d'un tissu résistant, et ses cachers sont égales à la pierre porquée. Ce n'est pas la seule variété Illinois ya, aussi, de la chalcédoine et de agaths de couleurs différentes. Même la pierre fut est assez souvent traversée de veines de chalcédoine, de quartz cristallisé, et de spath calcaire blanc en feuilles et en cristaux. Il arrive que la même veine est composée de ces trois species de pierres à la fois, de sorte que l'un semble passer dans l'autre, parce que les limites réciproques sont, souvent, assez indistincts. Il est évident, que le silex est forme de la pierre pointée, parce qu'on remarque ici les mêmes phénomènes dont j'ai parlé plus haut, c, d, les passages successifs de l'un dans l'autre pierre, tant en montant qu'en descendant. There is nothing particular in the silicious mixture in this species of limestone, except the vein of that substance. It is evident that this vein, traversing the mountain, had been introduced in the fluid state of fusion. I do not mean to say, that, in this particular case now described, the evidence of that truth peculiarly appears. But that, from the general nature of mineral veins breaking and traversing the solid strata of the globe, no other conclusion can be formed. And that in the particulars of this example there is nothing that could lead us to suppose any other origin to the petrifactions contained in this vein of stinking limestone. It is plain, that our author has imagined to himself an unknown manner of executing his mineral metamorphoses. He sees plainly that the common notion of infiltration will not at all explain the evident confusion of those calcareous and siliceous bodies which appear to him to be metamorphosing into each other. Nothing, indeed, can explain those phenomena but a general cause of fluidity, and there is no such general cause besides that of heat or fusion. But to show how mineralists of great merit, gentlemen who have examined systematically and with some accuracy, may impose upon themselves in reasoning for the explanation of mineral appearances from limited notions of things, and from the supposition of these having been formed where they now are found, that is, upon the surface of the earth, I would beg leave to transcribe what this author has said upon this species of petrifaction. It is not that he is ignorant of what mineralists have already said upon the subject, it is because he sees the incompetency of their explanations in those particular cases, and that he would employ some other more effectual means. Page 50. Tout terra calcaire a changer don un autre doit, avant tout chose, etre rendu refractaire ce que ne peut se faire chuen la saturant avec un acide. Mais un terra simplement, saturé d'un acide, est d'une reduction forte z, vu que l'acide ny tient pas trop fort, d'alors ce ne chuen sel nutriteros fort facile et dissoudre dans un quantité suffisante d'eau. Or pour rendre cette union plus constante, Illinois faut que la terre alcaline s'assimile intimement à l'acide, ce que ne sera jamais sans un intermédiaire, que homogène les parties de ce nouveau corps, et pour que cela se fasse il est indispensable. Chu il opère en dissolution foncière de parties terrestres de la chaux, que facilite l'ingress à l'acide, et à l'interméde pour chu il sy lie bien fortement. Supposons chu il se formi un liqueur savineuse de l'acide et du phlogistique, que l'air fixe, mais en liberté, over les interstices de parties que constituent la terre alcaline. Chu après cela cette liqueur savineuse ayant l'entrée libre s'assimile à la terre en proportion requise, que l'eau, que servoit de véhicule dans cette opération, s'évapore successivement, et importe le superflu de ingredients. Pour chu il se puisse opérer le rapprochement le plus exact de parcelles ou molécules homogénéises de nouveau corps chu enfin les molécules les plus pures et les mieux affines soyant réunies en forme liquide dans de cavités. Et que par l'évaporation et séparation de l'eau, els negioient Illinois sen forme de cristox en orans nous pas un boule de silex, avec de cristox de quartz dans ses creux intérieurs. The supposed case is this. A calcareous body is to be metamorphosed into a siliceous nodule, having a cavity within it lined with quartz, crystals, etc. De Carosi means to inform us how this may be done. Now, as this process requires no other conditions than those that may be found upon the surface of this earth, the proper way to prove this hypothetical theory, would be to exhibit such a mineral body produced by those means. But, even supposing that such a process were to be exhibited, still it would remain to be explained, how this process, which requires conditions certainly not be found at the bottom of the sea, could be accomplished in that place, where the strata of the earth had been deposited, accumulated, consolidated, and metamorphosed. This mineral process, which has been now described, will no doubt revolt the opinions of many of our chemists as well as naturalists. And I should not have thought of transcribing it, but as an example of that inconclusive reasoning which prevails in mineralogical writings upon this subject. But this is not all. We have, upon this occasion, a most remarkable example of the fallacious views that may be taken of things, and of the danger to science when men of sense and observation form suppositions for the explanation of appearances without that strict conformity with the principles of natural philosophy which is requited on all occasions. Both M. de Carosi, and also M. Macquart 43, to whom our author communicated his ideas and proper specimens, assert, that from their accurate experience, they find chalcedony growing daily, not only in the solid body of gypsum, etc. while in the mine, but also in the solid stone when taken out of the mine, and preserved in their cabinet. What answer can be made to this positive testimony of these gentlemen, by a person who has not seen any such a thing, and who has not the opportunity of examining the cases in which those naturalists may have perhaps been led into some delusion? Were I however to conjecture upon a subject in which I have not any positive information, I should suppose that some part of the chalcedony, like the oculus mundi when dipped in water, may be so transparent, while containing some portion of humidity, that it is not easily distinguishable from the gypsum in which it is concreted. But that in having the humidity evaporated, by being taken out of the mine and exposed to the dry air, those portions of chalcedony, which did not before appear, may be perceived by becoming more opaque. 44. There is, however, a subject in which I can more freely accuse this author of being deceived. This naturalist says, that calcareous stones become silex by a certain chemical operation, and that those flinty bodies, in being exposed upon the surface of the earth, out of their natural bed, are again, by a contrary chemical operation, changed from flint to a calcareous substance. I will give it in his own words, page 56. Cela dit, venens au fait. Tout silex progenier de chaud, détaché de son lieu natal, et exposé aux changements de saisons, s amulet, recueillit de crevasses, per sa transparence, devient, enfin, tout à fait opaque, le phlogistique s'en évapore, alicide en s détache, lave. Et de terra vitressible, tu il etoit Illinois redevient show, cum il etoit opérant. Here is no question with regard to mere opinion, but to matter of fact. And, in this case, nothing is more evident, than that upon the surface of this earth, that is, in the examinable parts above the level of the sea, there is no transition either of calcareous bodies into flint, nor of flinty bodies into calcareous substance. Calcareous matter is constantly dissolved by water, when it is exposed to the washing of that fluid. And it is even dissolved out of the most perfect union or combination with siliceous substance, and the most solid composition of an insoluble body, as may be perceived in the decaying of feldspar. A superficial view of flints which have come out of a body of chalk, may have created such an opinion, which will not either bear the light of chemical or mineral investigation. The subject of these chalk flints will be minutely examined in its proper place. Our author has carefully examined the subject of flintification, and the country where he makes his observations would seem to be well disposed for such a research. He has had great opportunity and inclination to examine the subject which he writes upon, and he has given a distinct account of what he has seen. His description of the flintification of sandstone is extremely interesting. I will therefore transcribe it, both as a valuable portion of natural history, and also in order to contrast this author's opinion, with regard to the means employed by nature in petrifying bodies, and that which I maintain to be the general consolidating operation of the globe. It is section 5, Generation du caillou du silex du grès, ou Pierre Sablinus. Tout grès est susceptible de cette métamorphose quant au grain et quant à la couleur, depuis la breccia quartzeuse jusqu'à la pierre à rasoir. Et depuis le grès blanc jusqu'au brun et presque moirateur, tiant ou non tiant, ou presque friable, c'est indifferent, tout ces variétés donnant du silex, et surtout de la chalcédoine, de la cornaline, et de agaths. Quant au ciment GLYAI toujours remarque calcaire et phase en effervescence avec les acides dans les endroits de la pierre que anytoyant point encore changes. Et jamais JNAI VUCE changement dans du grès dont le ciment fut ou quartzo ou argilo et refractaire. Ainsi le ciment entré pour quelque chose dans ce changement. Le commencement de cette métamorphose paroit, autant que JPU l'observer dans mes debris rules, se faire par le ciment, que desout la, o les agens urent LHs libre, rend les grains en quartz mobiles, les import. Les mêler avec sa masse dense liquide, les desout, meme en partie, e for me, don cet de veins et de masses calcedonieuses, carnia leaks, ou d'une autre espèce de silex, au milieu du gres pou, ou pas du tout, change. Car autant que je pousse voir, si n'est pas par couches ou veins tu les opère, mais par boules et masses rondoblongs. Au commencement ces veins et taches sont fort minces, et le reste du gres n'est point du tout, ou a peine sensiblement change hormis tu il gagni, plus de consistance, à proportion du changement souffert. Mais à mesure que le silex y augmente et perfection, on y applique les degrés par lesquels a passer cette opération. Les nuances du passage d'une pierre à l'autre deviennent plus visibles, les veins et masses de silex grandissent au point, meme. Tu il et jusqu'au ux3 quart du gres change en silex clair comme de l'eau niant que fort peu de grains de sable nagents dans sa masse. Des morceaux de cette espèce sont rares à la vérité, mais jnai, cependant, trouver quelques uns ordinairement, dans les beaux morceaux, le silex fait la base, et le sable y est, comme nagent tantot en grains sépars tantot en parties et flocons. Dans les pieces moins belles, le sable fait la base, et le silex sert à la fois de ciment, et forme aussi plus ou moins de veins, que traversent la masse en maintes directions. Mais si en gres à gros grains, au de la breccia, alors le reste prend la nature silicious mêlée de sable fin, et les gros grains de quartz restent téléphones, tu ils etoyant, sans changer. J'ai déjà remarqué que cette métamorphose semble s'opérer, comme celle de Caillou d'origine calcaire en forme approchant la sphérique Illinois faut encore y et jouter, que j'ai lu de croire, tu les face aussi du dedans en dehors, tout. Comme la décomposition s'y fait du dehors au dedans. Il arrive dans cette pierre, comme dans tout autre, tu ils forme de cristallisations dans les cavités. Lorsqu'elles sont de silex, leur figure est toujours mammalienne, mais leur ou purite, leur grandeur et leur couleur n'est pas par tout égale. Ils en que sont grands, et de la plus pure chalcédoine, d'autres sont petits et chaque goutte ou mammalian contient un grain de sable, de façon que cela a l'air d'un gres cristallise en mammalians ou stalagmatiques. D'autres encore sont, de chalcédoine, mais recouverts d'une croûte, tantot blanche que fait effervescence avec l'acide minéral, et que est, par conséquent, de nature calcaire, tantot cette croûte est bleu et foncé nuancé de bleu céleste. Tantot, enfin, elle est noire, mais touts les du réfractaires. Outre ces cristallisations silicieuses Illinois YNA, quoique rarement, de quartzieuses, que ou forment de petites veins de cristal, ou bien de groupes de cristox quartzo, ou que enfin, induisent les mammalians de silex. Our author then makes a specification of the different varieties, after which he continues, page 69. Après tout ceci, elle en conviendra j'espère, que notre grès est un pierre bien singulière, et surpassant, à bien de égards, le grès, faussement dit cristallise, de Fontainebleau. La raison de la figure du grès François est fort évidente, c'est le spath calcaire, que lui sert de ciment, que la lui fit prendre, mais tu est que opère les métamorphoses racontises dans notre grès siliceux. Seroit son ciment calcaire ou marnou par les mêmes raisons, que font changer le marne en silex. Le chose est très probable, et j'en sorwa pas même, deviner d'autre. Nce casse la nature auroit un moyen d'opérer par la voie humide, que nous faisons dans nos laboratoires en quelque façon, par la voie sèche, de fondre et de liquéfier la terre vitressible, au moyen d'alcalis. Secret que nous lui avons déjà arraché en partie, en faisant la liqueur silicious. J'nos, cependant, décider pas même hypothétiquement, sur cette matière, pour en avoir pu observer la nature dans ses ateliers, et parce que j'en possède que de pieces, que détachées de leur lunatal, depuis un très long temps. Ferent exposés aux intempéries de saisons, ou elles peuvent avoir souffert bien de changements. There cannot be a more fair exposition of facts, and it is only our author's opinion of this mineral transmutation that I would controvert. I do not pretend to understand the manner of operating that our author here supposes nature to take. I only maintain, that here, as everywhere in general, the loose and incoherent strata of the globe have been petrified, that is, consolidated, by means of the fusion of their substances. And this I think is confirmed from the accurate description here given of the flinification of sandstone. Here is described very distinctly an appearance which is very common or general on those occasions. This is the parts or particles of stone floating in the fluid siliceous substance, and their dissolving more or less. M. De Carosi describes very systematically the generation of silex, chalcedony, onyx, and quartz, in calcareous earth, marl, gypsum, sandstone, and also what he terms terre glaise, eau de l'argile. It is in this last that we find a perfect analogy with what is so frequent in this country of Scotland. These are the agates, chalcedonies, calcareous and zeolite nodules, which are found produced in our whinstone or subterraneous lavas, that is, the amygdaloids of Kronstadt. Naturalists explain the formation of those nodular bodies differently. The Chevalier de Dolomieu supposes these rocks to have been erupted lavas, originally containing cavities. And that these cavities in the solid rock had been afterwards filled and crystallized, by means of infiltration, with the different substances which are found variously concreted and crystallized within the solid rocks. Our author, on the contrary, supposes these formed by a species of chemical transmutation of calcareous and argillaceous earths, which, if not altogether incomprehensible, is at least not in any degree, so far as I know, a thing to be understood. This is not the place where that subject of these particular rocks, which is extremely interesting, is to be examined. We shall afterwards have occasion to treat of that matter at large. It is sufficient here to observe, that our author finds occasion to generalize the formation of those petrifactions with the flinifications in calcareous and gypseous bodies. When, therefore, the formation of any of them shall be demonstrated, as having taken its origin in the fusion of those substances, this mode of operation, which is generalized in the consolidation of strata, will be properly inferred in all the rest. Petrifaction is a subject in which mineralogists have perhaps wandered more widely from the truth than in any other part of natural history, and the reason is plain. The mineral operations of nature lie in a part of the globe which is necessarily inaccessible to man, and where the powers of nature act under very different conditions from those which we find take place in the only situation where we can live. Naturalists, therefore, finding in stalactical incrustation a cause for the formation of stone, in many respects analogous to what is found in the strata of the earth, and which had come from the mineral region in a consolidated state, have, without due consideration, attributed to this cause all the appearances of petrifaction or mineral concretion. It has been one of the objects of this work to show that this operation of incrustation, or petrifaction by means of solution, is altogether ineffectual for producing mineral concretions. And that, even were it capable of forming those mineral bodies, yet that, in the solid parts of this earth, formed by a deposit of travelled materials at the bottom of the sea, the conditions necessary to this incrustating process do not take place. Those enlightened naturalists who have of late been employed in carefully examining the evidences of mineral operations, are often staggered in finding appearances inconsistent with the received doctrine of infiltration. They then have recourse to ingenious suppositions, in order to explain that enigma. In giving examples of this kind, I have in view both to represent the natural history these mineralists furnish us with, which is extremely interesting, and also to show the various shapes in which error will proceed. When ingenious men are obliged to reason without some necessary principle in their science. We have just now had an example in Europe, I will next present the reader with one from Asia. M. Patron, in his Notice Mineralogique de la Douarie, Journal de Physique, Mars 1791, gives us a very distinct account of what he met with in that region. Describing the country of Douchersk upon the river Argun, in Siberia, he proceeds thus. Ces collines sont formes d'un hornstein gris que pourrait se convertir en pierre calcaire par l'action de météores. Car tout celu quon prend or du contact de l'air dans les plus vives étincelles, et ne fait pas la moindre effervescence avec les acids, même après avoir été calcine. Et il en observe celu que est à découvert, passer, par nuances insensibles, jusqu'à l'état de pierre calcaire parfait de couleur blanchâtre. Here M. Patron has persuaded himself, probably from an imperfect examination of the subject, that there takes place a mineral metamorphosis, which certainly is not found in any other part of the earth, and for which he does not find any particular cause. The natural effect of the meteors, in other parts of the earth, is to dissolve the calcareous substance out of bodies exposed to those agents. And the gradation from the one of those two things to the other, which seems to be the data on which he had proceeded in forming his conclusion, is not sufficient to prove the metamorphosis, even were there not so strong a physical objection to it. For, it is by no means unusual for mineral bodies to graduate thus from one substance to another. However that be, this is not the principal object of the example 45. After speculating upon the effect of the ancient ocean upon the mountains of that country, he proceeds as follows. Les ces conjectures pour remarquer un fait singulier, la colline, que est au nord de l'église de la Fonderie. A son arique composé de ces hornstein que se décompose en pierre calcaire. Mais ici, les parties, que sont ainsi décomposées, offrent une substance calcédoneuse disposées par zones concentriques, comme on l'observe dans les agates d'Oberstein. Mais si ne sont point ici de corps parasites forms par infiltration dans de cavités préexistantes comme les agates. On voit que ce sont les parties constituants de la roche que, par un travail interne, et par une sorte de cristallisation, out pris cette disposition régulière, que mot de cristallisation any revolt point. J'appelle ainsi tout tendance à prendre un fermi constant, polyhedra ou non polyhedra. Les couches les plus voisines du centre sont nettes et distincts, puels le sont moins, et enfin elles s'évanouissent et confondent avec le fond de la roche. Chaque assemblage de ces zones à un fermi rond ou ovale plus ou moins régulière de 7 à 8 pouces de diamètre. Cela ressemble en grand à ce qu'on observe dans les pierres uriles, et la cause est vraisemblablement la même. Je le répète, je regarde cette disposition régulière comme une véritable cristallisation, que peut s'opérer et que s'opère en effet dans l'intérieur de corps les plus solides, tant qu'ils sont fournis à l'action de agents de la nature. Tout ce que visitant l'intérieur de la terre savant que les roches mêmes le plus compacts y sont intimement pénétrées d'humidité, et ce fluide n'est certainement pas l'eau pure. C'est l'agent que opère toutes les agrégations, toutes les cristallisations, tous les travaux de la nature dans le règne minéral. On peut donc aisément concevoir tuer la faveur de ce fluide Illinois règne, dans les parties les plus intimes de corps souterrains, en circulation que fait continuellement changer de place aux éléments de la matière. Jusqu'à ce que réunis par la force de affinité, les corpuscules similaires prenant la forme que la nature leur a assignée. Those nodular bodies or figured parts which are here enclosed in the rock, are evidently what may be called chalcedony agates. M. Patron is persuaded, from the examination of them, that they had not been formed in the manner of German agates, which he supposes is by mean of infiltration. And he has endeavored to conceive another manner of operating, still however by means of water, which I suppose, according to this hypothesis, is to dissolve substances in one part, and deposits them in another. There must certainly be some great desideratum in that mineral philosophy which is obliged to have recourse to such violent suppositions. First, water is not an universal solvent, as it would require to be, upon this supposition. Secondly, were water allowed to be an universal menstruum, here is to be established a circulation that does not naturally arise from the mixture of water and earth. And, lastly, were this circulation to be allowed, it would not explain the variety which is found in the consolidation and concretion of mineral bodies. So long, therefore, as we are to explain natural appearances by reasoning from known principles, and not by ascribing those effects to preternatural causes, we cannot allow of this regular operation which M. Patron alleges to be acting in the interior parts of the most solid bodies. This is indeed evident, that there has been a cause operating in the internal parts of the most solid bodies, a cause by which the elements, or constituent parts of those solid bodies, have been moved and regularly disposed. As this author very well observes must have been the case in our agates or eyed stones. But to ascribe to water this effect, or to employ either an ineffectual or an unknown cause, is not to reason philosophically with regard to the history of nature, it is to reason fantastically, and to imagine fable. M. Monet has imagined a petrifying power in water very different from any that has hitherto been conceived, I believe, by natural philosophers, and I also believe, altogether inconsistent with experience or matter of fact. But as it is not without good reason that this naturalist has been induced to look out for a petrifying cause different from any hitherto supposed, and as he has endeavored very properly to refute the systems of petrification hitherto received, I would beg leave to transcribe his reasoning upon the subject in corroboration of the present theory of consolidation by the means of fusion. It is upon occasion of describing one of the species of alpine stone or schistous which contains quartzy particles. Nouveau Voyage Minéralogique, etc. Journal de Physique et Aoust 1784. Ilya loin de cette pierre, que je regarde comme une variété de roches ardoises, aux véritable ardoises. La composition de tout ces pierres est du aux terres quartzieuses et argileuses, et à la terre talcose, que je démontrerai un jour être une espèce particulière et distincte de autres, que constituent les bonnes ardoises, et fait. Ainsi que le quartz, quels resistant aux injures de l'air, sans effluer, comme je ferai voir que cette terre, qu'on désignera sous la dénomination de terre talcose, sil en voûte, résiste aux grandes faux sans s'y fondre. Les differences de toutes ces pierres, quoique composées de mêmes matières, mais dans de proportions différentes, sont frappantes, et pourraient faire croire qu'elles n'appartiennent pas à ces genres. Mais qu'en voit ici que toutes ces différences, ou ces variétés, any sont dus aux modifications de la matière première, elle éprouvise, soit nse mêlant avec de matières hétérogènes, prévenantes du débris de êtres que ont existe. Comme l'argile, par exemple, que, de l'élevé de presque tous les naturalistes, est le produit de l'organisation de plantes, ou soit nse mêlant avec de la matière déjà solidifiée depuis longtemps. Or nous any craniens pas de dire, que nous avons dit plusieurs fois quand l'occasion s'en est présentée, que cette matière unique, que se modifie selon les occasions et les circonstances. Et que prend un caractère analogue aux matières qu'elle rencontre, est lo, que beaucoup de naturalistes cherchent vainement leurs. Ils ne peuvent comprendre, malgré les exemples frappants que pourraient les porter à adopter cette opinion, que ce fluide général soit l'élément de corps solides du règne minéral, comme il est de ceux du règne végétal et du règne animal. L'on cherche sérieusement, par de expériences chimiques, à découvrir si l'eau est susceptible de se convertir en terre comme si la nature n'avait pas d'autre moyen que nous de la faire passer de l'état fluide à l'état solide. Voyez le spath calcaire et le quartz transparens, est il à présumer qu'ils ne sont que le résultat du dépôt de matières terreuses faites par les eaux. Mais, dans cela encore Illinois faut supposer que l'eau que est restée entre ces parties est solidifiée, car, qu'est-elle donc devenue, et quel est donc le lien que réunit ces parties et leur a fait prendre une forme régulière. Il est vrai qu'on nous parle d'un suc lapidifique, mais si est là un être de raison, dont il serait bien plus difficile d'établir l'existence, que de croire à la solidification de l'eau. On nous donne cependant comme un principe certain que l'eau cherry donne lieu à un autre les matières qu'elle a dissouts, et qu'elle les dépose à la manière de celles. Mais c'est supposer une chose démentie par l'expérience. Savoir, que lo 8 la propriété de dissoudre les matters terra uses, tels que la quartzos. A la vérité, Orchard de Berlin y joint de l'er fixe, mais cet fixe ni soroit tenor en dissolution un atome de quartz dans l'eau. Et calcuate l'exactitude de ce que ont repeat les expériences de Orchard, en napu réussir à imiter la nature, si est dire, former de Christox quartzo, comme il annonce. Que lo 8 la faculté de tenor en dissolution quelques petites parties de terre calcaire, au moyen de cet fixe, Illinois n'en faut pas conclure qu'elle puisse former de cette manière tous les Christox calcaires. Sans que lo elmime y concourt pour essa part. Car ce seroit conclure quelquefois que la partie seroit égale au tout. Voyez ces geodes calcaire et argileuses, que renferment de Christox nombreux de quartz au de spath calcaire. Any sont ils que le résultat du dépôt de l'eau que y a été renfermé, au que la cristallisation pure et simple de molécules que vous supposez avoir été tenues en dissolution par cette eau. Il n'étroit de cette opinion un foulée d'objections qu'il seroit impossible de résoudre. Cependant Geddard, dans la minéralogie du Dauphiné, que vint de Perreuter, ouvrage très estimable à beaucoup d'égards, explique, selon cette manière de penser, la formation de cristallisations quartzieuses qu'on trouve dans certains geodes de cette province. Et celle de mines de cristal de hautes montagnes. En supposant même comme vrai l'explication qu'il en donne, on trouverait en cela un de plus grands problèmes, et de plus difficiles à résoudre qu'il y ait en minéralogie. Car d'abord il faudrait expliquer comment un si petite quantité d'eau que celle que a été renfermée dans les geodes, et celle que est parvenue dans les fentes de rochers. Ont pu fournir un si grande quantité de matière que celle que constitue ces cristallisations, et ce que n'est pas le moins difficile à concevoir, comment l'eau a pu charrier cette matière à travers tant de matters différents. Et la conserver précisément pour cette destination. Comment, par exemple, l'eau est venue déposer de la terre quartzeuse dans les masses énormes de pierres calcaires, que forment la côte que domine le village de Champigny, à 4 lieues de Paris, au-delà de Saint-Maur. Car il nous faut citer un exemple frappant de cette singularité, et à partir d'être vu de naturalistes que sont dans la capitale, je ne pousse mieux faire que de citer cette côte, un de plus curieuses de la France. Et que je me propose de faire connaître en détail dans la troisième partie de la minéralogie de la France. On verra, dis je, dans cette bonne pierre à chaud, et un de plus pure de environs de Paris, de très abondantes cristallisations de quartz transparent, et quelquefois de belle eau, que les ouvriers sont forces de séparer de la partie calcaire. À laquelle elles adhèrent fortement. Mais c'est trop nous erreur à combattre une opinion que doit son origine aux premières idées qu'ont eus les premiers observateurs en minéralogie, que essaient de détruire d'elles-mêmes comme tant d'autres dont il nous reste à peine le souvenir. We find here an accurate naturalist, and a diligent observer, who, in conformity with what my sentiments are upon the subject, thinks it impossible that the crystallizations in close cavities and concretions of different solid substances within each other, which so frequently occur in the mineral regions, could have been produced, by means of solution and crystallization, from a fluid vehicle. But what has he now substituted in place of this solution, in order to explain appearances? A mere supposition, viz. That nature may have the power of converting water, in those secret places, into some other thing. Or rather that the substance of water is here converted into every other thing, for, though he has only mentioned quartz and calcareous spar, what mineral substance is there that may not be found in those close cavities? They are actually almost all, not even excepting gold, for small grains of gold are enclosed within the cavities of a porous stone, in the Siberian mine. Now, for what purpose should nature, to the power of which we are not to set a limit, have such an object in view as to convert water into everything, unless it were to confound human understanding? For, so far as human experience has been as yet able to reach, there would appear to be certain elementary substances, and among these is water, or the principles of that fluid 46. But because water is so generally found in bodies, and so necessarily in most of the operations of this world, why convert it into every other thing? Surely, for no better reason than that there has not occurred to this mineralist any other way of explaining certain natural appearances which aqueous solution could not produce. Here is no dispute about a matter of fact. It is on all hands allowed, that in certain cavities, inaccessible to anything but heat and cold, we find mineral concretions, which contain no water, and which, according to the known operations of nature, water could not have produced. Must we therefore have recourse to water acting according to no known principle, that is to say, are we to explain nature by a preternatural cause? I dare say that this is not the view that M. Monet takes of the subject, when he thinks to explain to himself the concretion of those different substances by means of water. But, according to my apprehension of the matter, his theory, when sifted to the bottom, will bear no other construction. And, unless he shall consider water like the matter of heat, as capable of producing the fluidity of fusion, and of being also again abstracted from the fluid, by pervading the most solid body, which would then be a substance different from water, he must employ this aqueous substance as a menstruum or solvent for solid bodies, in the same manner as has been done by those naturalists whom he justly censure, and conform to those erroneous ideas which first observations, or inaccurate knowledge of minerals, may have suggested to former naturalists. It is the dissolution and concretion of siliceous substance, no doubt, that gives such difficulty to our naturalists in explaining petrifaction. They have, however, something apparently in their favor, which it may be proper now to mention. In the first place, although siliceous substance is not soluble, so far as we know, by simple water, it is soluble by means of alkaline substance, consequently, it is possible that it may be dissolved in the earth. Secondly, the water of geyser in Iceland, actually petrifies bodies which are alternately imbibed with that hot water and exposed to the air. This water, therefore, not only contains siliceous substance in a dissolved state, but deposits this again, either by means of cooling, or being aerated, or of evaporating. Consequently, without knowing the principle upon which it proceeds, we here perceive a natural operation by which siliceous petrifaction may be performed. Lastly, we have another principle for the dissolution of siliceous substance. This is the fluor acid which volatilizes the siliceous substance. This, however, requires certain conditions, which cannot be found as a general cause in the mineral regions. Thus we would seem to have everything necessary for explaining the concretion and crystallization of siliceous bodies, provided we could find the proper conditions requisite for that operation. For whether it shall be by means of acid or alkaline substances that siliceous matter is to be dissolved, volatilized, and transported from one place to another, it is necessary that those dissolving substances should be present upon those occasions. Nor is it sufficient only to dissolve the siliceous substance which is to be transported, the necessary conditions for the concretion again of the dissolved substances, whatever these may be, are also absolutely required for this operation. Now, though those requisite conditions may be, upon many occasions, allowed in the earth, it is not according to the theory of our modern naturalists, who explain petrifaction upon the principles of simple infiltration of water, that any advantage can be taken of those conditions. Nor are natural appearances to be explained without employing more complicated chemical agents in the mineral regions. To this subject of the petrifactions of geyser, I may now add the information which we have received in consequence of a new voyage from this country to Iceland. When Sir Joseph Banks returned from his expedition to Iceland, he landed at this place, and, having brought specimens of the petrifications of geyser, Dr. Black and I first discovered that these were of a siliceous substance. I have always conjectured that the water of geyser must be impregnated with flinty matter by means of an alkaline substance, and so expressed my opinion in the theory of the earth published in the Transactions of the Edinburgh Royal Society. We have therefore been very desirous of procuring some of that water, in order to have it analyzed. An opportunity favorable to our views has occurred this summer. Mr. Stanley set out from this place with the same purpose of examining Iceland. He was so good as to ask of Dr. Black and I what inquiries we would incline that he should make. We have now, by the favour of this gentleman, obtained specimens of the petrifactions of Geyser. And, what is still more interesting, we have procured some of the water of those petrifying boiling springs. It appears from these specimens, that the boiling water which is ejected from those aqueous volcanoes, if we may use the expression, is endued with the quality of forming two different species of petrifaction or incrustation. For, besides the siliceous bodies, of which we had before received specimens, the same stream of water incrustates its channel with a calcareous substance. All the specimens which I have seen consist of incrustation, some purely siliceous, some calcareous, and others mixed of those two, more or less. Dr. Black has been analyzing the water. And he finds in it siliceous matter dissolved by an alkaline substance, in the manner of liquor silicum 47. My conjecture has thus been verified. It must not be alleged that nature may operate in the mineral regions, as she does here upon the surface in the case of Geyser. Such an argument as this, however sound it may be in general, will not apply to the subject of which we treat at present. There is no question about the limiting the powers of nature. We are only considering nature as operating in a certain determined manner, viz. by water acting simply upon the loose materials of the land deposited at the bottom of the sea, and accumulated in regular strata, one upon another, to the most enormous depth or thickness. This is the situation and condition of things in which nature is to operate. And we are to find the means of consolidating those strata, and concreting every species of substance in almost every possible composition, according to some known physical principle. Here is an operation which is limited. For, we must reason strictly, according to the laws of nature, in the case which we have under consideration, and we cannot suppose nature as ever transgressing those laws. It is acknowledged, that, by means sometimes of an aeriform, sometimes of an alkaline, perhaps also of an acid substance, calcareous matter is dissolved in the earth, and certain metallic substances, such as lead and iron. This solution also, upon particular occasions, where the proper conditions for separating the solvent from the dissolved substance exist, forms certain concretions. These are sometimes a mere incrustation, as in the case of the siliceous incrustation of Geyser, sometimes again in a crystallized or sperry form, as in the case of stalactical concretions. But here is no question of those cases where the proper conditions may be found, first, of dissolving the substance which is afterwards to be concreted, secondly, of separating the menstruum from the dissolved substance. And, lastly, of removing the fluid deprived of its solution, and of supplying a new solution in its room. The question is, how far those concretions are formed where those conditions do not take place. Now, this last case is that of almost all mineral concretions. It must not be here alleged that certain concretions have been found in mines posterior to these having been worked by man. Consequently, that those concretions have been formed by nothing but the infiltration of water. In those cases, where such concretions are truly found, I am persuaded that all the conditions proper to that operation will also be found. And it is only, I believe, in those cases where such proper conditions may be found, that this aqueous concretion ever appears. Now, if we shall accept calcareous stalactite, and the bog ore of iron, how seldom is it that any appearance of those aqueous mineral concretion ever is found? Those very few cases in which they are found, afford the strongest proof against these being operations general to the globe, or proper mineral concretions. Because it is only where all the necessary conditions conspire in each contributing its part, that the effect is accomplished, and this is a thing which cannot possibly take place in the aquiform strata below the surface of the sea. But, without attending to this clear distinction of things perfectly different, naturalists are apt to see false analogies, and thus in generalizing to form the most erroneous theories. I shall now give an example of this fallacious manner of reasoning. It is in the case of certain mineral appearances which are erroneously considered as stalactical concretions. The only true stalactical bodies are of a calcareous substance. They are formed by water containing this substance in a dissolved state, and the principles upon which this particular concretion is formed are well known. It is therefore easy to compare other concretions, which may have some superficial resemblance to these stalactical bodies, in order to see if they have proceeded upon the same principle of concretion from a dissolved state, or by water depositing its dissolved substance in a similar manner. There are two different mineral substances which give appearances of this sort. These are certain concretions of chalcedony, and also of iron ore, which are thought to have such resemblance to stalactical concretions as, by some superficial observers, to be reckoned of the same kind. It is now proposed to show that those conclusions are not well founded, and that, in this case of chalcedony and iron ore, it could not be upon the principle of stalactical concretion that the bodies now in question had their forms. The principle upon which calcareous substance is dissolved in water, and made to concrete by the evaporation of the acid substance, or fixed air by which it had been dissolved, is too well known to require any explanation in this place. We are only to consider the sensible effects of those operations of which we know so well the proper conditions. There are just two distinct views under which we may consider all stalactical concretions formed. These are the incrustation of the calcareous substance concreting upon a foreign body, and the incrustation of the same substance upon itself. By the first any manner of shape may be formed, provided there be a solid body, upon the surface of which the calcareous solution is made to pass. By the second, again, we have various forms, but we know the principles upon which they had been made. These are the shape and motions of the fluid which gives the calcareous concretion. Now, these principles are always to be perceived, more or less, in all the bizarre or fantastical, as well as regular shapes which are produced by stalactical concretions. At present, we shall confine our views to one particular shape, which is simple, regular, and perfectly understood wherever it is formed. Drops of water falling from a roof, and forming stalactite, produce first tubular bodies, and then gradually consolidate and increase those pendulous bodies by incrustation. These appearances are thought to be observed in the chalcedony and ferruginous concretions, which has led some mineralists to conclude that those concretions had been formed in the same manner, by means of water. We are now to show that these mineral appearances are not analogous to stalactites in their formation, and that they have evidently been formed in a different manner. It must be evident that, in the formation of those pendulous bodies, each distinct stalactite must be formed by a separate drop of water. Consequently, that no more stalactites can be formed in a given space, than there could have subsisted separate drops of water. Now, a drop of water is a very determined thing. And thus we have a principle by which to judge of those mistaken appearances. Let us suppose the gut of water to be but 1/8 of an inch, although it is a great deal more, we should have no stalactites formed nearer to each other than that measure of space. But those mineral concretions, which are supposed to be stalactical, are contained in half that space, or are nearer to each other than the 10th or 20th of an inch. I have them like needles, and in every degree of proximity or contiguity, at the same time that they are perfectly solid. Therefore, it is plainly impossible that they could have been formed upon this principle of calcareous stalactite. But it is only by this false resemblance, that any argument can be formed for the concretion of those bodies from an aqueous solution. In every other respect they are true mineral concretions. And, that these have had a very different origin, has been already the subject of investigation, and will be more particularly examined in the course of this work. The term infiltration, which has been much employed for explaining mineral appearances, is too vague, imperfect, or unexplicit, for science, whether as the means of knowing nature, or the subject of confutation. This is not the case with that of stalactite. Here is a term that implies a certain natural operation, or a most distinct process for attaining a certain end. And we know the principles upon which it proceeds, as well as the several steps that may be traced in the general result. It is an operation which has not only been analyzed to its principles. It is also a process which is performed by man, proceeding on his acquired knowledge. Now, were this operation common to the mineral regions, as it is proper to the surface of this earth, we could not remain in any degree of suspense with regard to the origin of those mineral bodies, for, having the true clue of knowledge, we should be able to unravel the most intricate and mysterious appearance. But, so far from this being the case, the more we come to inquire into nature, and employ this principle, the less we find it applicable, and the more involved in darkness is our science. The places where these false appearances of stalactite are found, are precisely those in which, from the nature of things, all possibility for such an operation is excluded. For, how can this take place within a close cavity in the mineral regions? The term vegetation may as well be employed for the explanation of those appearances, but what would now be said of such an explication? It is high time that science were properly applied to the natural history of this earth, and mineralists not allowed to impose upon themselves with false reasoning, or to please themselves with the vain attempt of explaining visible effects by unknown causes. Such various inconsistent opinions, respecting petrifaction or mineral concretion, as I have now exposed, opinions that are not founded on any sound physical principle, authorize me to conclude that they are all erroneous. If this be admitted, it will follow that we have no proof of any proper mineral concretion except that which had proceeded by congelation from the fluid state of fusion. This has been the doctrine which I have held out in my theory of the earth. And this will be more and more confirmed as we come to examine particular mineral appearances. Chapter 8. The nature of mineral coal, and the formation of bituminous strata, investigated. Section 1. Purpose of this inquiry. In the first chapter, I have given a perfect mark by which to judge, of every consolidated stratum, how far that had been the operation or effect of water alone, or if it had been that of heat and fusion. This is the particular veins or divisions of the consolidated stratum, arising from the contraction of the mass, distended by heat and contracted in cooling. It is not an argument of greater or lesser probability, it is a physical demonstration. But, so far as I see, it would appear to be for most mineralists an unintelligible proposition. Time, however, will open the eyes of men, science will some day find admittance into the cabinet of the curious. I will therefore now give another proof, not of the consolidation of mineral bodies by means of fusion, for there is no mineral body in which that proof is not found, but of the inconsistency of aqueous infiltration with the appearances of bodies. Where not only fusion had been employed for the consolidation, but where the application of heat is necessary, and along with it the circumstances proper for distillation. Short-sighted naturalists see springs of water issuing from the earth, one forming calcareous incrustations, the other depositing bituminous substances. Here is enough for them to make the theory of a world. On the one hand, solid marble is explained, on the other, solid coal. Ignorant suspects not error, their first step is to reason upon a false principle. No matter, were they only to reason far enough, they would soon find their error by the absurdity into which it lands them. The misfortune is, they reason no farther, they have explained mineralogy by infiltration. And they content themselves with viewing the beautiful specimens in their cabinet. The supposed product of solution and crystallization. How shall we inform such observators, how reason with those who attend not to an argument? As naturalists have explained all mineral concretions from aqueous or other solution, and attributed to infiltration the formation of those stony bodies in which there are marks of their original composition, so have they explained to themselves, I suppose, the origin of those bituminous bodies which are found among the strata of the earth. In the case of stony substances, I have shown how unfounded all their theories are for the production of those concretions, crystallizations, and consolidated bodies. I am here to examine the subject of inflammable and combustible bodies, which I believe have been little considered by those theorists who suppose mineral bodies consolidated by infiltration. It is here that we shall find an infinite difference between the aqueous and igneous theories. For, we shall find it impossible to explain by the one certain operations which must have necessarily required the great agent generally employed in the other. The subject of this chapter is a touchstone for every theory of the earth. In every quarter of this globe, perhaps in every extensive country, bituminous strata are to be found. They are alternated with those which are called aquiform, or which have been evidently formed by subsidence of certain moved materials at the bottom of the sea, so far, therefore, all those strata have had the same origin. In this point I think I may assert, that all the different theories at present are agreed, and it is only concerning certain transformations of those strata, since their original collection, that have been ascribed to different causes. Of these transformations, which the strata must have undergone, there are two kinds, one in relation to change of place and position, the other in relation to solidity or consistence. It is only the last of those two changes which is here to be the subject of consideration, because, with regard to the first, there is nothing peculiar in these bituminous strata to throw any light, in that respect, upon the others. This is not the case with regard to the transformation in their chemical character and consistence. Bituminous bodies may not be affected by chemical agents, such as fire and water, in the same manner as the argillaceous, siliceous, micaceous, and such other strata that are alternated with the bituminous. And thus we may find the means for investigating the nature of that agent by which those strata in general have been transformed in their substance. Or we may find means for the detecting of false theories which may have been formed with regard to those operations in which the original deposits of water had been changed. We have had but two theories, with regard to the transformation of those bodies which have had a known origin, or to the change of their substance and consistence. The one of these which I have given is that of heat or fusion. The other, which I wish to be compared with mine, is that of water and infiltration. It is by this last that all authors hitherto, in one shape or another, have endeavored to explain the changes that those strata must have undergone since the time of their first formation at the bottom of the sea. They indiscriminately apply the doctrine of infiltration to those strata of mineral coal as to any other. They say that bituminous matter is infiltrated with the water, impregnates certain strata of earth with bituminous matter, and thus converts them into mineral coal, and bituminous strata. This is not reasoning physically, or by the inductive method of proceeding upon matter of fact, it is reasoning fantastically, or by making gratuitous supposition founded merely on imagination. It was thus that natural philosophers reasoned before the age of science. The wonder now is, how men of science, in the present enlightened age, should suffer such language of ignorance and credulity to pass uncensured. The subject which I am now to treat of consists of peculiar strata of the earth, bodies which we may investigate through all the stages of their change, which is extreme. For, from vegetable bodies produced upon the habitable earth, they are now become a mineral body, and the most perfect coal, a thing extremely different from what it had been. And a thing which cannot be supposed to have been accomplished by the operation of water alone, or any other agent in nature with which we are acquainted, except the action of fire or heat. It is therefore impossible for a philosopher, reasoning upon actual physical principles, not to acknowledge in this a complete proof of the theory which has been given, and a complete refutation of that aqueous operation which has been so inconsiderately supposed as consolidating the strata of the earth, and forming the various mineral concretions which are found in that great body. To see this, it will be sufficient to trace the progress of vegetable and animal substances, bodies which had certainly lived by means of a former earth, to this changed state in which they have become perfect mineral bodies, and constitute a part of the present earth. For, as these changes are perfectly explained by the one theory, and absolutely inconsistent with the other, there arises from this a conviction that must be irresistible to a person who can give proper attention to a chain of reasoning from effect to cause. But if we thus succeed to illustrate the theory of the earth by the natural history of those particular strata, we have but one step farther to make in order to bring all the other parts of the earth, whether stratified or not, into the most perfect consistence with the theory. Now this step, it will be most easy to make. And I shall now mention it, that so the reader may keep it in his view. Pyrites is a sulfurio-metallic substance, which cannot be produced by means of water. A substance which the influences of the atmosphere decomposes or separates into its elements, and which even our imperfect art may be considered as able to produce, by means of fusion in our fires. Therefore, the finding of this creature of fire intimately connected with those consolidated strata of mineral coal, adds the greatest confirmation, were it necessary, to the doctrine of those mineral bodies having been consolidated by fusion. This confirmation, however, is not necessary, and it is not the only thing which I am at present to illustrate in that doctrine. What I have now in view is, to homologate the origin of those coal strata, with the production of every other mineral substance, by heat or fusion, and this is what the intimate connection of parietes with those strata will certainly accomplish. This will be done in the following manner. Parietes is not only found in great masses along with the coal strata. It is contained in the veins which traverse those strata, and in the minute ramifications of those veins, which are occasioned by the contraction of the mass, and generally divided into small cubical pieces. But besides that extrinsic connection, as it may be called, with the stratum of coal, parietes is found intimately connected with that solid body, in being mixed with its substance. If, therefore, it were proved, that either the one or other of those two substances had been consolidated by fusion, the other must be acknowledged as having had the same origin. But now I am to prove, from the natural history of mineral coal, that parietes had been there formed by fusion. And then, by means of the known origin of that sulfurio-metallic substance, we shall extend our knowledge to the origin of every other mineral body. The process of this argument is as follows: every mineral body, I believe, without exception, will be found so intimately connected with parietes, that these two things must be concluded as having been together in a fluid state, and that whatever may have been the cause of fluidity in the one, this must have also caused the fluidity in the other. Consequently, whatever shall be proved with regard to the mineral operations of parietes, must be considered as proved of every other mineral substance. But, from the connection of parietes with mineral coal, it is to be proved that the origin of this metallic body had been fusion. And then it will appear, that all other mineral bodies must have been more or less in fusion, or that they must have been consolidated by means of heat, and not by any manner of solution or aqueous infiltration. I therefore now proceed to take a view of the natural history of coal strata, a subject which mineralogists seem not inclined to engage with, although the most ample data are to be found for that investigation. Section 2. Natural history of coal strata, and theory of this geological operation. Fossil coal is the species of stratum best understood with regard to its accidents, as being much sought after. At least, this is the case in many parts of Britain, where it supplies the place of wood for burning. This fossil body has the most distinguished character. For, being inflammable or combustible in its nature, there is no other species of stratum that may be confounded with it. But, though coal be thus the most distinguishable mineral, and that which is best understood in the science of mining, it is perhaps the most difficult to be treated of in the science of mineralogy. For, not having properly any distinguishable parts, we have nothing in the natural constitution of this body, as we have in most other strata, to lead us to the knowledge of its original state or first formation. The varieties of coal are distinguished by their different manner of burning, but, from appearances of this kind, no perfect judgment can be formed with regard to the specific manner in which those strata had been made. Although, from chemical principles, some conclusion may be drawn concerning certain changes which they have undergone since they had been formed. Thus we have one species of coal which is extremely fusible, abounds with oil, and consequently is inflammable. We have another species again which is perfectly fixed and infusible in the fire. Therefore, we may conclude upon principle, that, however, both those coals must have undergone the operation of heat and fusion, in bringing them to their present state. It is only the last that has become so much evaporated as to become perfectly fixed, or so perfectly distilled, as to have been reduced to a caput mortuum. The argument here employed is founded upon this fact. That, from the fusible species of coal, a caput mortuum may be formed by distillation, and that this chemical production has every essential quality, or every peculiar property, of the fixed and infusible species. Although, from the circumstances of our operation, this caput mortuum may not have precisely the exterior appearance of the natural coal. But, we have reason to believe, it is not in the nature of things to change the infusible species, so as to make it fusible or oily. Now, that this body was not formed originally in its present state, must appear from this, that the stratum here considered is perfectly solid, but, without fusion, this could not have been attained, and the coal is now supposed to be infusible. Consequently, this fixed substance, which is now, properly speaking, a perfect coal, had been originally an oily bituminous or fusible substance. It is now a fixed substance, and an infusible coal. Therefore, it must have been by means of heat and distillation that it had been changed, from the original state in which this stratum had been formed. We have thus, in the examination of coal strata upon chemical principles, received a certain lesson in geology, although this does not form a proper distinction by which to specify those strata in general, or explain the variety of that mineral. For, in this manner, we could only distinguish properly two species of those strata, the one bituminous or inflammable, the other proper coal, burning without smoke or flame. Thus it will appear that, as this quality of being perfectly charred is not originally in the constitution of the stratum, but an accident to which some strata of every species may have been subjected, we could not class them by this property without confounding together strata which had differences in their composition or formation. Therefore, we are led to inquire after some other distinction, which may be general to strata of fossil coal, independent of those changes which this substance may have undergone after it had been formed in a stratum. Perfect mineral coal being a body of undistinguishable parts, it is only in its resolution that we may analyze it, and this is done by burning. Thus, in analyzing coal by burning, we have, in the ashes alone, that by which one species of coal may be distinguished from another. And, if we should consider pure coal as having no ashes of itself, we should then, in the weight of its ashes, have a measure of the purity of the coal, this being inversely as the quantity of the ashes. Now, though this be not accurately true, as the purest coal must have some ashes proper to itself, yet, as this is a small matter compared with the quantity of earthy matter that may be left in burning some species of coal, this method of analysis may be considered as not far removed from the truth. But, in distinguishing fossil coal by this species of chemical analysis, not only is there to be found a perfect or indefinite gradation from a body which is perfectly combustible to one that is hardly combustible in any sensible degree. We should also fall into an inconveniency similar to that already mentioned, of confounding two things extremely different in their nature, a bituminous body, and a perfect charcoal. Thus, if we shall found our distinction upon the fusibility in different degree of having been charred, we shall confound fossil coals of very different degrees of value in burning, or of very different compositions as strata. If, again, we found it upon the purity of composition, in judging from the ashes, we shall confound fossil bodies of very different qualities, the one burning with much smoke and flame, the other without any. The one fusible almost like wax, the other fixed and infusible as charcoal. It will now appear, that what cannot be done in either the one or other of those two methods, may in a great degree, or with considerable propriety, be performed in employing both. Thus, whether for the economical purposes of life, or the natural history of fossil coal, those strata should be considered both with regard to the purity of their composition as inflammable matter deposited at the bottom of the sea, and to the changes which they have afterwards undergone by the operation of subterranean heat and distillation. We have now considered the original matter of which coal strata are composed to be of two kinds, the one pure bitumen or coal, as being perfectly inflammable or combustible. The other an earthy matter, with which proper coal may be variously mixed in its composition, or intimately connected, in subsiding from that suspended state by which it had been carried in the ocean. It is a matter of great importance, in the physiology of this globe, to know that the proper substance of coal may be thus mixed with heterogeneous bodies. For, supposing that this earthy matter, which has subsided in the water along with coal, be no farther connected with the combustible substance of those strata, than that it had floated in the waters of the ocean, and subsided pari passu with the proper materials of the coal, we hence learn a great deal with regard to the state in which the inflammable matter must have been at the time of its formation into strata. This will appear by considering, that we find schistus mixed with coal in the most equal or uniform manner, and in almost every conceivable degree, from the purest coal to the most perfect schistus. Hence we have reason to conclude, that, at the formation of those strata, the bituminous matter, highly subtilized, had been uniformly mixed with the earth subsiding in the water. Not only is the bituminous matter of coal found mixed in every different proportion with the earthy or uninflammable materials of strata, but the coaly or bituminous composition is found with perhaps every different species of substance belonging to strata. This is certain, that we have the coaly matter intimately mixed with argillaceous and with calcareous strata. Thus it will appear, that it is no proper explanation of the formation of coal strata, to say that vegetable matter is the basis of those strata. For though, in vegetation, a substance proper for the formation of bituminous matter is produced, it remains to know by what means, from a vegetable body, this bituminous matter is produced. And how it comes to be diffused in that subtle state by which it may be uniformly mixed with the most impalpable earth in water. Could we once resolve this question, every other appearance might be easily explained. Let us therefore now endeavor to discover a principle for the resolving of this problem. There are two ways in which vegetable bodies may be, in part at least, resolved into that subtilized state of bituminous matter after which we inquire. The one of these is by means of fire, the other by water. We shall now consider these severally as the means of forming bituminous strata, although they may be both employed by nature in this work. When vegetable bodies are made to burn, there is always more or less of a fuliginous substance formed. But this fuliginous substance is no other than a bituminous body in that subtilized state in which it is indefinitely divided, and may be mixed uniformly with any mass of matter equally subtilized with itself. But this is precisely what we want, in order to compose the strata of coal in question. If, therefore, there were to be found in the ocean such a fund of this fuliginous substance as might suffice for the formation of bituminous strata, no difficulty would be left in explaining the original of fossil coal. But though sufficient quantity of this fuliginous matter might not be found for the explanation of natural appearances, yet there cannot be a doubt that more or less of this matter must be produced in the mineral operations of the globe, and be found precisely in that place where it is required for the forming of those strata of coal. In order to conceive this, we are to consider, that there are actually great quantities of coal strata in a charred state, which indicates that all their more volatile oleaginous or fuliginous matter had been separated by force of subterranean heat. And, we are to suppose that this had been transacted at the bottom of the ocean, consequently, a subtle oleaginous, bituminous, or fuliginous substance, must have been diffused in that ocean. And this bituminous matter would be employed in forming other strata, which were then deposited at the bottom of the waters. But besides this quantity of bituminous matter which is necessarily formed in the mineral operations of the earth, and with regard to the quantity of which we can never form a proper estimate, there must enter into this same calculation all the fuliginous matter that is formed in burning bodies upon the surface of this earth. This bituminous matter of smoke is first delivered into the atmosphere, but ultimately it must be settled at the bottom of the sea. Hence though, compared with the quantity that we think required, each revolution of the globe produces but a little in our estimation, yet the progress of time, in reforming worlds, may produce all that is necessary in the formation of our strata. There now remains to explain the other way in which bituminous matter may be obtained from vegetable bodies, that is, by means of water. For this purpose we must begin with a part of natural history that will throw some light upon the subject. All the rivers in Scotland run into the sea tinged with a brown substance. This is most evident in some of them after a flood, and while yet the river is swelled. But, in travelling to the north of Scotland in the summer season, without any rain, I saw all the rivers, without exception, of a brown colour, compared with a river of more clear water. This colour proceeds from the moss water, as it is called, which runs into the rivers, or the infusion of that vegetable substance which forms combustible turf, called peat. Now, this moss water leaves, upon evaporation, a bituminous substance, which very much resembles fossil coal. Therefore, in order to employ this vegetable infusion, delivered into the ocean for the purpose of forming bituminous strata at its bottom, it is only required to make this bituminous matter separate and subside. If now we consider the immense quantity of inflammable vegetable substance, dissolved in water, that is carried into the sea by all the rivers of the earth, and the indefinite space of time during which those rivers have been pouring in that oily matter into the sea, and if we consider, that the continual action of the sun and atmosphere upon this oily substance tends, by inspissation, to make it more and more dense or bituminous, we cannot hesitate in supposing a continual separation of this bituminous matter or inspissated oil from the water, and a precipitation of it to the bottom of the sea. This argument is corroborated by considering, that, if it were otherwise, the water of the sea must have, during the immense time that rivers are proved to have run, be strongly impregnated with that oily or bituminous substance. But this does not appear, therefore we are to conclude, that there must be the means of separating that substance from the water in which it had been dissolved. If there is thus, from the continual perishing of animal and vegetable bodies upon the surface of this earth and in the sea, a certain supply of oily or bituminous matter given to the ocean, then, however small a portion of this shall be supposed the whole oily or inflammable matter produced upon the surface of the earth, or however long time it may require for thus producing a stratum or considerable body of coal, we must still see in this a source of the materials proper for the production of that species of strata in the bottom of the sea. We have now considered the proper materials of which pure fossil coal is chiefly formed. We have at present to consider what should be the appearances of such a substance as this collected at the bottom of the sea, and condensed or consolidated by compression and by heat. We should thus have a body of a most uniform structure, black, breaking with a polished surface, and more or less fusible in the fire, or burning with more or less smoke and flame, in proportion as it should be distilled or inspissated. Less or more, by subterranean heat. But this is the description of our purest fossil coals, which burn in giving the greatest quantity of heat, and leave the smallest quantity of ashes. In order to form another regular species of coal, let us suppose that, along with the bituminous substance now considered, there shall be floating in the water of the ocean a subtle earthy substance. And that these two different substances shall subside together in an uniform manner, to produce a stratum which shall be covered with immense weight, compressed, condensed, and consolidated as before. We should thus have produced a most homogeneous or uniform body to appearance, but not so in reality. The mixture of heterogeneous matter, in this case, is too minute to be discovered simply by inspection. It must require deep reflection upon the subject, with the help of chemical analysis, to understand the constitution of this body, and judge of all the circumstances or particulars in which it differs from the former. It is worth while to examine this subject with some attention, as it will give the most instructive view of the composition of bituminous strata, both those which are not considered as coal, and also the different species of that mineral body. In the first place then, if the mixture of those two different substances had been sufficiently perfect, and the precipitation uniform, the solid body of coal resulting from this mixture, would not only appear homogeneous, but might break equally or regularly in all directions. But the fracture of this coal must visibly differ from the former, so far as the fracture of this heterogeneous coal cannot have the polished surface of the pure bituminous body. For, the earthy matter that is interposed among the bituminous particles must affect the fracture in preventing its surface from being perfectly smooth. This imperfect plane of the fracture may be improved by polishing. In which case the body might be sufficiently smooth to have an agreeable polish, but it cannot have a perfect polish like a homogeneous body, or appear with that glassy surface which is naturally in the fracture of the pure bituminous coal. But this is also a perfect description of that species of coal which is called in England kennel coal, and in Scotland parrot coal. It is so uniform in its substance that it is capable of being formed on the turning loom. And it receives a certain degree of polish, resembling bodies of jet. Thus, we have a species of coal in which we shall find but a small degree of fusibility, although it may not be charred in any degree. Such an infusible coal may therefore contain a great deal of aqueous substance, and volatile oily matter, consequently may burn with smoke and flame. But this same species of coal may also occasionally be charred more or less by the operation of subterranean heat. And, in that case, we should have a variety of coal which could only be distinguished, from a similar state of pure bituminous coal, by the ashes which they leave in burning. At least, this must be the case, when both species are, by sufficient distillation, reduced to the state of what may be properly termed a chemical coal. But in the natural state of its composition, we find those strata of kennel or parrot coal, possessing a peculiar property, which deserves to be considered, as still throwing more light upon the subject. We have been representing these strata of coal as homogeneous to appearance, and as breaking indifferently in all directions. This last, perhaps, is not so accurate. For they would seem to break chiefly into two directions, that is, either parallel or perpendicular to the bed. Thus we have this coal commonly in rectangular pieces, in which it is extremely difficult to distinguish the direction of the bed, or stratification of the mass. By an expert eye, however, this may be in general, or at least sometimes, distinguished, and then, by knowing the habit of the coal in burning, a person perfectly ignorant of the philosophy of the matter may exhibit a wonderful sagacity, or even of power over future events, in applying this body to fire. For, at his pleasure, and unknown to those who are not in the secret, he may apparently, in equal circumstances, make this coal either kindle quietly, or with violent cracking and explosions, throwing its splinters at a distance. The explanation lies in this, that, though the rectangular mass of coal appears extremely uniform in its structure, it is truly a stratified mass. It is therefore affected, by the sudden approach of fire in a very different manner, according as the edge of the stratum, which is seen in 4 of the sides of this supposed cube, shall be applied to the fire, or the other 2 sides, which are in the line of the stratum, or parallel to the bed of coal. The reason of this phenomenon now remains to be considered. When the edge of the coal is exposed to the fire, the stratification of the coal is opened gradually by the heat and expanding vapors, as a piece of wood, of a similar shape, would be by means of wedges placed in the end way of the timber. The coal then kindles quietly, and quickly flames, while the mass of this bituminous schistous is opening like the leaves of a book, and thus exhibits an appearance in burning extremely like wood. But let the fire be applied to the middle of the bed, instead of the edge of the leaves, and we shall see a very different appearance. For here the expanded aqueous vapors, confined between the laminae, form explosions, in throwing off splinters from the kindling mass, and this mass of coal takes fire with much noise and disturbance. The ashes of this coal may be determined as to quality, being in general a subtle white earth, but, as to quantity, the measure of that earth produces an indefinite variety in this species of coal. For, from the kennel or parrot coal, which is valuable for its burning with much flame, to that black schistous which our masons use in drawing upon stone, and which, though combustible in some degree, is not thought to be a coal. There is a perfect gradation, in which coal may be found with every proportion of this earthy alloy. Among the lowest species of this combustible schistous are those argillaceous strata in Yorkshire, from whence they procure alum in burning great heaps of this stone, which also contains sulphur, to impregnate the aluminous earth with its acid. We have also, in this country, strata which differ from those aluminous schisti only in the nature of the earth, with which the bituminous sediment is mixed. In the strata now considered, the earth, precipitated with the bituminous matter, being calcareous, has produced a limestone, which, after burning especially, is perfectly fissile. Therefore, with regard to the composition of mineral coal, the theory is this: that inflammable, vegetable, and animal substances, in a subtilized state, had subsided in the sea, being mixed more or less with argillaceous, calcareous, and other earthy substances in an impalpable state. Now, the chemical analysis of fossil coal justifies that theory, for, in the distillation of the inflammable or oily coal, we procure volatile alkali, as might be naturally expected. Thus we have considered fossil coal as various, both in its state and composition. We have described coal which is of the purest composition, as well as that which is most impure or earthy. And we have shown that there is a gradation, from the most bituminous state in which those strata had been formed in being deposited at the bottom of the sea, to the most perfect state of a chemical coal, to which they have been brought by the operation of subterranean fire or heat. We have been hitherto considering fossil coal as formed of the impalpable parts of inflammable bodies, united together by pressure, and made to approach in various degrees to the nature of a chemical coal, by means of subterranean heat. Because, from the examination of those strata, many of them have evidently been formed in this manner. But vegetable bodies macerated in water, and then consolidated by compression, form a substance of the same kind, almost undistinguishable from some species of fossil coal. We have an example of this in our turf pits or peat mosses. When this vegetable substance has been compressed under a great load of earth, which sometimes happens, it is much consolidated, and hardens, by drying, into a black body, not afterwards dilutable or penetrated by water. And almost undistinguishable in burning from mineralized bodies of the same kind. Also, when fossil wood has been condensed by compression and changed by the operation of heat, as it is frequently found in argillaceous strata, particularly in the aluminous rock upon the coast of Yorkshire, it becomes a jet almost undistinguishable from some species of fossil coal. There cannot therefore be a doubt, that if this vegetable substance, which is formed by the collection of wood and plants in water upon the surface of the earth, were to be found in the place of fossil coal, and to undergo the mineral operations of the globe, it must at least augment the quantity of those strata, though it should not form distinct strata by itself. It may perhaps be thought that vegetable bodies and their impalpable parts are things too far distant in the scale of magnitude to be supposed as subsiding together in the ocean. And this would certainly be a just observation with regard to any other species of bodies, but the nature of vegetable bodies is to be floatant in water, so that we may suppose them carried at any distance from the shore. Consequently, the size of the body here makes no difference with regard to the place or order in which these are to be deposited. The examination of fossil coal fully confirms those reasonable suppositions. For, first, the strata that attend coal, whether the sandstone or the argillaceous strata, commonly, almost universally, abound with the most distinct evidence of vegetable substances. This is the impressions of plants which are found in their composition. Secondly, there is much fossil coal, particularly that termed in England clod coal, and employed in the iron foundry, that shows abundance of vegetable bodies in its composition. The strata of this coal have many horizontal interstices, at which the more solid shining coal is easily separated. Here the fibrous structure of the compressed vegetable bodies is extremely visible. And thus no manner of doubt remains, that at least a part of this coal had been composed of the vegetable bodies themselves, whatever may have been the origin of the more compact parts where nothing is to be distinguished. The state in which we often find fossil wood in strata gives reason to conclude that this body of vegetable production, in its condensed state, is in appearance undistinguishable from fossil coal, and may be also in great quantity. As, for example, the Bovey coal in Devonshire. Thus the strata of fossil coal would appear to be formed by the subsidence of inflammable matter of every species at the bottom of the sea, in places distant from the shore, or where there had been much repose, and where the lightest and most floatant bodies have been deposited together. This is confirmed in examining those bodies of fossil coal, for, though there are often found beds of sandstone immediately above and below the stratum of the coal, we do not find any sand mixed in the strata of the coal itself. Having found the composition of coal to be various, but all included within certain rules which have been investigated, we may perceive in this an explanation of that diversity which is often observed among the various strata of one bed of coal. Even the most opposite species of composition may be found in the thickness of one bed, although of very little depth, that is to say, the purest bituminous coal may, in the same bed, be conjoined with that which is most earthy. Fossil coal is commonly alternated with regular sandstone and argillaceous strata, but these are very different bodies. Therefore, it may perhaps be inquired how such different substances came to be deposited in the same place of the ocean. The answer to this is easy. We do not pretend to trace things from their original to the place in which they have been ultimately deposited at the bottom of the sea. It is enough that we find the substance of which we treat delivered into the sea, and regularly deposited at the bottom, after having been transported by the currents of the ocean. Now the currents of the ocean, however regular they may be for a certain period of time, and however long this period may be protracted, naturally change. And then the currents, which had given birth to one species of stratum in one place, will carry it to another. And the sediment which the moment before had formed a coal stratum, or a bed of that bituminous matter, may be succeeded either with the sediment of an argillaceous stratum, or covered over with a bed of sand, brought by the changed current of the sea. We have now considered all the appearances of coal strata, so far as these depend upon the materials, and their original collection. But, as those bituminous strata have been changed in their substance by the operation of subterranean heat and inspissation, we are now to look for the necessary consequences of this change in the body of the stratum. and also for other mineral operations common to fossil coal with consolidated strata of whatever species. If coal, like other mineral strata, have been inspissated and consolidated by subterranean heat, we should find them traversed with veins and fissures. And, if the matter found in those veins and fissures corresponds to that found in similar places of other strata, every confirmation will be hence given to the theory that can be expected from the consideration of those bituminous strata. But this is the case, we find those fissures filled both with calcareous, gypseous, and pyritous substances. Therefore, we have reason to conclude, that the strata of fossil coal, like every other indurated or consolidated body in the earth, has been produced, first, by means of water preparing and collecting materials proper for the construction of land. And, secondly, by the operation of internal fire or subterranean heat melting and thus consolidating every known substance of the globe. Not only are those sparry and pyritous substances, which are more natural to coal strata, found forming veins traversing those strata in various directions, but also every other mineral vein may occasionally be found pervading coal mines, or traversing bituminous strata. Gold, silver, copper, lead, calamine, have all, in this manner, been found in coal. There remains now only to consider those bituminous strata of fossil coal in relation to that change of situation which has happened more or less to every stratum which we examine, but which is so much better known in those of coal, by having, from their great utility in the arts of life, become a subject for mining, and thus been traced in the earth at great expense, and for a long extent. Coal strata, which had been originally in a horizontal position, are now found sometimes standing in an erect posture, even almost perpendicular to the plane in which they had been formed. Miners therefore distinguish coal strata according as they deem them to approach to the one or other of those two extremes, in terming them either flat or edge seams or veins. Thus, it will appear, that every possible change from the original position of those strata may have happened, and are daily found from our experience in those mines. But besides the changed position of those strata, in departing from the horizontal line or flat position in which they had been formed, there is another remarkable change, termed by miners a trouble in the coal. The consideration of this change will further illustrate the operations of nature in placing that which had been at the bottom of the sea above its surface. Strata, that are in one place regularly inclined, may be found bended, or irregularly inclined, in following their course. Here then is a source of irregularity which often materially affects the estimates of miners, judging from what they see, of those parts which are to be explored, and this is an accident which they frequently experience. But, without any change in the general direction of the stratum, miners often find their coal broke off abruptly, those two parts being placed upon a higher and lower situation in respect to each other, if flat beds, or separated laterally if they are edge seams. This is by miners termed a slip, hitch, or dike. These irregularities may either be attended with an injected body of subterraneous lava or basalts, here termed whinstone, or they may not be attended, at least apparently, i.e., immediately, with any such accident. But experienced miners know, that, in approaching to any of those injected masses of stone, which are so frequent in this country, their coal is more and more subject to be troubled. As there is, in this country of Scotland, two different species of mountains or hills, one composed both in matter and manner exactly similar to the Alps of Switzerland, the other of whinstone, basaltic rock, or subterraneous lava. And as the fossil coal, argillaceous and sandstone strata, are found variously connected with those hills, nothing can tend more to give a proper understanding, with regard to the construction of the land in general, of the globe than a view of those different bodies, which are here found much mixed together in a little space of country, thus exhibiting, as it were in miniature, what may be found in other parts of the world, upon a larger scale, but not upon any other principle. I will therefore endeavor to give a short description of the mineral state of this country with regard to coal, so far as my experience and memory will serve. This country might very properly be considered as consisting of primary and secondary mountains. Not as supposing the primary mountains original and inexplicable in their formation, any more than those of the latest production, but as considering the one to be later in point of time, or posterior in the progress of things. The first are those which commonly form the alpine countries, consisting of various schistee, of quartzy stone, and granites. The second, again, are the whinstone or basaltic hills scattered up and down the low country, and evidently posterior to the strata of that country, which they break, elevate, and displace. Thus there are in this country, as well as everywhere else, three things to be distinguished: first, the alpine or elevated country; secondly, the flat or low country; and, thirdly, that which has been of posterior formation to the strata which it traverses, in whatever shape or quality, whether as a mountain, or only as a vein. Whether as a basalts, a porphyry, or a granite, or only as a metal, a siliceous substance, or a spar. Those three things which are here distinguished do not differ with regard to the chemical character of their substances. For, in each of these, every different substance is to be found, more or less, and it is not in being composed of materials peculiar to itself, that makes an alpine country be distinguished from a flat country. It is chiefly in the changes which the strata of the alpine country have been made to undergo, posterior to their original collection, that the rocks of the alpine country differ from those of the flat country. But the observation that is most to the purpose of the present subject of bituminous strata, is this: it is chiefly in the strata of the flat country that fossil coal are found. There are none that I know of in all the alpine countries of Scotland. And it is always among the strata peculiar to the flat country that fossil coal is found. Now, this appearance cannot be explained by saying that the materials of mineral coal had not existed in the world while those primary strata were formed in the sea. I have already shown, Chapter 4, that there had been the same system of a world, producing plants, and thus maintaining animals, while the primary strata were formed in the sea. I have even adduced an example of coal strata among those primary schistee, although this be an extremely rare occurrence. Consequently, we are under the necessity of looking out for some other cause. If the changes which have been evidently superinduced in the strata of alpine countries arise from the repeated operations of subterranean fire, or to the extreme degree in which those strata have been affected by this consolidating and elevating cause, it will be natural to suppose that the bituminous or combustible part among those stratifications may have been mostly consumed upon some occasion during those various and long-continued operations. Whereas, in the flat beds of the low country, although there is the most perfect evidence for the exertion of heat in the consolidation of those strata, the general quantity of this has been a little thing, compared with the universal manifestation of this cause in the operations of the alpine countries, the strata of which have been so much displaced in their situations and positions. To illustrate this, strata of sandstone are found in both the alpine and flat countries of Scotland. About lead hills, for example, there are abundance of those strata. But, in the flat country, the generality of the sandstone is so little changed as to appear to every enlightened naturalist aquiform strata. Whereas the most enlightened of those philosophers will not perhaps attribute the same original to a similar composition in the alpine country, which is so much changed from its original state. It is not because there had been wanting a sufficient degree of heat to consolidate the sandstone in the coal country, for I can show specimens of sandstone almost contiguous with coal, that have been extremely much consolidated in this manner. But this is only a particular stratum. And the general appearance of the sandstone, as well as other strata in the coal countries, is that of having been little affected by those subterranean operations of heat by which those bodies in the alpine country have been changed in their structure, shape, and position. If we shall thus allow the principle of consolidation, consequently also of induration, to have been much exerted upon the strata of the alpine country, and but moderately or little upon those of the low country of Scotland, we shall evidently see one reason, perhaps the only one, for the lesser elevation of the one country above the level of the sea, than the other. This is because the one resists the powers which have been employed in leveling what has been raised from the bottom of the sea, more than the other. Consequently, we find more of the one remaining above the level of the sea than of the other. Let us now take the map of Scotland, in order to observe the mixture of those two different species of countries, whereof the one is generally low and flat, the other high and mountainous. The one more or less provided with fossil coal, the other not. From St. Abb's Head, on the east of Scotland, to the Mull of Galloway, on the west, there runs a ridge of mountains of granite, quartz, and schistous strata, which contain not coal. On each side of this ridge we find coal countries, Northumberland, on the one side, and, on the other, the shires of Ayr, Lanark, and the Lothians. The one is a mountainous country, the others are comparatively low or flat countries. Let us now draw another alpine line from Buchan and Caithness, upon the east, to the island of Jura, on the west. This traverses a mountainous country destitute of coal, and, so far as I know, of any marks of marine bodies. But, on each side of this great alpine ridge, we find the hard country skirted with one which is lower, flatter, or of a softer nature, in which coal is found, upon the one side, in the shires of Fife, Clackmannan, and Stirling. And, on the other, in that hollow which runs from the Murray Frith southwest, in a straight line, directed upon the end of Mull, and composed, for the most part, of water very little above the level of the sea. Here, to be sure, the coal is scarce, or not so evident, but there is coal upon the sea coast in several places of this great bay betwixt Buchan and Caithness. And the lowness of the country, across this part of the island, is almost sufficient testimony that it had been composed of softer materials. Thus the coal country of Scotland may be considered as in one band across the island, and included in the counties of Ayr, Lanark, and all those which border upon the Frith of Forth. Now, in all this tract of coal and tender strata, we do not find ridges of alpine stone or primary mountains, but we find many hills of solid rock, little mountains, from 500 to 1,000 feet high. Such as that beautiful conical hill North Berwick Law, Torpender Law, Arthur's Seat, the Lomans, and others of inferior note. That is to say, the whole of this included space, both sea and land, has been invaded from below with melted masses of whinstone, breaking up through the natural strata of the country, and variously embossing the surface of the earth at present. When all the softer materials, with which those subterranean lavas had been covered, are washed away or removed from those summits of the country. Hence there is scarcely a considerable tubercle, with which this country also abounds, that may not be found containing a mass of whinstone as a nucleus. But besides those insulated masses of whinstone that form a gradation from a mountain to a single rock, such, for example, as that on which the castle of Edinburgh is built, we find immense quantities of the same basaltic rock interjected among the natural strata, always breaking and disordering them, but often apparently following their directions for a considerable space with some regularity. We also find dikes of the same substance bisecting the strata like perpendicular veins of rock. And, in some places, we see the connection of these rocks of the same substance, which thus appear to be placed in such a different form in relation to the strata. It will thus appear, that the regular form, and horizontal direction of strata throughout this country of coal, now under contemplation, has been broken and disordered by the eruption and interjection of those masses of basaltic stone or subterraneous lava. And thus may be explained not only the disorders and irregularities of coal strata, but also the different qualities of this bituminous substance from its more natural state to that of a perfect coal or fixed infusible and combustible substance burning without smoke. This happens sometimes to a part of a coal stratum which approaches the whinstone. Having thus stated the case of combustible or bituminous strata, I would ask those naturalists, who adhere to the theory of infiltration and the operation of water alone, how they are to conceive those strata formed and consolidated. They must consider, that here are immense bodies of those combustible strata, under hundreds, perhaps thousands, of fathoms of sandstone, ironstone, argillaceous and calcareous strata. If they are to suppose bituminous bodies collected at the bottom of the sea, they must say from whence that bitumen had come. For, with regard to the strata below those bituminous bodies, above them, and between them, we see perfectly from whence had come the materials of which they are formed. They cannot say that it is from a collection of earthy matter which had been afterwards bituminized by infiltration. For, although we find many of those earthy strata variously impregnated with the bituminous and coaly matter, I have shown that the earthy and the bituminous matter had subsided together. Besides, there are many of those coaly and bituminous strata in which there is no more than 2 or 3% of earthy matter or ashes after burning. Therefore the strata must have been formed of bituminous matter, and not simply impregnated with it. To avoid this difficulty, we shall allow them to form their strata, which certainly is the case in great part, by the collection of vegetable bodies. Then, I desire them to say, in what manner they are to consolidate those bodies. If they shall allege that it is by simple pressure, how shall we conceive the numerous veins of spar and parietes, which traverse those strata in all directions? To be formed in those bodies consolidated by the compression of the superincumbent masses? Here is a manifest inconsistency, which proves that it could not be. But, even were we to suppose all those difficulties to be overcome, there is still an impossibility in the way of that inconsiderate theory, and this will appear more fully in the following chapter. Section 3. The mineralogical operations of the earth illustrated from the theory of fossil coal. There is not perhaps a greater difference among the various qualities of bodies than that which may be observed to subsist between the burning of those two substances. That is, the inflammable bodies on the one hand, and those that are combustible on the other. I have treated of that distinction in dissertations upon subjects of natural philosophy, Part 3d. Where I have considered the different effects of those two kinds of bodies upon the incident light. And, in a dissertation upon the philosophy of fire, etc. I have distinguished those two kinds of substances in relation to their emitting, in burning, the fixed light which had constituted a part of those inflammable and combustible bodies. All animals and vegetable bodies contain both those different chemical substances united, and this phlogistic composition is an essential part in every animal and vegetable substance. There are to be found in those bodies particular substances, which abound more or less with one of those species of phlogistic matter, but never is the one species of those burning substances to be found naturally, in animal and vegetable bodies, without being associated with the other. And it is all that the chemical art can do to separate them in a great degree upon occasion. Pure ardent spirit may perhaps be considered as containing the one, and the most perfect coal the other. The chemical principle of the one is proper carbonic matter, and of the other it is the hydrogenous principle, or that of inflammable air. Thus we so far understand the composition of animal and vegetable substances which burn or maintain our fires. We also understand the chemical analysis of those bodies, in separating the inflammable from the combustible substance, or the volatile from the fixed matter, the oil from what is the proper coal. It is by distillation or evaporation, the effect of heat, that this separatory operation is performed, and we know no other means by which this may be done. Therefore, wherever we find peculiar effects of that separatory operation, we have a right to infer the proper cause. The subject, which we are to consider in this section, is not the composition of strata in those of mineral coal, but the transformation of those, which had been originally inflammable bodies, into bodies which are only combustible. An end which is to be attained by the separation of their volatile or inflammable substances. In the last section, I have shown of what materials the strata of mineral coal had been originally formed. These are substances containing abundance of inflammable oil or bitumen, as well as carbonic matter which is properly combustible. And this is confirmed by the generality of those strata, which, though perfectly consolidated by fusion, retain still their inflammable and fusible qualities. But now the object of investigation is that mineral operation by which some of those strata, or some parts of a fusible and inflammable stratum, have been so changed as to become infusible and only combustible. We have now examined those strata which may be considered as either proper mineral coal, or as only a bituminous schistous. We are now to class along with these another species of this kind of matter, which has had a similar origin, although it may assume a different character. According to the common observations of mankind, the eminent quality by which coal is to be distinguished, is the burning of that substance, or its capacity for making a fire. Therefore, however similar in other respects, a substance which had not that eminent quality of coal could hardly be considered as being allied to it, far less could it be supposed, as being in every other respect the same. We are however to endeavor to show, that there are truly substances of this kind, substances which to common observation, having none of the properties of coal with respect to fire, consequently, no utility for the purpose of burning, might be considered as another species of mineral, while at the same time they are truly at bottom a composition very little different from those which we have considered as the most perfect coal. It must be recollected that we have distinguished coal in general as of two different species, one perfect or proper coal, containing no perceptible quantity of either oil or phlegm. The other is burning with smoke and flame, consequently containing both aqueous and oleaginous substances which it emits in distillation. It is the first of these which we are now to consider more particularly, in order to see the varieties which may be found in this species of mineral substance. When that bituminous fossil, which is the common coal of this country, is submitted to heat, it is subject to melt more or less, and emit smoke which is composed of water and oil. If it be thus completely distilled, it becomes a perfect coal of a porous or spongy texture. Such a substance as this is extremely rare among minerals. I have however found it. It is in the harbour of Ayr, where a whinstone dyke traverses the coal strata, and includes some of that substance in the state of coals or cinder. I pointed this out many years ago to Dr. Black, and lately I showed it to Professor Playfair. But the culm of South Wales, the Kilkenny coal of Ireland, and the blind coal of Scotland, notwithstanding that these are a perfect coal, or charred to a coal, have nothing of the porous construction of the specimen which I have just now mentioned. They are perfectly solid, and break with a smooth shining surface like those which emit smoke and flame. Here is therefore a mineral operation in the preparation of those coals which we cannot imitate. And here is the clearest evidence of the operation of mineral fire or heat, although we are ignorant of the reason why some coal strata are charred, while others are not, and why, in some particular cases. The charred coal may be porous or spongy like our cokes, while in general those blind coals, as they are called, are perfectly solid in their structure. But to what I would call more particularly the attention of mineral philosophers is this, that it is inconceivable to have this effect produced by means of water. We might as well say that heat were to be the cause of ice. The production of coal from vegetable bodies, in which that phlogistic substance is originally produced, or from animal bodies which have it from that source, is made by heat, and by no other means, so far as we know. But, even heat alone is not sufficient to effect that end, or make a perfect coal. The phlogistic body, which is naturally compound, consisting of both inflammable and combustible substances, must be separated chemically, and this must be the operation of heat under the proper circumstances for distillation or evaporation. Here is the impossibility which in the last chapter 1 have alleged the aqueous theory has to struggle against, and here is one of the absolute proofs of the igneous theory. Not only must the aqueous part of those natural phlogistic bodies be evaporated, in order to their becoming coal, but the oily parts must also, by a still increased degree of heat, be evaporated, or separated by distillation from the combustible part. Here, therefore, is evidently the operation of heat, not simply that of fusion in contradiction to the fluidity of aqueous solution, but in opposition to any effect of water, as requiring the absence or separation of that aqueous substance. But those natural appearances go still farther to confirm our theory, which, upon all occasions, considers the compression upon the bodies that are submitted to the operation of heat, in the mineral regions, as having the greatest efficacy in modifying that operation. Coal strata, which are in the neighborhood of each other, being of those two opposite species, the one fusible and inflammable, the other infusible and combustible, afford the clearest proof of the efficacy of compression. For, it is evident, that the coal, which was once bituminous or fusible, cannot be charred without the distillation of that substance. Therefore, prevent the distillation by compression and the charring operation cannot proceed, whatever should be the intensity of the heat, and then, fusion alone must be the effect upon the bituminous body. But now, as we have both those species of coal in the vicinity of each other, and even the same strata of coal part charred, while the rest is not, this natural appearance, so far from being a stumbling block, as it must be to the opposite theory, is most clearly explained by the partial escape of vapors from the mineral regions, and thus confirms the theory with regard to the efficacy of compression. It is owing to the solidity of those natural charred coals, and the want of oil, that they are so very difficult of kindling, but, when once kindled in sufficient quantity, they make a fire which is very durable. There are even some of them which, to common observation, seem to be altogether incombustible. I have of this kind a specimen from a stratum at Stair, which shall be afterwards mentioned. M. Struve, in the Journal de Physique for January 1790, describes a mineral which he calls plombagen charbonneurs au hexadra, and gives for reason, parce qu'elle ressemble extrêmement au charbon de pierre schisteux, au dihexadra. He says farther, il est très commun, dans un roche que forme un passage entre les granites et les breaks, qu'on en trouvé jusqu'à présent qu'on masses roules dans le pays de Vaud. He concludes his paper thus, ce fossile singulier n'est pourrait pas appartenir à la Suisse seule. J'ai dans ce moment devant les yeux une substance parfaitement semblable, si on accepte la couleur que tient le milieu entre le gris de fer et le rouge madre, elle vient du pays de Gotha de la Friedrichsgrube, proche d'Umno. On le regarde comme un eisenraum uni à du charbon de pierre. The specimen which I have from Stair upon the water of air, so far as I can understand, perfectly resembles this plumbagen of M. Struve. It consumes very slowly in the fire, and deflagrates like plumbago with nitre. Now this comes from a regular coal stratum. And what is more remarkable, in this stratum is contained a true plumbago. Farther up the country, the Earl of Dumfries has also a mine containing plumbago along with other coal strata. And though the plumbago of these two mines have not all the softness and beauty of the mineral of the same species from Cumberland, they are nevertheless perfect plumbago. I have a specimen of steatetical whinstone or basalts from some part of Cumberland, in which is contained many nodules of the most perfect and beautiful plumbago. It is dispersed through this stone in rounded masses of all sizes from a nut to a pin's head, and many of these are mixed with parites. There is therefore reason to believe that this plumbago had been in fusion. Now, if we consider that every species of coal and every species of plumbago are equally, that is, perfectly combustible, and yield, in burning, the same volatile principles, differing only perhaps a little in the small quantity of fixed matter which remains, we shall be inclined to believe, that they have all the same origin in a vegetable substance, and that they are diversified by some very small composition of other matter. This being allowed, one thing is certain, that it is by the operation of mineral fire or heat that those combustible substances, however composed, have been brought to their present state of coal. Although we are ignorant of the circumstances by which their differences and their peculiar chemical and mechanical qualities have been produced. Let us resume in a few words. There is not perhaps one substance in the mineral kingdom by which the operation of subterraneous heat is, to common understanding, better exemplified than that of mineral coal. Those strata are evidently a deposit of inflammable substances which all come originally from vegetable bodies. In this state of their formation, those coal strata must all be oleaginous or bituminous. In many of them, however, these volatile parts are found wanting, and the stratum is found in the state of the most perfect coal or caput mortuum. There is, I presume, no other means to be found by which this eminent effect could be produced, except by distillation, and this distillation perhaps proceeded under the restraining force of an immense compression. To this theory it must not be objected, that all the strata of coal, which are found in the same place or neighborhood, are not reduced to that caput mortuum or perfect coaly state. The change from a bituminous to a coaly substance can only take place in proportion as the distillation of the volatile parts is permitted. Now this distillation must be permitted, if any passage can be procured from the inflammable body submitted to the operation of subterraneous heat. And, one stratum of coal may find vent for the passage of those vapors, through some crevice which is not open to another. In this way, doubtless, some of those bodies have been inspissated or reduced to a fixed coal, while others, at a little distance, have retained most of their volatile parts. We cannot doubt of this distilling operation in the mineral regions. When we consider that in most places of the earth we find the evident effects of such distillation of oily substances in the naphtha and petroleum that are constantly emitted along with water in certain springs. These oily substances are no other than such as may be procured, in a similar manner, from the fusible or inflammable coal strata. We have therefore every proof of this mineral operation that the nature of things admit of. We have also sufficient evidence that those fusible and inflammable coals, which have not been distilled to a caput mortuum, had been subjected to the operation of subterraneous heat. Because we find those fusible coals subject to be injected with pyrites, as well as the more perfect coal. If we now consider those various appearances of mineral bodies which are thus explained by the theory of mineral fire, or exertion of subterraneous heat, appearances which it is impossible to reconcile by any supposition of aqueous solution, or that unintelligible language of mineral infiltration which has of late prevailed, we shall be fully satisfied, that there is a uniform system in nature of providing a power in the mineral regions, for consolidating the loose materials deposited at the bottom of the sea, and for erecting those masses of mineralized substances into the place of land. We shall thus be led to admire the wisdom of nature, providing for the continuation of this living world, and employing those very means by which, in a more partial view of things, this beautiful structure of an inhabited earth seems to be necessarily going into destruction. Introduction. By the present theory, the earth on which we dwell is represented as having been formed originally in horizontal strata at the bottom of the ocean. Hence it should appear, that the land, in having been raised from the sea, and thus placed upon a higher level, had been of a different shape and condition from that in which we find it at the present time. This is a proposition now to be considered. In whatever order and disposition the hard and solid parts of the land were at the time of its emerging from the surface of the sea, no provision would have then been made for conducting the rivers of the earth. Therefore, the water from the heavens, moving from the summits of the land to the shores, must have formed for themselves those beds or channels in which the rivers run at present. Beds which have successively changed their places over immense extents of plains that have often been both destroyed and formed again. And beds which run between the skirts of hills that have correspondent angles, for no other reason but because the river has hollowed out its way between them. In this view of things, the form of our land must be considered as having been determined by three different causes, all of which have operated, more or less, in producing the present state of those things which we examine. First, there is a regular stratification of the materials, from whence we know the original structure, shape, and situation of the subject. Secondly, there are the operations of the mineral region, some of which have had regular effects upon the strata, as we find in the veins or contractions of the consolidated masses. Others have had more irregular effects, but which may still be distinguished by means of our knowing the original state and structure of those masses. Lastly, there are operations proper to the surface of this globe, by which the form of the habitable earth may be affected. Operations of which we understand both the causes and the effects, and, therefore, of which we may form principles for judging of the past, as well as of the future. Such are the operations of the fun and atmosphere, of the wind and water, of the rivers and the tides. It is the joint operation and result of those three different causes that are to be perceived in the general appearances of this earth, and not the effects of any one alone. Although, in particular places of the earth, the operation peculiar to each of these may be considered by itself, in abstracting those of the others, more or less. Thus there are several views in which the subject is to be examined, in order to find facts with which the result of the theory may be compared, and by which confirmation may be procured to our reasoning, as well as explanation of the phenomena in question. Chapter 1. Facts in confirmation of the theory of elevating land above the surface of the sea. The first object now to be examined, in confirmation of the theory, is that change of posture and of shape which is so frequently found in mountainous countries. Among the strata which had been originally almost plain and horizontal. Here it is also that an opportunity is presented of having sections of those objects, by which the internal construction of the earth is to be known. It is our business to lay before the reader examples of this kind, examples which are clearly described, and which may be examined at pleasure. No person has had better opportunities of examining the structure of mountains than M. de Saussure, and no body more capable of taking those comprehensive views that are so necessary for the proper execution of such a task. We shall therefore give some examples from this author, who has everywhere described nature with a fidelity which even inconsistency with his system could not warp. Speaking of the general situation of the beds of the Salève, page 179. Dans quelques endroits, et mean presque partout, les couches descendant tout droit du haut de la montagne jusqu'à son pied, mais au-dessus de Collonges le sommet arrondi en dos d'en présent de couches que descendant de part et d'autre. Au sud-est vers les Alpes, et au nord-ouest vers notre vallée. Avec cette différence, que celles que descendant vers les Alpes parviennent jusqu'au bas, au lieu que celles que nous regardons sont capables à pic, à une grande hauteur. Ces deux inclinaisons ne sont pas les seules que l'on observe dans le bancs du Mont Salive, ils ont encore un troisième, ils sont relèves vers le milieu de la longueur de la montagne, et descendant de la vers ses extrémités. Cette pente, que sur le grand salive n'est pas bien sensible, devient très remarquable au petit salive, et mean très rapide à son extrémité. Les derniers couches au nord au-dessus d'Étrembières descendant vers le nord-nord-est, sous un angle de 40 au 50 degrés. On verra, dans le cours de cet ouvrage, combien le montagnes calcaires ont fréquemment cette forme. Section 235. Outre ces grandes couches que constituent le corps de la montagne, et que peuvent en général être mises dans la classe de couches horizontales, on en trouve d'autres dont l'inclinaison est absolument différente. Elles sont situées au bas de grandes salives du côté que regarde notre vallée, on les voit appliquées contre les tranches inférieures de bancs horizontaux au très inclines en appui contre la montagne. Ces couches s'élèvent en quelques endroits, par exemple, entre Very et Creven, à peu près à la moitié de la hauteur du grande salive. Celles que touchent immédiatement la montagne, sont le plus inclines. On en voit là de verticales et mean quelquefois de renversés en sens contraire, que sont soutenues par le plus extérieurs. Celles-ci font avec l'horizon un angle de 60 à 65 degrés. Ces couches sont souvent très étendues, bien suivies, et continues à de très grandes distances. Leur assemblage forme un épaisseur considerable au pied de la montagne. Elles ont cependant été rompues, et manquent même totalement dans quelques places. C'est la même dans la facilité de les bien observer, parce qu'en s'y postant dans ces intervalles, on peut les prendre en flanc, et voir distinctement leurs tranches, et tout leur structure. On observe ces couches non seulement au pied de rocs nuds du grand salive, mais encore dans la partie de sa pente que est boisée par exemple au-dessus de la Croisette, le chemin que de ces hameaux descend au village de Collonges. Passez sur les couches inclines, comme celles que je viens de décrire. In section 237, the description is continued. En suivant le pied de la montagne entre le coin et Creven, on voit reparaître nos couches verticales au très inclines que vis à vis du coin, ont été détruites comme je viens de le dire. Ces couches là elles sortent que l'on peut comparer toutes les couches de la montagne à celles d'un jeu de cartes ploy en du suivant assez longueur. In considering the chains of the Jura, on the west side of that which looks to the lake, our author has the following interesting observations, page 275. Les chaînes dont il est composé, à mesure qu'ils s'éloignent de la haute ligne orientale perdent graduellement de leur hauteur et de leur continuité. Le plus occidentales n'y forment pas, comme la première, de chaînes de montagnes élevées et non interrompues, ces sont de monticules allonges il est vrai, mais isoles au que du moins n'y sont unis que par leurs bases. Section 338. Leur structure n'est pas la même dans tout l'étendue du Jura. La forme primitive la plus générale ressemble cependant à celles de la haute chaîne, c'est-à-dire, que ces sont de voûtes, composées et remplies d'arcs concentriques. C'est surtout entre Pontarlier et Besançon, que l'on rencontre de collines que ont régulièrement cette structure. La grande route traverse de larges vallées, dans lesquelles les couches sont horizontales. Mais ces vallées sont séparées par de chaînes peu élevées dont les couches arquées montent jusqu'au haut de la montagne, et descendant ensuite du côté opposé. En envoit aussi de la mime for me dans la prévote de Moutier Grand Val. La Burs traverse de rochers que offrent à découvert la construction intérieure de montagnes, les couches de roc formant dans cet endroit de buttes élevées l'un sur l'autre en suivant le contour extérieur de la montagne. Dictionary géographique. De la Suisse, Tom. 2, page 150. Daughters fois le sommet de la montagne est plus aigu que ne celui d'une voûte, un les couches parallèles entre elles, mais inclines à l'horizon en sens contraire, presentant dans leur section, la forme d'un chevron ou d'un lambda, Greek, L. Section 339. Mais cette même structure présente fréquemment un singularité remarquable. Ce sont de banques perpendiculaires à l'horizon que occupent à peu près le milieu ou le cœur de la montagne et que séparent les couches d'une des faces de celles de la face opposée. J'ai observé plusieurs montagnes secondaires, et du Jura et d'Alers, et surtout un grand nombre de montagnes primitives, dont la structure est la même 48. Section 340. Les couches perpendiculaires à l'horizon, que l'on rencontre fréquemment dans le Jura ont presque tous leurs plans dirigés du nord-nord-est au sud-sud-ouest, suivant la direction générale de cette chaîne de montagnes. Cette observation est d'une assez grande importance parce qu'elle exclut ou rend du moins improbable l'idée d'un bouleversement. J'ai cru pendant longtemps que tous les couches devaient avoir été formés dans une situation horizontale, ou peu inclinée à l'horizon, et que celles que l'on rencontre dans une situation perpendiculaire, ou très inclines. Avaient été mises dans cet état par quelque révolution. Mais à force de rencontrer de couches dans cette situation, de les voir dans de montagnes bien conservées, et que any paroissement point avoir subi de bouleversement. Et d'observer une grande régularité dans la forme et dans la direction de ces couches. Je suis venu à penser que la nature peut bien avoir aussi forme de ces banques très inclines, et même perpendiculaires à la surface de la terre. Here the reasoning of our author is sufficiently just. He sees too much order in the effect to ascribe it to a cause merely fortuitous. But surely nothing in those appearances hinders the conclusion, that the strata now found in all possible positions, had been originally horizontal when at the bottom of the sea, and that they had been afterwards regularly bent and broken. By the same cause which operated in placing them above the level of the ocean. The force of this argument will appear, by considering the various regular and irregular positions in which they are found. Section 242. Dans quelques endroits du Jura, en voit de species de demi-cercles formes par de rochers dont les couches sont de portions de la surface d'un même cône et tendant à un centre commun élève au-dessus de l'horizon. Ainsi opers de Pontarlier, etc. Section 343. Mais il est bien plus fréquent de voir de montagnes dont les couches ont la forme d'une demi-voûte, et que vues de profil presentant, comme notre montagne de Salive, en pente d'aus d'une côte, et de escarpements de l'autre. Plusieurs vallées du Jura sont situées entre deux chaînes de montagnes que ont cette forme, et que s'y présentent réciproquement leurs faces escarpées. On croit même apercevoir quelque correspondance, entre les couches de ces montagnes opposes, et l'on droit qu'elles furent anciennement unies, et que la partie intermédiaire a été détruite, ou que la montagne est fendue du haut en bas. Et que ces du moides se sont écartés pour faire place à la vallée qu'elles renferment. Section 346. Pour résumer en peu de mots les idées que j'ai mis formé de la structure du Jura. Je dirais que je crois qu'il est composé de différentes chaînes à peu près parallèles entre elles, et à celles de Alpes, mais tirant un peu plus du nord au midi, que la chaîne la plus élevée et la plus voisine de Alpes. A eu originairement la forme d'une dos dien dont les pentes partent du fait, recouvrant les flancs, et descendant jusqu'aux au pieds de la montagne, que les chaînes suivantes du côte de l'ouest. Sont composés de montagnes graduellement moins élevées et de moins étendues. Que les couches de ces montagnes ont généralement la forme de voûtes entières au lieu de moitié de voûtes. Et qu'elles viennent mourir dans de plaines, que ont pour base de banques calcaires tout à fait horizontax de la même nature que ceux du mont Jura, et que furent peut-être anciennement contenus avec eux. Our author has here described most accurately, not only the present shape and positions of particular strata, but the general shape and structure of the land in the Salive and Jura, which are not in the Alps, to the plains of France, where the strata are generally in a more horizontal situation. Having thus seen the structure of what are commonly termed the secondary mountains, a structure which prevails generally in all parts of the land, at least in all that which is not primitive in the estimation of naturalists, who suppose a different origin to different parts, it will now be thought a most interesting view of nature, to see the same accurate examination of the structure of the earth, from those secondary mountains of Geneva to the center of the Alps, where we find such a variety of mountains of different materials, whether they shall be called primitive or secondary, and where such opportunity is found for seeing the structure of those mountains. For, if we shall find the same principles, here prevailing in the formation of those supposed primitive mountains as are found over all the earth in general, and as are employed in fashioning or shaping every species of material, it will be allowed us to conclude, that, in this situation of things, we have what is general in the formation of land, notwithstanding imaginary distinctions of certain parts which have been formed one way, and of others which are supposed to be operations of an opposite nature. This question therefore will be properly decided in our author's journey to the Alps, for, if we shall there find calcareous strata perfectly consolidated, as they should be by the extreme operation of subterranean heat and fusion, if we find materials of every species formed after the manner of stratification, and if all those different strata variously consolidated shall be found in all positions, similar to those which we have now seen in the examination of the Jura and Salive, with this difference, that the displacement and contortion may be more violent in those highly consolidated strata, we shall then generalize an operation by which the present state of things must have been produced. And in those regular appearances, we shall acknowledge the operation of an internal heat, and of an elevating power. Section 287. Les pentes rapides de banques dont est forme le mole, les directions variées de ces mêmes banques sont aussi conformes à une observation générale et importante. Que les montagnes secondaires sont d'autant plus irrégulières et plus inclines qu'elles s'approchent plus de primitives. À la vérité, quelques montagnes calcaires même à de grandes distances de primitives ont ca et la de couches inclines et même quelquefois verticales. Mais ces exceptions locales n'empêchent pas qu'il n'y soit vrai qu'en général, les banques calcaires, qu'elles ont trouvé dans les plaines que sont éloignées de hautes montagnes, ont leurs banques au horizontax au peu inclines. Tandis, qu'au contraire, les montagnes que s'approchent, du centre de grandes chaînes, n'ont que très rarement de couches horizontales, et présentent presque partout de couches fortement et diversement inclines. That is to say, that there is no place of the earth, however plane and horizontal in general may be the strata, in which examples are not found of this manner of disordering or displacing strata. At the same time they are more crested and more disordered in proportion to the mountainous nature of the country. Here is the proposition contained in that general observation of natural history. And this is a proposition which either naturally flows from the theory, or is perfectly consistent with it. Section 360, Le Rocher dont je parle, Section 354, que touche celui de la dole, et que porte le nom de Voirne, est d'une structure singulière. Les banques dont il est composé sont escarpées, les uns montant contre le nord-est sous un angle de 40 à 50 degrés, les autres ens élevant contre le sud-est. Section 361. En avant de ces rochers, du côté l'est, on en voit un autre d'une structure très remarquable. Il a la forme d'un chevron aigu ou d'un lambda, Greek, L, on le nomme, sans doute à cause de sa forme, le rocher de fin château. Les banques dont il est composé sont très inclines à l'horizon, et s'appuyent réciproquement contre leurs sommets respectifs. Les planches que l'endresse en appui les uns contre les autres pour les faire secker, peuvent donner une idée de la situation de les banques. Cette forme n'est pas rare dans ces rochers calcaires. Mais elle est bien plus fréquente encore, et plus décidée dans les rochers primitifs, comme nous le verrons dans la suite. Le rocher de fin château présente dans cette forme même une circonstance très remarquable. C'est que l'intervalle que les jambes du lambda, grec, L, les cent entre elles, est rempli par de couches perpendiculaires à l'horizon. En droit que ces couches chassées en haute par une force souterraine, au soulève de part et d'autre, de banques que sont demeures appuyées contre elles. Nous avons déjà vu de rochers de cette forme, section 339. Here the truth of our theory is so evident, that this philosopher naturally acknowledges it without intention. In his Journey to Mont Blanc, he observes, page 364. Un peu au-delà de contamine en passé sous les ruines du château de Faucigny, bâti sur le sommet d'un rocher escarpé, que fait partie de la base du Mole. Tant qu'on est immédiatement au-dessus de ces rochers en une de mille pas bien essa structure, mais après avoir passé, on peut voir à l'aide d'une lunette, elle est composée de couches perpendiculaires à l'horizon, et diriges du nord-est au sud-ouest. Au-dessus de ces rochers au sud-est, on voit d'autres couches verticales, mais dont les plans couent à l'angle droit ceux de premiers. Et un bon demi-lieu de ces châteaux on observe, comme au pied du Mont Salive, un masse de rochers, dont les couches minces, presque perpendiculaires à l'horizon, sont adhesives aux escarpements de couches épaisses et bien suivies. Caparoissant horizontals. Speaking of the Mont Brezin, our author says, page 369. Mais le pied de cette montagne est encore, comme celui de Salive, couvert de grandes couches presque perpendiculaires à l'horizon et appuyées contre le corps même de la montagne. Et quoique le Brezin se termine à un petit demi-lieu de la bonne ville, cependant ces couches que sont appuyées contre le pied de la chaîne méridionale, et que tournent ainsi le dos à l'arve. Continuant de regner jusqu'au au village de Siang et pendant l'espace de près de 2 lieues. Elles sont à la vérité capises par un petit vallée à l'extrémité du pied du Brezin, mais elles recommencent au-delà de cette coupure. Section 446. Cette petite vallée, que s'ouvre au pied du Brezin, est étroite et tortueuse. Les angles salins engrenés dans les angles rentrants y sont extrêmement sensibles. Elle conduit au village de Brezin, que est situé derrière la montagne de ce nom. Au-dessus de ce village sont de grands et de beaux pâturages avec de chalets que n'y sont habits chuenete, et que l'on nomme les granges de Solaizan. C'est là que j'ai alloys coucher quand j'ai visité le Brezin et les montagnes voisines. Les granges de Solaizan sont dominées, au sud-est par le Mont Vergy, chaîne calcaire très élevée, dont j'ai aussi parcouru les sommets que s'y voyant de environs de Genève, sur la droite du Mole. Cette chaîne court du nord-est au sud-ouest, et vient s'y terminer derrière les montagnes que bordent notre route à droite. Section 447. On peut, de environs de Siang, observer la structure de la dernière montagne de cette chaîne. Elle est très remarquable. Les couches horizontales au sommet se courbent presque à angles droits, et descendant de la perpendiculairement du côté du nord-ouest. On droit qu'elles ont été ployées par un violent effort. On les voit séparées et éclatées en divers endroits. Section 449. Le Mole se termine à la jonction du Giffer avec l'Arve. Ces derniers couches descendant avec rapidité dans le lit de cette petite rivière. Les montagnes que suivent le Mole et que forment après lui le côté septentrional de la vallée de l'Arve, sont basses et indifferents. Un seul est remarquable par sa forme pyramidale, et par ses couches que convergent à son sommet, et lui donnant la forme d'un chevron. Section 450. La ville même de Cluse est bâtie sur le pied d'une montagne, dont la structure est très extraordinaire, en en jug mieux à un certain distance que de la ville même. Cette montagne de forme conique ici, au plutot parabolique, est pour ainsi dire coiffée d'une bande de rochers, que duo de sa tête descendant à droite et à gauche jusqu'à son pied. Ces rochers nuds sont relevés par le fond de verdure dont le reste de montagne est couvert. Ils sont composés de plusieurs bandes parallèles entre elles, les extérieures sont blanches et épaisses, les intérieures sont brunes et plus minces. Le corps même de la montagne, dont on aperçoit ca et la les rochers au travers du bois, que les couvre, pourrait composé de couches irrégulières et diversement inclines. On pourrait soupçonner que cette bande n'est que le reste d'une espèce de calotte que vraisemblablement couvrait autrefois toute la montagne. Section 463. Des que l'on est sorti de la ville de Close, on voit en se retournant sur la droite, les rochers en surplomb sous lesquels on a passé avant de traverser l'Arve. On distingue d'ici le profil de couches de ces rochers. Et on reconnaît qu'elles sont presque perpendiculaires à l'horizon. Ces couches sont adhesives à d'autres couches calcaires et verticales comme elles, mais que sont la continuation de couches à peu près horizontales, on droit une force inconnue apploie à angles droits à l'extrémité de ces couches. Il les a ainsi contraint à prendre une situation verticale. Section 467. Si du grande chemin que est au pied de la caverne, on jette les yeux sur le rocher dans lequel est son ouverture, on observera que les bancs de ces rochers sont très épais, et composés d'une pierre calcaire grise. Chuo de cette pierre grise on en voit un autre de couleur brune, dont les couches font très minces, mais que par leur répétition forment un épaisseur considerable. Ces couches de pierres à feuillets minces, continuant jusqu'à s'allanches et au-delà, ils sont renfermés par des entrées de bancs de pierre grise compactes et à couches épaisses. Quelquefois la pierre grise que sort de base, au comme descend les mines, de plancher à la brune, s'enfonce et alors celle-ci pourrait à fleur de terre, et leur cette pierre grise se relève et porte la brune à une grande hauteur. Cette pierre brune et feuilletée est comme la grise de nature calcaire. Mais un mélange d'argile, et peut être un peu de matière grasse au phlogistique lui donnant sa couleur brune et la disposant à se rompre en fragments angulaires et à côtes planes. Ce genre de pierre est fort sujet à avoir ses couches fléchies au ondes en forme de s de z au de c près de la caverne, on voit un lacune dans le milieu de bancs du roc gris. Les couches minces ont rempli cette lacune, mais elles sont dans cet espace extrêmement tourmentés. On comprend que ce vide et ce remplacement, se sont faits dans le temps même de la formation de ces rochers. We have the following description of the Cascade Mountain, page 396. Les couches de cette montagne sont la continuation de couches supérieures du rocher de la Cascade, et forment de arcs concentriques, tournes en sens contraires. En sorte que la totalité de ces couches à la forme d'une S, dont la partie supérieure se recourbe fort en arrière. Le rocher de la Cascade, représente par la planche fort. Est tout calcaire. Les couches, que sont au-dessus de lettre D et D, sont composés de ces rocs gris compacts dont les bancs, comme nous l'avons vu plus haut, sont ordinairement épais, mais les couches extérieures entre E et F, sont du roc brun à couches minces. Dont nous avons aussi parlé. Ces mêmes couches minces se voyant encore à l'intersection de perpendiculaires que passent par lettre A et T. Ici don't say le roc gris que est renferme entre du bancs de roc brun au lu chuopers de la caverne, si toit le roc brun, que y toit resserre entre du bancs de roc gris. Mais cette différence n'est pas si chuil et de plus difficile à expliquer, c'est la forme archi de ces grandes couches dont il faudrait rendre raison. Having measured this rock geometrically, the result is as follows. Le plus grand de arcs de cercle que forment ces couches extérieurs de ces rochers, a donc pour cord en ligne d'environ 800 pieds, dans tout cet étendu. Ces couches de même que les intérieurs sont suivis sans interruption. Je dois cependant avertir, en avant du rocher de la cascade à la hauteur de la lettre A, et au-dessus, en voie de couches détachées de circulaires, et indépendants d'elles. Ces sont de plans inclines en appui contre le corps de la montagne, semblables à ce que j'observe au pied du mont Salive, et d'une formation vraisemblablement plus récente que le corps même de la montagne. Mais derrière ces plans, on voit les couches arquées, que sont horizontales dans le bas, serveur de base au rocher, et relèver en soute sur la droite, et venir en tournant former le fait de ces mêmes rocher. It may be interesting to hear our author's reasoning upon this subject, more especially as it will give more faith or light, if it were possible, to his descriptions, which are irreproachable. Section 473. Il s'adroit à présent de dire quelle force pu donner à ces couches cette situation, comment elles out pu être rétrécies de façon que les plus basses soient devenues les plus élevées. La première idée que s'y présente est celle de aux souterrains. Ce que pourrait même faire soupçonner que ces couches ont été réellement relevées par une force souterraine c'est que, sur la droite du rocher qu'elles forment. Il y a un vide où il manque à peu près ce qu'il faudrait pour former la hauteur de la cascade. Car la montagne que l'on voit sous les lettres G et H, est sur une ligne beaucoup plus reculée. Sur la droite de ces vide ces couches recommencent sur la ligne de celles qui sont recourbées. On les voit capiz à pic de leur côte, avec les mêmes coulas, la même épaisseur, mais dans une situation horizontale. J'observe dans plus d'une montagne de couches ainsi rétrécies, opers desquels on voit le vide qu'elles paroissent avoir les NSE repliant sur elles-mêmes. Dans l'ober hasli la vallée de Miringen au-dessus du village de Stein. Dans le canton de Uri, sur le bord du lac de Lucerne, on en voit aussi plusieurs exemples bien distincts. Une montagne plus rapprochée de notre cascade, et que présente aussi ces phénomènes, est située derrière elle au nord-est entre le village de Ces et les granges de Fons. Cette montagne porte le nom d'Anterne. Elle est plus élevée que celle du Nantes d'Arpenaz, ses couches forment de arcs concentriques plus grands et plus recourbes encore, et elle en voit de même à leur droite un vide qu'elles semblent avoir les NSE levant et se repliant sur la gauche. Mais malgré ces observations, ce n'est pas sans peine que j'ai recours à ces agents presque surnaturels, surtout quand j'ai en aperçoit aucun de leurs vestiges, car cette montagne et celle d'alentour n'y laissent apercevoir aucune trace du feu. J'ai les donc cette question en suspens, j'y reviendrai plus d'une fois, et même avant la fin de ce chapitre. Il faut à présent jeter un coup d'œil sur les montagnes de l'autre côte de l'Arve. Section 474. Vis-à-vis de la cascade de l'autre côte de la rivière, on voit un chaîne de montagnes extrêmement élevées, que présentent leurs escarpements au-dessus de Salanches, et contre le Mont Blanc. Leurs couches descendent par conséquent vers la vallée du Reposoir, située à leur pied au nord-ouest. Mais au pied des escarpements de cette même chaîne, on voit un rangée de basses montagnes parallèles à sa direction, inclines en appui contre ces escarpements et que descendent en pente douce vers Salanches. De même encore une fois au Mont Salive. Section 475. De la cascade jusqu'à Saint-Martin, on voit fréquemment à sa gauche de couches singulièrement contournées, et toujours dans cette espèce de pierre calcaire brune que nous suivons depuis si longtemps. Quelques-uns de ces couches forment presque un cercle entier, les plus remarquables sont à un demi-lieu de la cascade. Elles représentent de arcs dont les convexités se regardent à peu près comme dans un X. Mais avec de plans situés obliquement entre les deux convexités, et de couches planes et horizontales immédiatement au-dessus de l'arc de la gauche. Ces diverses couches sont si bien suivies dans tous leurs contours, et si singulièrement entrelacées que j'ai peine à croire qu'elles ayant été formées dans une situation horizontale. Et tu ensuite de bouleversements leur ayant dans ces positions bizarres. Déjà il faudrait supposer que ces bouleversements sont faits dans un temps où ces couches étaient encore molles et parfaitement flexibles, car en ny voit rien de rompu, leurs courbes, même les plus angulaires, sont absolument entières. Ensuite il faudrait, que ces couches, dans cet état de mollesse, eussent été froissées et contournées d'une manière tout à fait étrange, et presque impossible à expliquer en détail. Dès lors de explosions souterraines rampantes, déchirant, et ne soulevant pas avec le management qui exigerait la conservation de continuité de toutes ces parties. La cristallisation put seule, à mon avis, rendrait raison de ces bizarreries. Nous voyons, comme j'ai déjà dit, de albères formes pour ainsi dire sous nos par de vraies cristallisations dans les crevasses, et dans les cavernes de montagnes. Presenter de couches dans les skels on observe de jeux tout aussi singuliers 49. Je ne répugnerais donc pas à croire que le rocher de la cascade a pu être formé dans la situation dans laquelle il est présent. Si void à essayer droit, ces couches que, bien que suivies, montrent pourtant quelques ruptures dans les flexions un peu fortes, et ces grands bancs de cette pierre grise compacte, que ne point si sujet à ces formes bizarres. En establissant pas un différence sensible entre elles et celles que nous venons examiner. It is impossible to be more impartial than M. de Saussure has proved himself to be on this occasion, or to reason more in the manner in which every philosopher ought to reason on all occasions. But to see the full value of this author's impartiality, notwithstanding of his system, let us follow him in the second volume of Voyages dans les Alpes. It is in chapter 20, entitled, Puddings de Valeur Sign, that we find the following description, with his reasoning upon that appearance. En voit là, page 99. Que la base de cette montagne est un vrai granite gris à grains médiocres, et dont la structure n'a rien de distinct. Mais au-dessus de ces granites on trouve de roches feuilletées quartzieuses mélanges de mica et de feldspath genre moyen entre le granit vein et la roche feuilletée ordinaire. Leurs couches courant du nord au sud, comme la vallée de Valorcine, font avec l'horizon un angle de 60 degrés, en s'appuyant au couchant contre cette même vallée. Ces roches continuant dans la même situation jusqu'à ce que après un demi-heure de marque, on les perd de vue sous la verdure que tapisse un petit plain, situé au milieu de bois, et que s'y nomme le plan de Sébiens. Section 689. De là, en montant obliquement du côte du sud, on rencontre de grands blocs d'un schiste gris au de couleur de l'Idavin, quelquefois même d'un violet decide, que renferment en grande quantité de cailloux étrangers, les uns angulaires. Les autres arrondis, et de différentes grosseurs, depuis celle d'un grain de sable jusqu'à celle de la tête. J'ai fus curieux de voir ces puddings dans leur lunatal, j'ai monté droit en haut pour y arriver, mais laquelle ne fut pas mon étonnement de trouver leurs couches dans une situation verticale. Section 690. On comprendra sans peine la raison de cet étonnement sil on considère qu'il est impossible que ces puddings ayant été formés dans cette situation. Que de particules de la plus extrême ténuité, suspendues dans un liquide, puissent s'agglutiner entre elles et former de couches verticales, c'est ce que nous avons la preuve en fait dans les albères, les agaths. Et même dans les cristallisations artificielles. Mais tu pierre tout formé, de la grosseur de la tête, soit arrêté au milieu d'une poroise verticale, et attendu là que les petites particules de la pierre vincent l'envelopper, la souder et la fixer dans cette place. C'est une supposition absurde et impossible. Il faut donc regarder comme une chose démontrée, KCES puddings ont forms don en position horizontale, ou à peu près tel, et redresses, and soot après leurs endurcissement. Quelle est la cause que les redresses? C'est ce que nous ignorons encore. Mais c'est déjà un pas important, au milieu de la quantité prodigieuse de couches verticales que nous rencontrons dans nos Alpes. Que den avoir trouvé quelques-uns dont on soit parfaitement sur quels ont été forms dans une situation horizontale. Section 691. La nature même de la matière qui enveloppe les cailloux de ces puddings rend ce fait plus curieux et plus décisif. Car si toit un pot en forme et grossière, on pourrait croire que ces cailloux et la pot que les ont été jetés pêle-mêle dans quelques crevasses verticales, ou la partie liquide s'est endurcie par le dessèchement. Mais bien loin de là, le tissu de cette pot est d'une finesse admirables, c'est un schiste, dont les feuillets élémentaires sont excessivement minces, mêlés de mica, et parfaitement parallèles aux plans que divisent les couches de la pierre. Ces couches même sont très régulières, bien sauvés et de différentes épaisseurs, depuis un demi-pouce jusqu'à plusieurs pieds. Celles que sont minces contenant peut être quelquefois point de cailloux étrangers, et on observe quelques alternatives de ces couches minces sans cailloux et de couches épaisses que en contenant. La couleur du fond de ces schistes varie beaucoup. Il est ici gris, la verdâtre, le plus souvent violet ou rougeâtre, on en voit aussi que est marbre de ces différentes couleurs. Ces couches sont dirigiées du nord au sud exactement comme celles de roches granitoides que sont au-dessus, section 688. Mais l'inclinaison du schiste est beaucoup plus grande, ces couches sont souvent tout à fait verticales, et lorsqu'elles ne le sont pas, elles montent de quelques degrés du même côté que les roches dont je viens de parler. C'est d'ailleurs, du côté de l'ouest. Section 692. Les cailloux enclaves dans ces schistes sont, comme j'ai dit, de différentes grandeurs, depuis celle du grain de sable, jusqu'à 6 ou 7 pouces de diamètre. Ils appartiennent tous à la classe de roches que j'appelle primitives, GNYAI cependant pas vu de granit en masse, seulement de granits feuilletés, de roches feuilletées, mélanges de quartz et de mica, de fragments même de quartz pur. Mais absolument aucun schiste purement argileux, ni aucune pierre calcaire, rien que fit effervescence avec l'eau forte, et la pot même que renferme ces cailloux en fait aucune. Leur forme varie. Les uns sont arrondis et ont manifestement perdu leurs angles par le frottement, d'autres ont tous leurs angles vifs, quelques uns même ont la forme rhomboïdale qui affectent si fréquemment les roches de ces genres. Dans les parties de la pierre ou ces cailloux étrangers sont entassés en très grand nombre, les éléments du schiste n'ont pas eu la liberté de s'arranger et de former de feuillets parallèles. Mais partout où les cailloux laissent entre eux de intervalles sensibles, les feuillets reparoissent, et sont constamment parallèles, et entre eux et aux plans que divisent les couches. Section 693. Les bancs de ces schistes puddings forment dans la montagne en épaisseur d'environ 100 toises, comme de l'est à l'ouest transversalement aux couches, et gelai suivi dans le sens de la longueur l'espace de plus d'un lot. On ne peut pas la suivre plus longtemps, parce que les bancs s'y cachent et s'enfoncent sous la terre. Here M. De Saussure, who is always more anxious to establish truth, than preserve theory, gives up the formation of the Alpine strata by crystallization. Let us now see how he acknowledges the evidence of softness in those strata. It is in his description of the Val de Montjoie, Tom. 2d, page 173. Ce sont de roches dures au fond de quartz, au lieu de feldspath blanc, confusement cristallise, avec de veins noirs de mica au lieu de chorle en petites lames. Ces veins, que pénétrent tout au travers de la pierre, sont la section de couches dont elle est composée, on les voies, ici planes et parallèles, entre elles, la en zigzags, renfermes entre de plans parfaitement parallèles. Accident donc les étoffes tout à la fois res et chinis donnant encore le dessin. Ces en fractuosites de couches sont elles un effet de la cristallisation, ou bien d'un mouvement de pression que refoule de couches planes lorsqu'elles étoient encore flexibles, après quoi d'autres couches planes sont venues se former sur elles. De Saussure has no idea of strata formed at the bottom of the sea, being afterwards softened by means of heat and fusion. He had already given up the supposition of those vertical or highly inclined strata having been formed in their present position. But had this geologist seen that it was the same cause by which those strata had both been raised in their place and softened in their substance, I am persuaded that he would have freely acknowledged, in this zigzag shape, which is so common in the alpine strata, the fullest evidence of the softening and the elevating power. At the Tour de Foles, near Saint Bernard, de Saussure found an appearance the most distinct of its kind, and worthy to be recorded as a leading fact in matters of geology. Voyages dans les Alpes, tome 2d. Pag. 454. La direction générale de couches de ces rochers et de ardoises que les séparent, est donc du midi au nord, ou plus exactement du sud-sud-ouest au nord-nord-est. Mais cette direction est capée à angles droits par de couches d'ardoises et de feuilles quartzo, que passent du levant au couchant par le milieu de couches que courant du midi au nord. Clearly as this fact must demonstrate, to a reasoning person, the fracture and dislocation of strata, our author, who knows so well the reasoning of naturalists on such an occasion, gives us his opinion as follows, quant à la raison de ce fait. On peut l'attribuer à de bouleversements, et c'est ce qui paroit le plus vraisemblable. On pourrait cependant supposer qu'il existoit au milieu de ces couches un grande fissure, que a été remplie par de couches transversales. Mais il faudrait pour cela que ce remplissage se fait dans le temps même de la formation de ces montagnes, puisque les ardoises et les pyramides quartzieuses, donc la direction est transversales, sont précisément de la même nature que les autres. Et il faudrait encore supposer, qu'elles ont été formes dans la situation très inclinée qu'on leur voit aujourd'hui, supposition qu'elles en aura quelque peine à admettre. In this second volume, M. de Saussure gives us a general view with regard to the mountains which border the valley of the Rhône, page 543. Section 1095. Cette suite de montagnes calcaires que nous avons côtoyées depuis Street Maurice jusqu'à Chillon, n'y présente presque nulle part de couches régulières et horizontales, elles sont presque partout inclines, fléchies. Et paroissent avoir été tourmentées par de causes violentes, car de simples effacements n'y suffisent pas à manger pour rendre raison de toutes leurs formes. Leurs escarpements sont aussi assez irrégulièrement situés, la plus grande partie d'entre eux paroit cependant tourner du côté de la vallée du Rhône. La suite de montagnes que correspond à celle-ci sur la rive gauche du Rhône et du lac est aussi calcaire, et à peu près aussi irrégulière. La plupart de ces montagnes, celles surtout que sont les plus voisines du lac, sont escarpées, et du côté du lac et de celle du Rhône. Les vallées que les séparent paroissent les diviser en chaînes parallèles au lac, que courant du nord-est au sud-ouest. Les plus voisines du lac sont escarpées contre lui, comme je viens de le dire, tandis que les plus éloignées du lac, ou les plus proches du centre de Alpes, sont inclines contre ces mêmes Alpes. Le Val de l'Aie sépare ces deux ordres de montagnes, cette vallée riche et fertile à la fourmi d'un berceau. Les deux chaînes que l'abordent s'élevant en pente douce de son côté, et tournant leurs escarpements, l'un contre le lac, l'autre contre les Alpes, au reste JNAI point parcouru ces montagnes, JNAI pu en juger chuen les observant de loin. Mais ce dont on peut être certain, c'est que, si les montagnes que bordent ces deux rives de la vallée du Rhône, si ressemblant par leur nature, que est calcaire de part et d'autres els nesi ressemblant point par leur structure. On ny voit aucune correspondance, ni dans les positions, ni dans les formes, les valeurs que les séparent nesi correspondent pas non plus. Ce défaut de correspondance me pourrait encore révéler l'idée de bouleversements. The general result, from these observations of our author, is this. First, there is no distinction to be made of what is termed primary and secondary mountains, with regard to the position of their strata. Every different species of stratum, from the stratified granite and quartzy schistous of the Alps to the oolites of the Jura and Salève, being found in every respect the same. Whether this shall be supposed as arising from their original formation, or, according to the present theory, from a subsequent displacement of strata formed originally in a horizontal situation. Secondly, it appears that, in all those alpine regions, the vertical position of strata prevails. And that this appearance, which seems to be as general in the alpine regions of the globe as it is here in the mountainous regions of the Alps, has been brought about both by the fracture and flexure of those masses, which, if properly strata, must have been originally extended in planes nearly horizontal. Whereas, in descending from that mountainous region towards the more level country of France, the same changes in the natural position of strata are observed, with this difference, that here they are in a less degree. Now that those vertical strata had been originally formed at the bottom of the sea is evident from this author's observation, which has been already referred to, volume 1, page 23. Thirdly, in all those accurate observations of a naturalist, so well qualified for this purpose, there appears nothing but what is perfectly consistent with such a cause as had operated by slow degrees, and softened the bodies of rocks at the same time that it bended them into shapes and positions inconsistent with their original formation, and often almost diametrically opposite to it. Although there appeared to our author an insurmountable difficulty in ascribing those changes to the operation of subterranean fire, according to the idea hitherto conceived of that agent, this grand mineral view of so large a tract of country is the more interesting, in that there has not occurred the least appearance of volcanic matter, nor basaltic rock, in all that space. Where so great manifestation is made of those internal operations of the globe by which strata had been consolidated in their substance, and erected into positions the most distant from that in which they had been formed. It is peculiarly satisfactory to me, and I hope also to my readers, to have the observations of so able a philosopher and so diligent a naturalist to offer in confirmation of a theory which had been formed from appearances of the same kind in a country so far distant from those of our author now described, as are the Alps of Savoy from those of Scotland. It gives me a singular pleasure, in thus collecting facts for the support of my opinion, to contribute all I can to recommend the study of a work in natural history the most exemplary of its kind, and a work which will remain the unalterable conveyance of precious information when theories making a temporary figure may be changed. To a person who understands the present theory, there can be no occasion here to give the particular applications which will naturally occur in reading those various descriptions. In these examples are contained every species of bending, twisting, and displacement of the strata, from the horizontal state in which they had been originally formed to the vertical, or even to their being doubled back. And although M. de Saussure had endeavored to reason himself into a belief of those inverted strata having been formed in their present place, it is evident that he had only founded this opinion upon a principle which, however just, may here perhaps be found misplaced. It is that of not endeavoring to explain appearances from any supposition of which we have not full conviction. I flatter myself, that when he shall have considered the arguments which have here been employed for the manifold, the general operations of subterranean fire, as well as for the long-continued operations of water on the surface of the erected land, he will not seek after any other explanation than that which had naturally occurred to himself upon the occasion, and which he most ingenuously declares to have great weight, although not sufficient to persuade him of its truth. Chapter 2. The same subject continued, with examples from different countries. Our theory, it must be remembered, has for principle, that all the alpine as well as horizontal strata had their origin at the bottom of the sea, from the deposits of sand, gravel, calcareous and other bodies, the materials of the land which was then going into ruin. It must also be observed, that all those strata of various materials, although originally uniform in their structure and appearance as a collection of stratified materials, have acquired appearances which often are difficult to reconcile with that of their original, and is only to be understood by an examination of a series in those objects. Or that gradation which is sometimes to be perceived from the one extreme state to the other, that is from their natural to their most changed state. M. de Saussure, who will not be suspected of having any such theory in his view, will be found giving the most exemplary confirmation to that system of things. I would therefore beg leave farther to transcribe what he has observed most interesting with regard to that gradation of changed strata. It is in the high passage of the Bon Tom. 2, page 179. Depuis le col, dont je viens de parler, jusqu'à la croix, que suivant el usage, est placé au point le plus élevé du passage, en a 3 quarts de l'eau, au un petit aire de route, dans lequel on traverse de graisse, de breaks calcaires. De pierres calcaires simples de couleur grise, d'autres calcaires bleuâtres et de ardoises, ces alternatives se répètent à plusieurs reprises. Parmi ces graisses on en trouve que renferment de quelques roules, et que font effervescence avec les acides, d'autres que any renferment point de quelques, et que any font point d'effervescence. Quelques uns de ces graisses aiment par remarquables par leur ressemblance avec de roches feuilletées, ils sont compacts mêlés de mica. On suc quartz remplit tous les interstices de leurs grains, et leur donne un durid et un solidite singuliers, il ny a personne, que en voyant de morceaux détachés de cette pierre, en la prit pour un roche feuilletée. Mais quand on la trouve dans le lieu de sa formation, et qu'on voit les gradations que l'alliant avec de graisses indubitables, par exemple avec ce que renferment de quelques roules, on any put plus d'autres de sa nature. Ces couches sont en general inclines de 30 degrees en descendant au sud-est. Our author would here make a distinction of the roche feuilletée and the graisse. The one he considers as primitive, and as having had an origin of which we are extremely ignorant, the other he considers as a secondary thing, and as having been formed of sand deposited at the bottom of moving water, and afterwards becoming stone. This great resemblance, therefore, of those two things so different in the opinion of naturalists, struck him in that forcible manner. Nothing can be a stronger confirmation of the present theory, which gives a similar origin to those two different things, than is the observation of so good a naturalist, finding those two things in a manner undistinguishable. He thus proceeds, J'ai vu dans les Vosges de très beaux graisses du même genre, ils n'y ressemblant cependant pas autant à de roches primitives, parce que ils n'y continuent pas de mica. Mais ce qu'il y a ici de plus digne d'attention, et que l'on n'y voit point dans les Vosges, c'est de trouver de graisses de cette nature renfermes entre de bancs de pierre calcaire. Cependant plus ces graisses éloignent de la roche primitive, que formi la base de la montagne, et moins ils sont solides et quartz jusqu'à ce qu'enfin les plus élevés font effervescence avec l'eau forte. Here again the alpine limestones, which, according to the present naturalists, should be primitive, are plainly homologated in their origin with strata formed of sand. Our author proceeds, p. 181, section 765, le haut du passage du bon homme, au pied de la croix est d'ardoises minces mêlées de feuillets de quartz. En descendant au Chaper, on trouve ces mêmes ardoises alternant avec de couches de graisse mince feuilletée, mêlées de mica, plus de calcaires simples, plus de breaks calcaires que renferment de fragments calcaires à angles vifs. Tout ces couches descendant au sud-est suivant la pente de la montagne, mais avec un peu plus de rapidité. Comme cette montagne est absolument dégarnie d'arbres, on y voit d'un coup d'œil les progrès de l'action de os. Des cylindres à peine visibles dans le haut, s'élargissent et s'approfondissent graduellement vers le bas, ils forment enfin de ravines profondes, que l'on pourrait presque nommer de vallées. Ces cylindres ramifient sur toute la pente de la montagne et remplissent encore de neige, tandis que leurs intervalles sont couverts de gazon, formant sur ces fonds verts une broderie blanche, dont lf it est extremement singulier. Lorsque je passai là, le 13 juillet 1774, tous les enfoncements de ces neige étoyant couverts de la poudre rouge que j'ai décrite section 646. Vers la bas de la descente, on trouvait de chalets que j'ai émidonné de voir construits en pierres de taille, d'une forme très régulière. J'ai demandé la raison de cette recherche, pour commune dans les montagnes, et j'ai appris que c'est toute la nature que avait fait tous les phrases de cette taille. Effectivement j'ai trouvé un peu plus bas un profond ravine, creusé par les eaux dans de couches d'un beaugrès que se devise de lui-même, et que l'envoie dans sa position originelle actuellement devise en grands parallélépipèdes rectangles. SCE un retrait opéré par le dessèchement, OUNSCE par plutot l'effacement successif de couches que les a devises de cette manière. C'est CE que j'ai ne desidérai pas dans CE cas particulier. The only thing which, in this particular case, makes our author express his wonder, is the extreme regularity of these natural divisions of stone. For, the same appearances are to be found in every case of consolidated strata, though not always with such extreme regularity. But this is one of the most irrefragable arguments for those various bodies having been consolidated by means of heat and fusion. The contraction of the mass, consolidated by fusion or the effect of fire, is the cause of those natural divisions in the strata. And the regularity, which is always to be observed more or less, depends upon the proper circumstances of the case, and the uniform nature of the mass. Page 184. Le matin avant de partir du Chaper, j'ai allé voir si les beaux gres rectangulaires, que j'ai avoir observes la vale descendant jusqu'au bas de la montagne. J'ai trouvé effectivement de gres mais à couches minces, et que ne divisoyant point avec régularité. En revanche, j'ai vu de couches de ces gres ployés et reployés en zigzags, comme celles que j'ai avoir rencontres aux contamines, section 755, et ces couches ondes étoyant aussi renfermées entre de couches planes et parallèles. Ce phénomène est bien plus rare dans les gres, que dans les roches feuilletées proprement dites. Thus every appearance is found by which the primitive schiste are perfectly resembled, both as to their original formation and their accidents, with the strata, which are acknowledged by naturalists as being the common operation of the sea. Our author then gives an account of the passage to Fours, in which he makes the following observations. Section 776. Tout près du sommet du col, on rencontre de beaux bancs de grès jaunâtre que sortent de dessus la pierre calcaire, et que portent en font aucune effervescence avec les acides. Section 777. J'ai mis du et trois quarts au montre depuis le hameau du glacier jusqu'au haut du col, d'où l'on descend à la croix du bonhomme. J'envoie mes mulets m'attendre à cette croix, et j'ai m'accompagné avec Pierre Baume sur ma droite, pour atteindre le fait de la montagne dont la cime arrondie me paroissoit devoir dominer sur toutes les montagnes d'alentour. J'ai donné à cette sommet, que n'avoit point de nom, celui de cime de Fours, cause du passage chuel domini. De grandes plaques de neige couvroyant en divers endroits la route que j'ai avoir à faire pour y aller. Le roc est montroit cependant assez pour que l'on put reconnoitre sa nature. Section 778. J'ai traversé d'abord de couches de grès que toyant la continuation de celles dont j'ai viens de parler, section 776. J'ai trouvé ensuite de banks d'une espèce de pudding grossière, dont le fond étoit ce même grès rempli de cailloux arrondis. Quelques uns de ces banks se sont décomposes, et les eaux out entraînent les parties de sable que lioyant les cailloux, en sorte que ceux-ci sont demeures libres et entassés exactement comme au bord d'un lac ou d'une rivière. Il étoit si étrange de marcher à cette hauteur sur de cailloux roules, que Pierre Baume en témoigne son étonnement, même avant, que j'ai en parles. On aurait été tant de croire une cascade tout anciennement de quelque rocher plus élève, de trut dolors par le temps, avoid arrondi cesk lu. Si on nn trivoit pas assemblables encore enclaves dans les couches réguliers du Grèce que compose le haut de cette montagne. Section 779. Quoique depuis longtemps jne de plus que les os n'ayant couvert et meme form ces montagnes, et chuily en 8 meme de preuves plus fortes que l'existence de ces que lu rules. Cependant leur accumulation sur cette cime avoit quelque chose d'assez extraordinaire, et que parloit aux sens un langage assez persuasif, que jne pouvoir par revenir de mon étonnement. Cn marchant sur cesk lu, etn les observant, j'oubliois pour un moment le lu au jeitois, me croyois au bord de notre lac. Mais, pour peu que mes us écartassent à droite ou à gauche, voyais au-dessus de moi de profondeurs immenses, contraste avoit quelque chose que tenoit d'un rêve. Me representois alors avec un extrême vivacité les os remplissant tout ces profondeurs, venant battre et rendre à mes pites ces lu sur lesquels marquois. Tandis que les hautes aiguilles formoyant sols de isles au-dessus de cette mer immense. Me demandois ensuite quand comment ces os citoyent retirees. Mais il fallit émerature à ces grandes speculations et employer plus utilement mon temps à l'exacte observation de ces singuliers phénomènes. The fact here worthy of observation is the effect of time in decomposing this grass, or sandstone, which contains the gravel. All the other appearances follow naturally from the situation of this place, which is a summit, and does not allow of such a collection of water as might travel or transport the loose gravel. Although it has been sufficient for carrying away the sand. This decomposition of the sandstone we shall find also explained from what follows of the description of this place. Section 780. Tous les bancs de Grèce que l'envoient sur cette montagne n'y renferment pas de que lu rules. Il de alternatives irrégulières, de bancs de Grèce per, et de bancs de Grèce mêlés de que lu. Les plus élèves en consonant point. Le plus haut de ce que en renferment est un banc bien suivi d'un pied d'épaisseur, et que monte de 30 degrés au nord-nord-ouest. Quelques uns de ces bancs, remplis de que lu, offrant un particularité bien remarquable. Envoyed à leur surface extérieure, exposé à l'air, un espèce de réseau forme par de veines noirs solides, et s'élantis de 2 ou 3 pouces au-dessus de la surface de la pierre. Les mâles de ces réseaux sont quelquefois irréguliers, mais ces sont pour la plupart de quadrilatères obliquangles, dont les côtés ont huit à 10 pouces de longueur. Comme ces pierres ont toutes un tendance à se partager en rhomboids, il pourrait chuily eu anciennement de fence que divisoyent les bancs en parties de cette forme. Et que ces fence ont été remplies par du sable que a été cementé par un suc ferruginex, ce gluten solide a rendu ces parties plus dures que le reste de la pierre. Et lorsque les ingers de l'air ont rangé la surface de ces bancs, les mâles du réseau sont demeurés sailantes. Les que lu arrondis, que out été longtemps exposés à l'air, out aussi pris par dehors un teint morateur ferrugineux, mais ce que sont encore renfermes dans les bancs de Grèce ont comme lui un couleur jaunâtre. Jn travaille la aucun que n'y fut de nature primitive, en la plupart toyant de feldspath gris ou retraster, et confusement cristallise. Ce sont donc de pierres que n'ont point naturellement un forme arrondi. Etica, par conséquent, n'y tenant celles quelles ont ici, que du roulement, et du frottement de os. Tous ces grès font effervescence avec l'eau forte, mais les parties du réseau ferruginex en font beaucoup moins que le fond même du grès. De même si l'on compare entre les grès que renferment de que lu avec ce que n'en consonant pas, on trouve dans ceci plus de gluten calcaire, l'eau forte diminue beaucoup plus leur cohérence. Sur la cime même de la montagne, ces grès sont recouverts par un ardoise grise, luisante, que s'exfolie à l'air. Edsi l'on redescend de cette même cime par le nord-est, du côté oppose au passage de Fours, on retrouvera de banks d'un gres parfaitement semblable, et que se divisent la deux mêmes en petits fragments parallélépipèdes. Du haut de cette cime, a levée de 1396 toises au-dessus de la mer, on a un vue très étendu. Au nord et au nord-ouest les vallées de Montchoix, de Passy, de Salanches, au couchant la haute cime calcaire dont je parle, section 759. Au sud les montagnes que s'étendent depuis le Chaper jusqu'au col de la Seine, à l'est, ce même col que l'on domine beaucoup. Sur la droite de ce col, on voit du côté de l'Italie la chaîne du Cramant, et plusieurs autres chaînes que lui sont parallèles, tournent tous leurs escarpements contre la chaîne centrale, de même qu'on voit du côté de la Savoie. Les chaînes du Reposoir, de Passy, de Servoz, tournent en sens contraire leurs escarpements contre cette même chaîne. Car c'est là un de vues très étendus sur les deux côtes opposées de Alpes. Puisqu'on découvre d'ici les montagnes de Cormier et de l'Île Blanche, que sont du côté méridional de la chaîne, et celles du Faucigny et de la Tarentaise, que sont du côté septentrional. Or les sites d'où l'on jute tout à la fois de ces deux aspects sont très rares. Parce que les hautes cimes de la chaîne centrale sont presque toutes inaccessibles, et les cols par lesquels on la traverse sont presque tout tortueux, étroites, et n'y présentent pour la plupart que de vues très bornes. We have here two facts extremely important with regard to the present theory. The one of these respects the original formation of those alpine strata. The other the elevation of those strata from the bottom of the sea, and particularly the erection of those bodies, which have been formed horizontal, to their present state, which is that of being extremely inclined. It is to this last, that I would now particularly call the attention of my readers. It is rarely that such an observation as this is to be met with. Perhaps it is rarely that this great fact occurs in nature, that is, so as to be a thing perceptible. It is still more rare that a person capable of making the observation has had the opportunity of perceiving it. And it is fortunate for the present theory, that our author, without prejudice or the bias of system, had been led, in the accuracy of a general examination, to make an observation which, I believe, will hardly correspond with any other theory but the present. If strata are to be erected from the horizontal towards the vertical position, a subterraneous power must be placed under those strata. And this operation must affect those consolidated bodies with a certain degree of regularity, which however, from many interfering circumstances, may be seldom the object of our observation. If indeed we are to confine this subterraneous operation to a little spot, the effect may be very distinctly perceived in one view. Such are those strata elevated like the roof of a house, which M. de Saussure has also described. But when the operation of this cause is to be extended to a great country, as that of the Alps, it is not easy to comprehend, as it were, in one view, the various corresponding effects of the same cause, through a space of country so extensive, and where so many different and confounding observations must be made. In this case, we must generalize the particular observations, with regard to the inclinations of strata and their direction, in order to find a similar effect prevailing among bodies thus changed according to a certain rule. This rule then directs our understanding of the cause. The general direction of those alpine strata, in this place, is to run SE and NW, that is to say, this is the horizontal line of those inclined beds. We also find that there is a middle line of inclination for those erected strata in this alpine region. As if this line had been the focus or center of action and elevation, the strata on each side being elevated towards this lint, and declined from it by descending in the opposite direction. The view which our author has now given us from this mountain is a most interesting object, and it is a beautiful illustration of this theory. For, the breaking of the tops of mountains, composed of erected strata, must be on that side to which their strata rise. And this rupture being here towards the central line of greatest elevation, the ridges must in their breaking generally respect the central ridge. But this is the very view which our enlightened observator has taken of the subject. And it is confirmed in still extending our observations westward through the kingdom of France, where we find the ridges of the Jura, and then those of Burgundy gradually diminishing in their height as they recede from the center of elevation, but still preserving a certain degree of regularity in the course of their direction. But our author has still further observed that this is a general rule with regard to mountains. I will give it in his own words, Tom. 2, page 338. Section 918. Mais la chaîne centrale n'est pas la seule primitive Ly8 de ce côté de Alpes. Du haut du cramant nse tournant du côté de Italie, on voit un entassement de montagnes que s'étendent aussi loin que peut aller la vue. Parmi ces montagnes on en distingue un au sud-ouest que est extrêmement élevé, son nom est Ruder, lse présente au cramant et peu près sous le même aspect que le Mont Blanc à Genève. Sa cime est couverte de neige, un grand glacier descend de sa moyenne région, il en sort un torrent que vient se jeter dans la rivière de la Tuile. Cette haute montagne, de nature primitive, est au centre d'une chaîne de montagnes moins élevées, mais primitives comme elle, et que passent au-dessus du Val de Cône. On voit de la cime du cramant de montagnes secondaires situées entre le cramant et cette chaîne primitive, et on reconnaît que les couches de ces montagnes s'élèvent contre cette chaîne en tournant le dos à la chaîne centrale. Section 939. L'inclinaison du cramant et de la chaîne contre le Mont Blanc, n'est donc pas un phénomène que n'appartient à cette seule montagne. Il est commun à toutes les montagnes primitives, dont c'est un loi général que les secondaires que les bordent, ont de part et d'autre leurs couches ascendants vers elles. C'est sur le cramant, que j'ai fait pour la première fois, cette observation alors nouvelle, que j'ai vérifié ensuite sur un grand nombre d'autres montagnes, non pas seulement dans la chaîne des Alpes, mais encore dans diverses autres chaînes. Comme j'ai le ferai voir dans l'Oive. Volume. Les preuves multiplies que j'ai en avoir sous les yeux au moment où j'ai les fait, et d'autres analogues que ma mémoire me rappela d'abord, me feront soupçonner son universalite. Et j'ai la liai immédiatement aux observations que j'ai venoir de faire sur la structure du Mont Blanc et de la chaîne primitive dont il fait partie. J'ai voyé cette chaîne composée de feuillets que l'on peut considérer comme des couches. J'ai voyé ces couches verticales dans le centre de cette chaîne et celles de secondaires presque verticales dans le point de leur contact avec elles, le devenir moins à de plus grandes distances. EDS approcher peu de la situation horizontale à mesure qu'elles s'éloignent de leur point d'appui. J'ai voyé ainsi les nuances entre les primitives et les secondaires, que j'ai déjà observé dans la matière dont elles sont composées, s'étendre aussi à la forme et à la situation de leurs couches. Puisque les sommites secondaires que j'ai là sous les yeux terminent en limes pyramidales et tranchantes, tout comme le Mont Blanc, et les montagnes primitives de la chaîne. J'ai conclus de tout ces reports, que, puisque les montagnes secondaires avoient été formes dans le sein de aux Illinois falloit que les primitives eussent aussi la même origine. Retricant alors dans ma tête la suite de grandes révolutions qui subissent notre globe, j'ai vis la mer, couvrant jadis toute la surface du globe, former par de dépôts et de cristallisations successives. D'abord les montagnes primitives poussent les secondaires. J'ai vis ces matters s'arranger horizontalement par couches concentriques. Et ensuite le feu au d'autres fluides élastiques renfermes dans l'intérieur du globe, soulever et rompre cette écorce, et faire sortir ainsi la partie intérieure et primitive de cette même écorce. Tandis que ces parties extérieures aux secondaires demeurent appuyées contre les couches intérieures. J'ai vis ensuite les eaux se précipiter dans les gouffres crèves et vides par l'explosion de fluides élastiques, et ces eaux, en courant à ces gouffres, entraîner à de grandes distances ces blocs énormes que nous trouvons épars dans nos plaines. Je vis enfin après la retraite de aux les germes de plantes et de animaux, féconds par l'air nouvellement produit, commencer à se développer, et sur la terre abandonnée par les eaux, et dans les eaux mêmes. Que essereteront dans les cavités de la surface. Tels font les pensées que ces observations nouvelles m'inspireront en 1774. En verra dans l'oive. Volume comment deux ou trois ans d'observations et de réflexions continuelles sur ces mêmes sujets auront modifié ces premiers germes de mes conjectures. J'en parle ici chu historiquement, et pour faire voir quelles sont les premières idées que le grand spectacle du crament doit naturellement faire éclore dans un tête que n'est encore épause aucun système. How far these appearances, which had suggested to this philosopher those ideas, agree with or confirm the present theory, which had been founded upon other observations, is here submitted to the learned. We have now not only found a cause corresponding to that which can alone be conceived as producing this evident displacement of bodies formed horizontally at the bottom of the sea, but we have also found that this same cause has operated everywhere upon those strata, in consolidating by means of fusion the porous texture of their masses. Now when the evidence of those two facts are united, we cannot refuse to admit, as a part of the general system of the earth, that which is everywhere to be observed, although not everywhere to such advantage as in those regular appearances, which our author has now described from those alpine regions. I have only one more example to give concerning this great region of the Alps belonging to Savoy and Switzerland. It is from the author of Les Tableaux de la Suisse. 50. On s'embarque à Fleulen à un demi-lieu d'Altorf sur le lac de Cotter Waldstoet ou cantons forestiers, les bords de ce lac sont de rochers sauvant à pic et d'une très grande élévation et la profondeur de ses eaux proportionnée. Ces roches sont toutes calcaires, et sauvant remarquables par la position singulière de leurs couches. Et un demi-lieu environ de Fleulen, sur la droite, de couches de 6 pouces environ d'épaisseur sont déposés en zigzags comme un tapisserie de pointe hongrie. A un lieu de mai à côté de couches bien horizontales, de 4 à 5 pieds d'épaisseur ilyn de contournées de formes circulaires et d'elliptiques. Il serait difficile de se faire une idée de la formation de pareilles couches, et d'expliquer comment les ont pu les déposer ainsi. Having thus given a view of a large tract of country where the strata are indurated or consolidated and extremely elevated, without the least appearance of subterraneous fire or volcanic productions, it will now be proper to compare with this another tract of country, where the strata, though not erected to that extreme degree, have nevertheless been evidently elevated, and, which is principally to the present purpose, are superincumbent upon immense beds of basalts or subterranean lava. This mineral view is now to be taken from M. de Luc, Lettres physiques et morales, tom. 4. This naturalist had discovered along the side of the Rhine many ancient volcanoes which have been long extinct. But that is no part of the subject which we now inquire after. We want to see the operations of subterraneous lava which this author has actually exposed to our view without having seen it in that light himself. He would persuade us, as he has done himself, that there had been in the ancient sea volcanic eruptions under water which formed basaltic rocks, and that those eruptions had been afterwards covered with strata formed by the deposits made in that sea, which strata are now found in the natural position in which they had been formed, the sea having retreated into the bowels of the earth, and left those calcareous and arenaceous strata, with the volcanic productions upon which they had been deposited, in the atmosphere. It would be out of place here to examine the explanation which this author has given with regard to the consolidation of those deposited strata which is by means of the filtration of water. But as in this place there occurs some unusual or curious examples of a particular consolidation of limestone or calcareous deposits, as well as similar consolidations of the siliceous sort, it may be worth while to mention them in their place that so we may see the connection of those things, and give all the means of information which the extremely attentive observations of this naturalist has furnished to the world of letters. At Oberwinter our author remarks a stratum of consolidated sand above volcanic matter, Tome 4, page 162. Tant que j'ai parcouru le pays du cône, j'nai vu un terrain composé de ces débris, et cultive en vigne. Mais après l'avoir dépassé, j'ai trouvé la coupe verticale d'une colline à couches pierreuses, si régulières, que j'ai les prises au premier coup d'œil pour de la pierre à chaud. L'esprit de niter ma de trompe, c'est un pierre sableuse très compact, dont les couches, que en sauvant que quelques pouces d'épaisseur. Es élevant par un pente insensible vers le cône volcanique tuel recouvrant de ces côtes-là sans aucune apparence de désordre. Ces couches que sont visiblement de dépôts de la mer, quoique j'n'ai pas trouvé de corps marins, ont été forms depuis que le cône est d'olive. This is a species of reasoning which this acute naturalist would surely not have let pass in any other cosmologist. But here the love of system, or a particular theory, seems to have warped his judgment. For, had our author been treating of beds or bodies deposited in water, and preserving the natural situation in which they had been formed, he would have had reason to conclude that the superior bed was of the latest formation. But here is no question of superincumbent strata, it is a stratum which is superincumbent on a lava, and it is equally natural to suppose the lava posterior to the stratum as the stratum posterior to the lava. Our author meets with a limestone too much erected in its position to be supposed as in its natural place, and then he explains this phenomenon in the following manner, page 333. Les rochers d'Arentbreitstein et de Lonstein sont donc de fait particuliers. Ces rochers la ont été formes par de dépôts de la mer, les corps marins ils renferment en font foi. This lors ils ont dû avoir dans leur origine la seule position que la mer peut leur donner, el horizontal ou légèrement incliné. Leurs couches sont aujourd'hui rompues, et leur inclination n'est plus celle de dépôts immédiats de la mer. Les collines, auxquelles elles appartenuient, sont en même temps entourées de volcans anciens, et il est naturel d'en conclure, que c'est à use que ces grands rochers doivent leur position actuelle. Here one would expect our author is to allow that volcanoes may erect rocks in heightening them in their place, but this is not the light in which it has been seen by him, as will appear from what follows. L'enfoncement d'une de leurs côtes n'est rien, quand on considère le prodigious excavation que ont dû s'y faire, pour porter au dehors toutes les montagnes, les collines, et les plains volcaniques que s'y trouvent dans ces vast circuit. When a small portion of a stratum is examined, such as the present case, it is impossible from inspection to determine, whether it owes its inclined position to the sinking or the raising of the ground. The stratum is changed from its original position, but whether this has been brought about by the raising of the one side, or the sinking of the other is not apparent from what then is seen. But unless we are to explain the appearance of strata above the level of the sea by a supposition which is that of the retreat of the ocean, a theory which this author has adopted, it is as impossible to explain the present appearance of horizontal strata as of those that are inclined. At the same time, if a power placed below the strata is to be employed for the purpose of raising them from the bottom of the sea, to the place in which we find them at present, it is impossible that this should be done without the fracture of those strata in certain places. And it is much more difficult to conceive this operation not to be attended with changing the natural horizontal position of strata, and thus leaving them in many places inclined, than otherwise by supposing that this internal power of the globe should elevate the strata without changing their original position. With this description of strata on the Rhine, we may compare that of M. Monet respecting those which he found upon the Meuse, Nouveau Voyage Minéralogique, etc. Journal Physique, A. Aust, 1784. Speaking of the schistus, or slate, he adds, mais ces petites veines nous donnent lieu de faire une observation importante. C'est qu'elles s'y présentent à ces communes perpendiculaires, tandis que les grandes banques d'ardoises, ce qu'on exploite, sont, comme nous l'avons dit, couches sur une ligne de 15 à 20 degrés. J. parle de montagnes de marbre que sont derrière Givet, et de celles sur lesquelles est situé Charlemont. J. fait voir que bien loin que les banques de marbre, que forment la montagne du givet, soyant horizontox comme on seroit tant de le croire, d'après les principes de quelques naturalistes systématiques. Que pensent que tous les bancs de pierres calcaires ne soroyant être autrement. J'ai fait voir, dis je, que ces bancs sont presque perpendiculaires à l'horizon, et de plus, ils sont tellement cols les uns contre les autres, tu peine on peut les distinguer. The changed structure and position of the strata, now exemplified from the observations both of M. de Saussure and M. de Luc, observations made in a great extent from France to Germany, show the effects without the means by which those effects had been produced. And, in this case, it is by judging from certain principles of natural philosophy that the cause is discovered in the effect. We are now to see the displacement of at least a great body of earth in another light, by having at the same time in our view both the cause and the effect. Nothing can give a more proper example of this than the mine of Ramelsburg. And no description better adapted to give a clear idea than that of M. de Luc, which I shall now transcribe. Lettres physiques et morales, tome 3. Page 361 to 364. Du filons principaux occupant les mines dans le Ramelsburg, filons immenses, car ils ont jusqu'à 18 20 toises d'épaisseur dans un étendu dont on ne connaît pas encore les bornes. L'un de ces filons fait avec l'horizon un angle de 25 degrés, c'est l'inférieur, l'autre s'élève de 45 degrés, et leur distance étant plus considerable, leurs plans doivent se rencontrer dans un point que n'est pas fort loin de mines. Leurs directions sont aussi différentes, celle du filon de 35 degrés est à 6.5 heures, et celle du filon de 45 degrés est à 5h-1/2, tellement qu'ils croisent à l'endroit où est pers le plus de pampas. On est embarrassé d'expliquer l'état de cette montagne par des cicatrices. Il faut au moins supposer que la montagne entière a été culbutée et encore reste-t-il à comprendre, comment est soutenu cette grande piece que sépare les filons, et que, en supposant vides les espaces de ceci, se trouverait absolument en l'air. Ce phénomène important à l'histoire de montagnes, je veux dire ces intersections de filons, est très fréquent dans les mines et très remarqué par les mines. Il arrive souvent que de filons, que sont à la même heure, c'est-à-dire, que ont de directions semblables vers l'horizon, ont une chute ou inclinaison différente, et tel que leurs deux plans se coulent à une certaine profondeur. Si le mineur ne s'en aperçoit pas c'est tot, et que de le commencement de son exploitation Illinois en attendant pas fortement pour tout ou il enlève les filons, tout son ouvrage peut être écrasé par l'enfoncement de la pièce que les séparait. Cette pièce même a un nom chez Luminez. Ils la nomment Bergkiel, c'est-à-dire coin de la matière de la montagne, et quand deux filons sont voisins l'un de l'autre, le diamètre souterrain en étudie l'inclinaison pour juger à l'avance y aura un Bergkiel. Et qnce cas la manière prenne ces précautions, en conservant de appuis naturels dans la gang, ou s'en faisant d'artificiels, à mesure qu'ils enfants. Or si, en élevant les filons, coin se trouve sans appui. Comment est-il soutenu avant que les filons fussent formes? Voilà une question forte embarrassante. Mais peut-être n'étant pas fait assez d'attention jusqu'ici à la mauvaise gang, que se trouve être de la même nature que la montagne. Peut-être trouverait on par là, tu en même temps que les fences font faits Illinois y estum de pieces de côtes, que ont empêche la réunion de parties de la montagne. Fragments que, aujourd'hui, font partie de filons, et qu'on pourrait laisser encore pour appuis naturels, en exploitant chuautre dies lorsqu'on aurait appris à les connaître. Ce peu d'inclinaison de filons du Ramelsburg rappellerait l'idée de couches formes de dépôts successifs, sils citoyens parallèles. Mais leur manque de parallélisme en tout sens exclut cette explication. Car don touts les montagnes que doivent leur formation aux dépôts de eaux, les couches sont parallèles, et en sent bien qu'elles doivent l'être. La nature de filons du Ramelsberg est aussi différente de celle de Clostbat que l'est leur situation. C'est un massif compact, et presque pour tout le même, de mineral de plomb et argent pauvre, pénétre de pyrite sulfureus. Ils sont traversés en plusieurs endroits par de rucheln, que ont fait glisser le toit vers le mur, tellement que malgré l'épaisseur de ces filons, on croit une fois en avoir trouvé la fin. Ils sont aussi coupes dans leur intérieur, en sens différents, par d'autres plus petits filons, composés de matières très différentes, surtout d'un pyrite cuivreuse dur et pauvre, et que par cette raison on n'y tente pas de séparer. En mettant à part ces petits filons particuliers, ainsi que les rucheln, dus probablement les uns et les autres à de causes postérieures à celles que ont produit les filons principaux. La masse compacte de ceci révèle beaucoup l'idée d'une matière fondue. En même temps qu'on serait fort embarrassé à concevoir, d'où viendrait cette matière, si distincte de tout autre, lorsqu'on voudrait l'attribuer à l'eau. Cette idée, que j'ai dois à Mr. de Redden, perfectionnée par l'étude de phénomènes, donnera peut-être un jour le mot de tout ces énigmes. Here is the clearest evidence that an enormous mass of mountain had been raised by a subterranean force. That this force had acted upon an enormous column of melted minerals, the specific gravity of which is great, and that this fluid mass had suspended a great wedge of this mountain, or raised it up. Now, if by means which are natural to the globe, means which are general to the earth, as appearing in every mineral vein, this mass of mountain had been raised up and suspended 20 fathoms. There is no reason why we should suppose nature limited, whether in raising a greater mass of earth, or of raising it a greater height. That the height to which the land of this globe shall be raised, is a thing limited in the system of this earth, in having a certain bounds which it shall not exceed, cannot be disputed, while wisdom in that system is acknowledged. But it is equally evident, that we cannot set any other bounds to the operation of this cause than those which nature appears actually to have observed in elevating a continent of land above the level of the sea for the necessary purpose of this world, in which there is to be produced a variety of climates, as there is of plants. From the burning coast under the equator to the frozen mountains of the Andes. Here therefore we have, although upon a smaller scale, the most perfect view of that cause which has everywhere been exerted in the greater operations of this earth, and has transformed the bottom of the sea to the summits of our mountains. Now, this moving power appears to have been the effect of an internal fire, a power which has been universally employed for the consolidation of strata, by introducing various degrees of fusion among the matter of those masses. And a power which is peculiarly adapted to that essential purpose in the system of this earth, when dry land is formed by the elevation of what before had existed as the bottom of the sea. I hope it will not be thought that too much is here adduced in confirmation of this part of the theory. The elevation of strata from their original position, which was horizontal, is a material part. It is a fact which is to be verified, not by some few observations, or appearances here and there discovered in seeking what is singular or rare, but by a concurrence of many observations, by what is general upon the surface of the globe. It is therefore highly interesting not only to bring together that multitude of those proofs which are to be found in every country, but also to give examples of that variety of ways in which the fact is to be proved. Were it necessary, much more might be given, having many examples in this country of Scotland, in Derbyshire, and in Wales, from my proper observation. But, in giving examples for the confirmation of this theory, I thought it better to seek for such as could not be suspected of partiality in the observation. Chapter 3. Facts in confirmation of the theory, respecting those operations which redissolve the surface of the earth. We have now discussed the proof of those mineral operations by which the horizontal strata, consolidated at the bottom of the sea, had been changed in their position, and raised into the place of land. The next object of our research is to see those operations, belonging to the surface of the earth, by which the consolidated and erected strata have been again dissolved, in order to serve the purpose of this world. and to descend again into the bottom of the sea from whence they came. Of all the natural objects of this world, the surface of the earth is that with which we are best acquainted, and most interested. It is here that man has the disposal of nature so much at his will. But here, man, in disposing of things at the pleasure of his will, must learn, by studying nature, what will most conduce to the success of his design, or to the happy economy of his life. No part of this great object is indifferent to man. Even on the summits of mountains, too high for the sustaining of vegetable life, he sees a purpose of nature in the accumulated snow and in majestic streams of the descending ice. On every other spot of the surface of this earth, the system of animal and vegetable life is served, in the continual productions of nature, and in the repeated multiplication of living beings which propagate their species. But, for this great purpose of the world, the solid structure of this earth must be sacrificed, for, the fertility of our soil depends upon the loose and incoherent state of its materials. And, that state of our fertile soil necessarily exposes it to the ravages of the rain upon the inclined surface of the earth. In studying this part of the economy of nature, we may perceive the most perfect wisdom in the actual constitution of things. For, while it is so ordered that the solid mass of earth should be resolved for the purpose of vegetation, the perishable soil is as much as possible preserved by the protection of those solid parts. And these consolidated masses are resolved in so slow a manner, that nothing but the most philosophic eye, by reasoning upon a chain of facts, is able to discover it. Thus it may be concluded, that the apparent permanency of this earth is not real or absolute, and that the fertility of its surface, like the healthy state of animal bodies, must have its period, and be succeeded by another. The study of this subject must tend to enlarge the mind of man, in seeing what is past, and in foreseeing what must come to pass in time, and here is a subject in which we find an extensive field for investigation, and for pleasant satisfaction. The hideous mountains and precipitous rocks, which are so apt to inspire horror and discontentment in minds which look at sensible objects only for immediate pleasure, afford matter of the most instructive speculation to the philosopher, who studies the wisdom of nature through the medium of things. As, on the one hand, the summit of the mountain may be supposed the point of absolute sterility, so, on the other, the sandy desert, moved by nothing but the parching winds of continents distant from the sources of abundant rains, finishes the scale of natural fertility, which thus diminishes in the two opposite extremes of hot and dry, of cold and wet. Thus is provided an indefinite variety of soils and climates for that diversity of living organized bodies with which the world is provided for the use of man. But, between those two extremes, of mountains covered with perpetual snow, and parched plains in which every living thing must perish, we find the most pleasant subject of contemplation. In studying the means employed in nature for producing the beautiful and benevolent system of hills and valleys, of fertile soils and well-watered plains, of the most agreeable circumstances and proper situations for everything that lives, and for the preservation of an indefinite variety of organized bodies which propagate their species. Without this philosophic view of things, the prospect of the surface of this earth is far from giving always satisfaction or contentment to the mind of man, who is subject to be continually displeased with that which is presented to his view, and which, in his opinion, is not the best. In his partial views of things, it is either too high or too low, too cold or too warm, too moist or too dry, too stiff for the labor of his plough, or too loose for the growing of his corn. But, considering nature as the common parent of living growing propagating bodies, which require an indefinite variety of soils and climates, the philosopher finds the most benevolent purpose in the end proposed, or effect which is attained, and sees perfect wisdom in the effectual means which are employed. This is the view that I would wish men of science to take, and it is for this purpose that I am now to examine the phenomena of the surface of this earth. If strata, formed at the bottom of the sea, had been consolidated by internal operations proper to the earth, and afterwards raised for the purpose of a habitable world, and if, for the purpose of vegetation, the solid land must be resolved into soil by the dissolution and separation of its parts, as is required in the theory, the strata, instead of being entire immediately below the soil, should be found in a mutilated state. The ends of hard and solid beds should present their fractures or abrupt sections immediately under the confused materials with which they are covered. And the softer strata should appear to suffer gradual resolution and decay, by which may be perceived their transition into soil, the most important part of all the operations of the globe which do not immediately concern our life. These are facts which every person of observation has it in his power to verify, they are facts for which nothing further can be laid than that the thing is truly so. And they are facts from which the most important arguments might be formed, were any doubt to be entertained concerning the justness of the theory which has now been given. The theory consists in this, that it is necessary to have a habitable country situated in the atmosphere, or above the surface of the sea. It is difficult to say precisely what constitutes a habitable country. A resting place out of the water suffices for such amphibious animals as, while they necessarily live in the atmosphere, feed in the sea. Man, more versatile in his nature than most animals, and more capable of adapting his manners to his circumstances, is even sometimes found subsisting in situations where the land affords him little more than it does the seal on which he feeds. The growth of terrestrial plants, however, seems necessary to the idea of a habitable country, and, for the growth of plants, there is required soil. Now, this is only to be procured by the resolution or decay of solid land. We are not to consider the resolution of our land as being the effect of accident, while it is performed by the operations of the sun and atmosphere, by the alternate action of moisture and of drought, and by the casual operations of a river in a flood. Nothing is more steady than the resolution of our land, nothing rests upon more certain principles, and there is nothing which in science may be more easily investigated. Calcareous, argillaceous, and other soluble earths, compose many of the strata, but in many more, which are partly or chiefly composed of insoluble substances, those soluble earths are mixed in various proportions. Now, when the siliceous substance, which is the insoluble part, shall be supposed resisting every effort of the elements towards its dissolution, those compound masses upon the surface of the earth, however endued with hardness and solidity, are gradually impaired by the dissolution of some of their constituent parts, and by the separation of others which are thus exposed to the ablution of water. In like manner, by the resolution of the surrounding parts, the solid silex, which is supposed to be insoluble, is removed from its bed, and thus suffers new parts of the solid land to be exposed to those injuries of the air, by which the general good of plants, of animals, and even of future worlds, are consulted. The solid land is resolved into stones, gravel, sand, earths, and clays, all or either of these, by retaining moisture, and affording places for the roots of plants, are disposed for vegetation in different degrees. A mixture of the different earths being, upon the whole, the best suited to that purpose, and this compound body, mixed with vegetable or animal substances, becoming a most luxuriant soil. Soils are thus formed, either by the resolution of the surface of that land upon which they are to rest, or by the transportation of those solid parts to be again deposited upon another basis. In this manner soils are constantly changing upon the same spot, sometimes they are meliorated, at other times impoverished. From the tops of the mountains to the shores of the sea, all the soils are subject to be moved from their places, by the natural operations of the surface, and to be deposited in a lower situation. Thus gradually proceeding from the mountain to the river, and from the river, step by step, into the sea. Countries are thus formed at the mouths of rivers in the sea, so long as the quantities of materials transported from the land exceeds that which is carried from the shore, by tides and currents, into the deeper water. The soil, with which the surface of this earth is always covered more or less, is extremely various, both with respect to quantity and quality. It is found resting upon the solid parts. And those solid parts are always more or less affected by the influences of the atmosphere near the surface of the earth. Those parts of the strata which approach the surface are always in a decayed state. And this sometimes may be observed for very considerable depths, according as the quality of the materials, and the situation of the place disposed to that effect. This general observation however may be formed, that, cet par. The strata become always more solid, or are found in their sound and natural state, more and more in proportion as we sink into the earth, or have proceeded from the surface. There is nothing of which we have more distinct experience than this, that, universally upon the surface of the earth, the solid parts are dissolving and always going into decay. Whereas, at a sufficient depth below, they are found in their natural consolidated state. The operations of man in digging into the ground, as well as the sections of the earth so often formed by brooks and rivers, afford such ample testimony of this truth that nothing farther need be observed upon this head, only that this is a most important operation in the natural economy of the globe, and forms a subject of the greatest consequence in the present theory of the earth, which holds for principle, that the strata are consolidated in the mineral regions far beyond reach of human observation. Consistently with this view of things, the strata, or regular solid parts, under the soil or travelled earth, should be found in some shape corresponding to the represented state of those things, when affected by the powers which have acted upon the surface of the earth. Here, accordingly, the strata are always to be observed with those marks of resolution, of fracture, and of separation, which have most evidently arisen from the joint operation of those several causes that have been now explained. But though every operation of the globe be necessarily required for the explanation of those appearances which we now examine, it is principally the action of the sun and atmosphere, and the operations of the waters flooding the surface of the earth, that form the proper subject of the present investigation. It must not be imagined that, from the present state of things, we may be always able to explain every particular appearance of this kind which occurs. For example, why upon an eminence, or the summit of a ridge of land which declines on every side, an enormous mass of travelled soil appears. Or why in other places, where the immediate cause is equally unseen, the solid strata should be exposed almost naked to our view. We know the agents which nature has employed for those purposes. We know the operations in which the solid parts are rendered soil of various qualities and for different purposes. And when we find the marks of those natural operations in places where, according to the present circumstances, the proper agents could not have acted or existed, we are hereby constrained to believe that the circumstances of those places have been changed, while the operations of nature are the same. It is thus that we shall find reason to conclude an immense period of time, in those operations which are measured by the depredations of water acting upon the surface of the earth. A period however which is to be esteemed a little thing compared with that in which a continent had taken birth and gone into decay. But a period which interests us the more to examine, in that it approaches nearer to another period, for the estimation of which some data may perhaps be found by naturalists and antiquaries, when their researches shall be turned to this subject. It is only in this manner that there is any reasonable prospect of forming some sort of calculation concerning that elapsed time in which the present earth was formed, a thing which from our present data we have considered as indefinite. In this view which we are now taking of the surface of the earth, nothing is more interesting than the beds of rivers. These take winding courses around the hills which they cannot surmount. Sometimes again they break through the barrier of rocks opposed to their current, thus making gaps in places by wearing away the solid rock over which they formerly had run upon a higher level, and thus leaving traces of their currents in the furrowed sides of rocky mountains, far from the course of any water at the present time. So strongly has M. de Saussure been impressed with this and some other appearances, that he has imagined a current of water which, however in the possibility of things, is not in nature, and which moreover could not have produced the appearances now mentioned, which is the work of time, and the continued operation of a lesser cause. We are further obliged to him for the following facts. Volume 1. Page 163. Les tranches nous et escarpes de grandes couches du petit surtout du grande salive, presentent presque partout les traces les plus marquises du passage de eaux, que les ont ringes et excaves, en voit sur ces rochers. De cylindres à peu près horizontox, plus aux moins larges et profondes. Il a de 4 à 5 pieds de largeur, et d'une longueur double ou triple, sur 1 ou 2 pieds de profondeur. 2 ces cylindres ont leur boards termines de courbes arrondies, tels que les os ont coutume de les tracer. Je dis ils sont à peu près horizontox, parce qu'ils sont parfois inclines de quelques degrés, en descendant vers le sud-sud-ouest, suivant la pente tu doit avoir le courant. This is evidently the effect of a river running along the side of a rock of such soft materials as may be worn by the friction of sand and stones, and such are the materials of the rocks now considered. Notwithstanding that it is so easy to explain this appearance by the operation of natural causes, Dissolution proceeds in taking it in another view. De téléphones filons ni s'orientent avoir été traces par les eaux de pluie. Car celles-ci forment de excavations, ou perpendiculaires à l'horizon ou dirigées suivant la plus grande inclinaison de faces de rochers, au lieu que celles la font traces presque horizontalement sur de faces tout fait verticales. Here our author takes it for granted that things upon the surface of this earth were always the same as at present, and he reasons justly from these principles. But we are now tracing a former state of things. And those furrowed rocks testify the former current of a river by their side. This operation of rivers undermining the sides of mountains, and causing scenes of ruin and destruction, may be illustrated by what our author has described under the title of Ravage du temps sur les rochers de Salive, section 236. La OUCES couches manquant Illinois estates de voir qu'elles ont été détruites par le temps, les couches meme horizontales, contre lesquelles elles out appuyées, ont souffert en bien de endroits de alterations considerables. Un peintre que voudrait monter son imagination, etc. faire de grandes idées de ravages du temps sur de grands objets, devrait aller au pays de Salive, à l'extrémité de ces grands rochers, au-dessus du coin. Homo for de livre de la paroisse de Collonges. Envoyez la de rochers tales à pic à la hauteur de plusieurs centaines de pieds avec de faces, ici planes et uniformes, la partages et salons par les eaux. La base de ces rochers est couverte de débris et de fragments énormes, confusement in tasses, on de ces débris soutenu fortuitement par d'autres est demeure, et paroit de près un obélisque quadrangulaire d'une hauteur prodigieuse. De plus loin on reconnoit que sa sommite est un arête tranchanti, et chuil a la fermi d'un coin, et se peut être set fermi que dans son nom au homo chuil domini. Langley meme de la montagne est partage par un fonte que le traverse de part en part. Set profond fisher marit qui on la voie, et meme qui on la pénètre. Ls tortues, et dans quelques endroits si étroit, tue pain un put il passer. Quand vous engages vous trouvez de places ou les sinuosités du rocher vous cache le ciel, plus loin elles le laissent apercevoir par échappes. Alors vous voyez de blocs de rochers engages dans la crevasse, et suspendus au-dessus de votre tête. In his route from Contamine to Bonneville, he observes, page 365, Enfin vis-à-vis la Bonneville, ces mêmes escarpements de bases du mole, presentant un grande écancrure. Que pourrait être le vide tué les un montagne que est anciennement écroulé. Ces débris sont encore en tasses au-dessus de l'écancrure. Il pourrait même tuer etoit plus élevé que ces voisins, jn jug par leur couches que montent à droite et à gauche, contre le vide tuel à l'aise. Section 493. En suivant la route de Cervez, on voit sur sa gauche la continuation de rocs escarpés que couronnent les montagnes situées au-dessus de Passy. Un de ces rochers est si élève, et en même temps si mince que l'on a peine à concevoir qu'il puisse se tenir debout et résister aux orages. Ces opers de cette sommite élevée étoit situé en montagne que essabola en 1751, avec un fracas si épouvantable, et une poussière si épaisse et si obscure, que bien de gens crurent que c'était la fin du monde. Vitaliano Donati, who was sent from Turin to examine this phenomenon, says in his letter, which M. De Saussure transcribes, that the great snows, which fell that year in Savoy, increasing the operation of some lakes, the waters of which continually undermined this mountain, occasioned the fall of 3 millions of cubic toises of rock. In describing the Salive, our author proceeds to mention other appearances equally conclusive with regard to the operations of water, but such as may be found over all the surface of the globe, to have been brought about by natural causes. Ce qu'Elon nomme le gros de l'hermitage, OUCES excavations profondes de 30 pieds, 88 ou 10 fois aussi longues produites par la destruction totale de plusieurs couches de rocher. La gorge mime de Monadier, ou cette grande écancrure que sépare le grand salive du petit, et dans le fond de laquelle est renferme le joli vallon de Monadier, pourrait avoir été formé par un courant semblable. Que descendant de Alpes par la vallée de l'Arve, venoit se jeter dans notre grand courant. Car les couches correspondants du grand et du petit salive indiquent leur ancienne jonction, et l'on ne comprend pas quel agent aurait pu détacher et importer la pièce énorme que manque cet endroit à la montagne. Further, in treating of the changes made in the form of the Jura by the ravages of time, our author observes, page 273, volume 1. Le fait de la montagne, battu de tous côtés par les vents, et par les pluies, a souffert de alterations les plus grandes, ici les couches du côte du lac ont été détruites, et les cent voire les sommets de couches opposes. Dont les escarpements paroissent tourner contre ce même lac. Là, ce font les couches du côte de la vallée de Mijou, que out été importés, et la montagne en pente uniforme de notre côte, est escarpée du côte de celle vallée. Plus loin, le fait entier a été enlevé, et là en voit de abasements au de gorges comme aux fossiles, à Saint-Serge, etc. Les flancs et la base de la montagne ont aussi été dégradés par les torrents qui produisent la pluie et les neiges fondues, que ont formed de larges et profondes excavations. These ravages of time, or rather of the wasting operations of the surface of the earth, however great, compared with the little changes that we find in our experience, or in the most ancient record of our histories, are little things. Considering the softness and solubility of the materials, and compared with the wasting of the Alps, which we find in tracing up those same rivers to their sources in the icy valleys. Let us go up the Arve to the valley of Chamonix. From this fertile valley, Dissolution heads us up the Montanvert, 428 fathoms above the level of the valley, and consequently 954 above that of the sea. From this mountain we descend again into the high frozen valley which runs between the granite mountains, and pours its ice into the valley of Chamonix. In this high valley, which communicates with an immensity of the like kind, we find ourselves among the most hard and durable materials. Here we must perceive, that most enormous masses of those solid materials had, in the course of time, been wasted by the flow effects of air and water, of the sun and frost, in order to hollow out those barren valleys of immense extent, which have, during an amazing tract of time, contributed from their solid rocks to the formation of traveled soils below, but which materials have long ago been traveling in the sea. The sides of those valleys are solid rock here exposed naked to our view. It is to such a place as this that we should go to see the operations of the surface wasting the solid body of the globe, and to read the unmeasurable course of time that must have flowed during those amazing operations which the vulgar do not see, and which the learned seem to see without wonder. Dissolution, in his second volume of Voyages dans les Alpes, has given us a most interesting view of this scene, page 6. En montant au Montanvert, on a toujours sous ses pieds la vue de la vallée de Chamonix, de l'Arve que l'arrose dans toute la longueur, d'une seule de villages et de hameaux entourés d'arbres et de champs bien cultivés. Au moment où l'on arrive au Montanvert, la scène change. Et au lieu de cette riante et fertile vallée, on s'y trouve presque au bord d'un précipice, dont le fond est une vallée beaucoup plus large et plus étendue, remplie de neige et de glace, et bordée de montagnes colossales. Que étonnant par leur hauteur et par leurs formes, et que effrayant par leur stérilité et leurs escarpements. It is the cause of this appearance, of deep valleys and colossal mountains, that I would now wish my readers to perceive. This is a thought which seldom strikes the mind of wondering spectators, viewing those lofty objects. They are occupied with what they see, and do not think how little what they see may have been, compared with what had been removed in the gradual operations of the globe. We have but to suppose this scene hewn out of the solid mass of country raised above the level of the valley, and, that this had been the case, must appear from the examination of all around. Let us follow our author up those valleys between the solid granite mountains, valleys which properly are great rivers of ice moving, grandly but slowly, the ruins of those mountains upon which they were gathered. It is the Glacier de Bois upon which he is set out, page 26. Après un bon demi-heure de marquer sur le glacier, nous traversons un arête de glace chargé de terre, de sable et de débris de roche. J. parle dans le 1 Volume. De ces arêtes parallèles à la longueur de glaciers, qu'elles envoient souvent dans le milieu de leur largeur, au à de distances plus au moins grandes de leurs bords. J. fait voir qu'elles sont produites par de débris que du haut de montagnes, roulant sur le glacier. Et que entraînent par la glace sur lequel ils reposent suivant comme elles en direction oblique and descendant tout à la fois vers le milieu et vers le bas de la vallée. 10 minutes après, nous traversâmes un second arête plus haut que la première. Et nous jugîmes que sous ces débris la glace était de 20 ou 25 pieds plus élevée que dans les endroits où elle et les rayons du soleil agissent librement sur elle. On rencontre un troisième arête à 20 minutes de la seconde, en la quatrième, que est la dernière, la suite de très près. Ici nous trouvons au point où le glacier de Bois et divise, comme Jelai dit, section 611, en deux grandes branches, dont elle tourne à droite vers le Mont Blanc et prend le nom de glacier de Tacle. Et l'autre à gauche est nommé le glacier de l'Echaude. Il serait, sans doute, plus intéressant de suivre celle de la droite, et de s'approcher ainsi du Mont Blanc. Ces pentes de neige et de glace, que s'y présentent à nous, semblant même en être point absolument inaccessibles, mais ci sont de apparences trompeuses. De glaciers entrecoupes de profondes crevasses masquent ci et la part de couches minces de neige les approaches de cette redoutable montagne, quoique peut-être en choisissant un année où il serait tombe beaucoup de neige. Et en prenant le temps où cette neige serait encore ferme, quelques chasseurs adroits et courageux pourraient tenter cette route. Comme dans ces moments cette entreprise est absolument impraticable, nous suivons la branche gauche de la vallée, et après 2 heures de marquer sur le glacier de Bois, nous en sortons au pied de celui du Talafre, si est d'ailleurs. À l'endroit où celui-ci 20 verser sa glacé dans celui-là que a changé de nom, et que s'appelle ici le glacier de l'Echaude. La vue du glacier du Talafre est ici majestueuse et terrible. Comme la pente par laquelle elle descend est extrêmement rapide, les glaçons s'y pressentent mutuellement, s'y dressent, s'y relevant, et presentent de tours, de pyramides diversement inclines. Que semblant prêts à écraser le voyageur téméraire que osserait s'en approcher. Pour parvenir au sommet de ces glaciers, où il est moins incliné par cela même moins inégal, nous gravissons le rocher que est à la gauche du côté du couchant. Ce rocher est nommé le couvercle. Il est dominé par un cime inaccessible, que, suivant l'usage du pays, est décoré du nom aiguille, et, en prenant le nom du glacier le plus proche, s'appelle l'aiguille du Talafre. La pente, par laquelle on gravite le couvercle, est excessivement rapide, en suit une espèce de cylindre creuse dans le roc par la nature. Quelques points de roc aux quels on s'y crampon, en montant avec les mains, autant plus chou avec les pieds, ont fait donner à ces passages le nom d'aigrelets au lieu de petits degrés. Ce passage n'est cependant point dangereux, parce que le roc, que est un granit très cohérent, permet d'assurer toujours solidement les mains et les pieds, mais la rapidité le rend un peu effrayant à la descente. Lorsqu'on est au haut de aigrelets, on suit un pente beaucoup moins rapide, on marque tantôt sur du gazon, tantôt sur de grandes tables de granit, et on arrive ainsi au bord du plan du glacier du Talafre. On nami le plan d'un glacier la partie élevée eta plus près horizontale dans lequel on put le traverseur. Nous avions mis un ret un quart à montre du glacier de l'Echaude au plan de celui du Talefre. Nous fûmes tents de nous reposer un moment avant d'entrer sur celui-ci. Tout nous invitoit à choisir cette place, un beau gazon arrose par un ruisseau que sortoit de dessus la neige et que reloit sun au crystalline sur un sable argent, ece que etoit plus séduisant encore. Un view d'une étendue et d'une butte dont une description en peut donner une bien foible idée. Section 631. En effet comment peindre, à l'imagination de objets que n'ont rien de commun avec tout ce que l'on voit dans le reste du monde. Comment faire passer dans l'âme du lecteur cette impression mêlée d'admiration et de terreur inspirant ces immenses amas de glaces entours et semence de ces rochers pyramidox plus immenses encore. Le contraste de la blancheur de neige avec la couleur obscure de rochers, mouillés par les eaux que ces neige distillant, la purité de l'air, éclat de la lumière du soleil, que donne à tous ces objets une netteté et une vivacité extraordinaires. Le profond et majestueux silence que règne dans ces vastes solitudes, silence que n'est trouble que de loin en loin par le fracas de quelque grand rocher de granit au de glacé que s'écroule du haut de quelque montagne. Et la nudite mime de ces rochers élèves, o l'on any découvre ni animo, ni arbustes, ni verdure. Et quand on s'y rappelle la belle végétation, et les charmants paysages que l'on a vus le jours précédents dans le basses vallées, on est tant de croire qu'on a été subitement transporté dans un autre monde oublié par la nature. Au sur un comet dans son affolie. La vue du montanvert any dans de celle-ci une idée très imparfaite. La on any voit un seul glacier, au lieu que d'ici vous voyez les trois grands glaciers de bois, de l'Echaude et du Tacle, sans compter un grand nombre d'autres moins considérables que, comme celui du Talefre. Versant leurs glaces dans les glaciers principaux. Les rochers innombrables que l'on voit au-dessus de ces glaciers sont tous de granit, car salya, comme j'en suis certain, de rochers feuilletés, interposes entre ces granits, des neufs, par exemple, au lieu de roches de corne. Comme elles étoient plus tendres que les granits, leurs parties phalantes ont été détruites par les ingers de l'air, et il n'y reste plus que leurs bases, cachées au fond de gorges que séparent les hautes pyramids. This is a fact which, independent of the good authority we have here, we would have been naturally led, from the theory, to suppose. For, in wearing out the solid mass, which had been once continuous among those mountains, something must have determined the situation of those valleys. But what so likely as some parts more destructible by the wasting operations of the surface than others, which are therefore less impaired, and remain more high? Now, whatever may be our theory with regard to the origin or formation of these solid masses of the globe, this must be concluded for certain, that what we see remaining is but a specimen of what had been removed. And that we actually see the operations by which that great work had been performed, we only need to join in our imagination that portion of time which, upon the surest principles, we are forced to acknowledge in this view of present things. Chaper 4. The same subject continued, in giving still farther views of the dissolution of the earth. To have an idea of this operation of running water changing the surface of the earth, one should travel in the Alps. It is there that are to be seen all the steps of this progression of things, and so closely connected in the scene which lies before one, that there is not required any chain of argument, or distant reasoning from effect to cause. In order to understand the natural operations of the globe, in the state of things which now appears. So strongly are the operations of nature marked in those scenes, that even a description is sufficient to give a lively idea of the process which had been transacted. With this view, I shall here transcribe, from the Tableau de la Suisse, a description of that remarkable passage by the mountain of St. Gothard, from Switzerland to Italy, hoping, that, even independent of the illustration hereby given to the theory, The reader will be pleased to see such a picture of that country as will either excite new ideas in a person who has not seen such scenes, or call up those which it is proper for a naturalist to have. 51. Nous allons donner les observations que nous avons faites, en montant le Saint Gothard par le côté septentrional, et nous terminerons ce que nous avons à dire par la description du haut de cette montagne. Ilyaux environs d'Altorf, chef-lieu du canton d'Uri, de grands terrains couverts de pierres roules, dont la plus grande partie est amenée par le Sketchen, torrent que descend de la vallée du même nom, et l'autre par la ruse que descend du St. Gothard. Sans y donner beaucoup de pains, on y a la facilité de voir et d'examiner une grande variété de pierres d'espèces différentes et de connaître d'avance les rochers que composent les montagnes qu'on va parcourir. Nous répétons ici que toutes les pierres arrondies ont pris cette forme par le roulis qu'elles ont suies dans les torrents, en se précipitant avec les eaux que les ont amenées, plus nous avons parcouru de montagnes. Plus nous sommes confirmes que cette observation était vraie et exacte. Si on a la constance de suivre un espèce jusqu'au lieu de son origine ou position première, on ly trouvera angulus, et en subi d'autres changements que celui que le temps imprime à toutes les substances que restent en place. On verra que mesure qu'elles s'éloignent de leur première position leurs angles et leurs parties saillantes se détruisent, et qu'elles finissent par prendre la forme ronde ou approchante. En raison de leurs durées et du chemin qu'elles auront parcouru. Nous renvoyons à ce sujet que a été dit vers le commencement de ces observations, en parlant du trient. Nous ajoutons seulement qu'il ny aguirre d'espèces de pierres roules dans les montagnes, dont nous n'ayons pas trouvé les rochers analogues, et qu'avec du temps et les courses convenables. En observant bien les directions de montagnes et de torrents, on les trouverait toutes. Altorf est entour de tres hautes montagnes, de vallons aboutissant de tous côtés dans ses environs, parce que c'est le lieu le plus basso les eaux vont se jeter dans le lac de Wallisthal ou de Lucerne, à l'extrémité duquel Altorf est situé. Le vallon est assez couvert dans le bas Illinois est cultive dans quelques parties, et de arbres fruitiers. C'est surtout aux environs de Bergland qu'on rencontre beaucoup de pierres roules et de rochers amens par les eaux. Les rochers sont de pierre calcaire, et continuant jusqu'aux silenen à deux lieues d'Altorf, les montagnes sont fort hautes et fort escarpées de deux côtés du vallon, de beaux prés sont dans le bas. Quelques arbres fruitiers et surtout de noyers sont à mi-côte, et entre les rochers, de forêts de sapins. Avant d'arriver à Silenen, on aperçoit le glacier de Titlis, il est sur le territoire d'Engelberg, et on trouve encore quelques heaters. Derrière les montagnes boises il s'en élève d'autres nous et arêtes. Des points et de vues admirables par la dégradation de montagnes et pour le sauvage, s'offrent de toutes parts. Des chalets, de habitations isolées, sont situés au pied de plus affreux rochers que les menaçant d'une ruine prochaine. L'habitant y vit sans crainte, entour de son prix et de son petit bien dont il est tranquille possesseur. L'Ushla concentré dans ces vallons y fait mûrir différentes productions pour recherches, à la vérité, ces sont de fruits fort communs, excellents pour le pays, parce qu'on ny en connaît pas de milers. C'est du petit village d'Amstig entour de fort hautes montagnes, qu'on commence à monter ce qu'on nomme le Saint Gothard General, le chemin devient plus roide. La ruse y est plus resserres et roule ses dans un lit fort profond et très escarpé, de torrents de cascades, tombant de différents endroits de deux côtés de ce vallon et de belles forêts de sapins. Oily de arbres prodigieux pour la hauteur, variant les points de vues. On s'élève beaucoup au-dessus du fond de vallons par de chemins rapides, l'exposition plus heureuse fait cultiver du jardinage et de arbres fruitiers, il beaucoup de chanvre dans ces environs. De l'autre côté du vallon, sur la gauche de la rue, est un usine ou en fabriquoit de l'alum et du vitriol, les travaux ont ces établissements et l'exploitation de mines sont plus connaissés plus suaves en Suisse. La rue semble toujours s'enfoncer d'avantage, partout elle roule ses flots avec brut et fracas, elle est crucie un lit à de profondeurs incroyables. ILNY a point d'endroit ou l'on puisse mieux voir cet étonnant travail de os quai sur le pont du Pfaffensprung, à un demi-le de Vassin. Il est à un hauteur si effrayant que le premier mouvement, quand on regarde au bas du pont, est de s'y tenir au parapet, et le second de le quitter, dans la crainte qu'il en y manque, si n'est que par réflexion qu'on y revient. On voit la progression et le travail successif de l'eau du haut jusqu'au bas. La roche a de sinuosités ou de angles arrondis, rentrants et phalans, alternativement de chaque côté, et dont salins sont opposés aux rentrants, de façon qu'il reste peu d'espace pour apercevoir l'eau, ce canal ouce. Gouffre n'ayant pas plus de deux toises et demi de large. Depuis silenen on any voit plus de pierres calcaires, les rochers sont schisteux argileux, mêlés de beaucoup de quartz, le lit de la Rousse est rempli de granites, mais que viennent de montagnes supérieures. Au-dessus du pont, dont nous venons de faire mention, on rencontre un passage de plus pittoresques, composé de moulins, de scieries, de chutes d'eau, dominis par le village de Vassin, et d'entours de montagnes fort extraordinaires. Un roche argileuse sur un plan incline, SS détaché de la hauteur, et y importe un pont et un moulin. On monte beaucoup après avoir passé Vassin, ces environs sont d'une variété étonnante pour la beauté et la singularité de paysages. Des nappes d'eau, de cascades que s'y précipitent de roches en roches, forment dix quins chutes avant de s'y perdre dans les sapins que contrastent avec la blancheur de aux touts redoites en écume. Des maisons d'une construction particulière, places contre les rochers pour les mettre à l'abri de avalanches. De poudres jetées sur différentes masses de rochers pour passer la Rousse et autres torrents dont les eaux sont bouillonnantes et gélissantes, de arcades de pierres pour joindre de rochers suspendus sur ces précipices. Rochers de mille formes bizarres occupant le voyageur, et lui donnant plus le temps d'apercevoir les mauvaises pas qu'il franquit. Il sans doute de hommes assez malheureux, qu'en verroyant que de dangers, et en serroyant a cups que de leurs craintes et de terreurs paniques. C'est en effet une grande privation de ne pas sentir les buts de la nature, elle devient un malheur réel quand ce plaisir est trouvé remplacé par de angoisses et de la frayeur. Un tableau d'un autre genre nouveau, et pour lequel les expressions manquent, est un forêt rasé et abattu par un avalanche Illinois y quelques années, ces sapins de plus de 100 pieds de long. Ont le temps de perdre leurs feuilles et de permettre à la vue de passer à travers cette énorme quantité de bois et de branches entrelacées de mille manières bizarres, et d'apercevoir de rocs épars, de eaux que circulent autour. Et de tombant quelquefois en cascades. C'est un spectacle que devient effrayant quand on pense à la force et à la violence du moyen que a pu occasionner un pareil effet. On recule dans ce canton la raison de malaises. Quoique Vassin soit déjà fort à l'eve, on y cultive encore quelque jardinage, et il y a aussi quelques cerisiers sauvages. Il y a environ s'incluse jusqu'au Altorf. Après avoir passé Vassin, on trouve 5 ou 6 superbes cascades formes par la Rousse. Elle fait un brut à étudier, la chaleur qu'il faisoit, avoit procure un abondant font de neige, et l'eau avoit beaucoup augmente depuis le matin. Des bouleaux, de sapins, et de malaises, groupes ensemble, formoyant de contrastes agréables par la variété et le mélange de différents verts. Les chemins sont faits à grandes phrases et avec beaucoup de soin. On a jeté de arcades en différents endroits pour joindre les rochers, et faire passer les chemins par-dessus, on entend mugger la Rousse sous ses pieds l'écume partout, il faut être coutume à ce spectacle pour n'en pas être frais. Les rochers de droite et de gauche sont partout à pic et d'un granit, que est jonater dans différents endroits, dans d'autres, ils décompose, passant à l'état d'argile, c'est le feldspathe que subit le premier changement. Des quartiers de rochers de parties de montagnes sont épars, de chalets, de habitations solitaires sont placés aux environs de endroits oily et quelques poterage. Ily et un de ces rochers que est un belle masse de granit, appelé la pierre du diable, on n'oublie pas de la faire remarquer, parce que ily est un conte populaire à son sujet que de graves auteurs musoenti conserve. Le vallon s'y retressit beaucoup avant d'arriver à Gestanen. On a élève partout de murailles à de très grandes hauteurs pour faire le chemin. Tout ce travail, vu le local, est incroyable pour la difficult. De gros blocs de granit sont rangés sur les bords du chemin pour servir de barrières dans les endroits les plus dangereux. Ces passages sont assez étroits qu'il faut peu de choses pour les interrompre. Le pont du diable est d'un seul archi à plein centre de 4 toises d'ouverture du et demi de large et de 2 toises d'élévation au-dessus de l'eau. Le fracas et de la rapidité avec laquelle l'eau passe sous ce pont, any permettant gears qu'on la considère tranquillement de dessus le pont, on est toujours temps de s'en éloigner. La distance depuis Gestanen jusqu'à Teufelsbruck au pont du diable, que est environ du luz, suffit pour prouver ce que nous disons. Cette vallée, qu'on nomme Skalanen, offre à chaque pas de difficultés vaincues, de rochers franquis, de intervalles comels par de murailles, oil a fallu employer de montagnes de pierres. Les chemins sont pavés partout mieux que dans beaucoup de villes, de chevaux et de mulets charges les fréquentent tout l'année, et dans quels pays ces grands travaux ont été exécutés. Dans un véritable chaos de rochers et montagnes dont parties sont bouleversées, et l'autre paroit prête à s'écrouler sur le passant, qu'en voit sous ces pites que de écules, de gouffres et de précipices. Au fond d'esquels roule un torrent écument et furieux. Si les rochers sont ménicans, les avalanches sont encore plus dangereuses dans ce redoutable passage, ilny à point d'Annie ilny paris de hommes et de bêtes de somme. En fait voir un endroit ou un avalanche transporta à plus de 100 toises au-delà de la Rousse, 19 chevaux et mulets charges ainsi que leurs conducteurs. Dans d'autres endroits de quartiers de rochers prodigieux que ont été de places et transportes de mime. Après avoir passé le pont du diable, le chemin tourne à gauche, pousse à droite, pour monter un rampe assez rapide, très bien pavé, que conduit à un ouverture dans le rocher, c'est le seul passage que s'y présente, nommé un lac. Trou du pays d'Iana ou Ursren. Un rocher fort d'olive est sur la gauche, et les cascades de la Rousse à droite. L'entrée du passage est obscure, c'est une galerie souterraine pratiquée dans le roc, haute de 9 pieds environ de fécond chuan put y passer à cheval, de 11 pieds de large et 32 toises de long. On a pratique dans le milieu un ouverture pour donner du jour, cette roche est tout de granit, ainsi que celles que sont autour du pont du diable, ILY et environ 60 ans que cette galerie a été ouverte. Le chemin passoit auprès en dehors sur un espèce de pont que tournoit le rocher, EDSE travaille exactement suspende et fort mal assure au-dessus de cascades de la Rousse. De fréquents accidents, de grandes phrases pour reconstruire et entretenir ce pont, souvent entraînés par les eaux, ont nécessité l'ouverture de ce passage. En sortant de ce passage obscur, on est surpris d'entrer dans un plain ouvert, riante et couvert de verdure, et de voir couler à côté de soi un onde limpide et tranquille. Ce tableau est d'autant plus frappant qu'on vient de voir le contraste le plus effrayant. Ce passage souterrain est comme le rideau que se lève entre deux décorations, dont l'un représente le chaos et le bouleversement de la nature, et l'autre celle de la nature naissante et pari de premières et de plus simples ornements. Cette plaine est unie, de fermi ovale, couverte d'un vaste gazon et de poteriches, entre l'esquile serpent d'ausment la rousse, sur ces boards il et quelques buissons et peu d'arbres, sont aulnes. Des cabanes de bois, de chalets isoles et solitaires sont répandus et là à l'entrée du vallon, à gauche est le village d'Indermatt bâti en pierres, et à neuf. Dans le fond celui de hospital est situé sur le penchant d'un coteau, Illinois est dominé par un gros tour, les montagnes du Saint-Gothard servant de fond au tableau, elles sont trop éloignées pour laisser apercevoir leur érudite. De montagnes news, couvertes d'une verdure légère sans arbres et sans buissons, bordant les deux côtés du vallon, enfin tout paroit jeune et d'une création nouvelle au premier coup d'œil. Comme le spectateur dans l'état où est un homme à son réveil après un rêve épouvantable, il n'a vu que d'objets effrayants. Il s'y trouvé heureux et content d'être en charité or de dangers que le menacoyant, tant les impressions de son rêve lui sont encore présentes. Ce vallon offre de remarques intéressantes pour l'histoire naturelle, sa position, sa forme, et son nivellement en laissant aucun doute que cet emplacement en était le séjour de os. En examinant les bords du lit de la Rousse, on reconnaît que le terrain de ce vallon est par couches horizontales de pierres argileuses. Le pied de montagnes que entourent le vallon sur la droite est de pierre calcaire graisse, à la même hauteur, et à mi-côte, sur la gauche, on trouve de la pierre à l'air. Voilà encore un de ces circonstances où il serait intéressant de connaître la hauteur exacte de cette pierre calcaire. Et de pouvoir comparer son niveau avec d'autres que nous avons déjà observé être aussi déposés au pied de montagnes dans de petits vallons fortalives, analogues à celui dont il est question. Quelques secus aura rompu l'enceinte de rocher que fermoit ce bassin, l'écoulement de os aura achieve de cruiser ce passage, au cul actuellement la Rousse, et le vallon que est au-dessus. Quoique les angles rentrants et salins de montagnes ayant lu dans quelques endroits Illinois s'en faut de beaucoup que ce soit un règle certain, le vallon que descend du Saint-Gothard à Altorf est un de ces exceptions. Un autre chose remarquable dans ce vallon, c'est chuo sortir du passage souterrain que nous avons dit être creusé dans le granit Illinois et tout à côté sans interruption, et formant la même masse de rocher, de la pierre schistous micaceae. Mêlée de quartz, dont les couches sont perpendiculaires, se fendant et tombant par morceaux, que ont la forme de poudres au de bois et quartz. Cette espèce de roche est aussi haute que celle de granit, et composée, dans de proportions différentes, de mêmes parties intégrantes que le granit. N'a-t-il pas été apposé et formé contre celle de granit, que sûrement doit être plus ancienne, puisqu'elle est enveloppée par la roche schistous 52. Ce vallon, d'une bonne de longueur sur moitié de largeur, peut occasionner bien de réflexions, nous avons été obligés de passer rapidement sur ces objets, nous en faisons que les indiquer. Au haut de la montagne rapide, que est au-dessus du village d'Indermatt, il y a un petit bois de sapins, auquel il est défendu de toucher sous peine de la vie. Il est réservé contre les avalanches. Ce sont les seuls arbres qu'on voit sur les hauteurs environnantes, derrière ce bois on aperçoit un glacier d'eau descend un torrent que va se jeter dans la Rousse. Il amène, ainsi que les autres que descendent de ce côte, de pierres schisteuses micaceaes, mêlées de quartz, de même nature que celle que est à côte du passage souterrain. On monte par un beau chemin au village de hospital, que dépend aussi du pays d'Ursren, tout ce canton est renommé pour ses excellents fromages. Il ny a que de poterage et point d'horticulture. Le bois, que est de première nécessité dans un pays aussi froid, aussi élève et toujours en tour de neige, y manque totalement, on est obligé de aller chercher dans la vallée de Scalanen, et entraîne sur la neige le bois de Charpent. Le village de Hospital est situé sur de roches schisteuses mêlées de mica et de quartz, elles sont bleues, verdâtres, et grises. C'est à Hospital chuis la rencontre de différents chemins pour passer le Saint-Gothard. Ilyn un convenant du Valais, passé à côté du glacier du Rhône et par la montagne de Forques. Un second convent de Grisons, passé par descentes et caillemets entre les sources du Bas Rhin. Ce sont des sentiers, qu'on juge de ce ils peuvent être d'après le grand chemin que nous venons de décrire, que conduit de la Suisse en Italie. Sur la droite du village de Hospital est un vallon que nous avons visité jusqu'au village de Zum Diorf, à un grand demi-lieu. Il y regne aussi une couche de pierre calcaire à même hauteur, au bas de la montagne que renferme le vallon, et nous prions de remarquer qu'elle est aussi sur la droite, et que sur la gauche il y a de pierre à l'air. Un masse énorme de cette espèce, sous lequel on travaille depuis longtemps pour en tirer de quoi faire de poles, ayant perdu son équilibre, est tombé sur le côté. Les rochers que dominant, sont de rochers schisteuses micaces avec du quartz. Ce dernier village fait aussi partie de la vallée d'Urseren, c'est le pays habite le plus élevé de l'Europe, les habitants sont forts et robustes, les montagnes de ce canton étant nous, arides, et fort rapides, les avalanches y sont fréquentes. C'est au sortir de Hospital qu'on monte véritablement le mont Saint-Gothard, le chemin est escarpé, pave, et bien entretenu. Par un vallon à droite descend le Garcerin, torrent que vient de glaciers. Son est blanchâtre, se jette dans la rousse, et en trouble la limpidite, les rochers sont de plus en plus dépouillés, secs et arides, on trouve les derniers buissons, de olmes rabougris. La rousse tombe de rocher en rocher, de blocs et de quartiers énormes, que remplissent sunlit, lui barrent souvent le passage. Ses excellents pardeses quand lne put le contourner. On envoie enfin que de rochers, de abîmes et de précipices, on marque néanmoins en charite au milieu de ce désordre de la nature. Les chemins sont bien pavés, et assez larges pour que du chevaux ou du mulets charges puissant y passer de front. Sur un rocher à droite, à un lieu de hospital environ, on trouve tales dans le roc les limites entre le pays d'Urseren et la partie italienne au vallée de l'Ivenen, ainsi tout sommet d'Usti. Gothard appartient à la partie italienne, que est actuellement sujet du canton d'Uri. On parvient enfin sur un terrain plus uni, et un espèce de plateau, c'est le haut du Saint-Gothard. À un demi-lieu sur la droite, entre de rochers forts hauts, forts escarpes et à pic, est un espèce d'entonnoir, aussi ressemblant les eaux de neige fondues. Elles y forment le petit lac de Lezendro, geli le trois quarts de l'année, d'où la rousse tire sa source en partie. Car le glaciers du mont de la Fourche au fort dans le haut Valais, fournissent aussi un torrent que est regard comme la seconde source de la Rousse, le Rhône prend sa source dans la partie opposée du main glacier. Le haut du Saint-Gothard est un vrai vallon, puisque de cimes, de pyramides, de montagnes prodigieuses, composées toutes de rochers, es élevant audaces, et l'entourant de tous côtés. L'espace que est entre ces rochers a un forme à peu près circulaire. Il pourrait avoir été un fond que a été élevé comble jusqu'au point où il est par les débris de montagnes que le dominant, et que sy amoncelant encore actuellement sous nos yeux. Il a un espèce de niveau que vient un peu en pente du côté du midi, et du côté du nord par lesquels se fait l'écoulement de eaux fournies par la fonte de neige, dont la rousse et le tessin sont les canaux. Des masses étonnantes de rochers remplissent la surface de ce vallon, elles y sont places dans un désordre que any ressemble point aux expositions de rochers actuels, et autorise à croire qu'elles y ont été jetées et culbutées au hasard. Ces masses isolées sont toutes de granit, composées de quartz, de feldspath, et de mica verdâtre, le chemin que traverse ce vallon tourne autour de ces masses. Il faut que les pixelives que bordent ce vallon ayant été beaucoup plus hauts qu'ils ne le sont actuellement pour avoir pu fournir à combler cette étendue, que un le moins. Il n'est pas de tournant plus, que les vastes montagnes que font au pied de toutes celles que forment l'enceinte du Gothard, au moyen desquelles on trouve un accès plus facile. Et de ramps moins rapides pour s'élever comme par degrés à cette hauteur, que composent enfin ces montagnes de seconde et de troisième formation, any doivent leur existence tuer aux débris de ces colosses que dominent tout. L'examen de ce que s'est passé sous nos yeux éléments, any put nous laisser aucun doute sur l'abasement de montagnes. Il a point de torrent, point d'écoulement d'eaux, quelque petit qu'il soit, que en entraîne en descendant de montagnes, de terraces, de graviers, au lieu de sables, pour les porter plus bas. Les grands torrents, les fleuves, les rivières, gonflés par les fontes subites de glaces et de neige, entraînant de rochers entières, creusant de vastes et profonds ravins. Ces masses de rochers diminuant par le choc et le frottement qu'elles échouent entre elles, et sur les rochers sur lesquels elles passent, dont elles occasionnent réciproquement la destruction. Ces sont de débris de cette espèce de trituration que troublent les eaux, et dont le dépôt élève insensiblement les bords de rivières, formi le limon fécondant de nos plaines, et va former jusque dans le sein de mers ces adourissements. Ces bars, et ces banks que en reculant les bornes. Les rochers les plus durs, ces granites que les milers outils ont tant de peine à façonner, any resistant point au temps et aux intempéries de saisons. Leur superficie est de nature et se décompose souvent au point de n'y pas les reconnaître, de lichens, de petites mousses s'insinuant dans leur tissu, l'eau y pénètre, et la gelée sépare leurs parties. Silsse trouvant place sur un pente de fécon à pouvoir être entraîné par les eaux, la plus grosse masse est bientôt réduite à peu de choses, après avoir parcouru un plan incline. Quels changements ne doit pas avoir opéré cette marque constante de la nature. À quel point n'est-elle pas rendu méconnaissable la superficie du globe que nous habitons? Pour peu qu'on réfléchisse que les montagnes fournissent continuellement aux plaines, et que celles-ci n'y rendent rien aux montagnes, on pourrait ainsi faire quelque idée de changements que la révolution de siècles a dû opérer. Aussi n'est-ce que sur les hautes montagnes qu'on aperçoit encore parmi leurs vastes débris, les matériaux que ont servi et servent aux créations nouvelles que la nature opère journellement, qu'ils sont grands. Qu'ils sont majestueux ces antiques débris. Qu'il home est petit, qu'il est confondu quand il os y porter un regard curieux. In this picture of the Alps, there is presented to our view the devastation of solid rocks by agents natural to the surface of the earth. Here is the degradation of mountains in the course of time. Of these ruins plains are formed below. And these plains are continually shifting their place, in affording materials to be washed away and rolled in the rivers, and in receiving from the higher grounds the spoils of ruined rocks and mountains. Such operations are general to the globe, or are to be found over all this earth, but it is not everywhere that we have descriptions proper to give just ideas of this subject, which escapes the common observation of mankind. As I have given an example in the Alps of Savoy and Switzerland, it may be proper to give some view of the same operation in those of the Pyrenees. Essai sur la minéralogie de Monts Pyrénées, page 76. La vallée d'Aspi est hérissée dans toute sa longueur, par le Gave, que prend sa source vers les frontières d'Espagne, dans les temps de pluie et d'orage, cette rivière est colorée en rouge par de terraces composées de schiste rougeâtre. Que est éboulant, de montagnes de Gabedale et de Pyrénées, au reste les eaux du Gave profondément encaissées dans leur lit n'y peuvent plus contribuer à la fécondité de plaines qu'elles ont formes. On observe, en suivant cette rivière que lorsque les montagnes courent parallèlement, les angles phalens quels forment correspondent aux angles rentrans. Cette règle générale cert à établir que les vallées de Pyrénées, il faudrait plutôt appeler de gorges puisqu'elles en ont demi-le dans leur plus grande largeur, sont à l'ouvrage de os, mais doit en les ranger parmi celles km. De Buffon a démontrer avoir été creuses par les courants de la mer, ou les supposer formes par les torrents que s'y précipitent de montagnes. Ne croyez pas, dit-M. D'Arcet, en faisant mention de vallées de Pyrénées, que les os ayant pris ces routes parce qu'elles les ont trouvées frayes antérieurement à leur cours. Ces sont les os mêmes d'Enote, que, s'y ressemblant peu à peu, s'y sont avert de for ces passages, elles s'y sont creuses ces lits dans le temps passes, comme elles les creusent encore tous les jours. Voyez la discours sur l'état actuel de Pyrénées, p. 10. Page 86. Les pierres que les os du val de Canfrac entraînent, sont rarement uses dans leurs angles. On en trouve peu dont la figure soit arrondie, comme celle de pierres que roulent les torrents de la partie septentrionale de Pyrénées. Le sol de environs de Chaper, plus élève que celui de plaines du côté de la France, suppose à ce qu'elles soient emportés à des grandes distances, et avec la rapidité nécessaire pour recevoir, par un long frottement. En figure arrondie, on any voit point de pierres roules dans les plaines que entourent cette ville, les bancs calcaires any sont couverts que d'une croûte de terre peu épaisse. Une telle formation diffère de celle qu'on observe au pied de Monts Pyrénées, du côté de la France, où le sol de plusieurs contres est composé de débris que les rivières ont déposes 53. En partie de l'Égypte, selon Hérodote, a été pareillement formé de matters que le Nil y a apportés, Aristotle la nommé à l'ouvrage du fleuve, c'est pourquoi les Éthiopiens s'éventoyent que l'Égypte leur était redevable de son origine. Les habitants de Pyrénées pourraient dire la même chose de presque tous les contres situés le long de la chaîne septentrionale, depuis l'océan jusqu'à la Méditerranée. Etica forment cette espèce d'isthme que sépare les deux mers, c'est ainsi que la nature change continuellement la surface de notre globe. Elle élève les plaines, abaisse les montagnes, et l'eau est principal agent qu'elle emploie pour opérer ces grandes révolutions, il n'y faut que du temps, pour que le mot de Louis XIV. À son petit fils, s'y réalise. La postérité pourra dire un jour. Il a plus de Pyrénées. On conquête combien cette époque est éloignée de nous. Jensen a trouvé, par de observations qu'il pretend non équivoques, que la surface de ces montagnes baisse d'environ 10 pouces par siècle. Ainsi, en les supposant seulement de 15 toises au-dessus du niveau de la mer, et toujours susceptibles du même degré d'abaissement, il s'écoulera 1 million d'années avant leur destruction totale. I do not know in what manner Jensen made his calculation. I would suspect it was from partial, and not from general observations. We have mountains in this country, and those not made of more durable materials than what are common to the earth, which are not sensibly diminished in their height with 1,000 years. The proof of this are the Roman roads made over some of those hills. I have seen those roads as distinct as if only made a few years, with superficial pits beside them, from whence had been dug the gravel or materials of which they had been formed. The natural operation of time upon the surface of this earth is to dissolve certain substances, to disunite the solid bodies which are not soluble, but which, in having been consolidated by fusion, are naturally separated by veins and cutters. And to carry those detached bodies, by the mechanic force of moving water, successively from stage to stage, from places of a higher situation to those below. Thus the beds of rivers are to be considered as the passages through which both the lighter and heavier bodies of the land are gradually traveling. And it is through them that those movable bodies are from time to time protruded towards the seashore. But, in the course of rivers, it often happens that there intervenes a lake. And this must be considered as a repository for heavy bodies which had been transported by the force of running water, in the narrow bed through which it was obliged to pass. For, being arrived in a lake, the issue of which is above the level of its bottom, the moving water loses its force in protruding heavy bodies, which therefore it deposits. Thus the bottom of the lake would be filled up, before the heavy materials which the river carries could be made to advance any farther towards the sea. Reasoning upon these principles, we shall find, that the general tendency of the operations of water upon the surface of this earth is to form plains of lakes, and not, contrarily, lakes of plains. For example, it was not the Rhone that formed the Lake of Geneva. For, had the lake subsisted in its present state, while the Rhone had transported all the matter which it is demonstrable had passed through that channel from the Alps, the bed of the lake must have been made a plain through which the river would continue to pass, but in a changing channel, as it does in any other plain. We are therefore led to believe, that the passage of the Rhone through the lake, in its present state, is not a thing of long existence, compared with the depredations which time had made by that river upon the earth above the lake. But how far there are any means for judging, with regard to the causes of that change which must have taken place, and produced the present state of things about this lake, can only be determined by those who have the proper opportunity of examining that country. If lakes are not in the natural constitution of the earth, when this is elevated from the sea into the place of land, they must be formed by some posterior operation, which may be now considered. There are in nature, that is, in the natural operations of the globe, two ways by which a lake may properly be formed in a place where it had not before existed. One of these is the sliding or overshooting of a mountain or a rock, which, being undermined by the river, and pressed by its weight, may give way, and thus close up the defile through which the river had worn for itself a passage. The other is the operation of an earthquake, which may either sink a higher ground, or raise a lower, and thus produce a lake where none had been before. To which, indeed, may be added a third, the dissolution of saline or soluble earthy substances which had filled the place. So many must have been those alterations upon the surface of the earth which we inhabit, and so short the period of history by which, from the experience of man, we have to judge, that we must be persuaded we see but little of those operations which make any sensible change upon the earth. And we should be cautious not to form a history of nature from our narrow views of things. Views which comprehend so little of the effects of time, that they may be considered as nothing in the scale by which we are to calculate what has passed in the works of nature. To form an idea of the quantity of the solid land which has been carried away from the surface of the earth, we must consider our land, with the view of a mineralist, as having all the soil and travelled materials removed, so as we might see the terminations of all the strata, where these are broken off and left abrupt. Now, the generality of those strata are declined from the horizontal plane in which they had been formed, and shew that the upper extremity had been broken off and carried away. And the quantity of that which has been carried away, since the time of the formation of those strata, so far as may be judged from the nature and situation of what remains, must be concluded as very great. This is best to be observed in mountainous countries, where not only the causes of this destruction of the land are more powerful, but the opportunities of investigating the effects more frequent, from the washing away of the loose soil or covering. The correspondent angles of the valleys among mountains is a subject of this nature, in which may be perceived a visible waste of the solid mountain which has those correspondent angles. I am happy to have an authority so much better than my own observations to give on this occasion, where the question relates to what is common or general in these appearances. It is that of M. de Luc, Lettres physiques et morales, tom. 2, page 221. Mais avant de finir sur les montagnes primordiales, Illinois faut que je revienne à ces angles salins et rentrants alternativement opposés, que lorsque Mr. Bourget les anonca, ferent un si grand brute parmi les naturalistes qu'ou on any doute plus que toutes les montagnes any fussent à l'ouvrage de la mer. Voici ce phénomène prétendu démonstratif. Lorsqu'on voyage dans les vallées, on vit ordinairement entrenoyant, et quand un angle salient oblige à courber la route, on trouver assez souvent un angle rentrant que lui fait face, il la vallée conserve à peu près la même largeur. M. Bourget ayant fait cette remarque, considerant que les bords opposés d'une rivière que serpente, offrant la même opposition de angles salins et rentrants, en conclut en général, que les montagnes avoyant été formes par les courants de la mer. Si toutes les montagnes, et les Alpes par exemple, avoyant tous les autres caractères qui exigent une telle formation cellulaire sans doute any paroitroit pas les contredire. Et il en peut même disconvenir, que au premier coup d'œil, ces zigzags any ressemblant beaucoup aux effets de aux courants. Cependant ces caractères appartiennent bien plus aux que se frayant en route, que celles que font de dépôts. Une rivière que creuse son lit, se détourne à la rencontre d'un obstacle, et dirige le côté oppose, c'est ce que produit ses méandres. Mais en any voit point les mêmes causes de zigzags dans les courants au sein de la mer. Au moins qu'il n'y ait déjà de montagnes. En effet sil on considère les montagnes et les collines que par leurs couches et les corps étrangers qu'elles renferment, modrant sans équivoque qu'elles sont à l'ouvrage de os, on les trouvera le plus souvent ranges sans ordre. Quelquefois elles n'y paroissent que de monceaux poses ca et là, comme dans une grande partie du Piémont. Elles sont sous la forme de chaînes continues, on y trouve peu de parallélisme, c'est-à-dire de ces angles rentrants opposés aux angles salins, tel est le Jura. Mais les courants de la mer ont trouvé de montagnes toutes faites, et qu'ils les ayant traversées, dans quelques sens que ce soit. Ils sont faits de routes dans les endroits où la résistance est moindre, et ont rangé les bords de leurs canaux à la manière de rivières. On doit donc y trouver du parallélisme. Si maintenant on considère la chaîne des Alpes, on verra qu'elle répond fort bien à cet effet naturel. Quoique ces montagnes forment une chaîne dans leur ensemble, leurs parties supérieures n'y montrent aucune sorte d'arrangement particulier, aucune trace de zigzags, c'est dans le fond de grandes vallées. Ou dans les coupures que servent à l'écoulement de os, que ce parallélisme de côtés opposés se remarque. Quoique avec bien de exceptions. ECE QILY est de plus important à considérer, c'est que ces grandes vallées ou les angles salins et rentrants forment l'agrément le plus sensible, qu'ont ordinairement la chaîne en travers, au lieu de la suivre. Ce que en one's plutot destruction tu edification. Ainsi les angles salins et rentrants alternativement opposés dans les vallées de montagnes, peuvent bien contribuer à prouver qu'elles ont été toutes sous les eaux de la mer. Mais non que la mer les ait toutes faites. C'est ici donc un nouvel exemple de la nécessité de considérer attentivement les idées que paraissent le plus naturelles au premier coup d'œil, car c'était aperçu et bien un de ce qu'on est tant d'admettre sans examiner autre chose que la vérité. Du fait. Here we have the testimony of this author concerning the nature of those causes by which the shape of the surface of the earth, in those regular appearances of corresponding parts, had been determined, viz. That these had been destroying operations, and not those by which the mountains had been formed. We differ, however, from this naturalist with regard to the particular agent here employed. It will be shown, in a subsequent chapter, that there is almost as little reason to conclude from this appearance, that the space between the correspondent angles had been hollowed by the currents of the sea, as that those angles had been formed by matters deposited in that shape and situation. Farther, treating of the calcareous mountains, the same author observes, Lettre 38. Page 229. Cette chaîne extérieure de Alpes évidemment d'origine marine, a cependant de caractères que la distinguent de la plupart de autres montagnes de la même classe, et ces caractères semblent annoncer plus d'antiquité. Je crois d'abord pouvoir les regarder comme les montagnes secondaires les plus hautes de notre continent. Je ne parle ici que de montagnes marines. En toute leur destruction est beaucoup plus grande que celle d'aucune autre montagne de ce genre que me soit connue, car elles sont presque aussi courantes de pics que les Alpes primordiales. ECES pics, étant par couches, montrent de restes d'anciens sommets que devoyant avoir un grande étendue. Ce que, joint à quelques dérangements dans leurs couches, pourrait indiquer que ces montagnes ont été exposées plus longtemps que la plupart de autres montagnes secondaires, aux révolutions chuesuyoit le fond de la mer. Et qu'elles en sont sorties déjà fort altérées. There is at present no question concerning the particular shape in which the mountains of the earth had come out of the waters of the sea. We are considering the wasting of those mountains, in being exposed to the atmosphere and waters of the earth. And the operation that the sea may have had upon their surface, is a subject for judging of which we have not the smallest data, unless by taking the thing for granted. Or supposing that the present state of things is that former shape after which we inquire. Now, this is a species of reasoning that M. de Luc would certainly explode. For he admits, as we shall afterwards find, great changes among the mountains of the Alps, from the influences of the atmosphere, perhaps more rapid changes than we are disposed to allow. Therefore, to call in the aid of the ocean, for the degradation of these secondary calcareous mountains, holds of no reason that I can see. Unless it be that of diminishing the time which otherwise would have been required in bringing about those changes by the atmosphere alone. To conclude, whether we examine the mountain or the plain, whether we consider the degradation of the rocks, or the softer strata of the earth. Whether we contemplate nature, and the operations of time, upon the shores of the sea, or in the middle of the continent, in fertile countries, or in barren deserts, we shall find the evidence of a general dissolution on the surface of the earth. And of decay among the hard and solid bodies of the globe. And we shall be convinced, by a careful examination, that there is a gradual destruction of everything which comes to the view of man, and of everything that might serve as a resting place for animals above the surface of the sea. Chapter 5. Facts in confirmation of the theory respecting the operations of the earth employed in forming soil for plants. I have distinguished the mineral operations of the earth, by which solid bodies are formed of loose materials, as well as the resolving or decomposing operations which are proper to the surface exposed to the sun and atmosphere. I have also pointed out the end or intention of those several operations, and likewise the means by which they have been brought about. We may now turn our view to that part of the system in which an indefinite variety of soils, for the growth of plants and life of animals, is to be provided upon the face of the earth, corresponding to that diversity which, in the wisdom of nature, has been made of climates. In this last view, now to be considered, some confirmation should be given to the theory, in finding the soil, or travelled materials upon the surface of the land, composed of earth, that is, of sand and clay, of stones and gravel. The earth and stones as arising from the resolution and separation of the solids in the neighbourhood of the place, the gravel, again, as having often travelled from more distant parts. It would be very improper to adduce any example of a particular, where the force of the argument lies in the generality alone. It is enough to have mentioned the facts which are to be examined. Every person of inquiry and observation will judge for himself how far those facts are true. But there is one general remark that may be made on this occasion, where the operations of the surface are concerned, and which may assist the investigation of this subject. It is with regard to the gravel or stones worn by attrition, which may have come from a distance. In proportion as hard and insoluble stones are near to their natural beds, they will be found with the sharp angles of their fracture, unless there may have been a cause of agitation and attrition on the spot. They will also be in greater quantity, cet par. In this place, whereas the farther they may have travelled, they will naturally incline to be more rounded, and, in equal circumstances, will always be more scarce. We have thus principles by which to judge of every appearance in relation to the travelled materials of our soil. When, for example, we find an immense quantity of the hardest stones worn round by attrition, and collected not far distant from their native place, we cannot suppose that they have acquired their shape by the attrition in the distance they have travelled, but in an agitation which they must have received nearly in the place from whence they came. Such is the gravel in the chalk country of England. Around London, in all directions, immense quantities of gravel are round, which consists almost entirely of flint worn or rounded by attrition. But this is the very centre of the chalk country, at least of England, and no doubt the same appearances will be found in France. We must therefore conclude, that the south of England was under water when that gravel was formed. And that immense quantities of the chalk above had been destroyed by the agitation of the sea in preparing such quantities of gravel which still remain upon the land. Besides the immense quantities which must have been dispersed all around during the operation, as well as carried into the sea by the rivers since the elevation of our land. It is not uncommon to find this gravel 20 or 30 feet deep. And masses are found of much greater thickness. Were these masses of gravel formed in a deep hollow place, they would draw to no conclusion beyond the appearance itself, but they are, on the contrary, in form of hills. And therefore they serve as a kind of measure or indication of what had been carried away when these were left remaining. We may observe a series or a progress in those forming and destroying operations, by which, on the one hand, the flinty bodies, already formed in the mineral region, were again destroyed, in being diminished by their mutual attrition. And, on the other hand, those diminished bodies were again consolidated into one mass of flinty stone, without the smallest pore or interstice. This example is to be found in the pudding stone of England. It consists of flint pebbles, precisely like Kensington gravel, penetrated or perfectly consolidated by a flinty substance. Here are the two opposite processes of the globe carried on at the same time and nearly in the same place. But it must be considered, that our land was then in the state of emerging from the sea, and those operations of subterranean fire fit for elevating land was then no doubt exerted with great energy. At present, no such thing appears in this place. But, from the momentary views we have of things, it would be most unphilosophical to draw such absolute conclusions. The argument now employed rests upon the identity of the substance of the gravel with that of the entire flint, which is found in the chalk country. And it goes to prove that the sea had worn away a great deal of that chalk country above the place upon which this body of gravel is now resting. Consequently that the sea had formerly flowed over that country covered with gravel, and had dispersed much of that gravel in transporting it to other regions, where that species of flint was not naturally produced. By a parity of reasoning, the gravel produced in the neighboring regions, and which would be proper to those places, as consisting of their peculiar productions, must have been likewise dispersed and mixed with the surrounding bodies of gravel. But as in the country of which we are now treating, there are considerable regions, the different productions of which are perfectly distinct, we have a proper opportunity of bringing those conclusions of the theory to the test of observation. For this purpose, let us examine the different countries which surround the chalk regions of England, France, and Flanders, if the gravel upon those neighboring countries contain flint which the country does not naturally produce. And if the mixture of this flint among the gravel, which is proper to the country itself, be with regard to quantity in proportion to the vicinity of the flint country, the theory will then be confirmed, and there is no doubt that this is so. On the other hand, let us examine the gravel about London, which is far distant from any place that produces quartz. If we shall find a very small proportion of quartz gravel in this flinty soil, we may be assured that the quartz has travelled from a distance, and that the theory is thus approved. This is actually the case, and I have seen pudding stone containing quartz gravel among the flint. In confirmation of this view of the travelled soil, it may be observed, that in Lower Saxony about Hamburg, and for a great way to the southwest, the gravel is mostly of broken flint. Such as is around the chalk countries, yet it is at a distance from the chalk of Flanders. There is however at Luxembourg chalk with flint, the same as in England and France. Therefore the flinty soil of that country, in like manner, demonstrates the great destruction of the solid parts, and illustrates the formation of soil by the remainder of the hard parts below, and the alluvion of other parts. There is most undoubted evidence that the solid body of our land had been formed at the bottom of the sea, and afterwards raised above the surface of the water. But, in the case which has now been described, it appears that the travelled soil of the surface of our land had been lately under the surface of the sea. We have thus therefore traced the different steps in the operations of nature, of which the last step may be considered as thus exposed to our view almost as much as the operations of man in building the pyramids of Egypt. But surely there are other documents to be found in examining the different coasts of this island with attention, and there must be a consistency in the general appearance which never fails to attend on truth. From the south to the north of this island, there are, in many places, the most evident marks of the sea having been upon a higher level on the land. This height seems to me to amount to about 40 or 50 feet perpendicular at least, which the land must have been raised. Some of those facts may now be mentioned. Upon the banks of the Thames, I have found sea shells in the travelled soil a considerable height above the level of the sea. In Low Suffolk there are great bodies of sea shells found in the soil which the farmers call crag, and with it manure their land. I do not know precisely the height above the sea, but I suppose it cannot exceed 100 feet. In the Frith of Forth there are, in certain places, particularly about Newhaven, the most perfect evidence of a sea bank, where the washing of the sea had worn the land, upon a higher level than the present. The same appearance is to be found at Ely upon the Fife coast, where the sea had washed out grottos in the rocks. And above Kinneil, there is a bed of oyster shells some feet deep appearing in the side of the bank, about 20 or 30 feet above the level of the sea, which corresponds with the old sea banks. I have seen the same evidence in the Frith of Cromarty, where a body of sea shells, in a similar situation, was found, and employed in manuring the land. There are many other marks of a sea beach upon a higher level than the present, but I mention only those which I can give with certainty. We have been considering an extensive country more or less covered with gravel. Such is England south of Yorkshire, both upon the east and west sides of the island. This country having no high mountainous part in the middle, so as to give it a considerable declivity towards the shores and rivers, the gravel has remained in many places, and in some parts of a considerable thickness. But in other parts of the island, where the declivity of the surface favours the transportation of gravel by the currents of water, there is less of the gravel to be found in the soil, and more of the fragments of stone not formed into gravel. Still, however, the same rule holds with regard to tracing the gravel from its source, and finding particular substances among the gravel of every region, in proportion to the quantity of country yielding that substance, and the vicinity to the place from whence it came. Here are principles established, for the judging of a country, in some respects, from a specimen of its gravel or travelled stones. In this manner, I think, I can undertake to tell from whence had come a specimen of gravel taken up anywhere, at least upon the east side of this island. Nor will this appear any way difficult, when it is considered, that, from Portland to Caithness or the Orkneys, there are at least 10 different productions of hard stone in the solid land which are placed at proper distances, are perfectly distinguishable in the gravel which is formed of them, and with all of which I am well acquainted. Let us suppose the distance to be 600 miles, and this to be divided equally into 10 different regions of 60 miles each. It must be evident that we could not only tell the region, which is knowing within 60 miles of the place, but we could also tell the intermediate space, by seeing an equal mixture of the gravel of two contiguous regions. And this is knowing within 30 miles of the place. If this be allowed, it will not seem difficult to estimate an intermediate distance from the different proportions of the mixed gravel. This is supposing the different regions to be in all respects equal, which is far from being in reality the case. Nevertheless, a person well acquainted with the different extent and various natures of those regions, may make allowances for the different known circumstances that must have influenced in those operations. Although it is most probable there will be others which must be unknown, and for which he can make no allowance. The author of the Tableaux de la Suisse has entered very much into this view of things. He has given us some valuable observations in relation to this subject, which I would here beg leave to transcribe. 54. Nous avons dit précédemment que si tout entre or fur et l'idée que nous avions vu les derniers granits roules, en une rencontre plus dans tout le reste de la route jusqu'au haut du Mont Saint-Bernard. Les rochers que dominant ce sommet ne sont pas composés de granits, et qu'aucun ne puisse aborder jusqu'à leur plus grande élévation, on peut juger de leurs espèces, par les masses que s'en précipitent. Do puvant donc provenir ces masses roules de granits que se trouvent jetés et répandus sur le penchant et au bas de ces monts. Ilya put être quelques montagnes ou rocher de granit que nous n'avons pas été à portée de voir, il faudrait plus d'un mois pour faire un parel examen et parcourir les montagnes environnantes, et faute de pouvoir parvenir à certains sommets. Examiner scrupuleusement les fonds pour juger de hauts. De perils recherches sont plus difficiles et plus longs qu'en any le croit communément quand on veut réellement voir et observer. Beaucoup de vallons sont communs à de hauteurs prodigieuses, par les hommes et les débris provenant de montagnes supérieures, ils cessent d'être de vallons, pour former ou faire partie de montagnes. Ces déplacements et de bouleversements, changeant la direction et le courant de torrents, entraînant dans de parties bien opposées de débris qu'on croirait devoir chercher et trouver ailleurs. On serait induit en erreur, en voulant suivre toujours le cours actuel de os que descendent de montagnes. Ce n'est pas dans cette occasion seul mais l'Allemagne, la Corse, la Sardaigne, et beaucoup de pays de hautes montagnes. Nous out fournit également d'exemples de masses de rochers roules de différentes species dont il n'existe pas de rochers parels, dont toutes les parties élevées environnantes, plusieurs lieues, à plusieurs journées de chemin. Et souvent totalement inconnus dans les pays d'alentour. Si nous avons remarqué les mêmes species de rochers faisant corps, et attachés au sol, à un ou plusieurs lieues de distance. Nous avons vu souvent que de montagnes plus hautes citoyent entre ces masses roules et les rochers, d'où on aurait pu supposer qu'elles ont été éradiquées, il répond à croire que de masses, d'un poids prodigieux. Ayant été transportés et roules en travers d'un vallon profond, pour remonter et passer de l'autre côté d'une montagne. Nous abandonnons, à ce que travaillant dans le cabinet, à l'arrangement du globe, la recherche de moyens que la nature a employés pour produire de pareils effets. Nous contenterons, ainsi que nous avons promis, de rendre compte de ce que nous avons vu et observe. Et d'engager ce que auront la facilité de faire de remarques analogues de constater leurs observations en indiquant toujours les le fidèlement, ainsi que nous le faisions pour la Suisse. Here the experience of our naturalist amounts to this, that, in those operations by which the solid land is wasted, and the hard materials worn by attrition and transported, it is not always evident from whence had come every particular body of stone or mineral which had travelled by means of water. Nor the particular route which, in descending from a higher to a lower place, the protruded body had been made to take, although, in general, these facts may be discovered without much difficulty. Now, this state of things is no other than the natural consequence of the great wasting of the surface and solid parts of our land, and the unequal degradation of this surface, by which means the shape of the earth is so changed, that it would often be impossible, from the present state, to judge of the course in which many bodies had been travelled by water. M. De Saussure has described a very curious appearance of this kind. It is the finding the travelled materials of Mont Blanc, or fragments detached from the summit and centre of the Alps. In such places as give reason to conclude that they had passed through certain openings between the mountains of the Jura. This is a thing which he thinks could not happen according to the ordinary course of nature. He therefore ascribes this appearance to some vast debacle, or general flood, which had with great impetuosity transported all at once those heavy bodies, in the direction of that great current, through the defile of the Alps, or the openings of those mountains. In giving this beautiful example of the wasting and transporting operations of this earth, this naturalist overlooks the principles which I would wish to inculcate. And he considers the surface of the earth, in its present state, as being the same with that which had subsisted while those stones had been transported. Now, upon that supposition, the appearances are inexplicable. For, how transport those materials, for example, across the Lake of Geneva? But there is no occasion to have recourse to any extraordinary cause for this explanation. It must appear that all the intervening hollows, plains, and valleys, had been worn away by means of the natural operations of the surface. Consequently, that, in a former period of time, there had been a practicable course in a gradual declivity from the Alps to the place where those granite masses are found deposited. In that case, it will be allowed that there are natural means for the transportation of those granite masses from the top of the Alps, by means of water and ice adhering to those masses of stone. At the same time perhaps that there were certain summits of mountains which interrupted this communication, such as the Jura, etc., through the openings of which ridges they had passed. In this case of blocks of alpine stones upon the Jura, the question is concerning the transportation of those stones, but, in other cases, the question may be how those blocks were formed. That many such blocks of stone are formed by the decay of the rock around them, is clearly proved by the observations of M. Hassenfratz, published in the Annales de Chimie, October 1791. He has particularly mentioned a place on the road from Saint Flour to Montpellier, where an amazing collection of these blocks of granite is to be seen. It is here particularly that he observes these blocks to be the more durable parts which remain after the rock around them is decayed and washed away. The proof is satisfactory, the operation is important to the present theory. And therefore I shall give it in his own words. 2 les blocs de granit der dégages et sortes entièrement de masses que forment les montagnes, posent immédiatement sur le granit friable ou sur d'autres blocs d'ers que eux-mêmes sont sur le granit friable. Quoique la plupart de blocs de granit der, que l'on observe sur tout l'étendue de ce terrain granitique, soyant entièrement sortes et dégages de la masse de pierre que formit la montagne. On en rencontre cependant que n'y sont pas encore tout à fait dégages. C'est ici l'observation essentielle que conduit directement à l'explication du phénomène de l'arrangement, de l'entassement, et de l'amoncellement de blocs d'une manière simple et absolue. On voit sur la surface du terrain de portions de blocs d'ers que semblent sortir peu à peu, et dégager de la masse de granit friable. Celui-ci se décompose et se réduit en poussière tout autour de cette masse dure que les causes de décomposition du granit friable semblent respecter. Quelques uns de ces blocs d'ers, sortants de la montagne granitique, sont déjà considérables. On distingue chuils ny tenant plus que par un très petite partie. D'autres commencent à paraître se dégager, ils ny saillant, ils ny sortent encore que de quelques pites, et même de quelques pouces. Enfin, en examinant soigneusement et attentivement toute la surface de ce terrain granitique, on aperçoit tous les intermédiaires entre un bloc de granit der contenu et en chasse dans la masse totale du granit friable et un bloc entièrement dégagé. Ces observations, suivies avec attention, enilissent aucun doute que les blocs de granit que l'on observe sur toute l'étendue de ce terrain granitique. En ayant fait autrefois partie d'une couche considerable de granit décomposable que couvroit ces montagnes et exaucent leur sol. Que cette couche, dont il semble impossible d'apprécier la hauteur, malgré les blocs considérables que restent et que attestent son existence, a été décomposée par l'air et l'intempérie de saisons. Que la poussière, le sable résultants de cette décomposition, ont été entraînés par les eaux, et déposés à divers points de la surface de la globe. Et que ces blocs ont été peu à peu dégagés de la couche, ainsi qu'ils s'en dégagent encore tous les jours. To enable the reader to form a notion of what these blocks are, I shall farther give what our author has said in describing this place where they are found. C'est après avoir quitté le terrain volcanique, c'est dans le terrain granitique que j'ai trouvé de blocs énormes de granit, que ont fixe mon attention. Tout l'étendue du terrain granitique que j'ai traversé, s'y trouvé presque couvert de ces masses, les uns sur les sommets de montagnes les plus élevés, les autres sur la pente et dans les vallées. Plusieurs de ces masses sont arrangées les uns sur les autres avec un art inimitable, les autres sont isolées et éparses. Peu de ces masses amoung présent un spectacle plus beau et plus imposant que celles que l'on rencontre à 6 heures de marque de flour, à un petit demi-heure avant d'y arriver à la gare. Sur le sommet d'une montagne, est un amas considerable de blocs de granit, étonnants par leur volume et leur nombre. La grande route passée à travers, circule autour de ces masses que les constructeurs de chemins n'ont pas aux attaquer. Le voyageur est pénétré d'admiration en voyant l'ordre et l'arrangement symétrique de ces blocs monstrueux par leur masse, et il necesse d'observer en suivant la trace tortueuse du chemin que les contourne. Quelques uns de ces blocs sont posés purement et simplement les uns sur les autres, et forment un colonne isolé, le plus gros sur de base, et les autres, graduellement plus petits, sont posés dessus. On voit jusqu'à trois de ces blocs immédiatement l'un sur l'autre. D'autres fois, le bloc que sur de base est beaucoup plus petit que celui que le couvre immédiatement, et arrangement de ces deux blocs présente l'aspect d'un champignon. Plus souvent plusieurs blocs séparent les uns de autres, formant la base, et en ou plusieurs blocs sont posés immédiatement dessus, sans ordre constant, tantôt inclines, mais toujours d'une manière stable et fixe. Propre à résister aux plus grands efforts. Enfin, parfois, de masses plus petites places entre les grosses, semblant assurer la situation fixe de l'ensemble de blocs, mais ces rencontres sont fort rares. Here is a distinct view of this part of nature. A view in which the present state of things plainly indicates what has passed, without our being obliged to raise our imagination to so high a pitch as is sometimes required, when we take the mountains themselves, instead of these blocks. As steps of the investigation. Here is a view, therefore, that must convince the most scrupulous, or jealous with regard to the admitting of theory, first, that those mountains had been much higher, secondly, that they had been degraded in their present place. Thirdly, that this continent has subsisted in its present place for a very long space of time, during the slow progress of those imperceptible operations. And, lastly, that much of the solid parts of this earth has been thus travelled by the waters to the sea, after serving the purpose of soil upon the surface of the land. But though M. Hassenfratz has thus given us a most satisfactory view of the natural history of those blocks of stone which are now upon or near their native place, this will not explain other appearances of the same kind. Where such blocks are found at great distances from their native places, in situations where the means of their transportation is not to be immediately perceived, such as those resting upon the Jura and Salève. And where blocks of different kinds of stone are collected together. These last examples are the records of something still more distant in the natural history of this earth, and they give us a more extensive view of those operations by which the surface of this earth is continually changing. It is, however, extremely interesting to this theory of the earth, to have so distinctly ascertained some of those first steps by which we are to ascend in taking the more distant prospect, and these observations of M. Hassenfratz answered this end most completely. Thus all the appearances upon the surface of this earth tend to show that there is no part of that surface to be acknowledged as in its original state, that is to say, the state in which it had come immediately from the mineral operations of the globe. But that, everywhere, the effects of other operations are to be perceived in the present state of things. The reason of this will be evident, when we consider, that the operations of the mineral kingdom have properly in view to consolidate the loose materials which had been deposited and amassed at the bottom of the sea, as well as to raise above the level of the ocean the solid land thus formed. But the fertility of the earth, for which those operations were performed, and the growth of plants, for which the surface of the earth is widely adapted, require a soil. Now the natural, the proper soil for plants, is formed from the destruction of the solid parts. Accordingly, we find the surface of this earth, below the travelled soil, to consist of the hard and solid parts, always broken and imperfect where they are contiguous with the soil. And we find the soil always composed of materials arising from the ruin and destruction of the solid parts. Chapter 6. A view of the economy of nature, and necessity of wasting the surface of the earth, in serving the purposes of this world. There is not perhaps one circumstance, in the constitution of this terraqueous globe, more necessary to the present theory. Then to see clearly that the solid land must be destroyed, in undergoing the operations which are natural to the surface of the earth, and in serving the purposes which are necessary in the system of this living world. For, all the land of the present earth being a certain composition of materials, perfectly similar to such as would result from the gradual destruction of a continent in the operations of the inhabited world. This composition of our land could not be explained without having recourse to preternatural means, were there not in the constitution of this earth an active cause necessarily, in the course of time, destroying continents. It is therefore of great importance to this theory, to show, that the land is naturally wasted, though with the utmost economy, and that the continents of this earth must be in time destroyed. It is of importance to the happiness of man, to find consummate wisdom in the constitution of this earth, by which things are so contrived that nothing is wanting, in the bountiful provision of nature, for the pleasure and propagation of created beings. More particularly of those who live in order to know their happiness, and who know their happiness on purpose to see the bountiful source from whence it flows. We are to conceive the continent of the earth, when first produced above the surface of the ocean, to be in general consolidated, with regard to its structure, by the same mineral operations which are necessarily employed in raising it from its primary situation at the bottom of the sea, to that in which we now inhabit it. We are now to consider the purpose of this mineral body, exposed to the influences of the atmosphere, that so we may see the intention of its solid composition, as well as that of its resolution, or natural solubility when thus exposed. And we are to trace the ultimate effects of this order of action in the economy of the globe, that so we may perceive the wisdom of nature perpetuating the system of a living world in an endless succession, of changing perishable forms. The purpose of the land of this earth, in being placed above the sea and immersed in the atmosphere, is to sustain a system of plants and animals. But, for the purpose of plants, there is required a soil. And, as there is in the vegetable system a vast variety of plants with different habits or natural constitutions, there is also required a diversity of soils, in which those vegetable bodies are to be made to live and prosper. From the bare rock exposed to the sun and wind, to the tender mud immersed in water, there is a series to be observed, and in every stage or step of this gradation, there are plants adapted to those various soils or situations. Therefore nothing short of that diversity of soils and situations, which we find upon the surface of the earth, could fulfill the purpose of nature, in producing a system of vegetables endued with such a diversity of forms and habits. The soil or surface of this earth is no more properly contrived for the life and sustenance of plants, than are those plants for that diversity of animals, which will thus appear to be the peculiar care of nature in forming a world. Scarce a plant perhaps that has not its peculiar animal which feeds upon its various productions, scarce an animal that has not its peculiar tribe of plants on which the economy of its life, its pleasure, or its prosperity must depend. If we shall suppose the continent of our earth to be a solid rock, on which the rain might fall, and the wind and waves might dash perpetually, without impairing its mass or changing its constitution, what an imperfect world would we have! How ill adapted to the preservation of animal and vegetable life! But the opposite extreme would equally frustrate the intention of nature, in producing bounteously for the various demands of that multiplicity of species which the author of this world has thought proper to produce. For if, instead of a solid rock, we shall suppose a continent composed of either dry sand or watery mud, without solidity or stability, how imperfect still would be that world for the purpose of sustaining lofty trees and affording fruitful soils. We have now mentioned the two extreme states of things. But the constitution of this earth is no other than an indefinite number of soils and situations, placed between those two extremes, and graduating from the one extreme, in which some species of animals and plants delight in finding their prosperity, to the other, in which another species, which would perish in the first, are made to grow luxuriantly. That is to say, the surface of this earth, which is so widely adapted to the purpose of an extensive system of vegetating bodies and breathing animals, must consist of a gradation from solid rock to tender earth, from watery soil to dry situations. All this is requisite, and nothing short of this can fulfill the purpose of that world which we actually see. We have been representing this continent of our earth as coming out of the ocean a solid mass, which surely it is in general, or in a great degree, but we find the surface of this body at present in a very different state. And now it will be proper to take a view of this change from solid rock to fertile soil. Upon this occasion I shall give the description of nature from the writings of a philosopher who has particularly studied this subject. It is true that M. de Luc, who furnishes the description, draws, from this process of nature, an argument for the perpetual duration or stability of mountains, and this is the very opposite of that view which I have taken of the subject. But as, in this operation of nature producing plants on stones, he allows the surface of the solid stone to be changed into earth and vegetables, it is indifferent to the present theory how he shall employ this earth and vegetable substance. Provided it be acknowledged that there is a change from the solid state of rock to the loose or tender nature of an earth, from the state of a body immovable by the floods and impenetrable to the roots of plants, to one in which some part of the body may be penetrated and removed. 55. Les pluies et les roses forment per tout ol séjournant, de dépôts que sont la première source de toute végétation. Ces dépôts sont toujours mêlés de semences desmesses, que l'air cherry continuellement, et auxquels se joignent bientôt les semences presque aussi abondantes de gramins, que sont l'herbe dominante de nos prairies. Ainsi per tout la pluie a forme quelques petits dépôts, il croit de la mousse au lieu de gramins. Ceci demandant un peu plus de terre végétale pour croître, ils germent, et conservant principalement dans les intervalles et les creux de pierres, mais la mousse croît bientôt sur la surface la plus unie. Il n'est aucune pierre longtemps exposée à l'air, que soit parfaitement polie, l'action de l'air, du soleil, de eaux, de gelies, de truroit ci poly quand il existeroit. Le moindre creux alors recueille un dépôt de la pluie, et nourrit un brin de mousse, ces brins poussent de racines. Et de nouveaux jets ardilleux, que contribuent à arroder l'eau de la pluie et de la rose, et par ces moyens à arroder les dépôts nourriciers. Quand la mousse a multiplié ses filets, les dépôts augmentent plus rapidement encore. Les brins de la mousse, en second et pourrissent, en forment eux-mêmes. Car leur substance en étoit que ces mêmes dépôts féconds, d'autres semences cherries par l'air, coopéravant glissant sur les pierres, parce que rien en les retenoit, tombant dans le fond de la mousse. Et y trouvant l'humidité nécessaire pour produire leurs premières racines, celles-ci s'entrelacent dans la mousse, elles se conservant à l'abri du soleil, et sont alors autant de petites bouches que pompent les sucs, que l'air, les pluies. Et les roses y déposent. Ces premières plantes sont foibles, quelquefois même elles n'y parviennent pas à leur perfection, mais elles ont contribuent à fixer la terre végétable. En second se décomposent, elles se transforment en cette terre, que tombe au fond de la mousse, et que prépare ainsi de la nourriture pour de nouvelles plantes qu'alors prospèrent et fructifient. Nous connaissons peu encore que cette terre végétable, dépôt de pluies ou en général de l'air. Cependant, en rassemblant les phénomènes, on peut conjecturer, que la plupart de corps terrestres sont susceptibles d'être changes en cette substance, et qu'ils agit pour cette transformation que de les décomposer. J'entends par là une telle division de leurs parties, que devenant presque de éléments, elles puissent être intimement mêlées à l'eau, et pompées avec elles par les tuyaux capillaires de plantes. En un mot, Illinois semble suffisant une matière puisse entrer en circulation dans les végétaux, pour qu'elle serve en développer le tissu, et qu'elle y prenne la figure et les qualités que chacun de ces laboratoires est propres à produire. Nous pouvons accélérer de bien de manières la transformation de matières terrestres en terre végétable. La fermentation, la calcination, une plus grande exposition à l'air, différents mélanges, rendant propres à la végétation, de matières que n'y élitoyent par elles-mêmes, voilà ce que peuvent nos soins. Mais l'air travaille sans cesse en mille manières. Son simple frottement sur tous les corps, en enlève de particules si atténuées que nous n'y les reconnaissons plus. La poussière de nos appartements en est peut-être un exemple. De quelque nature que soyant les corps dont elles se détachent, c'est un poudre grisâtre que semble être pour tout la même. La formation de la terre végétable a probablement quelque rapport à celle-là. Tout la surface de la terre, les rocs les plus durs, les sables et les graviers les plus arides, les métaux mêmes, approuvent l'action rangeante de l'air et leurs particules atténuées, décomposes, recomposes de mille manières. Sont probablement la source principale de la végétation. L'air lui-même ainsi quello, sy combinant, beaucoup d'observations et d'expériences nous prouvent que ces deux fluides fournissent leur propre substance aux parties solides de végétaux. Et par conséquent à la terre végétable que les produits et ils déposent. Quantité de plantes se nourrissent de l'eau sol, et nous les indépendant en se second, un résidu de matière solide permanente. L'air aussi se fixe dans les corps terrestres Illinois fait partie de leur substance solide. Les chimistes savent de plus en plus, et le fixer, et lui redonner son élasticité primitive, par divers procédés, et avant la multitude d'expériences que se sont de nos jours sur cet objet intéressant de la physique, le dire. Hales avoid monter, que les végétaux renferment un très grande quantité d'air, que sy trouvé sans ressort et comme matière constituante. Voilà donc probablement les sources où la nature puise pour la terre végétable dont elle recouvre la surface de nos continents. Ce sont les particules, peut-être, de tous les corps tant solides que fluides, extraits ou fixes par de procédés que les rapprochent de leurs premiers éléments, et leur font prendre à nos yeux une même apparence. Ces particules sont ainsi rendues propres à circuler dans les semences de plantes, à en étendre le tissu à y prendre toutes les propriétés que caractérisent chaque espèce, et à les conserver tant que la plante existe. Ces mêmes particules, après la destruction de plantes, prennent le caractère général de terre végétable, c'est-à-dire de provision tout faite pour la végétation. Les plus petits recoins de montagnes, que peuvent hériter l'eau de la pluie, sont certainement fertilisés, si n'y sont pas seulement les grandes surfaces plates, ni les pentes, si sont même les faces escarpées de rochers les plus dures. S'il sy fait quelque crevasse, un arbre sy établit bientôt, et souvent il contribue, par l'écouissement de ses racines, à accélérer la chute du lambeau de rocher que elle avoit recu. S'il y a quelque petite terrasse, ou seulement quelque partie salient grande comme la main, elle est bientôt gazonnée. Les plus petites sinuosités se peuplent de plantes. Et les surfaces les plus unies, celles mêmes que sont tournées vers la baisse, recueillent au moins quelqu'un de ces mousses plates, nommés lichen par les botanistes, que n'y font en apparence que passer une couleur sur la pierre. Mais cette couche est écalée, et elle loge bientôt de petites plantes dans ses replis. De celles que violent l'ardeur du soleil, si le rocher est au midi, ou la fraîcheur de l'ombre, sil est au nord, c'est sur ces rochers en un émote, que paroissent nous spectateurs ordinaires. Que trouver la plus grande variété de ces petites plantes, que font les délices de botanistes, et l'une des sources les plus abondantes où la médecine puise les secours réels qu'elle fournit à l'humanité. Quelle richesse dans les ressources de la nature. La pesanteur n'est pas plus prête à entraîner les pierres que se détachent de montagnes, qu'elle à fournir de semences celles que se fixent, et des une fois elles sont recouvertes de plantes, elles sont certainement fixes pour toujours. Du moins contre les injures de l'air. Le fait même nous l'annonce. Si ces ravens ou ces terrains quelconques, tendoyant encore à rouler ou à se dégrader, en un mot à se détruire de quelque manière que ce fait, ils ni le recouvriront, ni de mousses ni d'aucune autre plante. La première végétation est due à quelque dépôt de terre végétable, et les pluies ou l'air en fourment que lentement, le moindre mouvement la détruit. Le terrain est donc bien certainement fixe quand il s'y recouvre de plantes. Et s'y accumule de la terre végétable, c'est un signe bien évident que rien n'y l'attaque plus, car elle serait la première importée s'y quelque cause extérieure tendoit à détruire le sol que la porte. The doctrine here laid down by our author consists in this, first, that there is a genus of plants calculated to grow upon rocks or stones. Those hard bodies then decay, in decomposing themselves, and affording sustenance to the plants which they sustain. Secondly, that by this dissolution of those rocks, and the accumulation of those vegetable bodies, there is soil prepared for the nurture and propagation of another genus of plants, by which the surface of the earth, naturally barren, is to be fertilized. It is also in this natural progress of things that the solid parts of the globe come to be wasted in the operations of the surface, and that lofty rocks are leveled. In always tending to bring the uneven surface of the earth to a slope of vegetating or fertile soil. Here we are to distinguish carefully between the facts described by this author, who has seen so much of nature, and the conclusion which he would draw from his principles. The surface of most stones are dissolved, or corroded by the air and moisture. This gives lodgment to the roots of plants, which grow, die, and decay. And these are carried away with the earthy parts of the solid stone, in order to form a vegetable soil for larger plants, growing upon some bottom or resting place to which that earth is carried. Here is so far the purpose of rocks, to sustain a genus of plants which are contrived to live upon that soil. And here is so far a purpose for certain plants, in decomposing rocks to form a soil for other plants which have been made upon a larger scale, and are adapted to the use of man, the ultimate in the view of nature. Our author concludes thus, p. 37. Le temps n'y fera tu augmenter l'épaisseur de la couche de terre végétable que couvre les montagnes, et que les garantit ainsi de plus en plus de cette destruction à laquelle on les croit exposés, les pluies en anémote. Au lieu de les dégrader comme on s'y imagine y accumuleront leurs dépôts. Tel est l'agent simple tu employé si admirablement le créateur pour la conservation de son ouvrage. Such, indeed, is the admirable contrivance of the system, that, in the works of nature, nothing shall be destroyed more than is necessary for the preservation of the whole. But, that the whole is preserved by the necessary destruction of every individual body, and the change of every part which comes within the examination of our senses, is sufficiently evident to require no farther illustration in this place. Where we are contemplating the destruction of the strongest things, by means the most effectual, though really slow, and apparently most feeble. In his 30th letter, this author describes the progress of nature, in bringing precipitous rocks to that slope and covering of soil which is to maintain plants of every kind, and to establish woods. p. 40. J. Eleanor d'exposer à vm. Les causes que garantissent de destruction extérieure les terrains sur lesquels la pesanteur n'est pas plus aiguë que pour les consolider. Mais ce n'est pas ainsi que sont actuellement la plupart de nos montagnes. Il en est peu que soyant déjà parvenus à cet état permanent. Tout roc nud est attaqué par l'ret les météores, il tend à se détruire quelque soit sa durée. Mais ce serait peu que cette destruction extérieure. Elle pourrait même cesser enfin totalement par l'effet seul des masses, silny avoit pas de causes plus puissantes que pendant quelque temps agissant dans l'intérieur. Il n'est presque point de rocher que offre à l'air un seul masse compact. Ils sont ou crevasses, ou forms par couches, et l'eau insinue toujours dans ces fences. Quand cette eau vient à se galier, elle agite comme un coin pour écarter les pieces entre lesquelles elle s'y trouve. Vm. Seroit étonné de la grandeur de masses que cette cause peut mouvoir, elle agite exactement comme la poudre à canon dans les mines, détachant toutes les pieces extérieures que commencent à se séparer, et en découvrant ainsi de nouvelles. Chaque hiver renouvelle donc la surface de certains rochers, ou facilite l'ouvrage pour les hivers suivants. Plusieurs autres causes agissent encore pour séparer les rochers déjà crevasses, que se trouvent à l'extérieur de faces escarpées. Le petit moellon que sy accumule, les dépôts de pluies, les plantes que y croissent, les alternatives de l'humidité et de la sécheresse, les vicissitudes de la chaleur, les vents mimes. Sont autant de causes continuellement agissantes quand la pesanteur les seconde. Les rochers escarpées se détruisent donc par de continuels éboulements. Mais tout ces matters que tombent, ne sont pas perdus pour les montagnes, ils s'en perdent même bien peu. Elles s'arrêtent au pied de rochers dont elles sont successivement détachées, et là elles s'entassent, s'élevant en forme de talus contre ces rochers eux-mêmes. If the solid body of the Alps, the most consolidated masses of our land, is thus reduced to the state of soil upon the surface of the earth contrived for the use of plants, a fortiori, softer bodies, less elevated and less consolidated masses, will be considered as easily arriving at the purpose for which the surface of the earth has been intended. We only wish now to see the ultimate effect that necessarily follows from this progress of things. And how, in this course of nature, the land must end, however long protracted shall be the duration of this body, and however much economy may be perceived in this gradual waste of land. A waste which by no means is so slow as not to be perceived by men reasoning in science. Although scientific men, either reasoning for the purpose of a system which they had devised, or, deceived by the apparent state of things which truly change, may not acknowledge the necessary consequence of what they had perceived. Let us now suppose all the solid mass of land, contained in our continent, to be transformed into soil and vegetable earth. It must be evident that no covering of plants, or interlacing of vegetable fibers, could protect this mass of loose or incoherent materials from the ravages of floods, so long as rivers flowed, nor from being swallowed by the ocean, so long as there were winds and tides. From the border of the land upon the shore, to the middle of the ocean, there is either at present an equable declivity at the bottom of the sea, or everything tends to form this declivity, in gradually moving bodies along this bottom. But, however gradual the declivity of the bottom, or however slow the progress of loose materials from the shore towards the deepest bottom of the sea, so long as there are moving powers for those materials, they must have a progress to that end. The law of gravitation, always active, must prevail, and sooner or later the moving sea must swallow up the land. But, along the borders of our continent, and in the courses of our rivers, there are rocks. These must be surmounted or destroyed, before the parts which they protect can be delivered up to the influence of those moving powers which tend to form a level, and we may be assured that those bulwarks waste. The bare inspection of our rocky coasts and rivers will satisfy the enlightened observer of this truth. And to endeavor to prove this to a person who has not principles by which to reason upon the subject, or to one who has false principles, by which he would create perpetual stability to decaying things, would be but labor lost. In proportion as the solid bulwark is destroyed, so is the soil which had been protected by it. And, in proportion as the solid parts of the mass of land are exposed to the influences of the atmosphere and water, by the ablution of the soil, more soil is prepared for the growth of plants, and more earth is detached from the solid rock. To form deep soils upon the surface of the earth, and to establish fertile countries at the mouths of rivers, even in making encroachment on the space allotted for the sea. But this production of land, in augmentation of our coasts, is only made by the destruction of the higher country. While, therefore, we allow that there is any augmentation made to the coast, or any earthy matter traveling in our rivers, the land above the coast cannot be stable. Nor the constitution of our earth fixed in a state which has no tendency to be removed. M. de Luc, in his Histoire de la Terre, would make the mountains last forever, after they have come to a certain slope. He sums up his reasoning upon this subject in these words: Le doucissement de pentes arrête d'abord l'effet de ces deux grandes causes de destruction de montagnes. La pesanteur et les eaux, la végétation en soute arrête l'effet de toutes les petites causes. If all the great and little causes of demolition are arrested by the slope of mountains and the growth of plants, the surface of the earth might then remain without any farther change. And this would be a fact in opposition to the present theory, which represents the surface of the earth as constantly tending to decay, for the purpose of vegetation. And as being only preserved from a quick destruction by the solid rocks protecting, from the ravages of the floods and sea, the loose materials of the land. It will therefore be proper to show, that this author's argument does not go to prove his proposition in the terms which he has given it, which is, that those sloped mountains are to last forever, but only that these causes, which he has so well described, make the destruction of the mountains become more slow. 56. The slope which our author gives to his mountains, in order to secure them from the ravages of time, is that which, according to his own reasoning, renders them fertile and proper for the culture of man. But fertile soil yields always something to the floods to carry away, and, while anything is carried from the soil, the land must waste, although it may not then waste at the rate of those within the valleys of the Alps. According to the doctrine of this author, our mountains of Tweeddale and Teviotdale, being all covered with vegetation, are arrived at that period in the course of things when they should be permanent. But is it really so? Do they never waste? Look at the rivers in a flood. If these run clear, this philosopher has reasoned right, and I have lost my argument. Our clearest streams run muddy in a flood. The great causes, therefore, for the degradation of mountains never stop as long as there is water to run, although, as the heights of mountains diminish, the progress of their diminution may be more and more retarded. Let us now see how far our author has reasoned justly with regard to vegetation, which, he says, stops the effects of all the little causes of destruction. This is the more necessary, as, in the present theory, it is the little causes, long continued, which are considered as bringing about the greatest changes of the earth. Along the courses of our rivers there are plains between the mountains of greater or lesser extent. These are almost always fertile, and generally cultivated when large; when small, they are in pasture. The origin of these fertile soils, and their perpetual change, is to be described with a view to show, that vegetation, although most powerful in stopping the ravages of water, and for accumulating soil retained by this means, does it only for a time, after which the soil is again abandoned to the ravages of the running water, when no more protected by the vegetation. Let us suppose the river running upon the one side of the Haw, which is the name we gave those little fertile plains, and close by the side of the mountain. In this case the bed of the river is deepest at the side of the mountain, which it undermines, leaving a falling, an éboulement, on that side. On the other side, the river shelves gradually from the plain, and leaves soil in its bottom or stony bed upon the side of the Haw, in proportion as it makes advances in carrying away the bank at the bottom of the sloping mountain. The part which vegetation takes in this operation is now to be considered. When the river has enlarged its bed by preying upon one side, whether of the mountain or the Haw, the water only covers it in a flood; at other times, it leaves it dry. Here, among the rocks and stones, the feeds of plants, left by the water or blown by the wind, spring up and grow, and, in little floods, some sand and mud is left among those plants. This encourages the growth of other plants, which more and more retain the fertile spoils of the river in its floods. At last, this bed of the river is covered perfectly with plants, which having retained plenty of fertile soil, although still rooted among the stones, opposes to the river a resistance which its greatest velocity is not able to overcome. In this state, the Haw is always deepening or increasing its soil, and has its surface heightened. At last, when this soil becomes so high as only to be flooded now and then, it becomes most fertile, as the heavier parts are carried in the bed of the river, and the lighter soil deposited upon the plain. The operations of the river, upon the plain, thus increase at the same time the height and fertility of the Haw. But this operation, of accumulated soil upon the stony bottom, has a period, at which time the river must return again upon its steps, and sweep away the Haw which it had formed. This is the natural course of things. And it happens necessarily from the deepening of the soil. Let us then examine this operation. When no more soil is left upon the stony bottom than is sufficient for the covering of the ground, and rooting of plants which are also fixed in the solid ground or bottom of the soil, the water is not able to carry away the plants. And these plants protect the surface of loose soil. When again there is a depth of soil accumulated upon the haw, the surface only is protected by the vegetable covering. But what avails it to the soil to be protected from above, when undermined by the enemy? The vegetable roots now no longer reaching to the bottom where solidity is found, the tender soil below is easily washed away by the continued efforts of the stream. And the unsupported meadow, with the impregnable texture of its leaves, its roots, and its fibers, falls ruinously into the river, and is borne away in triumph by the flood. The water thus reclaims its long deserted bed, only in order to pass from it again, and circulate or meander from hill to hill in varying perpetually its course. Now this progress of the river, or this changing of its bed, is determined by the strong resistance of the new-made haw, humbly standing firm in the protection of its vegetation, while the elevated surface of the older haw, deserted by the inferior soil which it had ceased to protect, falls a victim to its exalted state, and passes away to aggrandize another. This is the fate of haws or plains erected by the operations of a river, and again destroyed in the natural course of things, or in the very continuation of that active cause by which they had been formed. The water is constantly carrying the movable soil from the higher to the lower place. Vegetation often disputes the possession of these spoils of ruined mountains for a while. But, in the end, this vegetable protector, not only delivers up to the destroying cause the mineral soil which it had preserved, but, by its buoyancy in water, it facilitates the transportation of the stony parts to which this fibrous body is attached. Over and over 1,000 times may be repeated this alternate possession of the transferable soil, by moving water on the one part and by fixed vegetation on the other, but at last all must land upon the shore, whether the river tends. Thus the mountain and the plain, the vegetable earth and the plants produced in that soil, must all return into the sea from whence either they themselves or their materials had come. In proportion as the mountains are diminished, the haw or plain between them grows more wide, and also on a lower level. But, while there is a river running in a plain, and floods produced in the seasons of rain, there can be nothing stable in this constitution of things evidently founded upon change. The description now given is from the rivers of this country, where it is not unfrequent to see relicts of 3 or 4 different haws which had occupied the same spot of ground upon different levels, consequently which had been formed and destroyed at different periods of time. But the same operation is transacted everywhere. It is seen upon the plains of Indostan, as in the haws of Scotland. The Ganges operates upon its banks, and is employed in changing its bed continually as well as the Tweed 57. The great city of Babylon was built upon the haw of a river. What is become of that city? Nothing remains, even the place, on which it stood, is not known. Chapter 7. The same subject continued, in giving a view of the operations of air and water upon the surface of the land. We have but to enlarge our thoughts with regard to things past by attending to what we see at present. And we shall understand many things which to a more contracted view appear to be in nature insulated or without a proper cause. Such are those great blocks of granite so foreign to the place on which they stand, and so large as to seem to have been transported by some power unnatural to the place from whence they came. We have but to consider the surface of this earth as having been upon a higher level, as having been everywhere the beds of rivers, which had moved the matter of strata and fragments of rocks, now no more existing. And as thus disposed upon different plains, which are, like the haws of rivers, changing in a continual succession, but changing upon a scale too slow to be perceived. M. Deluc has given a picture which is very proper to assist our imagination in contemplating a more ancient state of this earth, although in this he has a very different end in view, and means to show that the world, which we inhabit at present, is of a recent date. It is in the 32d letter of his Histoire de la Terre, which I beg leave here to transcribe. Des montagnes bases, cum le jura, que est bas comparativement aux Alpes, sont bientôt fixes par ce moyen. Ilnese fait presque chuan sol talus depuis leur sommet jusques dans les basses vallées, ou sur la plaine. Aussi l'état de ces montagnes est-il déjà presque entièrement fixe, on y voit très peu de rochers nudes que est éblant, except, opers de rivières. C'est dans ces lola que l'ouvrage tard le plus à se finer. Le bas de talus est mine par l'eau. Leur surface est beau donc, pour ainsi dire, sans cesse, les a découvert les rochers de sommets, que par la continuant aussi à essaboler. Mais les vallées s'élargissent enfin. Et les talus s'éloignent ainsi de rivières, commençant à éprouver les influences du repos. Here nothing can be more positively described than the natural destruction of those mountains by the operation of the rivers which run between them. And this is from the authority of matter of fact, which, on all occasions, this author faithfully describes. At the same time, we are desired to believe, upon no better authority than the imagination of a person hurried on by system, that those mountains are absolutely to come to rest. I am aware of the danger to which a spirit of systematizing leads. And I wish for nothing more than to have my theory strictly examined, in comparing it with nature. Our author thus proceeds, La vue sol de la chaîne du Jura nous apprend donc ce que deviendrait enfin toutes les montagnes. Dans la plus grande partie de son étendue Illinois n'y souffre plus aucun changement ruineux, la végétation le recouvre presque partout. Les bas sont cultives de toutes sortes de manières suivant leur exposition. Les sommets sont couverts de pelouses, que forment les pâturages les plus précieux. Cette gazonnade s'étend aussi sur toutes les parties de pentes que n'y sont pas trop rapides, et le reste est couvert de bois. J'ai parcouru fort souvent le pays de ces montagnes, leur état est presque partout tel que j'ai viens d'avoir l'honneur de la descrire à VM. J'ai surtout observé avec attention les lits de Torenska, en descendant pour s'y rendre dans les lacs de Geneva, de Neuchâtel et de Bienne. Ainsi que dans l'Eure et dans le Rhin, et hormis sur de ces Torenska viennent de gorges où les terrains sont encore escarpés, ils n'y roulant plus que l'ancienne gravure ils out apport autrefois. Mais il n'en est pas ainsi de Alpes, de Pyrénées, et de autres montagnes, que, comme celles-là, sont beaucoup plus élevées, au que sans l'être davantage ont livres aux influences de l'air dans un désordre plus grand. Dans ce genre de montagnes il reste encore à la végétation de bien grandes conquêtes à faire. Ces montagnes n'y sont pas telles que VM pourrait s'y les figurer naturellement, il faut y être monté pour s'en former une juste idée. Ce sont de montagnes sur d'autres montagnes. De près on n'y voit que les parties inférieures, de loin tout s'y confondent, il faut donc être arrivé sur un de premières terrasses pour voir les secondes, sur celles-ci pour les troisièmes. Et ainsi de suite. La plupart de ces terrasses successives sont de grandes plaines, dominées par de rochers que s'éblantent, et forment de talus. Si dans la succession de siècles, les éboulements de ces bands de rochers en amphithéâtre finissoyant sans importer les plaines ils succinanant. Et que les torrents usent creuse leur lit pendant ces temps là à quelque distance de talus tout seroit fini par cette première opération. Mais il y a peu de hautes montagnes où les arrangements soyant si simples, souvent ces bands impedant les uns sur les autres en s'éboulant, et alors le repos est bien diffère. Supposons que ces terrasses soyant étroites, et que leurs murs, c'est-à-dire les rochers que les succinanant, soyant fort élevés. Les terrasses alors n'y souffrent pas pour recevoir les éboulements que doivent s'y faire sur elles car le décès de chacune d'elles s'étressit de plus en plus par la destruction du rocher que la succiante. Il pourra donc arriver que ces talus, s'étant étendu jusqu'au bord de la terrasse, s'y trouver reposer sur un base que s'éboule encore, et même cela arrive très souvent, de sorte que chaque rétrécissement de la base, l'étalus lui-même s'éboule. Ainsi du talus, que étoyant peut être déjà en pleine végétation par la lenteur de éboulements de rochers que les formoyant, pourront être fort reculs à cet égard, le talus supérieur, parce que la surface fertilisée glissera en bas. Et le talus inférieur, parce que la sienne sera ensevelie sous de nouveaux décombres. Les montagnes que sont dans ce cas seront proportion element plus abyces que les autres. Parce que leurs talus se confondent ainsi et devenant par la forte tendance de durant long temps à devenir solides. Les os partant de fort haute, auront le temps de se rassembler et de devenir destructifs vers le bas. Au lieu que dans les montagnes ou les terrasses subsistent encore après que tous les rochers se seront éboulis, les os étant reçus par reprises, perdront beaucoup de leur rapidité. Elles se rassembleront dans les enfoncements de petites vallées supérieures, elles se formeront de lits qu'elles n'y rangeront presque point, et la végétation restera tranquille partout. Let us now consider the height of the Alps, in general, to have been much greater than it is at present, and this is a supposition of which we have no reason to suspect the fallacy, for the wasted summits of those mountains attest its truth. There would then have been immense valleys of ice sliding down in all directions towards the lower country, and carrying large blocks of granite to a great distance, where they would be variously deposited. And many of them remain an object of admiration to after ages, conjecturing from whence, or how they came. Such are the great blocks of granite which now repose upon the hills of Salive. M. de Saussure, who has examined them carefully, gives demonstration of the long time during which they have remained in their present place. The limestone bottom around being dissolved by the rain, while that which serves as the basis of those masses stands high above the rest of the rock, in having been protected from the rain. But no natural operation of the globe can explain the transportation of those bodies of stone, except the changed state of things arising from the degradation of the mountains. Everything, therefore, tends to show that the surface of the earth must wear, but M. de Luc, although he allows the principles on which this reasoning is founded, labors to prove that those destructive causes will not operate in time. Now, what would be the consequence of such a system, that the source of vegetation upon the surface of the earth would cease at last, and perfect sterility be necessarily the effect of allowing no farther degradation to the surface of the earth? For, what is to supply the matter of plants? Water, air, and light alone, will not suffice, there are necessarily required other elements which the earth alone affords. If, therefore, this world is to continue, as it has done, to form continents of calcareous strata at the bottom of the ocean, the animals which form these strata, with their exuvii, must be fed. But, on what can they be fed? Not on water alone. The consequence of such a supposition would lead us to absurdity, nor can they be fed on any other element without the dissolution of land. According to my views of things, it is certain that those animals are ultimately fed on vegetable bodies. And it is equally certain, that plants require a soil on which they may not only fix their fibrous roots, but find their nourishment at least in part, for, that air, water, and the matter of light, also contribute, cannot be doubted. But if animals, which are to form the strata of the earth, are to be fed on plants, and these are to be nourished by the matter of this earth, the waste of vegetable matter upon the surface of the earth must be repaired. The exhausted soil must be transported from the surface of the land, and fertility must be restored by the gradual decay of solid parts, and by the successive removal of soil from stage to stage. What a reverie, therefore, is that idea, of bringing the earth to perfection by fixing the state of its vegetable surface. The description of those natural operations, which M. de Luc has given with a view to establish the duration of the mountains, is founded upon nothing but their destruction. These beds of rivers, which, according to our author, are hardly to be wasted any more, will not satisfy a philosopher, who requires to see no degree of wasting in a body which is to remain forever, or continue without change. But, however untenable this supposition of a fixed state in the surface of this earth, the accuracy of the natural philosopher may still be observed in the absurdity of the proposition. L'état de montagnes sera fixe, per tout au les rivières seront arrivées au point de n'importe pas plus de limon or de leur ensemble, que l'ret les pluies ny déposeront de terre végétable, et voilà enfin quel sera le repos. L'état permanent de la surface de notre globe. Car alors il y aura compensation entre les destructions et les réparations simultanées, et les montagnes charmant n'y s'abaisseront plus. Surely, if there is in the system of nature wisdom, we may look for compensation between the destroying and repairing operations of the globe. But why seek for this compensation in the rest or immobility of things? Why suppose perfection in the want of change? The summit of the Alps was once the bottom of the sea, the existence of our land depended then upon the change of seas and continents. But has the earth already undergone so great changes, and is it not yet arrived at the period of its perfection? How can a philosopher, who is so much employed in contemplating the beauty of nature, the wisdom and goodness of providence, allow himself to entertain such mean ideas of the system as to suppose, that, in the indefinite succession of time past, there has not been perfection in the works of nature? Every material being exists in motion, every immaterial being in action and in passion, rest exists not anywhere, nor is it found in any other way, except among the parts of space. Surely it is contrary to every species of philosophy, whether ancient or modern, to found a system on the inutility of repose, or place perfection in the vacuity of rest, when everything that truly exists, exists in motion. When every real information which we have is derived from a change, and when every excess in nature is compensated, not by rest, but by alternation. De Luc allows the rivers to carry matter always to the sea. But then, at a certain period, this matter carried by the floods is to be compensated to the mountains by the vegetable earth received from the air and rains. Here is a proposition which should be well considered, before it be admitted as a principle, which shall establish the perpetuity of these mountains, if it be true, or, if false, assure us of their future demolition. Let us now examine it. If from air and rain there is produced earth which cannot afterwards be resolved by the operation of those elements, and thus again dissolved in the air and water of the land, then this author might have had some pretext, however insufficient, for alleging that it might be possible to compensate the loss of mineral substances, carried off the surface of the earth, by the production of this vegetable matter from the air and rain. But, when there is not sufficient reason to conclude that any substance, produced in vegetation, can resist the continued influences of the air and water, without being decomposed in its principles, and at last entirely dissolved in water. The cautious argument here employed by this author, for the permanency of mountains, must appear as groundless in its principle as it would be insufficient for his purpose, were it to be admitted. But this will require some discussion. That which preserves vegetable bodies so long from dissolution in water, is what may be called the inflammable or phlogistic composition of those bodies. This composition is quickly resolved in combustion. But it is no less surely resolved by the influences of the sun and atmosphere, only in a slower manner. Therefore, to place the permanency of this earth, or any of its surface, upon a substance which in that situation necessarily decays, is to form a speculation inconsistent with the principles of natural philosophy 58. But even supposing that the degradation of mountains were to be suspended by the pretended compensation which is formed, by the rivers carrying mineral mud into the sea, and the air and rain producing vegetable earth, in what must this operation end? In carrying into the sea, to be deposited at its bottom, all the vegetable earth produced by the air and rain. But our cosmologist, in thus procuring an eternal station to his mountains, has not told us whether this transmutation of the air and rain be a finite operation, or one that is infinite. Whether it be in other respects confident with the natural operations of the globe, and whether, to have the air and water of the globe converted into earth, would ultimately promote, or not, that perfection which he wishes to establish. Here, therefore, in allowing to this philosophy all its suppositions, it would be necessary to make another compensation, in preserving mountains at the expense of air and rain. And, the waste of air and water, which are limited, would require to be repaired. It is not in our purpose here to treat of moral causes. But this author having endeavored to fortify his system by observing, that the world certainly cannot be ancient, since men have not ceased as yet to quarrel and fight, Lettre 34. It may be proper to observe, that the absolute rest of land, like the peace among mankind, will never happen till those things are changed in their nature and constitution, that is to say, until the matter of this globe shall be no more a living world, and man no more an animal that reasons from his proper knowledge, which is still imperfect. If man must learn to reason, as children learn to speak, he must reason erroneously before he reasons right. Therefore, philosophers will differ in their opinions as long as there is anything for man to learn. But this is right. For, how are false opinions to be corrected, except in being opposed by the opinions of other men? It is foolish, indeed, for men to quarrel and fight, because they differ in opinion. Man quarrels properly, when he is angry. And anger perhaps is almost always ultimately founded upon erroneous opinion. But, in nature, there is no opinion, there is truth in everything that is in nature, and in man alone is error. Let us, therefore, in studying nature, learn to know the truth, and not indulge erroneous notions, by endeavoring to correct, in nature, that which perhaps is only wrong in our opinion. Having shown that everything, which is movable upon the surface of the land, tends to the sea, however slowly in its pace, we are now to examine, what comes of those materials deposited within the regions of the waves. Still however within the reach of man, and still subservient more immediately to that soil on which plants grow, and man may dwell. As, from the summit of the land, the natural tendency of movable bodies is to fall into the water of the sea, so, from the borders of the land or coast, there being a declivity towards the deepest bottom of the sea, and there being currents in the waters of the ocean occasionally rendered more rapid on the shore, every movable thing must tend to travel from the coast, and to proceed alone. The shelving bottom of the sea into the unfathomable deep, when they are beyond the reach of man or the possibility of returning to the shore. But it is not everywhere upon the coast that those materials are equally delivered. Neither is it everywhere along the shore that the currents of the ocean are equally perceived, or operate with equal power in moving bodies along the shelving bottom of the sea. Hence in some places deep water is found washing rocky coasts, where the waste of land is only to be perceived from what is visibly wanting in the continuity of those hard and solid bodies. In other places, again, the land appears to grow and to encroach upon the space which had been occupied by the sea. For here the materials of the land are so accumulated on the coast, that the bottom of the sea is filled up, and dry land is formed in the basin of the sea, from those materials which the rivers had brought down upon the shore. 59. Holland affords the very best example of this fact. It is a low country formed in the sea. This low land is situated in the bottom of a deep bay, or upon the coast of a shallow sea, where more materials are brought by the great rivers from the land of Germany than what the currents of the sea can carry out into the deep. Here banks of sand are gathered together by streams and tides, this sand is blown in hillocks by the wind, and those sand hills are retained by the plants which have taken root and fixed those moving sands. Behind that chain of hillocks, which line the sea shore, the waters of the rivers formed a lake, and the bottom of this lake had been gradually filled up or heightened by materials traveling in the rivers, and here finding rest. It grew up until it became a marsh, then man took possession of the soil, he has turned it to his own life. And, by artificial ramparts of his forming, preserves it in the present state, some parts above the level of the sea, others considerably below the ordinary rise of tides. M. de Luc, who has given a very scientific view of this country in his Lettres physiques et morales, has there also furnished us with the following register of what had been found by sinking in that soil. It was at Amsterdam at the year 1605 in making a well. Voici la désignation de matters que feront trouver en partant de la surface. 51 pieds, mêlées de sable turbieux, de fable. De dunes per et d'argile ou. Limon. 22. De meme sable de dunes per. Et d'argile bleuter. 14. Du meme sable per. 87 pieds. Au rein encore en indiquoit la présence de la mer. 55. De sable marin, et de limon. Mêlées l'un et de l'autre de coquilles. Dans plusieurs couches. 142 pieds. Soit la plus grande profondeur. Os est manifeste la présence de la mer. 49. Argile dur sans mélange de coquilles, soit que soit un couche argileus continental. Ou les premiers dépôts de Fleuves. Ce Chuil est difficile de determiner. 191 pites. 13. Sable mêlé de pierres, que est. Enfin charmant le sol vierge. Continental. 28. Sable per, continental encore. Car J remarque per tout. Dans la giste, que c'est. Dans la couche supérieure, ah. Un petite profondeur KSE. Trouvant les pierres, Odessus. Le sable est per. 232 pites. C'est à cette profondeur, OU. Dans la masse de CES du derniers. Couches, KSE trouva. L'eau douce, et par consequent. Le vrai sol continental. The light that we have from this pit which has been made in the soil, according to my view of the subject, is this, that here is the depth of 232 feet in travelled soil. And no solid bottom found at this distance from the surface or level of the sea. How far this depth may be from the bottom of these travelled materials is unknown, but this is certain, that all that depth, which has been sunk, had been filled up with those materials 60. It will thus appear of what unstable materials is composed the land of that temporary country. It will also be evident, that, by removing the sand banks of this coast, the whole of this low country would be swallowed by the sea, notwithstanding every effort that the power of man could make. But it may be all-edged, that those sand banks are increasing still with the alluvion of Germany, instead of being in a decreasing state. I should also incline to believe that this is truly the case. But, though we may acknowledge the growth of land upon the coast of Holland, we must deny that a stable country can be formed in the bed of the sea by such means. For, however increasing may be the sand in the German Sea, and however great additions may be made of habitable country to the coast of Holland, yet, as the islands of Great Britain and Ireland are warned by attrition on the shores, and are wasted by being washed away into the ocean, the causes for the accumulation of sand in the German Sea must cease in time, when, in this progress of things, the sand banks, on which depends the existence of Holland, must diminish, and at last be swept away, in leaving the solid coast of Germany to be again buffeted by the waves, as is at present the coasts of Ireland, France, and Spain. This reasoning is, indeed, very far removed from that which is commonly employed for the purpose of conducting human operations, or establishing the political system of a nation. It is not, however, the less interesting to man, in that it cannot direct him immediately in his worldly affairs. And it is the only way of reasoning that can be employed in order to enlighten man with a view of those operations which are not to be limited in time, and which are to be concluded as in the system of nature. A system which man contemplates with much pleasure, and studies with much profit. Thus we have shown, that, from the top of the mountain to the shore of the sea, which are the two extremities of our land, everything is in a state of change. The rock and solid strath dissolving, breaking, and decomposing, for the purpose of becoming soil, the soil traveling along the surface of the earth, in its way to the shore. And the shore wearing and wasting by the agitation of the sea, an agitation which is essential to the purposes of a living world. Without those operations, which wear and waste the coast, there would not be wind and rain. And, without those operations which wear and waste the solid land, the surface of the earth would become sterile. But showers of rain and fertile soil are necessarily required in the system of this world. Consequently, the dissolution of the rocks, and solid strata of the earth, and the gradual, slow, but sure destruction of the present land, are operations necessary in the system of this world. So far from being evils, they are wisely calculated, in the system of nature, for the general good. Chapter 8. The present form of the surface of the earth explained, with a view of the operation of time upon our land. It is not to common observation that it belongs to see the effects of time, and the operation of physical causes, in what is to be perceived upon the surface of this earth. The shepherd thinks the mountain, on which he feeds his flock, to have been always there, or since the beginning of things. The inhabitant of the valley cultivates the soil as his father had done, and thinks that this soil is coeval with the valley or the mountain. But the man of scientific observation, who looks into the chain of physical events connected with the present state of things, sees great changes that have been made, and foresees a different state that must follow in time, from the continued operation of that which actually is in nature. It is thus that enlightened natural history affords to philosophy principles, from whence the most important conclusions may be drawn. It is thus that a system may be perceived in that which, to common observation, seems to be nothing but the disorderly accident of things, a system in which wisdom and benevolence conduct the endless order of a changing world. What a comfort to man, for whom that system was contrived, as the only living being on this earth who can perceive it. What a comfort, I say, to think that the author of our existence has given such evident marks of his goodwill towards man, in this progressive state of his understanding. What greater security can be desired for the continuance of our intellectual existence, an existence which rises infinitely above that of the mere animal, conducted by reason for the purposes of life alone? The view of this interesting subject, which I had given in the first part, published in the Transactions of the Edinburgh Royal Society, has been seen by some men of science in a light which does not allow them, it would appear, to admit of the general principle which I would thereby endeavor to establish. Some contend that the rivers do not travel the material of the decaying land. Why? Because they have not seen all those materials moved. Others allege that stones and rocks may be formed upon the surface of the earth, instead of being there all in a state of decay. These are matters of fact which it is in the power of men who have proper observation to determine. It is my business to generalize those facts and observations, and to bring them in confirmation of a theory which is necessarily founded upon the decaying nature and perishing state of all that appears to us above the surface of the sea. Nothing is more evident, than that the general effect of mineral operations is to consolidate that which had been in an incoherent state when formed at the bottom of the sea, and thus to produce those rocks and indurated bodies which constitute the basis of our vegetable soil. But, that indurating or consolidating operation is not the immediate object of our observation, and, to see the evidence of that operation, or the nature of that cause, requires a long chain of reasoning from the most extensive physical principles. Our present subject of investigation requires no such abstract distant media, by which the effect is to be connected with its cause. The actual operation in general is the object of our immediate observation. And here we have only to reason from less to more, and not to homologate things which may, to men of narrow principles, appear to be of different kinds. But even here we find difficulty in persuading those who have taken unjust views of things. For, those who will not deny the truth of every step in this chain of reasoning, will deny the end to which it leads, merely because they are not disposed to admit the progress of that order which appears in nature. In the last chapter, I have been using arguments to prove that M. de Luc has reasoned erroneously, in concluding the future stability of a continent. And I have been endeavoring to show that our continent is necessarily wasted in procuring food to plants, or in serving the various purposes of a system of living animals. We have now in view to illustrate this theory of the degradation of the surface of the earth, a theory necessarily leading to that system of the world in which a provision is made for future continents, and a theory explaining various natural appearances which otherwise are not to be understood. A door may thus be opened for the investigation of natural history, particularly that which traces back, from the present state of things, those operations of nature which are more immediately connected with what we take much pleasure to behold, viz. the surface of the earth stored with such a variety of beautiful plants, and inhabited by such a diversity of animals, all subservient to the use of man. There are two ways in which we may look for the transactions of time past, in the present state of things, upon the surface of this earth, and read the operations of an ancient date in those which are daily transacted under our eye. The one of these is to examine the soil, and to trace the origin of that which we find loose upon the surface of the earth, or only compacted by the soft and cohesive nature of some of its materials. In thus studying the soil we shall learn the destruction of the solid parts. And though, by this means, we cannot form an estimate of the quantity of this destruction which had been made, we shall, upon many occasions, see a certain minimum of this quantity which may perhaps astonish us. The second method here proposed, is to examine the solid part of the earth, in order to learn the quantity of matter which had been separated from this mass. Here also we shall not be able to compute the quantity of what had been destroyed. But we shall everywhere find a certain minimum of this quantity, which will give us an extensive view with regard to the operation of the elements and seasons upon the surface of this earth. We shall now examine more particularly those two ways of judging with regard to the operations of time past, and the changes which have been made upon the surface of our land, by those active causes, which, being in the constitution of this earth, must continue to operate with undiminished power, and tend to preserve the whole amidst the destruction of its particular parts. The quality of the soil or travelled earth of the globe is various, because the solid parts, from the destruction of which the soil is formed, consist of very different substances, in the different portions of each country. Thus, in one part of a country, the soil will be calcareous, or containing much of that species of substance; in another, again, it will be argillaceous; in another sandy, where the prevailing substance is siliceous. These are the original soils. Other substances may be considered as adventitious to this soil, though natural to the surface of the earth, which is covered with plants and animals. The substance of those animal and vegetable bodies, mixed with the soil, adds greater fertility to the earth, and gives a soil which is still more compounded in its nature, but still composed of those materials now enumerated. We have been now supposing the solid parts below, or in the same field, as furnishing materials of which the soil is formed. This soil then partakes of the nature of those solid parts, whether more simple or more compound. There is, however, another subject of variety, or still greater composition in soils. This is the transportation of materials from a distance, and this, in general, is performed by the ablution of water, in following the declivity of the surface. But sand is sometimes travelled by the wind, and proceeds along the surface of the earth, without regard to the declivity, and changes the nature of soil in those places which happen to be exposed to this accident. There cannot be any extensive, great, or distant travelling of sand or soil by means of the wind, except in those places which are sterile for want of rain, and thus are destitute of rivers and of streams. For, these running waters form everywhere a bar to this progressive movement of the soil, even if the sterility or dryness should permit the blowing of the sand. But the operation of streams and rivers, carrying soil and stones along the surface of the earth, is constant, great, and general over all the globe, so far as a superfluity of water, in the seasons of rain, falls upon the earth. From the amazing quantity of those far-travelled materials, which in many places are found upon the surface of the ground, we may with certainty conclude, that there has been a great consumption of the most hard and solid parts of the land. And therefore that there must necessarily have been a still much greater destruction of the more soft and tender substances, and the more light and subtle parts which, during those operations of water, had been floated away into the sea. This appears from the enormous quantities of stones and gravel which have been transported at distances that seem incredible, and deposited at heights above the present rivers. Which renders the conveyance of those bodies altogether inconceivable by any natural operation, or impossible from the present shape of the surface. This therefore leads us to conclude, that the surface of the earth must have been greatly changed since the time of those deposits of certain foreign materials of the soil. Examples of this kind have been already given. I shall now give one from the Journal de Physique. Les boards du Rhône aux environs de Lyon, et sur la longueur de 40 lieues, et de plus, de montagnes entières, dans le même pays, sont formes de pierres dont on n'y trouve les analogues que dans la Suisse. Ce fait presque incomprehensible est accompagné de beaucoup de circonstances que méritent d'être détaillées dans un discours plus long que celui-ci. Il est cependant un que je ne peux pas m'empêcher de rapporter ici, comme une suite de ce que je viens de dire. Dans cette grande catastrophe, à laquelle j'attribue le transport de ces matters alpines, Illinois se fit de grandes écancures dans le Jura. Les plus profonds que j'ai vus sont celles de Jug de Sainte-Croix, du Val de Moustier Travers, de Sumbaz au Val de Saint-Inver, un cinquième aux environs du village de Grange, 3 lieues plus BASK-BN. Et un sixième à 4 à 5 lieues plus BASK Soler, à l'endroit dit la close. Cette dernière est la plus profonde, et trouver de niveau avec les eaux de l'art. Beaucoup de ces matters étrangers au jura, ont passé par ces écrins, et sans doute, par bien d'autres ets sont répandus, dans plusieurs de ces vallées. Gen ai vu un suite bien marqué que a passé par Jug, par Saint-Antoine, par Montperros, les Grangettes, les Granges Friards, oi, et que est allé jusqu'aux plains de Pontarlier. Cette suite est en ligne droite vis à vis à l'écrincure de Jug, en la direction de la vallée que est au bas de ces villages. On en trouve quelques morceaux à Metabifs, mais jnnai.vu aux Longevilles, ni à Rochejean. Ilyn Odessus de Saint-Croix ou d'autres ont pu passer aussi pour aller de même aux environs de Portelier. Ilyn dans le val de Moustier travers jusqu'au Odessus de village de Butte. Elles ont même passé les roches de Saint-Sulpice du côté de Verrières de Suisse, ou l'on a été obligé d'en faire sauter de gros blocs avec de la poudre pour dégager la grande route, ilyn dans les vallées de Tavannes, et de Delamont. On en trouve bien plus loin, jnai vu près de Rolands, et jne douterois pas que les pierres molières de Moïse et de environs enussent la même origin. M. De Saussure, who has so well observed everything that can be perceived upon the surface of the earth, gives us the following remarks which are general to mountainous countries. Voyages dans les Alpes, tome 2d section 717. Dans le haut de vallées entourées de hautes montagnes, on any voit point de Cailloux rules, que soyant étrangers à la vallée même dans laquelle on les trouve, ce que l'on y rencontre any sont jamais que les débris de montagnes voisines. Dans le plains au contraire, et à l'embouchure de vallées, que aboutissent aux plains et même ces hautes sur les pentes de montagnes que bordent ces plains, on trouve de cailloux et de blocs que l'on déroide tombes du ciel. Tant leur nature diffère de tout ce que l'on voit dans les environs. Here are facts which can only be explained in supposing that the valleys have been hollowed out of the solid mass, by the gradual operation of the rivers. In that case stones, travelled from afar, will be found at considerable heights, upon the sides of the valleys at their under end, or where, as our author says, they terminate in plains. We have a striking example of the operation of time and the influences of the atmosphere, in wasting the surface of the rocks, and forming soil upon the earth. This is the kaolin of the Chinese, or the true porcelain earth, which is the produce of granite countries. The feldspar of the granite rock exposed to the atmosphere is corroded very slowly indeed, by the effects of air and moisture, and in having the soluble earth or calcareous part of its composition dissolved. The surface of this stone, thus, in a long course of time, becomes opaque in having the white siliceous earth exposed to view, and thus appears like a calcined substance. The snows and rain detaches from this surface of the rock the white earth, which being deposited in the plain below, forms a stratum of kaolin more or less pure, according to the circumstance of the place. As this operation of the atmosphere upon the surface of granite is so extremely slow as to be altogether unmeasurable to man. And as there are in many places of the earth inexhaustible quantities of this kaolin, notwithstanding a small portion only of the ablution of the rock had been retained upon the surface and deposited by itself. It must appear that much time had been required for amassing those beds of kaolin, and that these operations, which in the age of a continent is nothing, or only as a day, are, with regard to the experience of man, unmeasurable. For approbation of this theory, it is not necessary to show, that wherever there is granite found, there should be also kaolin observed. But it is necessary that wherever kaolin is found, there should be also granite or feldspar to explain its origin, and to this proof the theory is most willingly submitted. The following are the places which have come to my knowledge. First, Loch Doon in the Shire of Ayr, this lake receives its water from the granite hills which are at its head. Secondly, some small lakes which receive the washings of the granite mountain, Crifel, in East Galloway. Thirdly, Cornwall, a county in which I have not been, but which is sufficiently known as possessing kaolin and granite. Another example from a very distant country we have both from M. Pallas, in the Aral Mountains, and from M. Patron, who has given a mineralogical notice of the Douari, Journal de Physique, Mars 1791. Here we find the following observation. Parmi les choses interessantes qui offrent les rives de Chilia, on remarque au-dessus de la fonderie, de collines de Petunfe blanc comme la neige, parcime de mica argentine de la plus grande tenuite. Dans le voisinage de ce Petunfe est un argile micaci, que en est peut-être en décomposition, on essaie en ma présence d'en faire de la poterie que avoid tous les caractères du Miller's biscuit de porcelain. We have now been endeavoring to illustrate the wasting and washing away of the solid land, in the examples of decayed rocks and water-worn stones, all of which are traceable, though at a great distance, to their source. We are now to consider another species of substance, which is still more particular as to the place of its production, or to its original situation, this being only in the veins of the earth. Among all the various productions of mineral veins, we have only now in view some particular metallic substances which do not seem to waste and be dissolved, as many of them are, in being long exposed to the influence of air and rain. When, therefore, the solid parts of the land are wasted in time, and carried away from the surface of the earth, the contents of the veins, which are occasionally found in those decayed parts of the land, are also carried away in the stream. But as the specific gravity of those metallic contents is much greater than the other stony materials moved in the stream, they sink to the bottom, and tend much more to be deposited upon the land than those stones which had moved with them from their place. Hence it is, that deposits, rich in those metallic substances, are formed in certain places of the soil, and these are sought for, upon account of the value of their contents. Thus, stream tin, which in the time of the Romans formed a subject of traffic, is still found in the soil of Cornwall, even in great profusion, at this day. Nothing can tend more to illustrate this travelling of the wasted surface of the solid land, than the contents of those mineral veins suffering in the general destruction of things, but partly saved from that total ablution by which so much of the solid parts have been made to disappear. And nothing can, in a more beautiful manner, show this order of things, than the method practiced by the Cornish miners in quest of the original country of that metal, by shotting, as it is called, upwards in running back the tract in which the stream tin had been conveyed. This is done by trying parcels of the soil, in always mounting to see from whence the mineral below had come. Gold is thus found almost in every country, but it is only in the most sparing manner that it may thus be in general procured, by reason of the few veins in which gold is found, and the small quantity of this metal contained in those veins. America, however, affords an example of veins rich in gold, and it is also there that quantities of stream gold is found in the soil, bearing a due proportion to the number and riches of the veins. I shall give an example concerning the situation in which this stream gold is found in Peru, Voyage au Peru, par M. Booger, page 49. Cette cordillère occidentale contient beaucoup d'or de même que le pays de l'Orient, et celle d'une autre chaîne très longue que s'en détache un peu au sud de Popayan, et qu'après avoir passé par Santa Fe de Bogota, et par Mérida, VASE terminer vers Caracas sur la mer du Nord. Outre que l'or en paillettes occupe toujours de postes assez bas à l'égard du reste de la cordillère, on any peut aussi jamais le découvrir en enlevant presque toujours du couches de différentes terres que le cachant. La première, que est de la terre ordinaire, a 3 ou 4 pieds d'épaisseur et quelquefois 10 ou 12. On trouve souvent au-dessus un couche moins épaisse que tire sur le jaune, et plus bas est un troisième que a une couleur violette, que a souvent 3 ou 4 pieds d'épaisseur, mais que n'a aussi quelquefois tu un pouce. Et c'est cette troisième dans laquelle l'or est mêlé. Au-dessus la terre change encore de couleur, elle devient more comme à la surface du sol, et elle n'y contient aucun métal. D'ailleurs on any cruise pas indistinctement par tout. On se détermine à chercher en certains endroits plotat tu en d'autres par la pente de terrain. On agit cum si lor avant que d'avoir été couvert par les deux couches supérieures, avoidate cherry par de aux courants. On ss assure aussi que les terres une fois lavis ou dépouillées de leurs richesses en produisent point d'autres, ce que prouve que lor y avoidate cum depose. Therefore, whether we consider the quantity or the quality of the materials which are found composing the soil upon the surface of the earth, we must be led to acknowledge an immense waste of the solid parts. In procuring those relicts which indicate what had been destroyed, we have now to examine what is left of that solid part which had furnished the materials of our soil. This is the part which supports the vegetable or travelled earth, and this earth sustains the plants and animals which live upon the globe. It is by this solid part that we are to judge concerning the operations of time past, of those destructive operations by which so great a portion of the earth had been wasted and carried away, and is now sunk at the bottom of the sea. Man first sees things upon the surface of the earth no otherwise than the brute, who is made to act according to the mere impulse of his sense and reason, without inquiring into what had been the former state of things, or what will be the future. But man does not continue in that state of ignorance or insensibility to truth. And there are few of those who have the opportunity of enlightening their minds with intellectual knowledge, that do not wish at some time or another to be informed of what concerns the whole, and to look into the transactions of time past, as well as to form some judgment with regard to future events. It is only from the examination of the present state of things that judgments may be formed, in just reasoning, concerning what had been transacted in a former period of time. And it is only by seeing what had been the regular course of things, that any knowledge can be formed of what is afterwards to happen. But, having observed with accuracy the matter of fact, and having thus reasoned as we ought, without supposition or misinformation, the result will be no more precarious than any other subject of human understanding. To those who thus exercise their minds, the following remarks may furnish a subject for some speculation. Now, though to human policy it imports not anything, perhaps, to know what alterations time had made upon the form and quantity of this earth, divided into kingdoms, states, or empires, or what may become of this continent long after every kingdom now subsisting is forgotten, it much concerns the present happiness of man to know himself, to see the wisdom of that system which we ascribe to nature, and to understand the beauty and utility of those objects which he sees. There are two different operations belonging to the surface of this globe which we are now to consider, and by which we shall be enabled to form some computation of what had been in space and time, from that which now appears. Moving water is the means employed in both those operations, but, in the one case, it is the water of the sea, in the other again, it is the water of the land. The effect of the one operation is the wasting of the coast, and the diminution of that basis on which our land and soil depends. Of the other, again, it is the degradation of our mountains, and the wasting of our soil. In the course of this last operation, there is also occasionally land formed in the sea, in addition to our coast. With regard to the wearing of the coast by the agitation of the waves, this is an operation of which some understanding is to be formed from the surest of all records, from a careful examination of our shores which are in this decaying state, and by observing what has been removed from those portions which we find remaining. Few people have either the skill or the opportunity of thus judging of the state of our earth from that which actually appears. But there is no person, who studies this science of geology, that may not satisfy himself with regard to the truth of this theory, by looking into our maps and charts, and making proper allowances for causes which cannot appear in the maps, but which may be understood by a person of knowledge making observations on the spot. In order to assist this study, the following observations may be made. It is a general observation among mariners, that a high coast and rocky shore have deep water, whereas a low coast and sandy shore are as naturally attended with shallow water. The explanation of this fact will appear by considering that a steep rocky coast is occasioned by the sea having worn away the land. And, when that is the case, we are not to expect sand should be accumulated upon that shore, so as to make the sea shallow. Look round all the coasts of Great Britain and Ireland that are exposed to the wide ocean, as likewise those of France and Norway, deep water, and a worn coast, are universally to be acknowledged. If again the coast is shallow, this is a proof that the land affords more materials than the sea can carry away. Consequently, instead of being impaired, the coast may here increase and be protruded from the land. Such is the case in many places along the coast of North America, where several reasons concur in accumulating sand upon that coast. For, not only is the shore plentifully provided with sand from the rivers of that continent, but also the sand of the Mexican Gulf would appear to be carried along this coast with the stream which flows here towards the north, and which has thus contributed to form the banks of Newfoundland. The second general observation is to be considered as respecting the shape of coasts, in like manner as the first had in view their elevations. Now, it is plain that the shape of the coast, in any part of the land, must depend upon a combination of two different causes. The first of these is the composition of the land or solid parts of the coast. If this be uniform and regular, so will be the shape of the coast. If it is irregular and mixed, consisting of parts of very different degrees of hardness and resistance to the wasting operations, the coast will then be, irregular and indented. The second, again, respects the wearing power. If this wearing power shall be supposed to be equally applied to all the coast, and, if every part of that coast were of an equal quality or resisting power, no explanation could be given, from the present state of things, for the particular shape of that coast, which ought then to be wasted in an equable manner by the sea. But neither is the coast, of any extensive country at least, composed of such uniform materials, nor is the application of the wearing power to the coast an equal thing, and this will form the subject of another observation. The third general observation, therefore, regards the operations of the sea upon the coast, and the effects which may be perceived in consequence of that cause, independent of the qualities of the coast, or supposing them in general to be alike. Here, according to the theory, we should expect to find deep water and an indented coast upon a country, in proportion as that coast is exposed to the violence of the sea, or is open directly to the ocean. We have but to look along the west coast of Norway, the northwest of Scotland, the west of Ireland, and the southwest of England and of France, and we shall soon be convinced that the sea has made ravages upon those coasts in proportion to its power, and has left them in a shape corresponding to the composition of the land, in destroying the softer, and leaving the harder parts. 61. With those hard and rugged coasts of Britain and Ireland, let us contrast the east coasts. What a difference between these and the west side. Upon the west side, there are no sand banks left upon the coast. The mariner has nothing there to fear but rocks. It is otherwise on the east. Here we find a tamer coast, and, in many places, a sandy bottom. On the west, nothing appears opposed to the storm of the ocean except the hardest and most solid rock. On the east, we find coasts exposed to the sea which could not have remained in a similar situation on the west. Let us but compare the two opposite coasts of England, viz. the promontory of Norfolk and Suffolk upon the one side, and Pembrokeshire and Carnarvonshire on the other, both similarly exposed, the one to the northeast storm of the German Sea, the other to the southwest billows of the Atlantic. What a striking difference! The coast in the Bay of Cardigan is a hard and strong coast compared with that of Norfolk and Suffolk. The one is strong schistous, the other the most tender clay. Yet the soft coast stands protuberant to the sea, the harder coast is hollowed out into a bay. The one has no protection but the sands with which it is surrounded, the other had not remained till this day but for the protection of the most solid rocks of Pembrokeshire and Carnarvonshire, which oppose the fury of the waves. The last general observation which I shall propose, has, for its subject, a more enlarged view than those now taken of the coast, a view indeed which is not so immediately the object of our observation, but which is nevertheless to be made most evident, by means of the others now considered. We have seen that the land exposed to the sea is destroyed, and the coast wasted more or less, in proportion to the wearing causes, and to the different resisting powers opposed to those causes of decay. We are now to make our observations with regard to the extent and quality of that which has been already destroyed, a subject which can only be conjectured at from the scientific view which may be taken of things, and from the careful examination of that which has been left behind upon the different coasts. Our land is wasted by the sea, and there is also a natural progress to be observed which necessarily takes place on this occasion. For, the coast is found variously indented, that is to say, more or less, according as the land is exposed to this wasting and wearing operation of the sea, and according as the wasted land is composed of parts resisting with different degrees of power the destroying cause. The land, thus being worn and wasted away, forms here and there peninsulas, which are the more durable portions of that which have been destroyed around. And these remaining portions are still connected with the main land, of which they at present form a part. But those promontories and peninsulas are gradually detached from the main land, in thus forming islands, which are but little removed from the land. An example of this we have in Anglesey, which is but 1 degree removed from the state of being a promontory. These islands again, in being subdivided, are converted into barren rocks, which point out to us the course in which the lost or wasted land upon the coast had formerly existed. To be satisfied of this, let us but look upon the western coast of Scotland, from the islands of St. Kilda to Galloway, on the one side, and to Shetland on the other. In this tract, we have every testimony, for the truth of the doctrine, that is consistent with the nature of the subject. The progress of things is too slow to admit of any evidence drawn immediately from observation. But every other proof is at hand, every appearance corresponds with the theory, and of every step in the progress, from a continent of high land to the point of a rock sunk below the surface of the sea, abundant examples may be found. We do not see the beginning and ending of any one island or piece of country, because the operation is only accomplished in the course of time, and the experience of man is only in the present moment. But man has science and reason, in order to understand what has already been from what appears, and we have but to open our eyes to see all the stages of the operation although not in one individual object. Now, where the nature of things will not admit of having all and every step of the progress to be perceived in one object, an indefinite progression in the various states of different objects, showing the series or gradation from a continent to a rock, must form a proof in which no deficiency will be found. I have given for example the coast of Scotland, but all over the world where there is a coast not covered with sand, or where it is exposed to the violence of the sea, it is the same. Take the map of any country, provided it be sufficiently particular, and you will see the breaking of continents or islands, first, into promontories or peninsulas, secondly, into islands which stand on the same solid basis with the continent, and, lastly, into rocks which are related to the islands, in like manner as those parasitical islands are related to the headlands and the shore. Here is a general fact, from the simple inspection of which we must conclude one of two things. Either that those rocks and smaller islands, which we have termed parasitical, are in a state of progression, by which in time they will be joined to the main land, and form one continent. Or that they are in a state of degradation, by which in time they will be made to disappear. There is no other supposition to be made, and, of that alternative, there is no room to hesitate a moment which to choose. This is not a matter of mere probability, it is the subject of physical demonstration. Should we find an old manuscript in a similar condition, we could not conclude with more certainty, that the deficient or intervening places had been destroyed, than we here conclude that the part which is now wanting, between the two remaining portions of the same rock or strata, had once connected those two portions, and had been destroyed by the operation of those causes which are every day employed in still increasing the breach. Though over all the world, where the shore is washed bare by the sea, examples are to be found which require but to be seen to give complete conviction. It is not in every place that the eye of a naturalist has been employed in taking this view of the coast. Nor is it upon every occasion that enlightened philosophers of this kind have given their thoughts upon the subject. M. de Spallanzani has given us the following observations with regard to the coast of Italy. 62. Autant l'intérieur du petit bourg de Portovenir et les rochers que l'environnement sont à l'abri de tempêtes, autant les parties extérieures sont exposées aux coups de mer les plus violents. Lorsqu'elles sont en proie aux deux terribles vents d'Afrique et à celle du sud-est. Ce dernier en particulier soulève les flots avec tant de violence et un tel hauteur contre les écules que servent de défense à si petit terrain, que la mer semble menacer de l'engloutir. J'ai été le témoin d'un de ces orages, et quoique j'ai fus à l'abri de tout danger, j'ai ne pourrais vous représenter l'horreur que me fit éprouver ce spectacle. J'ai voulu prendre avec exactitude la hauteur moyenne de l'élévation de flots dans les plus violents coups de vent, et quand j'ai vu en parlerai vous serez étant de leur force et de l'étendue de leurs effets. Les rochers que sont à la partie méridionale de Porto-Venir et rangent etc de Truzant peu de même que les trois îles voisines Tyro, le petit Tyro, et Palmarin. On le remarque surtout dans cette dernier. Les bords voisins de la terre ont un pente d'aus, ils sont couverts d'arbres et de plantes, tandis que la partie opposée est déserte et inaccessible couverte de précipices, de ruines et de horreurs. Les autres parties du rivage sont renfermées par la rivière du Ponant et par celle du Levant, de même que celles que s'approchent de côtes de Provence. Il me paraît que la mer a beaucoup gagné sur le terrain dans ces parages. Et pour parler seulement de Palmarin, la plus grande, et la plus remarquable de trois îles que j'ai nommées. J'ai crois être suffisamment fond pour conclure que la même pente facile et long qu'on observe du côté de la terre avoit aussi existe du côté de la mer. Mais que cette dernière avoit été détruite par les orages, que ainsi sont succèdes pendant le cours de siècles. La vue réfléchie de ces trois îles me force à les regarder comme ayant été autrefois réunies, et formant un au sol par leur réunion, ou plutôt comme un presqu'île attenante à Porto-Venir. We have a still more interesting observation made upon this same coast of Italy, by a naturalist to whom the world is much indebted for his excellent remarks upon what he has, by his great industry, brought to light. I mean the Chevalier de Dolomieu. Wherever he goes, natural history reaps the benefit of the most enlightened observations. We are now to avail ourselves of his memoir sur les Îles Ponces. The Pumice Islands form part of a chain of land that may be traced forming a circular line from the Cape Messine to the Mount Cercello at the other side of the Gulf of Gaeta. The islands of Ischia and Procida, which form part of this chain of land, might, from the inspection of the map, be allowed as having once formed a continuation of the land from the continent of Italy, even without the testimony of natural history. That traces this connection from the materials of those masses which now are separated. The Pumice Islands form the middle part of that chain, and are the farthest removed from that continent of which it is probable they once formed a part. They are connected with the promontory of Messine on the one hand, as being of the same or similar volcanic origin, and on the other with Mount Cercello, by a curious circumstance in the island Zanoni, which, but a little more of the devouring operation of the sea, would have concealed from our observation. The island of Ventotene, which is the nearest of them to Ischia, would appear to be the ancient island of Pendateria, in which Julia was confined. The marks of degradation in this island, I would wish to give in the Chevalier's own words, page 52. Cette île continue à être dévorée par la mer, elle attaque dans toutes les parties de son contour, où elle trouve peu de résistance, et elle ne cesse de creuser, principalement, tous les escarpements du nord. Il paraît, par les vestiges de antiquités que sont sur la pointe dit de Nevela, que sous l'empire de César cette île avoit encore un étendue plus considerable. Il fait journellement de éboulements. On peut prévoir qu'elle diminuera progressivement, qu'elle se divisera, et que dans les temps à venir elle sera réduite aux rochers de laves que la supportent, et que seuls peuvent résister, pendant une longue suite de siècles. À tous les efforts de flots. CNE sera sûrement pas la seule terre que le temps et la mer auront dévoré, et que les vicissitudes de la nature ont fait disparaître avant que l'histoire en ait pu constater l'existence. As the island of Ventotene connects this group of the Pumice Islands with the continent of Messine, that of Zanoni, on the other side, connects them with the continent at Mount Cercello. Here is a fact of which our author now gives proper evidence. It would appear that Mount Cercello is composed of an alpine limestone. But in the north end of the island of Zanoni, the Chevalier de Dolomieu finds a small part of a similar limestone in vertical strata, closely united with the volcanic materials of the islands now under consideration. It is impossible that this portion of calcareous rock could be formed in its present situation, and we have but to examine nature in order to be convinced that this limestone part had been once continued from Mount Cercello. Here again I beg leave to give this author's own words, page 141. Cette réunion de deux matters aussi différentes par leur origine que le font celles que forment l'île Zanoni, est une circonstance de plus singulières. La pierre calcaire any contient point de coquillages, essa densite essa durite, son odeur fétide en once en origine ancienne, elle n'est point formée par un dépôt de nouvelle date. Elle diffère de pierres calcaires coquillères que recouvrent les volcans du Paduan et du Vicentin. Et de celles que s'y sont mêlées avec les produits du feu dans les volcans éteints de la Sicile, les laves ici reposent sur elle, elle pourrait donc antérieure à l'époque de éruptions que ont élève les îles Ponces. Par sa nature elle est semblable aux pierres du Mont Circe, et à celles de l'intérieur de l'Apennine. Il semble que cette portion de montagne calcaire, abstraction faite de matters volcaniques que lui sont réunies, a appartenu à quelqu'un de montagnes que dépendent de la chaîne que traverse l'Italie. Car il n'est pas possible que le Mont Circe ayant été formes sols et isoles ainsi que nous les voyons. Mais quando elles étaient détachées. Etoyent-ils déjà isoles lorsque les feux ont commencé la formation de îles Ponces. Ou serait-ce la même révolution que les auroids séparés du continent, et que opère le désordre que nous voyons dans ces îles volcaniques? On n'y put former sur toutes ces questions que de conjectures bien vagues. Our present inquiry is only with regard to the operation of those causes which we now perceive to be acting upon the coasts of the land. Which must be considered as having been operating for a long time back, and which must be considered as continuing to operate. One example more I wish to give, not only as it is much to the purpose, and properly described, but because it contains the natural history of a coast well known from the circumstance of the Giant's Causeway which it contains. A coast composed of stratified chalk indurated and consolidated to a species of marble or limestone, and of great masses of basalts or columnar whinstone. Now, though our present object is not the formation of land, yet, knowing the mineral constitution of this land, the coast of which we are considering as having been worn by the action of the sea, the view here to be given of the white marble and basaltic cliffs, is satisfactory in the highest degree. It is from letters concerning the northern coast of the county of Antrim, by the Reverend William Hamilton, A.M. The chalky cliffs of the island of Raggery, crowned by a venerable covering of brown rock, form a very beautiful and picturesque appearance as one sails towards them. And, if the turbulence of the sea does not restrain the eyes and fancy from expatiating around, such a striking similitude appears between this and the opposite coast. As readily suggests an idea that the island might once have formed a part of the adjoining country, from whence it has been disunited by some violent shock of nature. You, to whom demonstration is familiar, will wonder to see two shores, 7 or 8 miles asunder, so expeditiously connected by such a slender and fanciful middle term as apparent similitude. And yet the likeness is so strong, and attended with such peculiar circumstances, that I do not entirely despair of prevailing even on you to acknowledge my opinion as a probable one. It does not appear unreasonable to conclude, that, if two pieces of land, separated from each other by a chasm, be composed of the same kind of materials, similarly arranged, at equal elevations, these different lands might have been originally connected, and the chasm be only accidental. For, let us conceive the materials to be deposited by any of the elements of fire, air, earth, or water, or by any cause whatever. And it is not likely that this cause, otherwise general, should in all its operations regularly stop short at the chasm. The materials of which the island of Raggery is composed are accurately the same as those of the opposite shore, and the arrangement answers so closely, as almost to demonstrate, at first view, their former union. But to explain this more clearly, it will be necessary to give you a general sketch of this whole line of coast. The northern coast of Antrim seems to have been originally a compact body of limestone rock, considerably higher than the present level of the sea, over which, at some later period, extensive bodies of vitrifiable stone have been superinduced in a state of softness. The original calcareous stratum appears to be much deranged and interrupted by those incumbent masses. In some places it is depressed greatly below its ancient level, shortly after it is borne down to the water's edge, and can be traced under its surface. By and by it dips entirely, and seems irretrievably lost under the superior mass. In a short space, however, it begins to emerge, and, after a similar variation, recovers its original height. In this manner, and with such repeated vicissitudes of elevation and depression, it pursues a course of 40 miles along the coast from Lough Foyle to Lough Larne. It naturally becomes an object of curiosity to inquire what the substance is from which the limestone seems thus to have shrunk, burying itself, as it were in terror, under the covering of the ocean, and, on examination, it appears to be the columnar basalts, under which the limestone stratum is never found. Nor indeed does it ever approach near to it without evident signs of derangement. Thus, for example, the chalky cliffs may be discovered a little eastward from Portrush. After a short course, they are suddenly depressed to the water's edge, under Dunluce Castle, and, soon after, lost entirely in passing near the basalt hill of Dunluce, whose crags, near the sea, are all columnar. At the river Bush the limestone recovers, and schemes a moment above the level of the sea, but immediately vanishes in approaching towards the great basalt promontory of Bangor, under which it is completely lost for the space of more than 3 miles. Eastward from thence, beyond Dunsavrock Castle, it again emerges, and, rising to a considerable height, forms a beautiful barrier to White Park Bay and the Ballantoy shore. After this it suffers a temporary depression near the basalt hill of Noxagee, and then ranges along the coast as far as Ballycastle Bay. Fairhead, standing with magnificence on its massy columns of basalts, again exterminates it. And once again it rises to the eastward, and pursues its devious course, forming, on the Glenarm shores, a line of coast the most fantastically beautiful that can be imagined. If this tedious expedition have not entirely worn out your patience, let us now take a view of the coast of Ragery itself, from the lofty summit of Fairhead, which overlook it. Westward we see its white cliff rising abruptly from the ocean, corresponding accurately in materials and elevation with those of the opposite shore, and like them, crowned with a venerable load of the same vitrifiable rock. Eastward, we behold it dip to the level of the sea, and soon give place to many beautiful arrangements of basalt pillars which form the eastern end of the island, and lie opposite to the basalts of Fairhead, affording in every part a reasonable presumption that the two coasts were formerly connected, and that each was created and deranged by the same causes extensively operating over both. But it is not in these larger features alone that the similitude may be traced, the more minute and accidental circumstances serve equally well to ascertain it. Thus, an heterogeneous mass of freestone, coals, iron ore, etc., which forms the east side of Ballycastle Bay, and appears quite different from the common fossils of the country, may be traced also directly opposite, running under Rathlin, with circumstances which almost demonstrably ascertain it to be the same vein. What I would infer from hence is, that this whole coast has undergone considerable changes. That those abrupt promontories, which now run wildly into the ocean, in proud defiance of its boisterous waves, have been rendered broken and irregular by some violent convulsion of nature. And that the island of Ragery, standing as it were in the midst between this and the Scottish coast, may be the surviving fragment of a large tract of country which, at some period of time, has been buried in the deep. Besides this argument of the gradation from a continent of land to a bare rock, we have another from the consideration of those rocks themselves, so far as these could not be formed by nature in their present state, but must have been portions of a greater mass. How, for example, could a perpendicular mountain, such as Street Kilda, have been produced in the ocean? Of whatever materials we shall suppose it formed, we never shall find means for the production of such a mass in its present insulated state. Let us take examples of this kind near our coast, and of known rocks. Staffa and Ailsa, on the west coast, and the base, upon the east, are mountains of either whinstone or granite, similar to many such mountains within the land. And they are perpendicular around, except perhaps on one part. It is demonstrable that such basaltic rock as contains zeolite and calcareous spar, as most of our whinstones do, could not have been the eruption of a volcano, consequently those rocks must have been masses protruded in a fluid state, under an immense cover of earth at the time of their production. And they could not have risen immediately out of the sea, with all their various minerals, their veins and cutters, their faces and their angles. In like manner, the east coast of Caithness is a perpendicular cliff of sandstone, lying in a horizontal position, and thus forming a flat country above the shore. But along this coast there are small islands, pillars, and peninsulas, of the same strata, corresponding perfectly with that which forms the greater mass. Now, shall we suppose those strata of sandstone to have been formed in their place, and to have reached no farther eastward into the sea? It is unsupposable. Or, shall we conceive that the sea, which has made such depredations in land composed of much more solid materials, had spared this, and had not wasted much more than that now pointed out by the ruins which remain? Impossible. We must suppose that there had once existed much land where nothing now is found but sea. But, if we are to suppose much to have been wasted, where shall we stop in this process of restoring continents? That is the question now to be discussed. With this view, let us now turn our attention to the northwest coast of Europe, in consulting the general as well as the most particular maps. Upon the one extremity of Britain, we find Cornwall separating it as it were from the main land. And, from this promontory, the Scilly Isles pointing out what had been destroyed in that direction, which is here to be considered as the line of greatest resistance. But what a quantity of the soft materials, or less resisting parts on either side, has been destroyed. Upon the other extremity of Britain, we find the country of Scotland, forming itself into promontories and islands, and those islands and rocks pointing out to us what had been the former extent of our continent and land around. But, in following this connection of things, we cannot refuse to acknowledge that Ireland had formerly been in one mass of land with Britain, in like manner as the Orkneys had been with Scotland 63. It will be still less possible to refuse the junction of England with the continent of France, the testimony of that peculiar body of chalk and flint, which borders each of those opposite coasts, forms an argument which is irrefragable. Now, in order to complete our continent, we have only to connect the Shetland Islands with the coast of Norway. But this is a notion which, however probable it may appear, is not proposed as a fact immediately supported by natural appearances. It is only to be considered as an enlarged view in which we may contemplate the operations of this earth upon a more extended scale. One which may be conceived as a step in our cosmogony, and one which, while it illustrates the theory of the earth already given, is by no means required in order to confirm a theory founded upon appearances which leave no manner of doubt. Chapter 9. The theory illustrated, with a view of the summits of the Alps. There are two different directions in which we may observe the destruction of our land to proceed. In the one of these, the basis of our continent is diminished by the encroachment of the sea, in the other, again, it is the height of the land above the level of the sea that is lowered. We have been considering the encroachment of the sea upon the continent. Let us now examine how far there may also appear sufficient documents, by which we may be led to conclude a long progress in time past, for the destruction of the solid mass of earth above the sea, without diminishing its basis. If we shall suppose this earth composed of horizontal strata, and of one level surface, without the least protuberance remaining by which we might be informed of what had been removed by time in the operation of second causes, we should be ignorant of everything of cosmogony but this, that the strata of the globe had been originally formed, by the sea, in the same shape as we had found them on the surface of the land. But this is not the shape of the surface of our continent. We have everywhere abundance of eminences, sufficient to give us great information with regard to what had passed in former periods of time. If the strata of the globe were in that regular shape which they had originally assumed in being deposited at the bottom of the sea. The strata, however, are not in that regular shape and position from whence we might learn, by examining the remaining portions, what had been carried away from the surface in general, they are found variously inclined to the horizon. And this we find both occasioned from the fracture and flexure of those bodies, thus changed from their natural horizontal state. Thus, though there are in many places immense masses of strata cut off abruptly, and exposed to view, without the remainder appearing, we cannot from hence form any estimate of the general quantity of destruction. At the same time, it must be evident, from a general inspection, that there has been an immense quantity removed. And that an immense time had been required in bringing about those revolutions of things, which are not done by violent changes, but by slow degrees. Besides that general conclusion with regard to the destruction of the strata, there is also in many places a demonstration of that fact, from a measured minimum of the quantity which had been removed. It is to the mining business chiefly that we are indebted for that demonstration of which we now shall give an example. The coal strata, about Newcastle upon Tyne, dip to the southeast at the rate of 1 in 12, or thereabouts. This is but little removed from the horizontal position. At the same time, the strata come all up to the soil or surface in a country which is level, or with little risings. But in those strata there is a slip, or hitch, which runs from northeast to southwest, for 17 or 18 miles in a straight line. The surface on each side of this line is perfectly equal, and nothing distinguishable in the soil above. But, in sinking mines, the same strata are found at the distance of 70 fathoms from each other. Here therefore is a demonstration, that there had been worn away, and removed into the sea, 70 fathoms more from the country on the one side of this line, than from that on the other. It is far from having given us all the height of country which has been washed away, but it gives us a minimum of that quantity. The examination of what is commonly called a secondary country is not sufficient to give us an idea of the immense operation of time in wearing the surface of this earth. It is not that those countries of inferior hardness and elevation have been spared in the course of time, but because we have not, in those leveled countries, such great remainders, by which we are to judge the quantity of what is lost. In the Alpine country, again, though it be the same system of things with that which takes place in the lower country, the revolution of things is more marked for our view. And the ravages of time, in destroying the solid parts of the globe, in order to make soil of that which is removed, may be seen in all the steps of that important operation. Whereas, in the more level countries, the scale of elevation is imperceptible, and that of time is so slow as renders our examination fruitless. It is the Alps, therefore, chiefly that we are to take for an example, in tracing this operation of nature upon the surface of this earth, and forming some idea of the course of time that must have flowed during that operation in which the height of our land had been diminished. On whatever side we approach the Alps, we find some great river discharging the waters which had been gathered above, and with that water all the waste of earth and stone which had been made among those lofty masses of decaying rock. Now, we find this river running in a valley proportioned, in general, to this vehicle, in which is travelled the wreck of ruinous mountains. Spacious plains attend those mighty streams. And, though, sometimes we find the greatest rivers much confined between approaching hills of solid rock, the valley opens again, and, on the whole, is always corresponding to the current of water which has successively run in all the quarters of this plain. Here a question occurs: has this valley been made by the operation of the river itself, or has it been the effect of other causes? Let us now resolve that question. If the valley was made for the river by any other natural cause, either we should tell by what means this work had been performed, or all reasoning upon the subject is at an end, and fancy substituted in its place. If again the river be considered as the means employed by nature in making this valley, then all the solid parts between the bounding mountains must have been removed. And the fertile plains must have been formed by the water depositing those materials which we find in the soil, and which had come originally from the solid mountains. There is no occasion to enter into any argument to prove this fact. Nobody that examines the matter will find any reason to doubt. And it would be as unreasonable for those to doubt who have not examined, as for those who find no reasonable subject of doubt to disbelieve. We are now to suppose the great river to have formed the valley and extensive plain in which the water runs, a valley corresponding to the grandeur of the river by which it has been formed. But, as we ascend this great valley, we find other valleys branching from this main valley, and, in all those subordinate valleys, we find rivers corresponding in like manner with the magnitude of the valley. Here, therefore, is infinitely more than a single river, and a valley corresponding to the river. Here is a system of rivers and of valleys, things calculated in perfect wisdom, or properly adapted to each other. Now it is just as easy, by our theory, to explain this system of rivers and valleys, as it is to understand the single appearance of a river and a valley. But it is only in this manner that such a complicated operation, of a series in rivers and their valleys, is to be explained. And we can neither suppose the land to be formed with this intention by a supernatural cause, nor imagine any other natural cause so arranging things, upon the surface of the earth, as to form this perfect system, which holds of nothing but itself. A system in which is manifested wisdom, so far as all the parts are properly adapted to each other, and thus made to answer that intention which is so visible in the economy of this world. The direction of the principal valleys of the Alps, or every mountainous region of the globe, may be considered as proceeding from the center of that region to the plain country in which each river is to terminate. Each secondary river with its valley then branches from the primary as from a stem, consequently runs in a direction perpendicular or inclined to the other. But the secondary rivers also have their branches. And subordinate branches still are branched. In thus tracing rivers and their branchings, we come at last to rivulets that only run in times of rain, and at other times are dry. It is here I would wish to carry my reader, in order to be convinced, with his proper observation, of this great fact, that the rivers, in general, have hollowed out their valleys. The changes of the valley of the main river are but slow, the plain indeed is wasted in one place, but it is repaired in another, and we do not perceive the place from whence that repairing matter had proceeded. Therefore, that which here appears does not immediately suggest to the spectator what had been the state of things before the valley had been hollowed out, or before that plain, through which the river runs so naturally as being in the lowest place, was made. But it is otherwise in the valley of the rivulet. No person can examine this subject without seeing that the rivulet carries away matter which cannot be repaired except by wearing away some part of the mountain, or the surface of that place upon which the rain, which forms the stream, is gathered. In those rivulets, or their little plains, we see the detached parts remaining in the soil, and also the place from whence those detached parts were taken. Here we need no long chain of reasoning from effect to cause. The whole operation is in a manner before our eyes. In this case, it requires but little study to replace the removed parts. And thus to see the work of nature, resolving the most hard and solid masses by the continued influences of the sun and atmosphere. In this state of things, we are easily made to understand how heavy bodies are traveled along the declivity of the earth, by means of water running from the height. Such is the system of rivers and their valleys. Nor is there upon the continent a spot on which some river has not run. But, in the Alps of Switzerland and Savoy, there is another system of valleys, above that of the rivers, and connected with it. These are valleys of moving ice, instead of water. This icy valley is also found branching from a greater to a lesser, until at last it ends upon the summit of a mountain, covered continually with snow. The motion of things in those icy valleys is commonly exceeding slow, the operation however of protruding bodies, as well as that of fracture and attrition, is extremely powerful. To illustrate those operations of excavating the valleys of rivers and of thus undermining mountains which fall by their proper weight, I shall transcribe some descriptions of what is to be found among the Alps. But first I would wish to carry my reader to the summit of that country, to examine the state of that part which nothing can have affected but the immediate influences of the sun and air. After having thus formed some idea of the summit of this wasting country, we shall next examine the valleys through which the materials of the degraded summit must have traveled. In order to give a proper idea of this central part of the Alps, which is so interesting a part in the natural history of the earth, M. de Saussure, in the plates of his Voyages dans les Alpes, Tom. 2. has given us two views, the one in profile, the other in face, of the Mont Blanc. I have caused copy those plates, which are necessary to be consulted in reading the following description of this center of the Alps. This author has taken much pains to form, to himself a proper idea of the object which we have now in view, and he gives a description of the Mont Blanc as seen from the top of the Cramant. It is that description which I am now to transcribe. 64. Section 910. Le premier objet de mon étude fut le Mont Blanc. ILSE présente ici de la manière la plus brillante et la plus commode pour l'observateur. On l'embrace d'un seul coup d'œil, depuis sa base jusqu'à sa cime, et il semble avoir écarté et regit sur ses épaules son manteau de neige et de glaces pour laisser voir à découvert la structure de son corps. Taille presque à pic dans une hauteur perpendiculaire de 1600 toises, les neige et les glaces n'y peuvent être que dans un petit nombre d'éclancures, et il monte partout en nud le roc vif dont il est composé. Ça formé pourrait être celle d'une pyramide, que présente au sud-est du côté du Cramant un de ses faces. Le rite droit de cette pyramide du côté du sud-ouest, monté au sommet, en faisant avec l'horizon un angle de 23 à 24 degrés. Le rite gauche du côté du nord-est, monté au même sommet sous un angle de 23 à 24 degrés, en sorte que l'angle au sommet est d'environ 130 degrés. Cette pyramide pourrait elle-même composée de grands fiolets triangulaires ou pyramidox. Trois de ces grands fiolets ont leurs bases dans l'allée blanche, et forment ensemble tout élevant corps de la base de la pyramide. Chacun de ces fiolets, vu de l'allée blanche, pourrait une grande montagne, j'ai les ai décrits dans le chapitre précédent sous le nom de Mont Petre, Mont Rouge et Mont Broye, section 830, 831, 834. Mais du haut du Cramant, on voit plus nettement leur forme, et de leur ensemble, on distingue, par exemple, ils sont eux-mêmes composés de grandes fieuilles pyramidales. On voit que les ingers du temps ont de triple point du Mont Rouge, tandis que celles de deux autres pyramides sont demeurées entières. Ces trois fiolets n'y élevant pas jusqu'à la moitié de la hauteur du Mont Blanc. D'autres fiolets plus petits, situés derrière et au-dessus d'eux, et placés sur deux lignes principales que convergent au sommet, achievant de couvrir la face de cette grande pyramide. Ces fiolets sont tous de forme pyramidale. Les plus petits sont les plus aigus, JNAI mesure plusieurs, dont l'angle au sommet n'était que de 70 degrés. Absolument tout, ont leurs plans parallèles à l'allée blanche, et par conséquent dirigés du nord-est au sud-ouest. Section 911. Quant à la matière dont est composée cette grande et haute montagne, tout sa cime et tout sa base, tant au centre que du côté du nord-est, sont indubitablement de granit. Mais le côté sud-ouest de la base, où le Mont Broye que nous avons vu de près, section 834, est d'une pierre moins dure, mélangée de schorl, de feldspath, de mica, de quartz gras et de pyrites. On voit très bien du haut du Cramant que cette partie de la base n'est point du granit, sa couleur est d'un brun rougeâtre, l'nese termine point par de arites vives et nettes, n'est point composé de grandes tables planes. Souvent cependant de fiolets pyramidox, mais petits et presses les uns contre les autres. À mesure qu'ils approchent du sommet, et par la même du cœur de la montagne, ils perdent leur couleur rouge, leurs angles deviennent plus vifs, leurs tables plus grandes et plus planes, et enfin près de la cime, et à la cime même. Ces sont de vrais granits parfaitement caractérisés. On peut donc conclure, que le corps entier du Mont Blanc, et même ces bases avances du côté de l'Italie, sont tous de granit, except la base de l'arête extérieure du côté du sud-ouest. Section 912. La montagne que touche le Mont Blanc du côté du nord-est, et que, vue de Genève, formé en quelque manière le premier escalier en descendant de la cime, est aussi composé de tables de granit que paroissent dirigées du nord-est au sud-ouest. Mais la sommite que suit celle-ci en tirant toujours au nord-est, et que formé le second escalier, pourrait avoir quelques fiolets tournants autour de son corps pyramidal, comme les fuelets d'un artichokes, et comme j'ai de paint l'aiguille du midi. Tome I. PL 6. En tyrant plus encore au nord-est, on reconnoit les jorises que nous avons vues du haut du Talifre, section 637, els paroissant dici, après le Mont Blanc et ses escaliers, les sommets les plus élevés de tout cette chaîne. EDL semblant résulter de l'assemblage de plusieurs suites de fuelets pyramidoques convergence vers leur sommet. En général tous les cimes élevés que l'on peut distinguer dans cette chaîne, depuis le Mont Blanc jusqu'au col Ferret, sont soutenus par de ogives composés d'une ou de plusieurs suites de fuelets pyramidoques appuyés les uns contre les autres. Les extérieurs ont leurs bases dans le fond de la vallée, et les intérieurs remontant par degrés jusqu'au haut des cimes. Les deux escaliers du Mont Blanc sont les seuls sommets que n'ayant pas de ogives de ce genre. Section 913. Je demande à présent quelle idée on peut se faire de l'origine de ces fuelets plans et de toutes ces pyramides grandes et petites que résultent de leur assemblage. Si on any les considère pas comme les restes ou les noyaux les plus durs de couches que out résiste aux ravages du temps, tandis que les parties intermédiaires, que les liant entre elles, out été détruites par ces mêmes ravages. Mais jusqu'à quel point la cristallisation ATL contribue à déterminer ces formes pyramidales. Doit-on considérer le Mont Blanc ou tel autre de ces aiguilles, comme un énorme cristal? C'est une question de théorie que j'examinerai à l'heure. Quant à présent je me contenterai de conclure, que la face méridionale de la chaîne centrale de Alpes est, comme la face septentrionale de cette même chaîne, composée, pour la plus grande partie, de couches de granit et poutres verticales. Et dirigées pour la plupart du nord-est au sud-ouest. This theoretical question of our author is so properly connected with the natural history which he has here given us, that it is not difficult to resolve it in the most satisfactory manner. Here is an enormous mass of granite, the origin of which we are not now inquiring after, but the causes of its present form. The internal part of this granite subsists in a state of the most perfect solidity. The external again is evidently in a decaying state. This is a fact which we learn from the nature of feldspar, of which granite is in part composed. This crystallized substance is everywhere decomposed, where long exposed to the atmosphere. But it is not this gradual decay of the mass of granite perishing equably from its external surface, and resolved into some of its component parts, that we are here to consider. It is only mentioned to show that the mass of granite is subject to decay, when exposed to the influence of the atmosphere, like every other compound mineral body, and to lose that perfect solidity which we find in the center of the mass. We find the granite masses not only subject to decay from the external surface, by the decomposition of the feldspar, or the dissolution of its constituent parts, but also liable to be separated into blocks of different degrees of regularity, commonly rectangular or approaching to the rhombic shape. This is the consequence either of larger veins and fissures, filled with matter which is still more dissolvable than is the substance of the granite, or else by imperceptible crevices or cutters, into which the atmospheric influences gradually insinuate, and form at last a visible separation. In examining the tops of granite mountains, or where this rock is exposed to the weather, we may perceive those two species of decay proceeding together. The external surface of the stone, where there is a sufficient mixture of feldspar, is separating into grains which form a species of sand, being nothing but the particles of granite separating by means of the decaying sperry part. But a similar progress may be observed from the external surface penetrating in lines the mass of solid rock, and dividing that mass into the rectangular blocks into which those exposed places are gradually resolved. Now the tops of all those mountains are formed into an assemblage of pyramids, declining in height from the central pyramid, and all those pyramids are again in like manner subdivided into lesser pyramids. But the smallest of those pyramids are no other than the rectangular blocks into which those granite masses always separate by the influence of the atmosphere. It will now be evident that those mountains, thus resolving into separate blocks, must acquire this series of pyramidal constructions. For, in every particular mass of mountain, there must be a central part, from which the separated blocks cannot be removed, while those around, or towards the sides, are detached by the swelling water upon freezing, and separated from the more central masses which are thus the latest of being removed. It is impossible to see this series of pyramidal relics, without at the same time perceiving that manner of formation, by the gradual resolution of the solid mass of granite, as it comes to be exposed in succession to the influences of the atmosphere, which M. de Saussure has termed les ravages du temps. But if it be in this manner, that time wastes the solid masses of this globe, and if all the solid masses of the earth have acquired their solid state by the same means, i.e., by heat and fusion, as is maintained in the present theory, we should find similar pyramidal mountains formed of different materials. Now there can be nothing more different than masses of limestone and those of granite. But pyramidal mountains are equally formed of those two different materials. In Plate V, under the letter B, may be seen the calcareous pyramids which are near the Col de la Seine, and which in Plate 6 are represented under the letter G. Here is a view of the summit of the Alps, from whence we may be allowed to draw the most important conclusions in favor of our theory. This summit is of solid granite, a mass in which there is no stratification, such as is to be perceived in all the other masses of those alpine regions. With regard again to the extent of this mass of granite, its basis is about 2 leagues in breadth, by at least thrice that space in length, and now we are to consider in what shape this mass of granite presents itself to our view. The summit of Mont Blanc, which may be considered as in the center of this mass, is a pyramid, and this great central pyramid is surrounded by a number of other great pyramids of the same kind. The points of those pyramids are extremely lofty, and, having sides often vastly steep, if not perpendicular, those colossal pyramids rise from the icy valleys in such a shape as has given occasion to their being named needles. Thus we find the whole space of this granite mass consisting of a mixture of icy valleys, and pyramidal rocks on which hardly anything rests. Now, these lofty rocks or pointed mountains must have been either originally formed of that shape, or posteriorly hewn out by the hand of nature, gradually wasting mountains in the course of time, and operations of the surface. If it is by the first that we are to explain the present state of things, then observation is superfluous, and our reasoning is at an end. For, when even observation should not contradict the proposition, which it actually does, it would be useless, as it can afford no data from a former state, which is supposed to have been no other than it is at present. And reasoning cannot be admitted if we have no data. Therefore, if we are to reason upon the subject, we are obliged to admit, that nature must have hollowed out of the solid rock all those pyramidal mountains, and a system of inclined valleys carrying the ice from the summits. Let us now reason from our principles, in order to see how far the present appearances of things would naturally result from those wasting causes acting upon a mass of granite, of a given basis and of sufficient height, during a space of time which is unlimited. We are to suppose our mass of granite without any structure except that of the veins and cutters, formed by the contraction of the solid mass in cooling. Now, those separations will naturally give direction to the operation of the wasting causes, whether we consider these as chemical or mechanical. Hollow tracks would thus be formed in the solid mass. In those hollow ways would flow the water, carrying the detached portions of the rock, and those hard materials, by their attrition upon the solid mass, would more and more increase the channels in which they move. Thus there would be early formed a system of valleys in this rock, and among those valleys a number of central points, or summits over which no running water would carry hard materials to operate upon the solid rock over which it flows. Here therefore, in the nature of things, is placed the rudiments of our needles, those colossal pyramids which acquire height gradually as the valleys widen, and whose apices may arrive at an angle of a certain degree of acuteness. But what a waste of rock to have formed all those needles which we find rising from the icy valleys round Mont Blanc. Upon the supposition that this had been the origin of those pyramidal mountains, it must be evident, that there is any plus ultra of acuteness to which the apex of a pyramid would in time arrive. And that then the decaying summit would tumble by the lump alternately, and regain the acuteness of its point. Now, if this be the case, although we cannot see the process, which is too slow for human observation, we should actually find them in all the stages of this progress. But this is precisely the state in which the summits of those mountains are to be found. M. de Saussure gives a view of one of those pyramids, which will serve to illustrate this subject in the most perfect manner. It is from the Montanvert that this object is to be perceived. Voyages dans les Alpes, Volume 2. These high peaks of solid rock demonstrate the manner in which those enormous masses of mountains are degraded, and also the means which are employed by nature for that purpose. But this scene, however well represented, is too far removed, in its appearance, from the ordinary mountains of this earth, to satisfy the doubts of every reader or to generalize a principle which must be universal in the system of this earth. We therefore have occasion for a mean, by which the extreme of those alpine summits shall be generalized or connected with our low inclined plains, and, on this occasion, I will give M. de Saussure's most excellent description of the Breven. Nothing can better suit our present purpose than the subject of this natural history, and I am persuaded that most readers will be better informed by the description of this naturalist, than they would be by their own observation. 639. J'ai déjà plusieurs fois nommé cette montagne, que est située immédiatement au-dessus du prieur de Chamonix, du côté du nord-ouest, elle est li par sa base avec les aiguilles rouges, dont j'ai aussi parlé dans le premier volume. Mais sa cime est nu, isolé, arrondi sur les derrières, et que à pic du côté de Chamonix. C'est à tous égards un de montagnes les plus intéressantes pour un naturaliste. J'ai monté pour la première fois en 1760, et j'ai n'y crois pas qu'un naturaliste l'ait visité avant moi, j'ai retourné l'année suivante. J'ai allé encore en 1767, et j'ai monté enfin pour la dernière fois en 1781, afin de vérifier mes anciennes observations, et de me mettre en état d'en donner une description plus exacte. Section 640. On peut du prier monter au sommet du Breven et redescendre dans le même jour, mais c'est un course pénible, car il faut au moins 5 heures pour monter, et la pente est extrêmement rapide. On peut cependant faire un mulet le premier tiers de cette montée. Comme j'ai voulu avoir le temps d'observer tout avec soin, j'ai destiné 2 jours, et j'ai allé coucher le premier jour dans un chalet, nommé Plainpre, que, en partant du prier, SDUX du tiers de la hauteur totale de la montagne. En montant à Plainpre, on fait près de 3 quarts du chemin sur de débris tombs et roules du haut de la tête du Breven. La colline même sur laquelle est bâti le village du prier n'est composé que de débris de cette montagne. Ces débris ont débouché par un gorge que nous traversons en montant, EDSE versant en sud à droite et à gauche, ILSONT pris la forme d'un cône, dont le sommet est au milieu de cette gorge. Les collines de ce genre et de cette forme se rencontrent bien fréquemment dans les vallées bordes par de hautes montagnes. Ces débris, que ne viennent pas seulement de la tête du Breven, mais de ses flancs et de sa base, sont de roches feuilletées mélanges de quartz, de mica et de feldspath dont toutes les proportions imaginables. De ces différentes proportions naissent différents degrés de durite, depuis le granit feuilleté le plus dur jusqu'à la roche micacée la plus tendre. Section 641. Les rochers au pied d'esquels ont passé avant de graver la montée rapide et herbie que aboutit à Plainpre, sont composés d'une roche feuilletée assez dure, dont les couches bien parallèles aux veines intérieures de la pierre. Suivant la direction de l'aiguille aimantie et sont très inclines à l'horizon. Le chalet de Plainpre est situé au milieu d'une assez grande prairie en pente douce du côté de la vallée de Chamonix, et dominée du côté opposé par les rocs nus que forment les sommets de la chaîne du Breven. Du bord de cette prairie, on a une très belle vue du Mont Blanc, de la vallée de Chamonix et de glaciers que y aboutissent. Ces mêmes objets se présentent avec bien plus d'éclat de la cime du Breven. Cependant la vue de Plainpre mériterait bien que ce que en orient par la force ou le courage d'y aller jusqu'à la cime, Montescent du moins jusqu'à la pour s'en former une idée. Comme je n'y vouloir monter sur le brevin que lendemain, j'ai employé le reste de la journée à observer les environs du chalet. J'examinai surtout avec soin de rochers situés à un demi-lieu au nord-ouest du chalet, que de loin paroissent colorés en rouge, comme plusieurs sommets de cette chaîne, c'est par cette raison qu'elle porte le nom d'Aiguilles Rouges. Section 642. J'ai trouvé que citoyent encore de granits veins, mélanges de quartz, de feldspath, de mica et de fer que color la pierre en se décomposant odor, set teint pénétre même quelquefois assez avant dans l'intérieur. Ces rochers sont divisés par couches bien distincts et peu près verticals, et dans la direction de l'aiguille aimantie, comme celles que j'ai avoir observées au-dessus du chalet. Ces couches sont capies par de fences et peu près perpendiculaires à leurs plans, et que sont pour la plupart parallèles à l'horizon, de manière que ces rochers se trouvent ainsi divisés en grandes pieces de forme et peu près rhomboidales. Les veins mêmes intérieurs de la pierre sont aussi très bien prononcés, et exactement parallèles à ces couches. Observation générale est de la plus grande importance, parce qu'elle prouve que ces couches sont bien de vraies couches, et non point de fissures produites fortuitement par la retraite ou par un effacement inégal de parties du rocher. Ces veins sont dessinés sur le fond blanc de la pierre de feuillets minces de mica noirâtre. Elles sont tantôt plaines, tantôt ondes, mais toujours régulières et parallèles entre elles, except la OILSE rencontre de nodes. Encore reprennent-elles leur direction après en avoir fait le tour. Comme le mica sy trouvé en petite quantité, la pierre est dure, et ne brise tuer grands coups de marteau. Lorsqu'on elle observe de près dans sa cassure, on voit que les petites lames ou écailles de mica sont constamment couchées dans le sens de veins de la pierre. Ces mêmes écailles n'ont presque aucune adhérence entre elles, en sorte que les feuillets dont la pierre est composée, en adhérent entre eux que par les points o ilnese trouvé point de mica. Section 643. Je me demandois à moi-même, en observant cette pierre, est-il est possible qu'elle eût été formée dans cette situation verticale. Ces écailles incohérents auraient pu venir s'attacher à ces murs verticoques, et le mouvement de os, clairement indiqué par le tissu feuilleté de la pierre, n'aurait pas dû les détacher et les faire tomber à mesure qu'elles se formoyent. Je me demandois encore, est-ce les fentes que couent ces feuillets, perpendiculairement à leurs plans, any dataroyant point d'un temps ou ces couches auraient été horizontales. Et en auraient point été produites alors par le poids et l'effacement inégal de parties de la pierre. Mais pour admettre cette supposition Illinois faudrait expliquer comment ces banks, d'abord horizontaux, ont pu se redresser, pourquoi ce redressement a été si fréquent, si régulier, etc. etc. Je réserve pour un autre temps la discussion de ces grandes questions, mais je n'y crois pas inutile de faire apercevoir la liaison qu'ont avec la théorie de observations si minutieuses en apparence. En faisant ces réflexions, j'ai retourné au chalet de Plainpre où j'ai passé la nuit sur de la pelle que j'ai avoir fait étendre auprès du feu, parce que la soirée était extrêmement fraîche. Section 645 On commence à monter par de jolies sentiers peu inclines, pratiques le long d'un grand rocher semblable à ce que j'ai avoir observé la veille. On a ensuite le choix de monter, ou par de pentes couvertes de rocailles un peu fatigantes, ou par de gazons extrêmement rapides. Ceci paroissent d'abord plus agréables et moins pénibles. Cependant ces gazons sont si serres et si glissants, qu'ils en deviennent dangereux, au moins pour ceux qui n'ont pas l'habitude de montagnes. Ces rocailles sont débris de roches feuilletées, semblables à celles que l'on rencontre en montant du prieur à Plainpre. Section 646. B. Au bout d'une heure de marque, on arrive au pied d'un rocher assez escarpé, il faut escalader pour parvenir à la cime de la montagne. C'est un roche micassé, mais que contient cependant assez de quartz pour avoir de la consistance. LSE sépare par fulets SI decides, que sans employer d'autres instruments que mes mains, JN dédicaille un dal, que avoit sept pieds de hauteur sur 4 de largeur, et à peine un pouce dans SA plus grande épaisseur. J'avois quelques dessert de descendre de là au pied de grandes tables verticales que composent la tête du brevin, pour les observer de près et comparer ainsi leur base avec leur cime. Mais de cet endroit la chose est impossible, la pente est d'une telle rapidité qu'un pierre médiocrement grosse, que j'ai mis en mouvement, roula avec beaucoup de vitesse, en entraîna d'autres, celle-ci d'autres. Idéals formant enfin un torrent de pierres que se précipita avec un fracas 1000 fois repeat par les grands rochers du brevin. Comme donc je n'y pouvoir pas descendre, j'ai monté par le passage ordinaire, que est une espèce de couloir au lieu de cheminée ouverte, adossé à un rocher presque à pic, de 40 au 50 pieds de hauteur. Bien de curieux sont venus jusques au pied de ce passage sans oser le franchir. Mais j'ai vis en revenant tuer un demi-quart de le plus au nord, on trouvé un autre passage extrêmement commode, camino même but, il faut par conséquent toujours préférer. Sur rocher une fois escalade, on monte par un pente douce, sans danger et sans fatigue, jusqu'au sommet du brevin. Section 646. C. En montant le long du bord, du côté de Chamonix, j'ai eu un plaisir inexprimable à contempler les magnifiques tables de granit dont est composée toute la tête de cette montagne. Car bien que les écales du miconnoirateur dont cette roche est mélangée, soyant parallèles entre elles et lui donnant ainsi quelque ressemblance avec un roche feuilletée. Cependant la quantité de quartz et de feldspath que entrant dans sa composition, son extrême durite, le peu de disposition actuelle à se fondre dans le sens de ses fulets, la plaçant, sinon pour le nomenclateur, du moins pour le naturaliste. Dans la classe de vrais granits 65. Et le parfait parallélisme de ces fulets avec les faces de grandes tables, au lieu de grandes divisions du rocher, démontre que ces tables sont de couches, et non de parties séparées par de fissures accidentelles. L'extrême régularité de ces tables achieve de démontrer que ces sont de véritables couches. Leurs plans que sont ici à découvert dans un hauteur perpendiculaire de plus de 500 pieds, sont parfaitement suaves, comme tales au ciseau, diriges tout comme l'aiguille aimantée et verticox. À quelques degrés près dont ils s'appuient contre le corps de la montagne. On est sûr en montant que cette structure est celle de la montagne entière. On voit les profils d'une infinite de ces couches, on passe sur les sommets de ces tranches verticales, et on les voit se prolonger dans cette même direction tout au travers de la montagne. Or je demande si un naturaliste que aura observe cet ensemble et ces détails pour regarder cette montagne comme le produit du concours fortuit de grains de sable agglutines entre eux. Ces tables sont copiées un peu obliquement à leurs plans par défense dont la plupart sont à peu près horizontales et d'autres très inclines à l'horizon. La pierre se trouve ainsi très fréquemment copiée en parallélépipèdes obliquangles. Ces mêmes fences rendent raison, d'une observation que j'avais faite en 1776. En examinant avec un bon lunette, depuis une fenêtre du prieur, les faces verticales de couches de la sommet du brevin, j'avais remarqué un grand dis bien nettement écrit sur la face de la montagne, j'ai le vis de près en 1781. Et j'ai reconnaissent qu'il était formé par quatre de ces fences que se coupoyent obliquement. Section 647. La cime de la montagne est un point mousse, copié à pic du côté de la vallée de Chamonix et arrondi de tous les autres côtés. Cette tête est entièrement couverte de débris et de blocs confusément en tasse. En estatant de trouver la ces débris, car set sim est absolument isolé, e séparé par de larges et profondes vallées de sommets que la surpassent en hauteur, il semble que ces débris n'aient pu tumeur que du ciel. Mais quand on les examine avec soin, on voit qu'ils sont du même genre de pierre que la montagne elle-même, et que tous leurs angles font vifs, leurs faces plaines et leurs formes souvent rhomboidales. On reconnaît donc par là que les parties supérieures de la montagne, que sont plus exposées aux injures de l'ret que n'y sont pas assujetties par de masses situées au-dessus d'elles, se dilatant et se séparant. Je travaille cependant sur la cime en pierre d'une espèce différente, c'est en roche composée de chorle noir en aiguilles, de quartz et de granats, se forme et exactement rhomboidale. Mais ce genre de pierre se rencontre assez souvent en filons dans les roches feuilletées et dans les granits veins. Il est donc vraisemblable que le filon auquel ce fragment avoid appartenu ss de trut avec la partie supérieure du rocher, du moins nnaij pu trouver aucun indice dans la partie solide de la montagne. L'admirable régularité de couches de cette cime élevée mérite l'attention des amateurs de la géologie, et la vue qu'elle présente dédommagera sol de la peine d'y monter. Section 648. Mon but principal dans la première course que j'ai fis au brevet était de prendre de la une idée juste des glaciers de la vallée de Chamonix, de leur forme, de leur position, et de l'ensemble de montagnes sur lesquelles ils sont situés. Comme cette montagne est postée peu près au milieu de la vallée de Chamonix, en face du Mont Blanc et vis-à-vis de principaux glaciers que en descendant. C'est était certainement un de meilleurs observatoires que l'on put choisir dans cette intention. J'ai monté par le jour le plus beau et le plus clair, c'était mon premier voyage dans les Hautes Alpes, j'ai n'étais point encore accoutumé à ces grands spectacles. En sorte que cette vue fit sur moi une impression que n'y s'effacera jamais de mon souvenir. On découvre tout à la fois et presque dans un seul tableau les 6 glaciers que vont se verser dans la vallée de Chamonix, les cimes inaccessibles entre lesquelles ils prennent leur naissance. Le Mont Blanc surtout, que l'on trouve d'autant plus grand, d'autant plus majestueux, qu'on l'observe d'un lieu plus élevé. On voit ces étendues immenses de neige et de glaces, dont, malgré leur distance, on a peine à soutenir l'éclat, ces beaux glaciers que s'en détachent comme autant de fleuves solides que vont entrer de grandes forêts de sapins. Descendre en replis tortueux, et verser au fond de la vallée de Chamonix. Les yeux fatigues de l'éclat de ces neige et de ces glaces se reposent délicieusement au sur ces forêts, dont le verde fond contraste avec la blancheur de glaces que les traversent. Au dans la fertilité riante vallée chuerescent les eaux que découlent de ces glaciers. Our object at present is not to see the degradation of that great mass of granite out of which have been hewn, by the hand of time and influences of the atmosphere, these lofty pyramids which surround Mont Blanc. It is to see the degradation of that immense mass of vertical or highly inclined strata, out of which that great mass of granite rises. And it is to understand the conical and rounded forms which are to be perceived more or less in all the inferior mountains, where apparently the degradation has come to a stand, and where the surface is actually employed in vegetation, or in maintaining the system of living bodies in this world. How high those vertical strata may have been erected, or how much may have been wasted of that mass in forming the mountains and their valleys, is a question which it is impossible to resolve. It is evident, however, that this quantity must have been very great. In the Mont Rosa we find those strata at present in the horizontal situation, as high as the summits of those granite pyramids that overlook the mass of vertical strata which we are now considering. And, in those mountains of Rosa, the valleys are most profound. It is therefore most reasonable to suppose, that the mass out of which the Brevin and all the other mountains had been formed, was once as high, at least, as the summit of Mont Blanc. It is altogether inconceivable, that this mass of vertical and horizontal strata could have been formed, either originally, or by any mineral operation, into the present shape of things, therefore, we must look out for another cause. Let us now suppose them degraded by the hand of time, and all their movable materials transported in the floods. In what state would they be left for our examination? Here is a question that must decide the theory of those mountains. For, if it is not possible to conceive the present appearances as arising from any other cause than this gradual degradation which we see operating at present, we must conclude that this is the system of nature established for the purpose of this world. But this is the very state in which they are found, everywhere the solid parts are going into decay, and furnishing those heaps of earth and stones that form the slopes by which we ascend from step to step. Wherever earth and stones may lie, there they are found to form a bank for vegetation. Whenever these loose materials are carried away to a lower station, the more solid parts above are still decaying in order to furnish more. There is not one step in all this progress, of the summit of the solid mountain forming earth and stones, and traveling to the sea, that is not to be actually perceived, although it is only scientifically that man, who reasons in the present moment, may see the effect of time which has no end. The summit of the granite pyramids of Mont Blanc, the summit of the Brevin, that of the Salève 66, and of every little hillock upon the surface of the earth, attest this truth, that there is no other natural means by which this end may be attained. It is true, indeed, that geologists everywhere imagine to themselves great events, or powerful causes, by which these changes of the earth should be brought about in a short space of time, but they are under a double deception. First, with regard to time which is limited, whereas they want to explain appearances by a cause acting in a limited time. Secondly, with regard to operation, their supposition of a great debacle is altogether incompetent for the end required. How, for example, accumulate the debris of the Brevin, as we have now seen, upon the summit of that mountain, by the force of running water? But this is only one of 1,000 appearances that proves the operations of time, and refutes the hypothesis of violent causes. From the top of those decaying pyramids to the sea, we have a chain of facts which clearly demonstrate this proposition, that the materials of the wasted mountains have traveled through the rivers. For, in every step of this progress, we may see the effect, and thus acknowledge the proper cause. We may often even be witness to the action. But it is only a small part of the whole progress that we may thus perceive, nevertheless it is equally satisfactory as if we saw the whole. For, throughout the whole of this long course, we may see some part of the mountain moving some part of the way. What more can we require? Nothing but time. It is not any part of the process that will be disputed. But, after allowing all the parts, the whole will be denied, and, for what? Only because we are not disposed to allow that quantity of time which the ablution of so much wasted mountain might require. Chapter 10. The theory illustrated with a view of the valleys of the Alps. Such is the summit of the Alps, a body wasting by the influence of the elements, slowly changing, but in actual decay. This mass of granite is arrived at such a perfect state of degradation as leaves no trace of its original shape or height, from whence we might compute the quantity which has been lost, or time which had flowed in bringing about that event. We are now to take a view of the valleys that are formed at the same time that the mountains are degraded. To the valleys of ice succeed those formed by water upon the same principle by moving the hard materials procured from the summits. Let us now begin at the bottom of one of those fertile valleys, and ascend, tracing the marks of time and labor in those operations by which the surface of the earth is modified according to the system of the globe. M. Buet 67, Nouvelle Description des Alpes. Saint-Maurice est entre le Rhône et une montagne. Quoique la situation de Saint-Maurice paroisse l'exposer au malheur d'être un jour in Thevalleys sous les ruines de montagnes, cependant on n'invite pas ici avec moins de sécurité tuilers, ce tuil et de plus à craindre. C'est la submersion du pays. Ce malheur pourrait arriver si l'un ou l'autre de montagnes que forment la gorge, venoit à tumor soit par un tremblement de terre, soit par de effacements considerables, cette gorge étant étroite. Le Rhône n'y pourrait plus s'écouler il s'étendrait nécessairement au large, bientôt toute la vallée jusqu'aux Martigny, chaun mime, rentreroit sous les eaux que l'ont autrefois couvert, e tout ce pays any formeroit plus chuan lac. Au moins que le ron nese fit jour sous les rochers renverses, comme il passé au travers de ce que semblant lui disputer le passage à Saint-Cloud Odesses de Genève. Avant de pénétrer dans le Valais Illinois convient den donner une idée générale, il formi cette partie de Alpes connue sous le nom d'Alpes Pennines. Il contient non seulement les plus hautes montagnes de Alpes, mais encore la plus longue vallée que il y en Europe, puisqu'elle a 34 lieues depuis Saint-Maurice jusqu'à la source du Rhône. Que la traverse dans tout cet étendu, sa largeur est depuis demi-lieue jusqu'à un lieu de mai. Sa direction sous le soleil. Outre cette vallée Illinois y en a d'autres que y viennent aboutir dans diverses directions, celles-ci sont enclaves dans les deux chaînes de montagnes que bordent la grande vallée. Quelques-uns remontent à 4 lieues et même à 6, dans les sinuosités que forment les rochers que bordent les deux côtés du fleuve. To give an idea of these valleys which proceed to the icy tops of mountains, or to the high valleys of ice, I shall transcribe some descriptions of this country from the Tableaux de la Suisse Discours, etc. page 21. Route au Mont Saint-Bernard. On passe par Martigny pour aller au Mont du Grand Saint-Bernard, cette ville est un dépôt pour les marchandises que vont et viennent d'Italie. Le château à côté de cette ville est situé sur de rochers calcaires que bordent la Drance dans cette partie, ce torrent prend sa source au Mont Saint-Bernard. On compte 8 lieues de Martigny à El Hospice situé sur ce mont. À un demi-lieue on commence à monter insensiblement, le chemin est beau et peut se faire en voiture jusqu'au bourg Saint-Pierre. Le vaste base de ces monts accumules n'est qu'un composé de débris de montagnes supérieures. On rencontre ici de granites rouges, composés de quartz, de feldspath, et de mica. De gravures et de sables provenant de la décomposition de granites de pierre calcaire grise, poussent de grosses masses de granit arrondies, dont il serait difficile d'assigner l'origine. Puisque toutes les montagnes à portée de la vue étique formi cette gorge sont absolument de pierres micaces par lits et par couches, au schisteuses mêlées de gros et petits rognons, de filons et de veins de quartz. Elles font en général toutes feu avec le briquet. Le chemin de la Drance qu'on passe et repasse plusieurs fois, occupant tout le fond de la vallée que devient fort étroite. On rencontre de pierres schisteuses, quartzieuses et sabloneuses, sols sans mélange d'autres espèces. Saint-Branchier, bon village, est situé entre de montagnes très hautes et très escarpées composées de mêmes espèces de pierres schisteuses micaces que les précédentes. Elles sont de couleur bleuâtre, vues en grandes masses et inclines à l'horizon. Cette inclinaison suivant la même direction de ce côté ci de la Drance, et les couches se correspondent l'un à l'autre, on voit que ce torrent est creuse un passage. En avancant, on trouve de l'ardoise feuilletée bleuie avec de veins de spath calcaire, en sud une grande quantité de granites et de pierres calcaires rouges, sans que les montagnes environnantes changent d'espèces. Les montagnes à l'est sont bien cultivées, reportant différentes sortes de grains, avant et après avoir passé Orsières, on retrouve de l'ardoise entre ces villages et l'ide et les derniers granites rouges. La Drance est ici fort resserrée et très encaissée. Ce n'est pas sans frémir qu'on s'approche, quand on est sur deux morceaux de bois jetés d'une roche à l'autre, appels ici pont, qu'on a un gouffre de plus de 300 pieds au-dessus de soi. Il faut être sur cette espèce de pont pour s'en apercevoir et distinguer les différentes sinuosités tracées sur chaque côté de cette roche du haut jusqu'au bas. Ce sont autant de preuves de différentes hauteurs au lot à passer avant de parvenir à sa profondeur actuelle. La dernier village qu'on rencontre, avant d'arriver au Saint-Bernard, est le bourg Saint-Pierre, on monte insensiblement jusqu'à ce village, et on n'y peut plus se servir de voiture pour aller au-delà. Les montagnes sont plus rapides, Illinois ny a plus de chemin fait, ion nn put point pratiquer, moins à cause de la quantité de rochers dont tout cette partie est couverte que par la difficult de les entretenir au lieu de les renouveler chaque année. Parce que les torrents et les avalanches les détruiront. De plus on n'y pourrait y travailler que 3 au 4 mois de l'année, les huit au 9 autres mois le pays, au-delà du bourg, étant presque toujours couvert de neige. La truite n'y remonte pas au-delà du bourg Saint-Pierre, LSE trouvé arrêté par les cascades et chutes trop considérables de la vasserie que VASE jeter dans la Drance. Ce torrent sort en case de recer dans le lit chuil est cruz, provient d'un glacier qu'on rencontre en montant le Saint-Bernard que porte le même nom. L'entrée du Valais est fermée et défendue de ce côté par le lit de la vasserie. C'est le fosse le plus profond et le plus escarpé qui existe. Des ouvrages créneaux et en port sont places à l'entrée du bourg Saint-Pierre, nous avons dans un dessin de la chute de ce torrent, on voit le travail de os dans le rocher chuil a mine et au ils est ouvert un passage. On compte 3 luz de ce bourg à el hospice, sur le haut du Saint-Bernard, c'est le passage le plus fréquent pour communiquer du Bas-Valais en Italie par le Piémont et la vallée d'Aoste. Le transport de marchandises n'est fait tuer dos de mulettes et de chevaux, c'est du produit de ces transports que vivent la plupart des habitants que sont de deux côtés de ces monts. Celui de fromages, que est la principale production de ces hautes Alpes, fait le plus fort article. On any rencontre sur cette route que de rochers entassés les uns sur les autres, entre les quels on passe par 1000 détours, en suivant les petits vallons chuils forment. Des torrents de eaux y roulant et des y précipitant de tous côtés. On voit dans CESBAS, de bois de sapins mêlés de quelques pins et pousses de mélèzes. Ils diminuent insensiblement, leurs végétation est moins vigoureuse, les arbres sont plus rares les derniers qu'on rencontre sont de mélèzes à 1 heure de Saint-Pierre. Plus loin, on en voit plus que de buissons bas et rebougris. Au bord de quelques ruisseaux au torrent ce sont de 11 au verns, le dernier arbreau que nous avons vu, entre les mélèzes et les almes, est un sereau sans fruit. Les pâturages, l'herbe et le gazon suivant la même progression. Ce n'est que dans quelques endroits, les os en pas entrain en restant de terre végétale, chuils voit un gazon fin, menu et serra. De petites fleurs, aussi basses que ces gazons, nuances de plus belles et de plus vives couleurs, y forment de groupes de la plus grande beauté, de mousses non moins curieuses que variées, couvrant et colorant quelques parties de rochers. Le reste en offre à l'œil que d'énormes masses de rochers, entrecoupes de fentes, de crevasses, de pierres culbutées et amoncelées dans les fonds, que font en partie couvertes de neige. Et un demi le de el hospice dans un vallon assez large pour un peril hauteur, nommé les envers de foireuse, on rencontre une énorme quantité de pierres rouges que remplissent presque tout le haut de ces vallons. Cet amas de pierres provient de glaciers et de hauteurs que descendent du mont Vilain, que est la partie la plus élevée du groupe de montagnes, que forment le Grand Saint-Bernard. La sont de neige et de glaciers de cette partie, fournit aussi la Drance que VASE jeter dans le Rhône desses de Martigny. On y voit de ces pierres rouges chuen cet endroit, elles viennent directement de glaciers, elles ont été cherries par les eaux que en viennent, et n'y peuvent avoir pris leur forme que par les mêmes causes. Dont nous avons parlé ci-devant dans l'observation faite en Savoie sur les pierres rouges. Elles sont toutes, ainsi que les rochers odesses, d'où elles proviennent, composées de parties micaces argillacees, plus au moins mêlées de parties de rognons, de veins et de filons de quartz, par lits et par couches irrégulières. Plus au moins épaisses. Les parties micaces de ces pierres sont variées de différentes nuances, tirant sur le gris, le bleu, le vert, et le John, ces nuances sont quelquefois mêlées. Tous les rochers composant ce côté de montagne tourne au nord, sont de la même espèce. Nous n'avons pas vu un seul granit, c'est-à-dire, un pierre composée de petites masses irrégulières de quartz, mêlées et agglutinées, avec de parties micaces argillacees, et quelquefois mélanges de feldspath. Parmi ces pierres Illinois y en a quelques-uns provenant du même filon, que contenant de la pyrite cuivreuse dans un filon de quartz. Nous avons dit précédemment que ce toit entre orfure et lid de que nous avions vu de derniers granits roules, en rencontre plus dans tout le reste de la route jusqu'au haut du mont Saint-Bernard. Les rochers, que dominant ce sommet, ne sont pas composés de granits, et quoiqu'on ne puisse aborder jusqu'à leurs plus grandes élévations, on peut juger de leurs espèces, par les masses que s'en précipitent. Page 35. Malgré la chaleur qu'elle avait fait le jour de l'arrivée au Saint-Bernard, la nuit fut froide. Le lendemain, 31 juillet, le haut de la montagne était enveloppé de nuages épais, mais tranquilles, Illinois n'y avait point d'agitation dans l'air en assurant qu'elle faisait beau au-dessus de ce sommet. Nous fûmes visiter le revers méridional de la montagne que conduit au Val d'Aoste. Après un demi-heure de marche, nous fûmes hors de cette atmosphère sombre et humide, le soleil était chaud. Le ciel pur était serein, on voyait dans le lointain les sommets de plus hautes montagnes enveloppés dans les nuages comme le Saint-Bernard, les sommets les plus à portée toyant découverts et éclairs par le soleil. Ces rochers termines en point, en pyramides et en aiguilles, semblant à se lancer dans la région pure de l'éther, de vallons profondes, de écules, et de précipices effrayants les entourant. Toutes ces masses sont, comme dans la partie opposée de la montagne, de pierres schisteuses, argillacees et micaces, la plupart schisteuses, c'est-à-dire par fiolets, par lits ou par couches différemment inclines. Le tout mêlé de veines et de parties quartzieuses, de couleurs variées, mais les vertideurs dominantes, et de plus sur la hauteur de ces revers de masses et de blocs prodigieux, sans mélange, de quartz blanc et de grenu, à sa superficie, les squales. Au premier coup d'œil, paroissent être de marbre de Carrare. À quelque distance c'est un chaos immense de blocs de pierres de toutes grandeurs, jetés, culbutes, entassés dans la plus grande confusion, c'est la même espèce de pierre micacees. Il faut que de sommets, de rochers prodigieux et soyant écrolés pour avoir produit un pareil désordre que ressemble à la destruction d'un monde. Page 40. On trouve aux environs du couvent quelques schists argilliques ou ardoises grises feuilletées détruites à moitié. On n'y voit nulle part de ces ardoises sur pied ou formant de masses attachées au sol. Il faut que les couches ou les lits de ces ardoises, que voyant été formes et places sur ces hauts, ayant été détruites et renversées par le temps. Enfin toute cette montagne, un de plus hautes de Alpes ponines, que conserve de neige et de glaces permanentes, est composée en général de pierres et de roches schisteuses. Dont les couches et les lits sont plus en moins sensibles et inclines, et d'une grande durite. Leurs parties constituants sont un mica argilliques dont les lames ou les parties sont plus ou moins grandes et brillantes et diversement colores. Elles sont traversées de filons et de veines mêlées de rognons et de globules de quartz ordinairement blancs. Quelquefois vitreux, transparent, opaque ou grenu, nous n'y avons vu de granits que sur le penchant de la montagne. Ils y toyant isoles et roules. Quelqu'un que aura plus de temps, plus de loisirs, découvre peut-être d'où ces masses proviennent 68. We have here a picture of one of those valleys which branch from, or join the main valley of the Rhône. In this subordinate valley, there is the most evident marks of the operations of water hollowing out its way, in flowing from the summits of the mountains, and carrying the fragments of rocks and stones along the shelving surface of the earth. Thus wearing down that surface, and excavating the solid rock. On the summit of the mountain, again, there is an equal proof of the operation of water and the influences of the atmosphere continued during a long succession of ages. It is impossible perhaps to conjecture as to the quantity of rock which has been wasted and carried away by water from this alpine region. The summits testify that a great deal had been above them, as that which remains has every mark of being the relics of what had been removed, and moved only by those operations which here are natural to the surface of the earth. Let us now abstract any consideration of that quantity above the summits of those mountains, as a quantity which cannot be estimated. And let us only consider all the cavity below the summits of those ridges of mountains to have been hollowed out by those operations of running water which we now have in view. In taking this view of the mountains on each side which supply the water of the Rhône, what an immense quantity of stones, of sand, and fragments of rock, must have travelled in the bed of that river, or bottom of that valley which receives the torrents coming from the mountains. The excavation of this great valley, therefore, will not be found any way disproportionate to that which is more evident in the branches. And, though the experience of man goes for nothing in this progress of things, yet, having principles in matter of fact from whence he may reason back into the boundless mass of time already elapsed, it is impossible that he can be deceived in concluding that here is the general operation of nature wasting and wearing the surface of the earth for the purposes of this world, and giving the present shape of things, which we so much admire in the contrast of mountains and plains, of hills and valleys, although we may not calculate with accuracy, or ascribe to each particular operation every individual appearance. With a view to corroborate what has been here alleged of the valley of the Rhône, I would beg leave to transcribe still more from the same author. From the immense masses of horizontal strata remaining upon both sides of the valley of the Rhône, with a face broken off abruptly, we shall find the most perfect evidence of that which had been carried away in the course of time, and in the forming of those valleys. Page 49. Route aux bains de l'Oise. Nous quitterons un moment les bords du Rhône pour visiter les bains de l'Oise, afin de n'y pas revenir sur nos pas. De sier en passer par Claire et Salgi, en laissant le Rhône sur la droite. Tout ce terrain est calcaire et fort pierreux. A Ferran, villages que n'y font point sur les cartes, on commence à monter la montagne de Ferran, le chemin est fort rapide et mauvais, et dur un bon or et demi. On trouve sur le haut de cette montagne de blocs de granit composés de quartz, de feldspath, et de mica, d'où viennent ils. On any voit que de roches calcaires et point de montagne plus élevés au-dessus. On passe par un bois de pins, on parvient enfin à un escarpement à pic, dont on n point d pour la hauteur. On reste stupéfait de voir le gouffre coulant à devant soi, et on n'y prévoit pas trop comment on parviendra dans ce fond, ou la vue à peine à distinguer la dalle, gros torrent que y précipite ses. On attire à grands frais un sentir tortueux dans cette roche tout calcaire, on a eu soin de garnir le côte scabreux du sentir avec de pierres au lieu de garde faux, pour rendre ce passage moins effrayant. Ces précautions n'y peuvent courir de la crainte de voir tomber d'énormes quartiers de rochers suspendus au-dessus de soi, ils sont fendus et crevasses partout, et menaçantes et précipiteurs à chaque instant. On n'y put même s'empêcher de remarquer qu'il y en a que sont tombes nouvellement. Ce sont de mines tyroliennes que ont fait cet ouvrage, ainsi que le passage du Montgemi. Quand on est descendu aux tiers environ de cet énorme fond, on passe sur les décombres de cette vaste montagne, et par un bois de pins et de sapins. La vue n'y perce pas dans ce fond ténébreux, on entend plutôt le bruit du torrent coulant n'y l'apercoit. Ayant eu occasion de voir et d'examiner par la suite CESBAS et le pied de cette étonnante montagne calcaire, nous avons vu dans plus d'un endroit où pose. Et que ces fondements sont un lit de schistes argiliques au d'ardoises feuilletées sans mélange, que ce lit est détruit et détruit dans différents endroits, où il est incline et affaissé dans d'autres. Et que c'est la destruction que occasionne la chute d'une partie de cette montagne. Elle est partout à pic de ce côté, idia subi successivement ces renversements caperoisant plus anciens les uns que les autres, car ces debris sont plus ou moins couverts de bois, d'arbres, et de productions végétales. On continue la route à mi-côte au travers de ces debris. Le sommet de ces montagnes éclairés par le soleil, étoit peint de rouge, de jaune, de blanc, de bleu, et de noir, dans les endroits où les eaux avoyant col pardessus, ils ressemblant de loin à de murailles, de tours, de forts. Et de fortifications de différentes formes places pour se défendre contre de ennemis que viendroient par les airs. Les neiges coulent apricoit dans différents endroits, produisant de chutes d'eau, de cascades, dont partie se réduit en vapeurs avant d'atteindre le bas, le haut de montagnes coulent voit de l'autre côté de ces vallons, est également calcaire. Elles sont plus basses, couvertes d'arbres et de sapins. Au lieu que celles dont il est question sont nus et arêtes, elles sont le séjour de neige et sont partie de la gemie. Un de plus hautes montagnes du Valais, et située sur un terrain très élève, est la gemie. Elle fait partie de la grande chaîne que sépare le canton de Berne du Valais. Elle est remarquable, cause de l'importance du chemin coulant y pratique, de grandes difficultés il a fallu surmonter, et elle est la seule communication entre les deux cantons. Nous parlerons de ce chemin, après avoir décrit la nature de ce prodigieux rocher. La gemie est la partie la plus haute de cette chaîne que commence aux galeries, elle est en général calcaire. On commence à monter insensiblement en sortant de l'oche, on traverse beaucoup de potages, on voit quelques champs de seigle que étoyent encore sur pied et à moitié verts, de bosquets et de petits bois de sapins. Des masses considerables de rochers, de monceaux de pierres entassées descendues de hauteurs. Couvrant cette superficie que devient d'autant plus rapide qu'on approche plus du pied du rocher, cette pente que est au pied de l'escarpement et de toutes les autres montagnes. Est forme de pierres et de sables que tombent de hautes et produisant, all along, de tales formes en pain de sucre, adossées contre les parties escarpées. Les plus grosses pierres roulant ETSE précipitant plus BAS, servant de point d'appui aux nouveaux matériaux que SY irritant, augmentant la hauteur de talus, en élargissant les bases. Et finissant par devenir de montagnes très considérables que ont augment en raison de la quantité de débris qu'ont pu fournir les parties plus élevées. CCE qu'on nomme montagnes de troisième formation, composées de ruines de celles que dominant CES talus. CES éboulements sont ordinairement plus fertiles, plus couverts de végétaux, d'arbres et de forêts, surtout SALS sont composées de différentes espèces de débris. Nous avons déjà vu que les montagnes calcaires sont elles-mêmes assises sur de couches et de lits d'ardoise au lieu de schiste, que, par l'arrangement de leurs fuelets et de leurs couches, paroissent aussi avoir été arrangés et formes successivement. Quelle est donc la base primitive sur laquelle sont appuyées et reposent ces masses que étonnent l'imagination, à quelle profondeur faudrait-il leur chercher? Si nous concevons la formation et la manière dont elles sont accrues et élevées ces troisièmes montagnes, pouvons-nous imaginer comment elles sont arrangées celles que sont assez élevées au-dessus d'elles, ces tout que règne en domini. C'est en examinant en considerant ces grands spectacles que ces réflexions nous viennent, nous arrêtons, pour continuer à décrire ce que nous avons vu et remarque, que est la tâche que nous sommes imposés. En arrivant au pied de l'escarpement, le premier objet que frappe la vue, sont de banks de schistes au d'ardoises bleues, mêlées de larges filons de quartz que forment la base. Et les fondements sur lesquels est élève murs de pierres calcaires. Car cette roche est élevée de même à pic, lit d'ardoises est un peu incline vers le couchant, ainsi que tout que repose dessus. La destruction de lit a cause, ainsi aux galeries, la chute de rochers supérieurs, et de leur occasion cet aplomb. Avant ces éboulements, ces couches schistieuses devoyant être découvertes à une grande hauteur, être exposées aux ingérs du temps et de saisons, se détruire et se décomposer plus aisément. Peut être que l'enveloppe calcaire les couvroyant entièrement, et que ces schistes anointés commencent à se détruire tout après la ruine de la pierre calcaire. Actuellement ces schistes sont entiers et couverts. Ce n'est qu'un peu d'endroits qu'on les apercoit. Appui satinas et couverts par ces immenses débris en talus, ces sont de contreforts que les aiderons à supporter plus longtemps les prodigieuses masses sous lesquelles ces schistes sont ensevelis. Nous allons placer par ordre les différentes substances, telles qu'elles y presentent en montant. 1. Base de schiste ou d'ardoise feuilletée bleuter, traverse, de larges filons de quartz. En any voit, en any peut estimer son épaisseur donc partie est enterée. 2. Immédiatement dessus pose la pierre calcaire, elle est d'une grain fin, serra, couleur grise jaunâtre, ainsi que tout le reste. 3. Des filons de différentes épaisseurs, d'un spath calcaire jaunâtre. 4. Quelques petits filons ou granules de schiste per. 5. De la pierre calcaire d'un grain plus grossier. 6. Daughters couches d'un grain plus fin. 7. Couches de pierres calcaires mêlées d'une quantité suffisante de sable pour faire feu avec le briquet, sans cesser de faire effervescence avec les acides. 8. De petits filons ou couches ondoyantes de spath. 9. De la pierre calcaire dans laquelle sont déposées de species de noyaux oblongs, quelquefois par couches, mais sans suite, composées d'un sable fin de couleurs grisâtres, plus blanc que la pierre calcaire, très durs, faisant feu au briquet. Et sans effervescence avec les acides. 10. On retrouve encore de couches minces sabloneuses mêlées de parties calcaires. 11. Daughters de pierre calcaire compacte et d'une épaisseur considerable. 12. Alternativement de moins compacts. Dans l'un de ces couches il et de la pyrite vitriolique décompose, que teint en jaune les parties du rocher sur lesquelles afflue la décomposition martiale. 13. Quelques filons de spath jaunâtre, entremêlés de veins de schiste per, any faisant pas effervescence. 14. De la pierre calcaire. 15. Des schistes mêlés de parties calcaires. 16. De la pierre calcaire pure. 17. De larges filons de spath calcaire jaunâtre mêlés de quartz, faisant feu au briquet, et un peu d'effervescence. 18. De la pierre calcaire pure grise, plus foncée que dans le bas. 19. Des couches calcaires jaunâtres. 20. Enfin tout le haut n'est que pierre calcaire grise et dénaturée. Cette partie supérieure du monte est fort étendue. Tout ce que est sur le local que vient en pentéases d'aus vers le milieu, n'est pas été assujetti à de roulis et à de frottements Illinois ny à que la longueur du temps que elle dégrade, et lui est imprime le caractère de la vétuste. En any voit que de pierres calcaires, elles sont remplies de trous, de fentes, et de crevasses, beaucoup, paroissent pour uses comme de la pierre ponce grossière, le séjour de neige de eaux, la gelée, et l'intempérie de saisons à tout fait. On voit de tous côtés que l'eau sy infiltre et sy perd. L'arrangement de cette espèce de pierre par couches, facilite l'entrée de eaux dans l'intérieur de la montagne pour leur donner naissance à de sources, à de torrents. Et quelquefois à dieses fortes rivières que sortent du pied de ces montagnes calcaires. Lors de la fonte de neige, l'ONE vers point de sommets de ces sortes de montagnes comme de dessus les autres espèces de rochers que absorbent moins les eaux. Dans le milieu de ces hautes îles y a un petit lac d'un grand court de l'eau de long de Fermio-Valley, OUSE ressemblant les eaux de neige fondues, ILNY à point d'issues à ces lacs, SCSOs sont absorbés, ESE perdent dans l'intérieur de la montagne. Il ny avoit que peu de glace alors sur ce lac, mais il y avoit encore beaucoup de neige aux environs, un glacier est sur la droite, se prolonge et va fermer le sommet du vallon ouest loich. C'est le même glacier qu'on apercoit derrière les sources chaudes. Du aiguilles de rocher en cône, fort hautes es élevant au-dessus du sommet. Elles sont toujours couvertes de neige, leur ressemblance et leur proximité donne le nom de Gemi Jumeaux, à cette montagne, on voit à ses pieds à une profondeur immense le village de Loich, que pourrait être tout au pied du rocher. Il faut cependant un grand et demi pour sy rendre, tant la hauteur diminue le point de perspective. Le chemin que est pratique dans ces rochers, y a été partout taille. Il le contourne certains endroits, dans d'autres il est creuse de faken chu il fermi un voûte couverte, et qu'on a le rocher suspendu au-dessus de soi. Il est rare de trouver l'occasion de pouvoir examiner de détails avec autant de facilité un montagne d'une pareille hauteur. A contour de galeries jusqu'aux glaciers de la Gemi, ces rochers perpendiculaires et à pic ont plus de trois luz d'étendue. Ils diminuent en hauteur à mesure que le pays s'élève, et se confond dans les plus hautes Alpes, que sont surmontés d'autres masses de rochers. De l'autre côté du vallon, et vis-à-vis de montagnes que forment celles de la Gemi, est la montagne du Midi, séparée par la Dala, torrent que vient du glacier à la tête du vallon, dont les eaux paroissent avoir creusé le lit étroit et profond. Cette montagne est calcaire comme la Gemi, et pourrait en avoir fait partie, gnaipu vérifier nulle part sil étoit posé sur de schistes, tout est dans un grand bouleversement sur sa pente que est fort rapide. Et environs 3/4 de l'eau de bains, un sentier fort difficile, que passe sur les décombres de cette montagne et dans de bois de sapins fort obscurs, conduit par un pente fort rapide à un rocher perpendiculaire. Comme sont presque tous ceux du canton on y trouver de échelles appuyées contre. On parvient à la première, en grimpant par les avances et les salies du rocher, d'autres roches facilitant le moyen d'arriver à la seconde. On trouve ainsi sept échelles dont quelques-unes sont fort hautes, et par lesquelles on se guide au sommet de ces rochers. On est bien surpris d'y trouver un terrain en pente, OILYA de champs labours et de vignes que entourent le village d'Albinian, dont les habitants ont placé ces échelles pour raccourcir le chemin que conduit à Loich. OILS vont vendre leurs denrées. Nous quittons les bains de Loich pour nous rapprocher du Rhône, on repasse par Indon, on y trouve un soute quai de pierres, de rochers, de escarpements, c'est un chemin de plus mauvais jusqu'au bord de Loich. C'est pour éviter ce chemin qu'on a fait celui de galeries. Le bourg de Luc, au Loich, est un de principaux endroits du Valais, bâti en pierres, dans une position fort élevée et très forte. L'art avoit encore ajout anciennement à la force de son assiette Illinois y a encore d'anciens forts et de tours, tout cette hauteur est calcaire, on a la plus belle vue de ce lieu, elle s'étend sur tout le bas Valais jusqu'au delà de Martigny. Nous avons dans une foible idée de cette vue, avant d'arriver aux bains de Loich, car les expressions manquent pour rendre ces grands tableaux. Un spectacle bien intéressant pour ceux qui étudient les changements que arrivent journellement à la surface du globe, est la vue du Colbech, montagne fort élevée en face du bord de Luc, et de l'autre côté du Rhône. Cette montagne est calcaire ainsi que la chaîne sur la rive gauche du Rhône, du moins la partie avancée que forme le vallon au col ce fleuve. Des chutes, de éboulements y ont produit de grands changements. Les eaux et les torrents que viennent de parties élevées, ont entraîné ces débris, les ont déposés aux pieds de la montagne, et ont forme un colline que a plus d'une demi-le jusqu'au Rhône, et plus d'une grande le de large. En forme circulaire. Elle s'étend vers le haut et le bas Valais, la partie supérieure est couverte de prés et de poteriches, celle du côté du bas valais est couvert d'une forêt, lva en pente d'aus. La grosseur de arbres prouve combien la formation de ce terrain est ancienne. Depuis la consolidation de ce terrain de torrents nouveaux yont creux un ravin large et profond, par l'équal s'éclatent actuellement les eaux de montagnes, et les pierres qu'elles en arrachent. Le Rhône mine et importe le pied de cette colline que resseroit son cours, avec ces matériaux ilva plus loin former de adorisments composés de matters les plus pesantes. Les parties les plus fines le limon suspendu dans ces eaux servant en soute à couvrir les anciens adorisments, au moyen desquels ils deviennent susceptibles de toute espèce de végétation. Ces eaux finissent de s'épurer dans le lac Léman, d'où sort clair et limpide, ainsi que toutes les rivières que sortent de lacs jusqu'au ce que d'autres torrents, tombant de montagnes, viennent les troubler de nouveau. Here is a most satisfactory view of the structure of this country on each side of the Rhône. Strata of limestone and schiste, almost horizontal or little inclined, compose the mountains from their most lofty summits to the deepest bottom of those valleys. Such mountains cannot have been formed in any other manner than by the waste and degradation of their horizontal strata. Consequently, here we are certain, that, from the summit of the Gemmi to those upon the other side of the Rhône, all the solid substance had been hollowed out by water. Thus were formed the valleys of the Rhône, the Dala, and a multitude of others. M. Dissolution has given us a description of a tract of alpine country of the same kind with that of the Valleys now considered, so far as the strata are here in a horizontal position. Instead of that highly inclined situation in which those primary bodies are commonly found. It is the description of Mount Rosa Journal de Physique, Juillet 1790. Here the same interesting observation may be made with regard to the immense destruction which must necessarily have taken place, in the elevated mass of solid earth, by the dissolving or wearing power of running water. And this will be clearly explained by the formation of those mountains and valleys, which, while they correspond with mountains and valleys in general, have something particular that distinguishes them from most of the Alps, where the strata, being much inclined, give occasion to form ranges of peaks disposed in lines according to the directions of the inclined strata. Here on the contrary, there being no general inclination of the strata to direct the formation of the peaks, they are found without any such order. I shall give it in M. Dissolution's own words. En effect toutes les hautes sommets que j'avois observes jusqu'au ce jour sont ou isolées comme l'Etna, ou ranges sur de lignes droites comme le Mont Blanc et ses cimes collatérales. Mais la je vois le Mont Rose composé d'une suite non interrompue de pics gigantesques presque égaux entre eux, former un vaste circuit renfermé dans leur enceinte, le village de Macugnaga, ses hemos, ses poterets, les glaciers que les bordent. Et les pentes escarpées que s'élevent jusqu'aux cimes de ces majestueux colosses. Mais ce n'est pas seulement la singularité de cette famille que rend cette montagne remarquable, c'est peut-être plus encore sa structure. Je constate que le Mont Blanc et tous les hauts sommets de sa chaîne sont composés de couches verticales. Au Mont Rose jusqu'aux cimes les plus élevées, tout est horizontal ou incline au plus de 30 degrés. Enfin il se distingue encore par la matière dont il est construit. Il n'est point de granites en masse, comme le Mont Blanc et les hautes cimes que l'entourent. Ce sont de granites veins et de roches feuilletées de différents genres que constituent la masse entière de ces assemblages de montagnes, depuis bases jusqu'aux ses plus hautes cimes. Ce n'est pas que l'on n'y trouve du granit en masses, mais il est purement accidental, et sous la forme de rognons, de filons, ou de couches interposes entre celles de roches feuilletées. On any dira donc plus que les granites veins, le gneiss et les autres roches de ce genre, any sont que les débris de granites ressemblent et agglutinent au pied de hautes montagnes. Puisque voilà de roches de ce genre dont la hauteur égale à 3 peu près celle de cimes granitiques les plus hautes connues. Etou elon pharos bien embarrass à trouver la place de montagnes de granit dont les débris out pu leur serveur de matériaux. Surtout si l'on considère la masse énorme de l'ensemble de mers d'un cercle tel que celui du Montrose. En effet, ce serait une hypothèse inadmissible que de supposer, qu'anciennement il existe dans le void actuel du cercle une montagne de granit, et que ce cercle est le produit de débris de cette montagne. Car comment any restaurait-il aucun vestige de cette montagne? On concoit bien que sa tête aurait pu se détruire, mais son corps, la base du moins, protégé par les débris de sa tête accumules autour d'elle juste ce que aurait pu l'anéantir. D'alors les parois intérieures du cercle quoique très escarpées n'y sont pourtant pas verticales, elles s'avancent de tous côtés vers l'intérieur, et le fond, le milieu même du cercle n'est point du granit, Illinois est de la même nature que ses bords. Enfin nous avons reconnu que les montagnes que forment la couronne du Montrose se prolongent au dehors à de grandes distances en sorte que leur ensemble formait une masse incomparablement plus grande que celle que aurait rempli le vide intérieur du cercle. Il faut donc reconnaître, comme tous les phénomènes le démontrent d'alors, qu'il existe de montagnes de roches feuilletées, composées de mêmes éléments que le granit. Et que sont sorties comme lui de mains de la nature sans avoir commencé par être elles mêmes de granit 69. Here is an example the most interesting that can be imagined. Those mountains are the highest in Europe, and their lofty peaks are altogether inaccessible upon one side. They had all been formed of the same horizontal strata. How then have they become separated peaks? And how have the valleys been hollowed out of this immense mass of elevated country, no otherwise than as we may perceive it, upon every mountain, and after every flood? It is not often indeed, that, in those alpine regions, any considerable tract of country is to be found, where an example so convincing is exhibited. It is more common for those mountains of primary strata or schistus to rise up in ridges, which, though divided into great pyramids, may still be perceived as connected in the direction of their erected strata. These last, although affording the most satisfactory view of that mineral operation by which land, formed and consolidated at the bottom of the sea, had been elevated and displaced, are not so proper to inform us of the amazing waste of those extremely consolidated bodies, as are those where the strata have preserved their original horizontal portion. It is in this last case, that there are data remaining for calculating the minimum of the waste that must have been made of those mountains, by the regular and long-continued operations of the atmospheric elements upon the surface of this earth. It is the singularity of these horizontal strata in that extensive alpine mass, which seems to have engaged M. de Saussure, who has inspected so much of those instructive countries, to make a tour around those mountains, and to give us a particular description of this interesting place. Now, from this description, it is evident, that there is an immense mass of primary or alpine strata nearly in the horizontal position, which is common to all the strata at their original formation. That this horizontal mass had been raised into the highest place of land upon this globe. And that, in this high situation, it has suffered the greatest degradation, in being wasted by the hand of time, or operations of the elements employed in forming soil for plants, and procuring fertility for the use of animals. Here is nothing but a truth that may almost everywhere be perceived. But here that important truth is to be perceived on so great a scale, as to enable us to enlarge our ideas with regard to the natural operations of this earth, and to overcome those prejudices which contracted views of nature and magnified opinions of the experience of man may have begotten, prejudices that are apt to make us shut our eyes against the cleared light of reason. Abundant more examples of this kind, were it necessary, might be given, both from this very good observator, and from M. de Luc 70. I will now only mention one from this last author, which we find in the Journal de Physique, June 1792. Entre Frankfurt et Hanau, le main est bord sur ses deux rives, de collines dans lesquelles la lave s'est trouvée enchâssée entre de couches calcaires. Ces couches sont très remarquables par leur contenu, que est le même audaces idiodeces de la lave, et qu'on retrouve dans les couches d'une grande étendue de pays, ou, comme d'ordinaire. On voit leurs sections abrupts dans les flancs de collines, mais sans lave, except dans le lieu indique. The particular structure of those limestone strata, with the body of basalts or subterraneous lava which is interposed among them, shows evidently the former connection of those two banks of the river, by solid matter. The same as that which we see left there, and in the flanks of those hills. That which is wanting, therefore, of those stratified masses, in that great extent of country, marks out to us the minimum of what has been lost, in having been worn by the attrition of travelled materials. I would now beg leave, for a moment, to transport my reader to the other side of the Atlantic, in order to perceive if the same system of rivers wearing mountains is to be found in that new world, as we have found it in the old. Of all the mountains upon the earth, so far as we are informed by our maps, none seem to be so regularly disposed as are the ridges of the Virginian mountains. There is in that country a rectilinear continuity of mountains, and a parallelism among the ridges, nowhere else to be observed, at least not in such a great degree. At neither end of those parallel ridges is there a direct conveyance for the waters to the sea. At the south end, the Allegheny Ridge runs across the other parallel ridges, and shuts up the passage of the water in that direction. On the north, again, the parallel ridges terminate in great irregularity. The water therefore, that is collected from the parallel valley, is gathered into two great rivers, which break through those ridges, no doubt at the most convenient places, forming two great gapes in the Blue Ridge. Which is the most easterly of those parallel ridges? Now, so far as mountains are in the original constitution of a country, the ridges of those mountains must have been a directing cause to the rivers. But so far as rivers, in their course from the higher to the lower country, move bodies with the force of their rolling waters, and wear away the solid strata of the earth, we must consider rivers as also forming mountains. At least as forming the valleys which are correlative in what is termed mountain. Nothing is more evident than the operation of those two causes in this mountainous country of Virginia. The original ridges of mountains, or indurated and elevated land, have directed the courses of the rivers, and the running of those rivers have modified the mountains from whence their origin is taken. I have often admired, in the map, that wonderful regularity with which those mountains are laid down, and I have much wished for a sight of that gap, through which the rivers, gathered in the long valleys of those mountains, break through the ridge and find a passage to the sea. A description of this gap we have by Mr. Jefferson, in his Notes on Virginia. The passage of the Potomac, through the Blue Ridge, is perhaps one of the most stupendous scenes in nature. You stand on a very high point of land. On your right comes up the Shenandoah, having ranged, along the foot of the mountains, 100 miles to seek a vent. On the left approaches the Potomac, in quest of a passage also. In the moment of their junction, they rush together against the mountain, rend it asunder, and pass off to the sea. The first glance of this scene hurries our senses into the opinion, that this earth had been erected in time. That the mountains were formed first, that the rivers began to flow afterwards, that in this place particularly they have been dammed up by the Blue Ridge of mountains, and have formed an ocean which filled the whole valley. That, continuing to rise, they have at length broken over this spot, and have torn the mountain down from its summit to its base. The piles of rock on each hand, but particularly on the Shenandoah, the evident marks of this disrupture and avulsion from their beds, by the most powerful agents of nature, corroborate the impression. But the distant finishing which nature has given to the picture is of a different character. It is a true contrast to the foreground. It is as placid and delightful as that is wild and tremendous. For the mountain being cloven asunder, she presents to your eye, through the cleft, a small catch of smooth blue horizon at an infinite distance in the plain country, inviting you, as it were, from the riot and tumult roaring around, to pass through the breach, and partake of the calm below. Here the eye ultimately composes itself, and that way too the road happens actually to lead. You cross the Potomac above the junction, pass along its side through the base of the mountain for 3 miles, its terrible precipices hanging in fragments over you, and within about 20 miles reach of Fredericktown, and the fine country around it. This scene is worth a voyage across the Atlantic. Yet here, as in the neighborhood of the natural bridge, are people who have passed their lives within half a dozen of miles, and have never been to survey these monuments of a war between the rivers and mountains, which must have shaken the earth itself to its center. To this description of the passage of the Potomac may be added what Mr. Jefferson, in the appendix, has given from his friend Mr. Thomson, Secretary of Congress. The reflections I was led into on viewing this passage of the Potomac through the Blue Ridge were, that this country must have suffered some violent convulsion, and that the face of it must have been changed from what it probably was some centuries ago. That broken and ragged faces of the mountain on each side of the river, the tremendous rocks which are left with one end fixed in the precipice, and the other jutting out, and seemingly ready to fall for want of support. The bed of the river for several miles below obstructed, and filled with the loose stones carried from this mound. In short, everything on which you cast your eye evidently demonstrates a disrupture and breach in the mountain, and that before this happened, what is now a fruitful vale, was formerly a great lake, or collection of water, which possibly might have here formed a mighty cascade, or had its vent to the ocean by the Susquehanna, where the Blue Ridge seems to terminate. Besides this, there are other parts of this country which bear evident traces of a like convulsion. From the best accounts I have been able to obtain, the place where the Delaware now flows through the Kittatinny Mountain, which is a continuation of what is called the North Ridge, or mountain, was not its original course, but that it passed through what is now called the Wind Gap, a place several miles to the westward, and above 100 feet higher than the present bed of the river. This Wind Gap is about a mile broad, and the stones in it such as seem to have been washed for ages by water running over them. Should this have been the case, there must have been a lake behind that mountain. And, by some uncommon swell in the waters, or by some convulsion of nature, the river must have opened its way through a different part of the mountain, and meeting there with less obstruction, carried away with it the opposing mounds of earth, and deluged the country below with the immense collection of waters to which this new passage gave vent. There are still remaining, and daily discovered, innumerable instances of such a deluge on both sides of the river, after it passed the hills above the Falls of Trenton, and reached the Champaign. On the New Jersey side, which is flatter than the Pennsylvania side, all the country below Crosswick Hills seems to have been overflowed to the distance of from 10 to 15 miles back from the river, and to have acquired a new soil, by the earth and clay brought down and mixed with the native sand. The spot on which Philadelphia stands evidently appears to be made ground. The different strata through which they pass in digging for water, the acorns, leaves, and sometimes branches which are found above 20 feet below the surface, all seem to demonstrate this. How little reason there is to ascribe to extraordinary convulsions the excavations which are made by water upon the surface of the earth, will appear most evidently from the examination of that natural bridge of which mention is made above, and which is situated in the same ridge of mountains, far to the south, upon a branch of James's River. Mr. Jefferson gives the following account of it. The natural bridge, the most sublime of nature's works, is on the ascent of a hill, which seems to have been cloven through its length by some great convulsion. The fissure, just at the bridge, is by some measurements 270 feet deep, by others 205, it is about 45 feet wide at the bottom, and 90 feet at the top. This of course determines the length of the bridge, and its height from the water. Its breadth in the middle is about 60 feet, but more at the ends, and the thickness of the mass at the summit of the arch about 40 feet. A part of its thickness is constituted by a coat of earth, which gives growth to many large trees. The residue, with the hill on both sides, is one solid rock of limestone. The arch approaches the semi-elliptical form, but the larger axis of the ellipsis, which would be the chord of the arch, is many times longer than the transverse. Though the sides of the bridge are provided in some parts with a parapet of fixed rock, yet few men have resolution to walk to them, and look over into the abyss. You involuntarily fall on your hands and feet, and creep to the parapet, and look over it. Looking down from this height about a minute gave me a violent headache. If the view from the top be painful and intolerable, that from below is delightful in the extreme. It is impossible for the emotions arising from the sublime to be felt beyond what they are here. On the sight of so beautiful an arch, so elevated, so light, and springing as it were up to heaven, the rapture of the spectator is really indescribable. The fissure, continuing narrow, deep, and straight, for a considerable distance above and below the bridge, opens a short but very pleasing view of the North Mountain on one side, and Blue Ridge on the other. At the distance each of them of about 5 miles. This bridge is in the county of Rockbridge, to which it has given name, and affords a public and commodious passage over a valley, which cannot be crossed elsewhere for a considerable distance. The stream passing under it is called Cedar Creek. It is a water of James's River, and sufficient in the driest seasons to turn a grist mill, though its fountain is not more than 2 miles above 71. Thus both in what is called the Old World and the New, we shall be astonished in looking into the operations of time employing water to move the solid masses from their places, and to change the face of nature, on the earth, without defacing nature. At all times there is a terraqueous globe, for the use of plants and animals. At all times there is upon the surface of the earth dry land and moving water, although the particular shape and situation of those things fluctuate, and are not permanent as are the laws of nature. It is therefore most reasonable, from what appears, to conclude, that the tops of the mountains have been in time past much degraded by the decay of rocks, or by the natural operations of the elements upon the surface of the earth. That the present mountains are parts which either from their situation had been less exposed to those injuries of what is called time, or from the solidity of their constitution have been able to resist them better. And that the present valleys, or hollows between the mountains, have been formed in wasting the rock and in washing away the soil. If this is the case, that rivers have everywhere run upon higher levels than those in which we find them flowing at the present, there must be everywhere to an observing eye marks left upon the sides of rivers, by which it may be judged if this conclusion be true. I shall now transcribe a description of a part of the valleys by which this will appear. Discours sur l'histoire naturelle de la Suisse. Après avoir passé le village de Saint-Léonard, on commence à monter la montagne de la Platière. Cette route est en ennui put plus intéressante pour le naturaliste, etc. On s'y trouve fort de livre dessus du Rhône quand on est sur le haut de ce chemin, dont on découvre un de plus singuliers, de plus riches, et de plus variés passages qu'on puisse imaginer. On voit sous ses pieds le Rhône serpentir dans le lit qu'il s'y creuse actuellement, car il change et tout prouve qu'il en a souvent change, en quantité prodigieuse de petites îles le séparent et le couent en une multitude de canots et de bras. Ces îles sont couvertes les uns d'arbres, de potages, de bosquets et de verdure, d'autres de pierres, de sable, et de débris de rochers. Quelques-uns sont formes ou occasionnées par un amas de troncs d'arbres entassés avec de grands sapins renversés dont les longues tiges hérissées de branches droites et nous représentent de chevaux de frisée. Et donnant l'idée de ces habitats destinés à préserver un pays contre l'approche de l'ennemi. Du côté du Bas Valais, on sud à perte de vue le fleuve dans ses sinuosités et ses détours, on l'aperçoit également dans le Haut Valais. De avances de montagne le cachant quelquefois, il reparoit et diminue insensiblement en approchant de ces monts élèves où il prend ses sources, le fond du vallon paroit être de niveau. S'abaisser seulement d'une pente douce du côté du Bas Valais, de mamelons, de hauteurs de monticules isoles, quelquefois groupes de différentes manières, sont répandus dans cet espace, et repellent la vue d'une prix de vaste par les taupes. Plusieurs de ces hauteurs sont surmontées de ruines d'antiques châteaux, d'églises, et de chapelles, de villages distribués ca et la enrichissant ce fond, que d'allers est couvert de poterages, de champs d'arbres, de bois, et de bosquets. Les enclos de possessions le couent en mille figures bizarres et irrégulières. Ces monticules avec leurs fabriques élevant au-dessus de tous ces objets variés, quelques-uns s'y distinguent par leurs côtés écrous que sont à pic. La blancheur de ces éboulements contraste singulièrement avec les verts que sont les couleurs dominantes du vallon. Au-delà de Coteau, de Montagnes s élevant et vent supérieur ets adosser à ces masses, à ces colosses énormes de rochers à pic leaves comme de murailles et d'une hauteur prodigieuse que forment cette barrière que sépare le Valais de la Savoie. Les contours du pays de ces monts forment de autres de vallons et de vallées d'eau descendant ets précipitant de torrents que viennent grosser les eaux du Rhône. La vue church à pénétrer et à s'étendre dans ces espaces, l'imagination church vainement de passages dans effrayantes limites, parmi ces écules et ces rochers amoncelées, est arrêté partout. De noirs forêts de sapins sont suspendus parmi ces rochers blancs jaunâtres, que se terminent enfin par une multitude d'aiguilles et de pyramides qu'on voit percer au travers de neige et de glaces, se lancer dans les nues. Sy cacher et sy perdre. En examinant de plus près ces mamelons répandus dans le vallon, on voit qu'ils sont composés de pierres, de sables. Et de débris rapports et de amoncelés sans ordre depuis de temps dont rien put fixer l'époque. On voit que les eaux du Rhône ont coulent à leurs pieds, qu'ils en amènent plusieurs et à occasion leurs chutes et leurs ruines. On voit actuellement quelques mamelons que subissent ces mêmes dégradations, et fournissent au Rhône les matériaux dont il va former plus loin ces adressements dont nous avons parlé. La confusion et le désordre que se remarque dans la composition intérieure de ces mamelons prouvent qu'ils ne sont pas le produit de la mer au de eaux que ont travaillé successivement et lentement à la formation de la plupart des terrains. Mais que le fond de ces vallons a été rempli de décombres et de débris de montagnes supérieures, qu'ils ont été entraînés par de inondations et de débordements subits. Que les eaux du Rhône en sud ont parcouru ces vallons qu'ils a souvent changé de lit. Que s'en tournent et en circulant dans ces terrains nouvellement formes, qu'ils a creusent les espaces que sont entre ces mamelons, et que s'en creusant le terrain qu'ils se sont élevés. Leurs formes et de leurs pentes allongées vers le bas Valais, sont de nouvelles preuves que ces sont les eaux actuelles que ont changé la surface de ces terrains. Nous verrons de nouvelles preuves de ces que nous disons en avançant d'avantage vers le haut Valais. Il a peut être point d'endroit plus propre à étudier le travail de eaux que ces vallons qu'on a la facilité de voir et d'examiner sous de aspects différents. Another example of the same kind, with regard to the bed of the Rhine, we have from the same author. Discours, etc. page 259. De Richena à Quar, Troyen, B. Saint Gall. Pour aller à Quar on passe le port que est sur le haut Rhin. En côtoyant ces fleuves, que coule dans un fond, on entre dans un plain de niveau, que en chuan pente très insensible de 3 quarts de l'eau, le fond du terrain ne chuan amas de pierres roules de toutes species. Les du côtés sont bords de montagnes calcaires que courent parallèlement entre elles. Celle de la gauche, au pied de laquelle coule le Rhine, est très rapide et perpendiculaire à son sommet. Celle que est à droite de la plaine au petit vallon, puisqu'il se trouve entre de montagnes, est moins haute, plus boisée, et couverte de sapins. Le vallon est aussi couvert, en partie, de très grands et de beaux pins. Mais ce qu'on voit de plus remarquable, c'est un dizaine de gros mamelons au beauties, élevés de 50 à 60 toises, plus au moins isolés, et à différentes distances les uns de autres. Ces beauties sont rondes, la plupart allongées dans le sens du vallon, et composées de débris calcaires et de sables. Le fond du vallon est mêlé de plus d'espèces de galettes. On ne croit pas se tromper en disant que ce vallon a été rempli de matters apportés par les eaux jusqu'à la hauteur où sont encore actuellement les mamelons. Que de nouvelles inondations ont ensuite creuses et entraînent ce que manque de terrain à ces mamelons, que c'est en circulant autour de ces mamelons que les eaux leur ont dans la forme ronde. Et surtout allongé dans le sens du vallon, que c'est par le moyen de ces memes os que le fond actuel de cette plane après ce niveau et cette pente insensible vers un pays plus ouvert que est au-delà. On a déjà fait mention de parelles mamelons que se trouvent dans le vallon du Valais parcouru par le Rhône. These examples may also be supported by what this author observes in another place 72. Le vallon au est situé méridien, est visiblement formed par le dépôt de eaux Illinois est de niveau, et s'étend 3 lieues en longueur jusqu'au lac de Bryance, à la suite duquel est le même terrain nivellé, que va jusqu'au lac de Thun. Don't on a parle. Une autre observation que concorde à favorisir ce sentiment, c'est que toutes les roches calcaires, que entourent le vallon, sont à pic, qu'on y remarque de cavités circulaires et de enfoncements à même hauteur et à différents points. Que constatent la fouille et le mouvement de eaux contre ces parois. Thus we have seen the operation of the atmospheric elements degrading mountains, and hollowing out the valleys of this earth. The land which comes from the mineral region in a consolidated state, in order to endure the injuries of those atmospheric elements, must be resolved in time for the purposes of fertilizing the surface of this earth. In no station whatever is it to be exempted from the wasting operations, which are equally necessary, in the system of this world, as were those by which it had been produced. But with what wisdom is that destroying power disposed? The summit of the mountain is degraded, and the materials of this part, which in a manner has become useless from its excessive height, are employed in order to extend the limits of the shore, and thus increase the useful basis of our dwellings. It is our business to trace this operation through all the intermediate steps of that progress, and thus to understand what we see upon the surface of this earth, by knowing the principles upon which the system of this world proceeds. Chapter 11. Facts and Opinions Concerning the Natural Construction of Mountains and Valleys. The valley of the Rhône is continued up to the mountain of St. Gothard, which may be considered as the center of the continent, since, from the different sides of this mountain, the water runs in all directions. To the German Sea it runs by the Rhine, to the Mediterranean by the Rhône, and to the Adriatic by the Po. Here it may be proper to take a general view of this mountainous country, or that great mass of rock or solid strata which has been either formed originally in its present shape, or has been excavated by the constant operation of water running from the summit in all the different directions. On the one hand, it is supposed that the forming cause which had produced those mountains, in collecting their materials at the bottom of the sea, had also determined the shape in which their various ridges are at present found. On the other hand, it is supposed that the destructive causes, which operate in degrading mountains, have immediately contributed to produce their present forms. And that it is only mediately or more remotely that this shape has been determined by mineral operations and the constitution of the solid parts, which thus oppose the wearing operations of the surface with different degrees of hardness and solidity. Whether natural appearances correspond with the one or the other of those two different suppositions, every person who has the opportunity of making such an examination, and has sufficient knowledge of the subject to judge from his observation, will determine for himself. I will here give the opinion of a person who has had great opportunities for this purpose, who is an intelligent as well as an attentive observer, and who has had particularly this question in his view. It is from Tableaux de la Suisse 73. Quand nous sommes trouvés sur ces points élevés, nous avons toujours considéré le total de montagnes prises ensemble, leurs situations respectives, les uns par rapport aux autres. Afin de reconnoître, s'il y avoit quelque chose de constant dans leurs positions, rien n'est plus vrai. Dans la grande chaîne de montagnes que sépare le canton de Berne du Valais d'un côté, et les Alpes que séparent le Valais de la Savoie de l'autre, and considérant le cours du Rhône sous différents points de vue. On n point vu que les angles salins de ces tres hautes montagnes faisant opposes aux angles rentrants de montagnes que sont vis-à-vis. Le fameux vallon que est sur le haut du Saint-Gothard, le point le plus élevé de l'Europe, contredit également cette observation, aussi que les positions de la plus grande partie de montagnes que forment son vaste circuit. Le vallon de Scolanen, que plus de Huit Luz, dans l'école la Russe col du sommet du Saint-Gothard jusqu'au lac de Lucerne, offre à peine quelques exemples d'angles rentrants opposés à de angles salants. Les nombreux vallons que nous avons constamment traversés ce que conduisent au Grindelwald, et celu camine au pays de Hasli que sont sous nocio, n'établiront pas d'avantage cette correspondance d'angles salants et d'angles rentrants. Qu'on regarde comme si constant. Dans les montagnes basses, du troisième et du quatrième ordre, ou inférieurs, on remarque plus souvent cette correspondance, encore n'est-elle pas constante, les eaux ordinaires ont forment ces vallons. Mais si on veut donner une théorie générale, c'est assurément dans les plus hautes montagnes qu'il faut prendre ces exemples. Ce que s'y trouve au-dessus de ces points les plus élevés, après sa forme de la disposition même de plus hautes sommets. M. de Saussure, in his second volume of Voyages dans les Alpes, gives the strongest confirmation to the theory of the gradual degradation of mountains by the means of rain. Section 920. J. Reviens aux observations. Il est un très importante pour la théorie de la Terre, dont on peut du cramet apprécier la valeur, mieux que d'aucun autre site. J. veut parler de la fameuse observation de Bourget sur la correspondance de angles salants avec les angles rentrants de vallées. J. a déjà dit un mot dans le 1er. Volume, section 577, mais J. renvoie à ce chapitre les développements que J. va donner. Ce que avoid fait regarder cette observation comme très importante, c'est que l'on avoid cru qu'elle pourrait servir à démontrer que les vallées ont été creusées par de courants de la mer, dans le temps où elles couvraient encore les montagnes. Au que les montagnes que bordent ces vallées avoyant été elles-mêmes formes par l'accumulation de dépôts rejetés sur les bords de ces mêmes courants. Mais l'inspection de vallées que l'on découvre du cramet démontre pleinement le peu de solidité de ces deux suppositions. En effet, toutes les vallées que l'on découvre du haut de cette cime sont fermes, au moins à l'un de leurs extrémités et quelques-uns à leurs deux extrémités, par de cols élèves. Au même par de montagnes d'une très grande hauteur, toutes sont capables à angles droits par d'autres vallées, et l'on voit enfin clairement que la plupart d'entre elles ont été creuses, non point dans la mer, mais, au moment sa retraite. Au depuis sa retraite, par les eaux de neige et de pluies. On a d'abord sous sur la grande vallée de l'Île Blanche, que est parallèle à la direction générale de cette partie de Alpes, est du nombre de celles que j'ai nommé longitudinales. Et l'on voit cette vallée barrée à l'un de ses extrémités par le col de la Seine et à l'autre par le col Ferret. En s'y retournant du côté de l'Italie, on voit plusieurs vallées à peu près parallèles à celle-là, comme celle de la Tuile, celle du Grand Saint-Bernard, que toutes aboutissent, par le haut, à quelques cols très élevés, et par le bas, à la Doyer. Elles viennent se jeter vis-à-vis de quelques montagnes que leur correspondent de l'autre côté de cette vallée. Si l'on considère ensuite cette même vallée de la Doyer, que descend de Cormier à Ivry, on la verra barrée par le Mont Blanc et par la chaîne centrale, que la courant à angles droits dans la partie supérieure. On verra cette même vallée s'ouvrir, dans un espace de sept ou huit luz, du ou trois inflexions tout à fait brusques. Et on la verra enfin capée à angles droits par une quantité de vallées que viennent y verser leurs eaux, et que sont elles mêmes capées par d'autres, dont elles recueillent aussi le tribut. Or quand on réfléchit à la largeur et à l'étendue de courants de la mer, peut on concevoir que ces cylindres étroits, bars, que se courant en échiquier à de très petites distances, ayant pu être creusés par de semblables courants. L'observation de la correspondance de angles, faut-elle aussi universelle qu'elle l'est peu, n'y prouverait donc autre chose, sinon que les vallées sont nées de la fissure et de l'écartement de montagnes. Au qu'elles ont été creusées par les torrents et les rivières que y coulant actuellement. On voit un grand nombre de vallées naître, Cum Jelai fait voir au bon homme, section 767, sur les flancs d'une montagne, on les voit s'élargir et s'approfondir à proportion de eaux que y coulant. Un ruisseau que sort d'une glacier, ou que sort d'une prairie, creuse un sillon, petit diabord, mais que s'agrandit successivement à mesure que ses eaux grossissent, par la réunion d'autres sources ou d'autres torrents. Il n'est même pas nécessaire, pour se convaincre de la vérité de ces faits, de graver sur le cramant. Il suffit de jeter les yeux sur la première carte qu'elle en trouvera sous la main, de Pyrénées, de l'Apennine, de Alpes, ou de quelque autre chaîne de montagnes que s'y puisse être. On y verra toutes les vallées indiquées par le cours de rivières. On verra ces rivières et les vallées dans lesquelles elles coulent, aboutir par un de leurs extrémités au sommet de quelque montagne ou de quelque col olive. Les replis tortueux d'un grand fleuve, indiqueront un vallée principale, dans lequel de torrents ou de rivières que indiquent d'autres vallées moins considerables, viennent aboutir, sous de angles plus ou moins approchants de l'angle droit. Or ces rivières que viennent de droite et de gauche se jeter dans la vallée principale, ne s'accordent pas pour se jeter par pairs dans le même point du fleuve. Elles sont comme les branches d'un arbre que s'implantent alternativement sur son tronc, et par conséquent, chaque petite vallée se jette dans la vallée principale vis-à-vis d'une montagne. Et de plus on verra aussi sur les cartes que même les plus grandes vallées ont presque toutes de étranglements que forment de écluses, de fourches, de défiles. Je ne prétends cependant pas que l'érosion de eaux pluviales, de torrents et de rivières, soit l'unique cause de la formation de vallées, le redressement de couches de montagnes nous force à en admettre un autre, dont je y parlerai à l'heure. Je voulais seulement prouver, ici que la correspondance de angles, lorsqu'elle a lieu dans les vallées, ne prouve point que ces vallées soient à l'ouvrage de courants de la mer. The place to which M. Dissolution here remits us is where he afterwards, in describing the Val d'Aoste, makes the following observation. Section 960. Au-delà de nous, les montagnes que bordent au midi la vallée, et dont on voit d'ici très bien la structure, sont composées de grandes couches appliquées les uns contre les autres, et terminent par de cimes aiguës, escarpées contre le midi. Elles tournent ainsi le dos à la vallée, dont la direction est toujours à 10 degrés de l'est par nord. Celles de la gauche que nous côtoyons, et que sont de nature schistous, tournent aussi le dos à la vallée en s'élevant contre le nord. Je crois pouvoir conclure de là, que cette vallée est un de celles dont la formation tient à celle de montagnes mêmes, et non point à l'érosion de courants de la mer ou de rivières. Les vallées de ce genre, paroissent avoir été formées par un effacement partiel de couches de montagnes, que ont consenti, dans la direction où ont actuellement ces vallées. Here I would beg leave to differ a little from this opinion of M. Dissolution, at least from the manner in which it is expressed, for perhaps at bottom our opinions upon this subject do not differ much. M. Dissolution says that the formation of this valley depends upon the mountains themselves, and not upon the erosion of the rivers. I agree with our author, so far as the mountains may have here determined the shape and situation of the valley. But, so far as this valley was hollowed out of the solid mass of our earth, there cannot be the least doubt that the proper agent was the running water of the rivers. The question, therefore, comes to this, how far it is reasonable to conclude that this valley had been hollowed out of the solid mass. Now, according to the present theory, where the strata consolidated at the bottom of the sea are supposed to be erected into the place of land, we cannot suppose any valley formed by another agent than the running water upon the surface. Although the parts which are first to be washed away, and those which are to remain longest, must be determined by a concurrence of various circumstances, among which this converging declivity of the strata in the bordering mountains, doubtless, must be enumerated. With regard to any other theory which shall better explain the present shape of the surface of the earth, by giving a cause for the changed position of the strata originally horizontal, I cannot form a judgment. As I do not understand by what means strata, which were formed horizontally, should have been afterwards inclined, unless it be that of a power acting under those strata, and first erecting them in relation to the solid globe on which they rested. Besides, in supposing this valley original, and not formed by the erosion of the rivers, what effect should we ascribe to the transport of all those materials of the Alps, which it is demonstrable must have travelled through this valley? Whether is it more reasonable to suppose, on the one hand, that the action and attrition of all the hard materials, running for millions of ages between those two mountains, had hollowed out that mass which originally intervened? Or, on the other, that this valley had been originally formed in its present shape, while thousands of other valleys have been hollowed out of the solid mass? But to put this question out of doubt, with regard to this very valley of the river Doyer, M. de Saussure has given us the following decisive fact, section 881, Immediatement Odessus de cette source. Est un rocher que répond si précisement à un autre rocher de la même nature, situé de l'autre côté de la vallée de Cormier, qu'ou en any soroit d'autre chui ls n'ayant été anciennement unis par un montagne intermédiaire. Detroit par les ravages du temps. Now, to see how little the situation of the strata influences the shape of the valleys, I shall transcribe the two paragraphs immediately following that which has given occasion to the present discussion. Un peu au-delà de Nux, la vallée s'est d'être large et plaine, comme elle était dans l'environs de la site, elle devient étroite et très variée, la stérile sauvage, ici couverte de verdures et de prairies arrosées par la Doyer. Section 961. Les couches de montagnes à notre gauche, que depuis la site avoyant constamment couru à l'est et monter au nord, paroissent changer à un quart de le du village de Chambais, que est à un loïdi un quart de Nux. Els montent d'abord au sud-est, et peu plus loin droit au sud, tandis que l'autre côté de la vallée els paroissent monter à l'est. In every mountain, and in every valley, the solid parts below have contributed in some manner to determine the shape of the surface of the earth. But in no place is the original shape of the earth, such as it had first appeared above the sea, to be found. Every part of the land is wasted, even the tops of the mountains, over which no floods of water run, are degraded. But this wasting operation, which affects the solid rock upon the summit of the mountain, operates slowly in some places, compared with that which may be observed in others. Now, it is in the valleys that this operation is so perceptible. And it is in the valley that there is such a quick succession of things as must strike the mind of any diligent observer. But this is the reason why we must conclude, that at least all the valleys are the operation of running water in the course of time. If this is granted, we have but to consider the mountains as formed by the hollowing out of the valleys, and the valleys as hollowed out by the attrition of hard materials coming from the mountains. Here is the explanation of the general appearance of mountain and valley, of hill and dale, of height and hollow, while each particular shape must have its dependence, consequently its explanation, upon some local circumstance. But, besides the general conformation of mountains and valleys, there may be also, in the forms of mountains, certain characters depending upon the species of substances or rocks of which they are composed, and the general manner in which those masses are wasted by the operations of the surface. Thus there is some character in the external appearance of a hill, a mountain, or a ridge of hills and mountains. But this appearance is generally attended with various circumstances, or is so complicated in its nature, as to be always difficult to read, and it is but seldom that it affords any very particular information. Although, after knowing all the state and circumstances of the case, I have always found the appearances most intelligible, and strictly corresponding with the general principle of atmospheric influence acting upon the particular structure of the earth below. M. de Saussure has given us an observation of this kind, in describing the mountains through which the Rhône has made its way out of the Alps, at the bottom of the Valais. 1061. Plus loin le village de Juviana ou Vian en voit de rochers que ont un fermi que j'ai nami mutane, car en est tant de donner de noms à de modifications que n'ont pas, et que ont portant un caractère propre. Les montagnes que j'ai design par cette expression sont composées d'un assemblage de têtes arrondies, couvertes quelquefois de bois, mais plus souvent d'herbes, ou tout au plus de brazils. Ces rondeurs contigues et repeties forment en grand effet d'une toison bien fournie, au lieu de ces perruques que l'on nomme aussi moutonnées. Les montagnes que s'y présentent sous cette forme, sont presque toujours de rochers primitives, au moins de stalactites, car je n'ai jamais vu aucune montagne de pierre à chaud au d'ardoise revêtir cette apparence. Les signes que peuvent donner quelque indice de la nature de montagnes, à de grandes distances et au travers de plantes que le couvrent, sont en petit nombre, et méritent d'être étudiés et consacrés par de termes propres. When philosophers propose vague theories of the earth, theories which contain no principle for investigating either the general disorder of strata or the particular form of mountains. Such theories can receive no confirmation from the examination of the earth, nor can they afford any rule by which the phenomena in question might be explained. This is not the case when a theory presents both the efficient and final cause of those disorders in bodies which have been originally formed regular, and which shows the use as well as means for the formation of our mountains. Here illustration and confirmation of the theory may be found in the examination of nature, and natural appearances may receive that explanation which the generalization of a proper theory affords. The particular forms of mountains depend upon the compound operation of two very different causes. One of these consists in those mineral operations by which the strata of the earth are consolidated and displaced, or disordered in the production of land above the sea. The other again consists in those meteorological operations by which this earth is rendered a habitable world. In the one operation, loose materials are united, for the purpose of resisting the dissolving powers which act upon the surface of the earth. In the other, consolidated masses are again dissolved, for the purpose of serving vegetation and entertaining animal life. But, in fulfilling those purposes of a habitable earth, or serving that great end, the land above the level of the sea is wasted, and the materials are transported to the bottom of the ocean from whence that consolidated land had come. At present we only want to see the cause of those particular shapes which are found among the most elevated places of our earth, those places upon which the wasting powers of the surface act with greatest energy or force. In explaining those appearances of degraded mountains variously shaped, the fact we are now to reason upon is this. First, that in the consolidated earth we find great inequality in the resisting powers of the various consolidated bodies, both from the different degrees of consolidation which had taken place among them, and the different degrees of solubility which is found in the consolidated substances. And, secondly, that we find great diversity in the size, form, and positions of those most durable bodies which, by resisting longer the effects of the wearing operations of the surface, must determine the shape of the remaining mass. Now so far as every particular shape upon the surface of this earth is found to correspond to the effect of those two causes, the theory which gave those principles must be confirmed in the examination of the earth. And so far as the theory is admitted to be just, we have principles for the explanation of every appearance of that kind, whether from the forming or destroying operations of this earth. There being no part upon the surface of this earth in which the effect of both those causes must not more or less appear. But though the effects of those two causes be evident in the conformation of every mountainous region, it is not always easy to analyze those effects so as to see the efficient cause. Without sections of mountains their internal structure cannot be perceived, if the surface which we see be covered with soil as is generally the case. It is true, indeed, that the solid bodies often partially appear through that covering of soil, and so far discover to us what is to be found within. But as those solid parts are often in disorder, we cannot, from a small portion, always judge of the generality. Besides, the solid parts of mountains is often a compound thing, composed both of stratified and injected bodies. It is therefore most precarious, from a portion which is seen, to form a judgment of a whole mass which is unexplored. Nevertheless, knowing the principles observed by nature both in the construction and degradation of mountains, and cautiously inferring nothing farther than the data will admit of, some conclusion may be formed. In reasoning from what is known to what is still unknown. It is with this view that we are now to consider the general forms of mountains, such as they appear to us at a certain distance, when we have not the opportunity of examining them in a more perfect manner. For, though we may not thus learn always to understand that which is thus examined, we shall learn, what is still more interesting, viz. that those mountains have been formed in the natural operations of the earth, and according to physical rules that may be investigated. We are to distinguish mountains as being either on the one hand soft and smooth, or on the other hand as hard and rocky. If we can understand those two great divisions by themselves, we shall find it easy to explain the more complex cases, where these two general appearances partially prevail. Let us therefore examine this general division which we have made with regard to the external character of mountains. The soft and smooth mountains are generally formed of the schistee, when there is any considerable extent of such alpine or mountainous region. The substance is sufficiently durable to form a mountain, or sufficiently strong, in its natural state, to resist the greatest torrent of water. At the same time this fissible substance generally decays so completely, when exposed to the atmosphere, as to leave no salient rock exposed by which to characterize the mountain. Of this kind are the schistee of Wales, of Cumberland, of the Isle of Man, and of the south of Scotland. I do not say absolutely, that there is no other kind of material, besides the schistee which gives this species of mountain, but only that this is generally the case in alpine situations. It may be also formed of any other substance which has solidity enough to remain in the form of mountains, and at same time not enough to form salient rocks. Such, for example, is the chalk hills of the Isle of Wight and south of England. But these are generally hills of an inferior height compared with our alpine schistee, and hardly deserve the term of mountain. This material of our smooth green mountains may be termed an argillaceous schistous. It has generally calcareous veins, and is often fibrous in its structure resembling wood, instead of being slaty, which it is in general. There is however another species of schistous, forming also the same sort of mountain. It is the micaceous quartzy schistous of the north of Scotland. Now it must be evident that the character of those mountains arises from there being no part of those schistee that resists the influence of the atmosphere, in exfoliating and breaking into soil. And this soil is doubtless of different qualities, according to the nature of those schistee from which the soil is formed. Such mountains are necessarily composed of rounded masses, and not formed of angular shapes. They are covered with soil, which is more or less either stony or tender, sterile or fertile, according to the materials which produce that soil. The fertile mountains are green and covered with grass. The sterile mountains again are black, or covered with heath in our climates. Thus we have a general character of smooth and rounded mountains. And also a distinction in that general character from the produce of the soil indicating the nature of the solid materials, as containing either on the one hand calcareous and argillaceous substances, or, on the other, as only containing those that are micaceous and siliceous. With regard again to the other species of mountain, which we have termed rocky, we must make a subdistinction of those which are regular, and those in which there is no regularity to be perceived. It must be plain that it is only of those which have regularity that we can form a theory. It is this, that the regularity in the shape of those mountains arises from the rock of the mountain being either on the one hand an uniform solid mass, or on the other hand a stratified mass, or one formed upon some regular principle distinguishable in the shape. In the first of these, we have a conical or pyramidal shape, arising from the gradual decay of the rock exposed to the destructive causes of the surface, as already explained in this chapter. In the second, again, we find the original structure of the mass influencing the present shape in conjunction with the destructive causes, by which a certain regularity may be observed. Now, this original shape is no other than that of beds or strata of solid resisting rock, which may be regularly disposed in a mountain, either horizontally, vertically, or in an inclined position. And those solid beds may then affect the shape of the mountain in some regular or distinguishable manner, besides the other parts of its shape which it acquires upon the principle of decay. In distinguishing, at a distance, those regular causes in the form of mountains, we may not be able to tell, with certainty, what the substance is of which the mountain is composed. Yet, with regard to the internal structure of that part of the earth, a person of knowledge and experience in the subject may form a judgment in which, for coming at truth, there is more than accident. There is even often more than probable conjecture. Thus, a horizontal bed of rock forms a table mountain, or such as M. Booger found in the valley of the Madalena. An inclined rock of this kind forms a mountain sloping on the one side, and having a precipice upon the upper part of the other side, with a slope of fallen earth at the bottom, such as the ridges observed by M. De Saussure from the top of the Cramant, having precipices upon one side, which also had a respect to certain central points, an observation which draws to more than the simple structure of the mountain. Were it vertical, again, it would form a rocky ridge extended in length, and having its sides equally sloped, so far as the other circumstances of the place would permit. Therefore, whether we suppose the mountains formed of a rock in mass, or in that of regular beds, this must have an influence in the form of this decaying surface of the earth, and may be distinguished in the shape of mountains. It is but rarely that we find mountains formed altogether of rock, although we often find them of the other sort, where little or nothing of rock is to be seen. But often also we find the two cases variously compounded. This is the source of the difficulty which occurs in the reading of the external characters of mountains. And this is one of the causes of irregularity in the form of mountains, by which there is always some degree of uncertainty in our judgment from external appearances. We may form another distinction with regard to the structure of mountains, a distinction which depends upon a particular cause, and which will afford an explanation of some other appearance in the surface of the earth. Mountains in general may be considered as, being either on the one hand associated, or on the other insulated. And this forms a distinction which may be explained in the theory, and affords some ground for judging of the internal structure from the external appearance. The associated mountains are formed by the wearing down of the most decayable, or softer places, by the collected waters of the surface. Consequently there is a certain similarity, or analogy, of the mountains formed of the same materials, and thus associated. The highest of those mountains should be near the center of the mass. But, in extensive masses of this kind, there may also be more than one center. Nor are all the associated mountains to be of one kind, however, to a certain extent, similarity may be expected to prevail among them. It must now be evident, that when we find mountains composed of very different materials, such as, e.g. of granite, and of limestone or marl, and when the shape of those mountains are similar, or formed upon the same principle, such as, e.g. the pyramidal mountains of the Alps, we are then to conclude, as has already been exemplified, Chapter 9, page 306, that those consolidated masses of this earth had been formed into the pyramidal mountains in the same manner. We have there also shown that this principle of formation is no other than the gradual decay of the solid mass by gravity and the atmospheric influences. Consequently, those pyramidal mountains, though composed of such different materials, may, at a certain distance, where smaller characteristic distinctions may not be perceivable, appear to be of the same kind. And this indeed they truly are, so far as having their general shape formed upon the same principle. We come now to treat of insulated mountains. Here volcanoes must be mentioned as a cause. By means of a volcano, a mountain may be raised in a plain, and a volcanic mountain might even rise out of the sea. The formation of this species of mountain requires not the wearing operations of the earth which we have been considering as the modifier of our alpine regions. This volcanic mountain has a conical shape, perhaps more from the manner of its formation which is accretion, than from the wasting of the surface of the earth. It is not, however, of this particular species of mountain that I mean to treat, having had no opportunity of examining any of that species. The genus of mountain which we are now considering, is that of the eruptive kind. But there is much of this eruptive matter in the bowels of the earth, which, so far as we know, never has produced a volcano. It is to this species of eruption that I am now to attribute the formation of many insulated mountains, which rise in what may be termed low countries, in opposition to the highlands or alpine situations. Such is Wrekin in Shropshire, which some people have supposed to have been a volcano. Such are the 100 little mountains in the lowlands of this country of Scotland, where those insulated hills are often called by the general term law. As, for example, North Berwick Law. When masses of fluid matter are erupted in the mineral regions among strata which are to form our land. And when those elevated strata are, in the course of time, wasted and washed away, the solid mass of those erupted substances, being more durable than the surrounding strata, stand up as eminences in our land. Now these often, almost always, form the small insulated mountains which are found so frequently breaking out in the lowlands of Scotland. They appear in various shapes as well as sizes. And they hold their particular form from the joint operation of two different causes. One is the extent and casual shape of the erupted mass. The other is the degradation of that mass, which is wasted by the influences of the atmosphere, though wasted slower than the strata with which it was involved. When the formation of this erupted mass has been determined by the place in any regular form, which may be distinguished in the shape of a mountain, it gives a certain character which is often not difficult to read. Thus, our whinstone, interjected in flat beds between the regular strata, often presents its edge upon, or near the summit of our insulated mountains and eminences. They are commonly in the form of inclined planes. And, to a person a little conversant in this subject, they are extremely distinguishable in the external form of the hill. We have a good example of this in the little mountain of Arthur's Seat, by this town of Edinburgh. This is a peaked hill of an irregular erupted mass, but on the south and north sides of this central mass, the basaltic matters had been forced also in those inclined beds among the regular strata. On the north side we find remarkable masses of whinstone in that regular form among the strata, and lying parallel with them. The most conspicuous of these basaltic beds forms the summit of the hill which is called Salisbury Crag. Here the bed of whinstone, more than 60 or 80 feet thick, rises to the west at an angle of about 40 degrees, it forms the precipitous summit which looks to the west. And this is an appearance which is distinguishable upon 100 other occasions in the hills and mountains of this country. Rivers make sections of mountains through which they pass. Therefore, nothing is more interesting for bringing to our knowledge the former state of things upon the surface of this earth, than the examination of those valleys which the rivers have formed by wearing down the solid parts of alpine countries. We have already seen that the wide extensive valley of the Rhône, between Loiche and Colbech, as well as the whole extensive circus of the Rosa Mountains, has on each side mountains of the same substances, the strata of which are horizontal. Consequently, here the valley must have been hollowed out of the solid rock, for there is no natural operation by which those opposite mountains of horizontal strata could have been formed, except in the continuation of those beds. We are therefore to conclude, that the solid strata between those ridges of lofty mountains had been continuous. The most perfect confirmation which this theory could receive, would be to find that those ridges of mountains, which the Rhône divides in issuing from the Alps into the plain, had been also united, in forming one continued mass of solid rocks. But the observations of M. de Saussure, who has most carefully examined this subject, will leave no room to doubt of that fact. This view of the entry to the valley of the Rhône is too interesting not to give it here a place. It follows immediately after that which we have last transcribed. Ces montagnes que Geology sonder au haut de prairies que les séparent de la grande route, sont composées d'un mélange très ressemblant au précédent, etc. sont là. Les derniers rochers primitifs que l'on rencontre en sortant de Alpes par cette vallée. Le village de Juviana, dont ils occupent les derrières, est encore à un le de Saint-Maurice. Section 1062. Et l'extrémité de ces rochers, on voit une grande ravine, où plotot une vallée ouverte du nord au midi, dans laquelle coule le torrent esti. Barthélemy. Cette vallée termine les montagnes primitives que je viens de décrire, au delà commencent les montagnes calcaires. Cependant le pied de la montagne primitive, coupé par le torrent, est demeure engagé sous les premières couches de la montagne calcaire. Au travers de cette vallée, on voit de hautes montagnes couvertes de neige, situées derrière celles que bordent notre route. La plus haute et la plus remarquable de ces montagnes est nommée la dent au laguel du Midi. De l'autre côté du Rhône, envoyed un autre cime aussi très élevé, que si nami la dent ou l'aiguille de la morelle. Ces du hots cimes ont entre elles un correspondance de hauteur, de forme, et même de matière tout à fait singulière. L'un et l'autre présentent leurs escarpements à la vallée du Rhône. Leurs cimes crénelées sont de la même couleur brune. Sous ces cimes brunes, envoyent de part et d'autre un band gris, que paroit horizontale, et au-dessus de cette bande gris, le rocher, dans l'un comme dans l'autre, reprend sa couleur jaunâtre. Ces montagnes sont sûrement secondaires, les bandes grises paroissent être de pierre à chaud, et les jaunes de schiste argileux et de graisse, à en juger du moins à cette distance, car j'en ai les ai point observes de plus près. Els paroissent aussi appartenir de chaînes secondaires que passent derrière les chaînes primitives, que nous avons observés sur les bords du Rhône, et quoique les bandes jaunes et grises que l'on y observe, semblent horizontales. J'en de point que les couches mêmes, dont ces bandes sont les sections, any descendant en arrière avec essais de rapidité. Les escarpements de ces montagnes en font un preuve peu près certain. Ces hautes montagnes orientales étaient anciennement liées entre elles par de intermédiaires de la même nature, que couvroyant, et les primitives que nous avons observés, et tout cette vallée dans laquelle coule aujourd'hui le Rhône. Je me garderois bien de l'affirmer, mais je ferois tant de le croire. Section 1063. Depuis la vallée dont je viens de parler, et que termino couchant les montagnes primitives, celles que suivent jusqu'ici. Maurice, sont de nature calcaire à couches épaisses et suaves. Ces couches s'élèvent contre les primitives que nous avons côtoyées, et celles que en sont les plus voisines paroissent fort tourmentées, ici fléchies, la rompures. Après une interruption, ces rochers sont suivis d'autres rochers, aussi calcaires, coupes à pic du côté de la vallée, et composés de grandes assises horizontales. Ces rochers forment un enceinte demi-circulaire, que vient presque s'y joindre à ce que bordent la rive droite du Rhône, et former ainsi l'entrée de cette vallée, dont le fleuve n'y sort que par un issue très étroite. La ville d'Esti. Maurice est ainsi renfermé par cette enceinte de rochers, dont les bancs épais, bien suivis, séparés par de cordons de verdure, et courants par de forêts, avec un hermitage niche entre ces bancs, présente un aspect singulier et pittoresque. Section 1064. Les rochers correspondants de l'autre côté du Rhône, ou sur la rive droite de ces fleuves sont aussi calcaires. La montagne que domine cette rive, un peu au-dessus d'Esti. Maurice, est composé de couches contournées, froisses et replies de la manière la plus étrange. Ce qui est encore de remarquable, c'est que ces couches ainsi replies n'ont d'autres à côté d'elles que sont planes, presque verticales, et d'autres sous elles, que sont horizontales. Il faudrait avoir observé de près ces singuliers rochers, et avoir déterminé comment et jusqu'à quel point ces couches sont unies entre elles pour former les conjectures sur leur origine. Car la vallée est trop large pour que l'on puisse en juger avec précision d'une rive à l'autre. On voit avec peine que cette large vallée soit aussi peu cultivée. Elle est presque partout couverte, au lieu de marais, au lieu de débris de montagnes voisines. Section 1065. Avant de quitter cette vallée, je jetterai un coup d'œil général sur la singulière suite de rochers que composent la chaîne que nous venons d'y observer. Les deux extrémités sont calcaires, avec cette différence, que celle que est la plus près de Martigny est mêlée de mica, tandis que celle de Saint-Maurice en contient point. Entre ces calcaires sont reformées de rochers que l'on regarde comme primitives, et au milieu de ces roches on trouve de ardoises et de puddings. En fait que ce dernier genre est ordinairement classé parmi les montagnes tertiaires, au lieu de la formation la plus récente. Mais ces puddings que any contenant aucun fragment de pierre calcaire, que any sont mine point unis par un gluten calcaire, any sont vraisemblablement pas postérieurs à la formation de montagnes calcaires. Ou du moins ils any doivent point être confondus avec ces grécies ces puddings de formation nouvelle, que entrent dans la composition de montagnes du troisième ordre. Quant aux ardoises que se trouvent interposes au milieu de ces grécies et de ces puddings, section 1054, elles sont de nature argileus, et dans l'ordre de pierres que en nomi secondaires. Ces ardoises, de mine que touts les pierres de ces montagnes, ont leurs couches dans une situation verticale, mais nous avons vu qu'il lu de croire qu'elles ont été anciennement horizontales. It is singularly fortunate that such remarkable appearances, as are found in the rocks of this place, had called the attention of M. de Saussure to investigate a subject so interesting to the present theory. And it is upon this, as well as on many other occasions, that the value of those observations of natural history will appear. They are made by a person eminent for knowledge. And they are recorded with an accuracy and precision which leaves nothing more to be desired. From Martigny to St. Maurice, about 3 leagues, there is a most interesting valley of the Rhône, through which this river makes its way from the Valleys, or great valley above, among those mountains which seem to have shut up the Valleys, and through which the river must pass in running to the lake. M. de Saussure found some singular masses, which attracted his attention, in examining the structure of the rocks on the left side of this little valley. Like a true philosopher, an accurate naturalist, he desired to compare what was to be observed in the other side of this valley of the Rhône, which he had found so singular and so interesting on that which he had examined. Accordingly, in spring 1785, he made a journey for that purpose. In this survey he found the most perfect correspondence between the two sides of this valley, so far as rocks of the same individual species, and precisely in the same order, are found upon the one side and upon the other. This author, after describing those particular appearances, sums up the evidence which arises from this comparison of the two sides of the valley. And he here gives an example of just reasoning, of accuracy, and impartiality, which, independent of the subject, cannot be read without pleasure and approbation. But when it is considered, that here is a matter of the highest importance to the present theory, or to any other system of geology, no less than a demonstration that the rocks, of which the mountains on both sides of the valley of the Rhône are formed, are the same, and must have been originally continued in one mass. The following observations of our author will be most acceptable to every person who inclines to read upon this subject. Section 1079. Envoyé par cet exposé, que bien que la vallée du Lion est dans ce trajet près d'une de largeur moyenne, les montagnes que l'abordent sont en général du même genre, et dans la même situation sur l'un et l'autre rive. Il y a cependant 3 différences que je dois exposer et apprécier en peu de mots. La plus importante est dans ces couches de pierre calcaire, section 1073, que j'ai trouvées sur la rive droite, et que je n'ai point vue sur la gauche. Mais il est possible qu'elles y soient, et qu'elles aient échappé, masques par de débris ou par d'autres causes accidentelles, cette supposition est d'autant plus possible, que l'épaisseur de ces couches n'est que de quelques pieds. D'ailleurs il arrive souvent, que de filons, tel que pourrait être celui dont je parle, n'y s'attendent pas à de grandes distances, quoique la nature de la montagne demeure la même. Enfin ce que diminue l'importance de cette différence, c'est que ces couches calcaires se trouvent dans le voisinage de l'ardoise capacée, comme la pierre calcaire, pour une pierre de nature secondaire, et que alterne très fréquemment avec elle. Une autre différence que l'on aura pu remarquer, c'est que sur la rive droite, je n'ai point trouvé de pétrosilex per et en grandes masses, comme sur la rive gauche dans les environs de la cascade. Mais cette différence ne frappe pas non plus beaucoup, parce que lu de pétrosilex, j'ai trouvé sur la rive droite de roches composées en très grande partie de feldspath. Or je regarde le petrosolex et le feldspath comme de pierres de la même nature. Leur durite est très peu près la même, leur densité la même, leur fusibilité la même. L'analyse chimique démontre dans l'un et dans l'autre les mêmes principes, la terre siliceuse, la terre argileuse et le fer, et de plus ces ingredients sy trouvant à très peu près dans les mêmes proportions. Il reste donc de différence que dans la couleur et dans l'agrégation de éléments. Or en fait que ces qualités accidentelles tenant souvent à de causes que peuvent être purement locales. La troisième différence, celle que s'y trouve dans la direction de quelques-uns de couches, JELAI déjà indiqué, section 1075. Il semble inutile de répéter, que quand de couches formes originairement dans une situation horizontale, ont été redressées par de opérations violentes de la nature. Il a pas lieu de s'étonner qu'elles n'ayant pas exactement la même position dans tout l'espace qu'elles occupent. Les différences n'y sont donc pas très significantes, et les ressemblances sont au contraire du plus grand poids. Ce que leur donne à manger la plus grande force, c'est la rarité de pierres dont ces montagnes sont composées, ces species de porphyres à base de petrosolex, ces rochers feuilletées mélanges de feldspath et de mica. C'est encore la correspondance de l'ordre dans l'équal elles s'y suivant, ces banks de pudding séparés par de ardoises sur un rive comme sur l'autre, leur situation également au peu près telle. Viola Delaware grandes et fortes analogies éthiques n'y permettent pas de doubter que ces montagnes, produites dans le même temps et par les mêmes causes, n'ayant été anciennement unies. Having thus shown, that the Rhone had in the course of time hollowed out its way from the central mountain of the St. Gothard through the extensive valley of the Valleys, we may still further trace the marks of its operation in the more open country towards the lake. It is an observation which M. de Saussure made in his way from the valley of the Rhone to Geneva. Section 1090. La grande route de Bex à Villeneuve suit toujours le fond de la vallée du Rhône, en côtoyant les montagnes que bordent la droite au le côte oriental de cette vallée. Ces montagnes sont en général de nature calcaire, mais en void à leur pied, jusques aupres de la ville d'Aigle, située à un lieu demi de Bex, la continuation de collines de gypse que renferment les sources salées. Section 1091. À l'opposite de ces collines, au couchant de la grande route, on voit sortir du fond plat de la vallée du collines allonges dans le sens de cette même vallée. Ces collines sont l'un et l'autre d'une pierre calcaire dure et escarpées presque de tous les côtés. L'une la plus voisine de Bex, au la plus méridionale, est nommée Charpigny, l'autre Saint-Tryphon. Il paraît évident que ces rochers isoles au milieu de cette large vallée sont de noyaux plus durs et plus solides que ont résistent aux causes destructrices par lesquelles cette vallée a été creuse. Ils n'y sont cependant pas exactement de la même nature, et surtout pas de la même structure. Car celui de Saint-Tryphon est composé de couches régulières, horizontales au peu près telles, tandis que celui de Charpigny a les siennes très inclines et souvent dans un grand désordre. In M. de Saussure's Journey to the Alps, we have now seen a description of the shape that had been given to things, by those operations in which strata had been consolidated and elevated above the sea. Nothing but disorder and confusion seems to have presided in those causes, by which this mass of continent had been exposed to the sight of men. And nature, it would appear, had nothing in view besides the induration, the consolidation, and the elevation of that mass into the snowy regions of the atmosphere. From the descriptions now given, we see the operation of the waters upon the surface of the earth. We perceive a regular system of mountains and valleys, of rivulets and rivers, of fertile hills and plains, of all that is valuable to the life of man, and that which is still more valuable to man than life, viz. The knowledge of order in the works of nature, and the perception of beauty in the objects that surround him. Let us now turn our view to distant regions, and see the effect of causes which, being general, must be everywhere perceived.